This video has over 9 hours of content and contains 21 unique Python projects. These projects go in ascending order of difficulty, so the very first project in the video is pretty simple. It's just teaching you Python, completely designed for beginners, and as you go through the projects, they get harder and harder and harder and harder until you get into some pretty advanced stuff. We have games, we have using APIs, we have scripting, we have automation, we have fun tools, we have alarm clocks. Anything you can imagine is probably in this video, and there is definitely a project that you will enjoy and you can learn from. In terms of navigating here, all of the projects will be timestamped in the description. I've made this so it's really easy to find the projects, and all of the links in terms of code resources, assets, sound effects, whatever you might need for the project will be linked directly below the timestamp. So let's say you're at project number 4. Well, what you can do is go down to the description, find project number 4, find the timestamp for it, and you'll see beneath there'll be a link that contains all of the code for that individual project. Now, just for your information, this is simply a combination of a ton of other Python videos that I've done in the past. I had so many on my channel, many of which you guys didn't even know exist or new subscribers haven't seen. So I wanted to make one massive resource that just had so much practice that you can save this video and come back to it for days, weeks, or even months and constantly have a new project to work on. I hope you guys are going to enjoy this. It's taken me a fair amount of time to edit it, and I've chopped out all of the intros and the outro so you just get right into the content, no fluff, straight to the point, and right into practicing your Python skills. If you guys enjoy this type of content and you like my teaching style, I do have a software development course. I'll leave a link to it in the description. Check it out, and I hope you enjoy this video. So this quiz game, the idea behind it is we want to ask the users a bunch of questions, and then if they give us the right answer to these questions, we'll kind of add 1 to their score. Then at the end of the program, we'll print out what they got out of the number of questions. So if there was 10 questions, we would say, hey, you got, 3 out of 10 or 7 out of 10 or whatever, and maybe we'll even give them a percentage or something like that. So let's get started. The first thing I'm going to do here is use the print command or the print function. I'm going to assume you guys are familiar with this, but when you want to print something to the screen, output something to the console, you say print, you put some value in here. The value you typically put is a string. A string is anything encapsulated in double quotation marks or single quotation marks, and then this will be what is outputted. So the first thing I'm going to do is just kind of welcome my users to the game. I'm going to say, welcome to my, and then computer quiz. So the specific quiz I'll go with is a computer quiz. Please feel free to go with whatever type of quiz that you want. All right, now we've welcomed the user to our game. Let's just quickly test this out. In VS Code, to run your code, you press this little kind of run button right here. You're going to see it should open up a terminal down here. And then notice it says, welcome to my computer quiz, because the program just ran. Awesome. So now what I want to do is ask the user if they want to play my game. If they say, no, I don't want to play, then we'll just immediately quit the game. So to do that, I'm going to create a variable. I'm going to say playing is equal to, and then I'm going to use this function called input. Now what input allows you to do is ask the user to start typing something in the console. So inside of input in here, you put what's known as the prompt. Now the prompt is kind of what appears before the user can start typing. So for example, if you're asking the user for their name, you may have the prompt be name and then colon and then maybe a space. And then right here after this space, the user could start typing whatever their name was. So in my case, I would put Tim. And then whatever they type after the prompt, and then when they press enter, that will be stored in playing. So if I type Tim and then I press enter, now playing will be equal to Tim because after the prompt, that's what the user typed before they hit enter, right? Hopefully that kind of makes sense. And even if the user has a space, they say like Tim and then R, all of this Tim space R will be included in playing because this is all the stuff they typed after the prompt before they pressed enter. So I'm going to ask them here, do you want to play? ? And then I'm going to add a space here. The reason I'm adding a space is because if I don't add a space, then the user is going to start typing right on the question mark, and that's going to be kind of all smushed together and it doesn't look nice. And so we're going to add a space to make sure the user starts typing 1 space after the question mark. All right, so now if I run my program, so I press the run button, it says, welcome to my computer quiz. Do you want to play? Notice the cursor is here, and now I can start typing whatever I want. When I press enter, nothing's happening because we haven't done that yet. We haven't configured that, but that's kind of the basics. That's how you get user input. And just to show you here, if I print out playing, what this will do is give me whatever the value of this variable is. So if I run this here, it says, welcome to my computer quiz. Do you want to play? Say yes. And then it prints out yes, right? So pretty straightforward. Okay, so now that we know if the user wants to play or not, right? Because after this line is done, we'll have something stored in playing. We want to check if the user typed yes, right? And specifically, if they didn't type yes, we want to end the program. So what I'm going to do is use something known as an if statement. Now, an if statement allows us to conditionally check or compare values together and see if something is true or false. And so I'm just going to write out the kind of entire if statement, and then I'll run through it step by step. I'm going to say if playing does not equal to, so an exclamation point and then the equal sign, and then I'm going to say yes, then what I want to do is I want to quit the program. And there's this function in Python that you can use called quit, and this will just immediately terminate the program. So what I'm doing is using if, I'm writing what's known as my condition. This is the thing that I want to check. So I want to check if the variable playing, which is what the user typed in, is not equal to yes. The reason I'm checking if it's not equal to yes is because if they typed anything other than the word yes, I want to quit the program. Whereas if they typed yes, I don't want to quit. And so what happens here is we're going to compare whatever the user typed in with yes. And since we're using not equal to, if what the user typed in is not equal to yes, this condition evaluates to a Boolean, which is known as true. And then if this is true, right? So if whatever the condition is true, then whatever is indented after this colon here is going to be run. So hopefully that makes sense. I won't go too much more into the syntax. I assume you guys can probably figure it out yourself. But the idea is you put a colon, and then all the stuff you want to happen when this condition is true, you indent here. And an indent is kind of 4 spaces. I would recommend you use tabs rather than kind of going 1, 2, 3, 4. You'll get some issues with your indentation if you try to do spaces and tabs together. So anyways, let's just see this now. Let's run this program, okay? I'm going to say, welcome to my computer quiz. Do you want to play? I'm going to type yes, and well, the program's going to end regardless because we're not doing anything after this if statement. But if I go here and I print, okay, exclamation point, and then let's play, smiley face. Oops, okay, I need to fix my quotations here. Yeah, okay, that's all good. Let's run this now. It says, welcome to my computer quiz. Do you want to play? I'll type yes, and it says, okay, let's play, right? And then it gives a really bad smiley face that I need to fix. And if we run this one more time, and then this time we type no, notice that it doesn't say, okay, let's play, because this condition was true, and so the program quit. All right, so that's about if statements. Hopefully that all makes sense. We're going to be using a lot of if statements in this video. So now that we say, okay, let's play, what we want to do is ask the user their first question. And so what we're going to do is the exact same thing we did when we were asking the user if we want to play. We're going to say some variable, I'm just going to call it answer because that seems to make sense, is equal to, and then input. And then I'm going to put whatever the question is. I'm going to say, ask something about a computer. I'll say, what does CPU stand for? Question mark. And then what I'm expecting is that the user is going to type in the answer, right? And so what I'm going to do is just add a space here to make sure that, again, the user's not typing right beside the question mark. They have a little bit of space. And now what I want to do is check if the user's answer is equal to the correct answer. So I'm going to say if answer is equal to, and then I need to type out what the actual answer is. Now, in this case, this is central processing unit. And I think I spelled processing correct. Obviously, you're going to want to make sure your answers are actually spelled correctly, because even if the user types in central processing unit, but they forgot the G, or they spell something wrong, or they have a capital P, they're going to have the question marked as incorrect because the answer has to match exactly with what the user typed in. Okay, so now we have a colon, and now we're saying, okay, well, if the answer was equal to central processing unit, what do we want to do? I'm going to print that they got it correct. So I'll say correct like that. And notice I'm using single quotes and double quotes kind of interchangeably. It doesn't matter which one you use, so long as you're consistent with the starting and ending quote. Awesome. So let's just run this now and see if this works. So I'm going to press run. It says, welcome to my computer game. Do you want to play? Yes. Okay, let's play. What does CPU stand for? Central processing unit. And then it gives me the output saying correct. Now, if I run this again, do you want to play? Yes. Okay, let's play. What does CPU stand for? I type in just CPU. It doesn't give me anything because, well, this was not true. Sweet. Okay, so now the thing is, though, if the user gets this wrong, I want to tell them that they got it incorrect, right? We need some output saying, hey, no, that was not correct. And so what we're going to use now is what's known as the else statement. So whenever you have an if statement like this, and you are checking if something is equal to something else. And that's what the to equal sign is doing, or you have some condition here. If this condition here does not evaluate to true, you can put this else statement here, which means if this is not true, whatever's in the else statement will run. So if I go here and I say print incorrect exclamation point, now if this is false, so if the answer does not equal central processing unit, then we will print out incorrect. If we type anything, doesn't matter, just so long as this right here that we typed out is equal to false, whatever's in the else here will end up running. So let me just show you what I mean, and then we can talk about this a bit more. So let's run. Do you want to play? Yes. Okay, let's play. What does CPU stand for? Central processing unit. And then it says correct. And oops, I should have typed in the incorrect one, but that's fine. Let's just type in no. And then notice it gives me incorrect. And if I ran this one more time, type yes, and I type some other random thing, it still gives me incorrect. So if I type anything other than central processing unit, the else statement runs. And again, the syntax for the else statement is you write else, you do a colon, and then any stuff you want to run, you do indented after the else. And you could do multiple things as well. I could do another print statement, and then both of these print statements would run if we got this question incorrect. Sweet. Okay, so now we have our first question. And now what we can do is kind of just copy this to do the rest of our questions, right? So I'll copy this one more time. I'll do 4 questions for my quiz. Please feel free to do more. And it's totally fine if we want to leave this answer variable the same. I don't need to change this to be something else. We could if we want to, but since we are done using the answer for this question after this if statement, it's fine if we use the same variable to store the answer for our next question. So now what we're going to do is we're going to kind of remove all of our answers and questions. And we're going to type in, well, new answers and new questions. And I'll show you some more things that we can do here and kind of some fixes and all that as we go through, but let's just get our questions done first. All right, so now my next question, I'll say, what does GPU stand for? Question mark, and then this will be, and I'll copy this, graphics processing unit. Okay, so let's go. Graphics processing unit like that. I hope that's correct. And then the next question we can ask, I'll just do a bunch of acronyms. What does RAM stand for? Question mark. This will be random access memory like that. Okay. And then lastly, we can say, what does PSU stand for? Question mark. And we'll just say power supply like that. Sweet. So now we've got all of our different questions here, and we're kind of printing out whether we got them correct or incorrect. So let's just quickly test this out. Let's make sure this is all working. So do you want to play? Yes. What does CPU stand for? Central processing unit. What does GPU stand for? Notice I didn't add the space here. And since I didn't add the space, you're going to see when I start typing here that's kind of smushed with the question mark. So I'll say graphics processing unit. What does RAM stand for? Random access memory. Okay, and what does PSU stand for? Let's just type PSU, and then notice it tells me incorrect. So I'm going to start by fixing these spaces here. You guys saw what happened when I didn't add the space for the input. So now it should be all spaced out properly. Sweet. So now we've got this all working. Hopefully you guys are all familiar with this if and kind of else syntax now. It just needs to be in this structure. Whenever you have a colon, typically in Python, the next line after that does need to be indented. If I did this and like I didn't indent this line here, you can see we're getting this red highlight. And it's the reason we're getting that is because the indentation's all messed up. This is supposed to be indented after we have the else statement. And a small note, you can only have the else statement after an if statement, right? So I can't just randomly come down here and put an else statement. It needs to come after an if statement appears, right? So hopefully that's clear. Okay, so now the one thing that I want to show you though is that we might be getting some kind of weird results from our program that we don't expect. So I'm going to run my program and I'm going to say, do you want to play? And I'm just going to type yes with a capital Y. And notice when I do that, it doesn't actually start my program, right? It immediately quits. And the reason for that is whenever you have a capital, that is different than lowercase, right? So if you have yes, that is not equal to yes. These are different strings. And so if we want to check if the person's answer, regardless of the case, right? If they have a capital Y or a capital E or a capital S or something, or, you know, multiple capitals, if we want Y or capital Y, capital E, lowercase s to be valid and to allow the user to play, we need to do something. Now, there is this method in Python called .lower. And what .lower does is it takes whatever text we type in and it just makes it completely lowercase. So if I go here and I print, Tim is great, like that. And then I say dot lower. And actually, let me do this in another way that's not as confusing. Let me say text is equal to this. And then I say text dot lower. What this will do, and make sure you have the parentheses, by the way, is it will convert all of this text to lowercase. So if I just run my program here and we have a look at our terminal, notice that, I have to type something. Let's just type that. It says Tim is great, all in lower cases. And so we can use this here to convert all of the answers that our user types in to lower cases. So I can say playing.lower, and then if the user typed in something with capitals, it will just all be lowercase. And that way, if they type yes with any different casing, it will still evaluate to true because we're converting it to lower. Now, in the same fashion, there is something called upper. If you say .upper, it will convert everything into upper cases. And so then what you would do if you're using .upper is you would make your answer in complete upper cases because you're always going to be converting anything lowercase to uppercase. So hopefully that's clear, but we're going to just throw .lower on here to all of our answers. So I'm going to say .lower, I'm going to say .lower, I'm going to say .lower, going to say .lower. And alternatively, if you didn't want to do it this way, you could actually just do it at the end of this input here. You could say input .lower, and then you could just remove this because now your answer is already converted to .lower. So you don't need to convert it kind of in this condition right here. Okay, hopefully that's all clear, but yeah, that's just taking your answer, converting it into lowercase, and then you're checking if the lowercase answer is equal to, well, the lowercase answer you actually have. All right, so let's rerun this. I'm going to open up my terminal. I'm going to run. Do you want to play? I'm going to type yes with a capital Y. Notice this works now. And now I'm going to do some capitals. So central processing unit. That works, right? GPU, graphics, processing unit. And then you get the idea. I won't do the rest of them. Okay, so the last thing I want to do here is implement some notion of score, right? We want to be able to tell how many questions our users got correct. So what I'm going to do is make a variable here at the top of my program. I'm going to say score is equal to 0. This is going to allow us to keep track of how many correct answers they have. Now, all we have to do here, since we define score equal to 0, is every time the user gets a question correct, we just need to increment score, so add 1 to score. So inside of this if statement here, because this is if the user got it correct, right? I'm going to say score plus equals 1. What that says is, okay, take the value of score and add 1 to it. That's equivalent to saying score is equal to score plus 1. So hopefully that's clear, but that's a way that you can just add 1 to the variable. And so if we add 1 to score every time we get something correct, that means that at the end of our program, we'll have some number, right? We'll have 2, 3, 0, whatever, however many questions we got right. And we can then use that to display how well the user did. So I'm going to say score plus equals 1. I'm going to do this inside of all of these if statements here. Okay. And now we've added 1 to score. So now what I can do at the very end of my program, once we're done with all our questions, is I can say you got, and then I need to use a plus sign. This is a concatenation operator. I'll discuss this in a second. Score plus, and then questions correct exclamation point. But I need to convert this to a string. So let me go through what I just did here. Okay, so I said you got, I did a space. Notice I manually added the space here. I then had a plus sign, and then I said string, score, and then plus, questions correct. So the reason I'm doing this string here is because score is a number, right? Score is an integer. It's not a string. And so if I tried to do something like, Tim plus 1, well, this doesn't really make much sense, right? Because I'm trying to add a number to a string, and how do you add 1 to text? That's just an undefined operation. That doesn't exist. So what I need to do instead is convert this 1 to a string. Because now that I have 2 strings, when I add them together, what I get in Python is Tim1, right? They kind of get combined. And so that's what I can do. I'm going to convert this score here into a string. So then when I add it to the other strings that I have here, it's valid. This operation works, and I'm not getting some issue popping up. Okay, and then I'm adding the questions correct. So I'm kind of putting this string score in the middle of the string, right? You got whatever the number is, questions correct. Okay, so let's run this. And you want to play? Yes. I'm going to say, let's CPU stand for central processing unit. Okay. Graphics processing unit. Okay. PSU, RAM, and it says incorrect. You got 2 questions correct. Right now it's giving me how many questions I got correct. And so the very last thing we can do here is we can copy this line and we can give them kind of a percentage, right? Like you got 50% or you got whatever percent. And the way we do that is now we're just going to take our score, we're going to divide it by the number of questions that we have is 4, and then we're going to multiply all of this by 100, right? And if we want to be extra clear here, what we can do is put parentheses around this score over 4 to make sure this operation happens first before we multiply by 100. But you'll see if we did it the other way around, we didn't add the parentheses, it would still work fine because we would do the division before we did the multiplication. But anyways, we're going to say now, instead of you got questions correct, we're going to say you got, and then we're just going to add a percent on here. Now notice I'm not doing a space, and since I'm not doing a space, it's going to be whatever this number is, and then plus, and then the percent sign. So it'll come right after, and then we can do a period. So now we've calculated the percent. Again, just taking the score, dividing it by our number of questions, which is 4, and then multiplying it by 100. Now note here, if you change the number of questions, you got to change this number, right? So let's go here and let's run this. And let's go to our terminal. Yes, we'll play. I'll just type something random. Okay, random access memory, correct. And then power supply. And then it says you got 50%. You got 2 questions, correct. And with that, that is going to wrap up our first Python mini project. So I know I went really slowly through this and really explained everything in depth. That's because this is the very first project. I'm trying to make sure this video works for everyone, regardless of your skill level. And now I will go a little bit faster. I won't re-explain a lot of the syntax that I've already explained now as we move into the new projects. Just anything new that I kind of come across or that we use, I will explain, but this is our first project. This is the quiz game. There will be some code that has, or there will be a link, sorry, that has this code in the description if you want to download this yourself. But I would highly recommend you modify this, change it around, maybe add like more than 1 point for questions that are worth, more than 1 point that are more difficult or something like that, right? And you guys can do this as you please. Regardless, that is the quiz game. Now we're going to move on to do a number guesser. I think this is the one I was saying I was going to do second. So this one is pretty straightforward, but what we're going to do is generate a random number, and we're going to track how many times it takes the user to guess this number. And so what I'm going to do is zoom in a bit here so that we can see our code. The first thing I'm going to do is import this module in Python called random. All right, so first thing to mention here is that this right here is what's known as a module. So when you import random, you're importing the random module. Now this just lets you use all of the functionality that's kind of in here. This is default. This is installed with Python by default. You don't need to install it or anything like that. And quick note, there is modules that are built by, people like me or other developers out there, and you can import them, but you have to install them first. This one is just built into Python by default, and so no installation is required. Anyways, let me show you how to make a random number. So there's a few different ways to do this, but the 2 simplest ways are to do random dot and then rand range. And then you're going to do an open and closing parenthesis. And let me get rid of the print statement so we can see this better for right now. And here you're going to put the start and then the stop of the range for your random number. So you would do something like -1 if you wanted to start the range at -1 and stop at 10. Excuse me. And then what this would do is generate a random number that goes from -1 to 10, but does not include 10. So that's very important. The number you put here is the absolute upper bound. You cannot have the number 10 be generated if 10 is here. If you wanted the range to generate a number between -1 and 10, you would have to put 11. Again, I don't know why they do that. There's just some things in Python that aren't necessarily intuitive for beginners, but with this is 11, it's not going to generate 11. It will generate up to 10. So make sure that's clear. Now, there's another thing you can do here. If you want the range to just start at 0, you can say random.randRange and just put the stop. If you just put one thing here, what this will do is generate a random number between 0 and this number -1, so up to 10. And yeah, there you go. That's how that works. Okay, so let's do something from -5 to 11. And let's say r is equal to random.randRange. And let's just print r. Okay, so let me run this. And we'll look at our thing here. Okay, run. And notice we get a 5. Now, if I run this again, we're getting a -3. I run a bunch of times, we get a bunch of random numbers. You see, this is random. And there you go. That's working. We got a 9. We can just run a bunch of times. We got a 10. Notice we won't get 11 if we do this. Sweet. So we're getting a random number. So that's one way. Another way to do this is with a function called randint. Now, randint works the exact same way as randRange, except now it will include 11. So the upper bound range now includes the number that you typed, doesn't go up to, but not included. So now if I do -5 to 11, 11 will possibly be generated. So if I run this now, we get 6, right? And if we keep running it, we might see that we get 11. Okay, I'm not, this could take a while. Yeah, there you go. So we do get 11, so that works. Okay, sweet. And same thing here. If you decide to not include the start, it will just generate up to and including this end number that you put right here. So that's how you make a random number. So what we want to do is generate a random number. So actually, let's leave this here. Let's say random underscore number. And then we want to ask the user to guess this number. And every single time they guess it, we're going to tell them if they were above or below the number so that they can do it in like a reasonable number of guesses, especially if we make this number like really large, right? So the first thing I'm going to actually ask the user is how large of a number they want to generate. So we'll assume it starts at 0, and then we'll ask them to type in a number, and we'll generate up to that number. So I'm going to say, let's say top of range is equal to, and then input, and we'll say type a number. We won't even tell them what it's for. We'll just say type a number. Okay, so now they're going to type a number. So what we actually need to do here is we need to make sure that this thing they typed in here is a number. Because if the user types in like hello or Tim or some random string, something that's not a number, then we can't use that, right? And we also need to make sure the number they type in is greater than 0. So I'll show you how we do that. I'm going to say if the top of range dot is digit, okay? And then I'm going to do an if statement inside of this if statement. I'm going to say if the int, and actually we're going to do this. We're going to say top of range is equal to int top of range. And let me pause here and explain what I'm doing. So first of all, you can make a variable using underscores. When you want to have multiple words, it makes a lot of sense to make the name with underscores. So like top underscore of underscore range. You can't have a variable that's like top range. That won't work. You need to have it connected. You can't have like two separate words like that. Anyways, this is equal to input. The user is going to type something in. Now, by default, when the user types something in, it's going to return it to us with double quotation marks. So it's going to be a string. So even if the user types in like 25, it's going to be returned to us like this. And this here for Python is not considered a number. It's not considered an integer. It's considered a string. And so we need to convert this 25 so that it looks like this, so that it's actually a number. And the way you do that is you use this function called int. So you surround the string with int, and then it will convert this string into its numeric representation, so it will give us 25. However, if you try to convert something that's not an actual integer into an int, it's going to fail. You're going to get an error. And so we need to make sure that what the user typed in is a digit before we try to convert it into an int. And the way you check that is with this isDigit method. So I say if top of range dot isDigit, what isDigit will do is return to us true if this is a number, otherwise it will return false. And so if this right here is true, we will convert top of range into an integer. So top of range is equal to int top of range. Then we will check if top of range is greater than 0. So we'll say if top of range is, actually we're going to say less than 0, less than or equal to 0 specifically. Then what we will do is we'll print out, please type a number larger than 0 next time, and then we'll just quit. So we'll tell them what they did wrong, and then we're just going to quit the program right there. Otherwise, if we make it through all of this, we're good. But one thing we need to do here is we need to put an else, and we need to put quit, and we need to put a print statement that says, please type a number next time. So let me run through this. What we're doing is checking if it is a digit. If it's not a digit, so in the else statement, we need to tell them, hey, you got to type in a digit. This doesn't work if you don't type in a number, right? And then we quit. Now, if that works, if it is a digit, we convert it into an int. We make sure it's greater than 0. If it isn't, then we tell them, hey, you got to type in a number, and then we quit. But if we make it through all of this and we don't quit, so we've now converted the number to an int, we can now use that number to generate our random number. So we can say random number, random.randint, and then we can put top of range as our variable for generating that random number, and we'll now generate up to whatever number they typed in. Sweet. So now that we have that, let's just print out the random number, and let's just test this and make sure it's all working. So I'm going to run this, type a number, let's type 5, and we got one issue, randint missing one potential argument b. Okay, so this is my fault. I was saying when we used randint, we could just include the top of the range. That's false. We need to include the bottom of the range as well. So I'm going to put 0 there, and now this should work. So let's run this, and let's type a number. Let's type 5, and there you go. We generated a random number, which was 4. If we run this again, type 5, we get 3. You can see this is indeed working. Sweet. So now that we have our random number, we want to keep asking the user to type in a guess for the number until they get it correct. And so I'm going to use a while loop here, and I'll explain how this works in a second. I'm just going to say while true. Now, what this means is, okay, we're going to do whatever is indented after this while loop here, after the colon, while this condition, whatever's at the top of here, is true. So right now, if we just decided to like print Tim, this would happen infinitely. This loop would never stop unless we actually like manually close the program. The reason is because there's no way for this to end, right? I say while true, well, true is always true, and so we're just always going to print 10. However, there is this keyword, it's called break, and what break will do is immediately stop the loop as soon as this line of code is executed. So what we can do is use this break keyword to break out of the loop, stop running the loop as soon as the user types in the correct number. So we're going to say while true, this is the condition for the while loop. We could do a real condition. We could say something like while like input, and actually we'll say like user guess is not equal to random number. We could do something like that. That would work as well. But I want to show you using the break keyword. So instead we're going to do while true. All right, so what we're going to do is we're going to start by asking the user to guess what the number is, right? That's the very first thing we do every single time we ask them. We say, okay, make a guess. So I'm going to say user underscore guess is equal to, and then input. I'm going to say make a guess colon. Now, same thing here. We need to check if the user's guess is actually an integer, right? And so I'm going to copy exactly what we just did right here. And I'm going to paste it down below. And I'm going to say, okay, if the, and now instead of saying top of range, I'm going to say user underscore guess dot is digit, then user underscore guess is equal to int of user underscore guess. And then I'll even take this, and we don't need to check if the number is less than 0. That's fine. We can just do this. So I'm going to say, and I'm going to get rid of this quit. Okay, let me explain this. But what I'm saying is, okay, the user guess is equal to input, make a guess. They're going to type in some number. This comes in as a string. We need to make sure that what they've typed in is actually a number. If it is a number, we'll convert it to a number. We're all good. However, if it is not a number, then we're going to say, please type a number next time. And we're going to use this keyword called continue. Now, what continue will do is automatically bring us back to the top of our loop. So it's a little bit different than break. Rather than ending the loop, it just brings us back to the very top. So if I did something down here like printed after continue, if we hit this continue keyword, this won't run. We won't print. We'll just go back up to the top of the loop and ask the user to make another guess. And so that's what we're going to do. However, we're going to come down here now. And we're going to say if the user guess is equal to the random number, we're going to print, and we're going to say you got it. You got it correct. Otherwise, we'll say else print you got it wrong. So if they didn't get it right, they got it wrong, obviously, right? Whereas if they didn't type a number, we'll just say please type a number next time, and then we'll continue rather than doing this and telling them they got it wrong after they didn't even type a number in. Okay, hopefully that makes sense. We can test this out though and make sure it's working. So save the program and run. Now type a number. Let's type a number, let's say 10. Okay, make a guess. We're going to guess 3. And wow, okay, we actually got it. That's great. But notice that it's still asking us to keep making guesses. And to quit this, you can type Control-C on your keyboard if you get into an infinite loop. The reason it's telling us to do that is because we didn't break out of the while loop, right? We said you got it, but we didn't stop. And to stop, we need to use the break keyword. So now you'll see if we do guess it, we'll immediately stop looping. Whereas if we don't get it, we will continue looping because the break keyword's not here. So let's run this now. Type a number. Let's just go up to 5. Make a guess. 1, you got it wrong. Okay, we'll guess 2, you got it wrong. 3, you got it wrong. 4, you got it wrong. 5, you got it. Sweet. And then we exit the loop. There you go. Okay, so that's working fine. Now what I'm going to do is I am going to keep track of how many times the user actually makes a guess. So to do this, I'm going to make a variable similar to what we had with score before. I'm going to say guesses is equal to 0. And now every single time we start this while loop again, I'm going to increment add 1 to guesses. So I'm going to say guesses plus equals 1. So at the very top of the loop, we'll increment guesses. So the first time this runs, guesses will be equal to 1. We'll go through all of this, then we'll come back up to the top. Guesses will now be equal to 2. The user will now make another guess. And now when we exit this while loop, once this is done, we're going to print out how many guesses they got. I'm going to show you a different way to do this time. I'm going to say you got it in, and then we'll say comma, guesses, and then the string guesses. So another way to print multiple things on the same line is to use commas. So I'm going to say you got it in, and then I'm going to say whatever the number of guesses is. Notice I don't need a space here. Whenever you have commas separating your different things that you're printing out, it will automatically add spaces in between them. And then notice here, I didn't even convert this to a string. And that's because the print statement is smart enough to say, okay, hey, this is an int. I'm going to convert this into a string for you and kind of automatically add it to this string. So what we were doing manually before, the print statement can just do for us. And so this time we'll let the print statement do it. This line here is completely equivalent to just having the plus, the space, the string, the other plus, and the space, right? It's the exact same thing. Okay, so let's go back to what we had. And there you go. We are all good. Now, let's just run this. And I am going to show you how we can tell them if they got it greater than or less than, because I did tell you that we were going to do that. Okay, so let's run this. And let's say type a number. Let's go 5, make a guess. 1, you got it wrong. 2, you got it. And then it says you got it in 2 guesses. Sweet, all is working. So now the last thing we want to do is tell the user if they were greater than or less than the number so that they can kind of narrow down their guesses. And so rather than just telling them you got it wrong, now inside of the else statement, we're going to check if the user was above or if they were below. And there's a ton of different ways to do this. I'm just going to do it this way. I'm going to say if the user guess is greater than the random number, then what I want to do is say print you were above the number, exclamation point. Otherwise, I'm going to say print, and I'll say you were below the number. All right, so let's run through this. We're just checking if the user guess is greater than whatever the random number is. If it is, we're going to tell them they were above the number. Otherwise, if it wasn't greater than, it must be less than, and we're going to say you were below the number. Now, some of you may have heard that statement, if it wasn't greater than, it must be less than. You say, no, it could be equal to. That's correct. But the thing is, up here, we checked if it was equal to. And so if it was equal to, we would have gone into here. We would not have hit this else statement. So if we're in this else statement, we know we must not be equal to the random number. And so instead, what we can do is just run this if statement that's inside of the else. I'm going to show you a more elegant way to do this in 1 second, but let's just run the program and see if this works now. Okay, let's run this. Type a number. Let's type 20. Make a guess. Let's guess 10. You were above the number. Okay, so now I don't have to guess below 10. So I'm going to guess 5. You were above the number. Okay, it's less than 5. 4, 3, 2, 1. You got it in 9 guesses. Okay, so anyways, that did work, but it was telling us whether we were above or below. Let's see if I can guess something that's actually, I guess I couldn't have guessed anything below 1. So let's run this again. Let's type 10. Let's guess 1. And then this time it is telling us we're below the number. Okay, great. So that is working. Okay, so the one thing I want to show you here is how we can clean this up a little bit using something new that we haven't seen yet, which is known as an elif statement. So an elif statement is something that kind of happens after the initial if statement is checked. So I'm just going to type this out, and then I'll show you how this works. So I'm going to say elif. Okay, so now what I've done is I've made this code a little bit cleaner. And the way I've done this is I've removed that kind of nested if statement that we had, and I've now implemented an elif instead. So what the elif does is if the initial condition is not true, it will then check another condition. So it says, okay, if this is true, we're going to do this. We're going to skip all of this. If this is not true, we're going to check this. If this is true, we're going to do this, and we're going to skip whatever else is after it. However, if this is not true, then we're going to do whatever is in the else. So we're going to check this. If it's true, we do this. Otherwise, we check this. If it's true, we do this. And otherwise, if both of these things are false, we do what's in the else. And so that's just another way to do this rather than having what we had before, which was the else, and then all of this kind of indented in the else, right? This just cleans it up. And small note, you can have as many elif statements as you want. So I could add another one like this if I wanted to do that. But in our case, it doesn't really make any sense to do that. Okay, so that's actually it. I'm not going to run the program. Just believe me, this does work. And yeah, that is going to be our number guessing game. So I'll zoom out a bit so you guys can kind of see all of the code. But that is how that works. I guess there's not really much more to say about that. And now we'll move on to the next one. All right, so now we're moving on to rock, paper, scissors. Now, obviously, you guys know how this game works. But what I'm going to do here is make it so that the computer keeps track of how many times the user gets it correct versus how many times the computer gets it correct. And when I say correct, sir, I mean whoever wins rock, paper, scissors. So the first thing we're going to do here is import random. Now, small note here, when you are importing modules, it's typically best practice to do it at the very top of the program. I see some beginners import the module like right before they use it. That's fine, you can do that, but it's just better practice to have it right at the top, so it's really easy to see what stuff you've imported, and obviously remove it, and then you can use it throughout the entire file, whereas if I tried to use like random up here, it doesn't work until after I've imported, right? So hopefully that's clear. But anyways, that's what we're going to do. So what we need is we need two variables, one for the user score and one for the computer score. So I'm going to say user underscore wins is equal to 0. And I'll say computer underscore wins is equal to 0 as well. All right, now I'm going to have a while loop. I'm going to say while true. And the first thing I'm going to do here is I'm just going to ask the user, actually, yeah, I'll ask the user to input rock, paper, or scissors. And then I will also let them type in Q, like the letter Q. And if they do Q, then we'll just immediately quit the program. So let's handle that first. Let's say user underscore input is equal to input. And I'll say type, and then we can say rock slash paper slash scissors. Is scissors with two S's? I think that's how you spell it. Okay, rock, paper, scissors. And well, paper should be spelled correctly. Okay, rock, paper, scissors, or Q to quit. Okay. All right, so now that we have that, we will go down and we will check. Let me just zoom out so we can see this here, what the user actually typed in. So the first thing I want to do is I want to see if they typed in Q. So I will actually convert this to dot lower in kind of the way that I showed you we could do it previously. We'll take whatever the user types in and we'll just convert it to dot lower. And actually, instead of a period, let me do a colon and let me add a space so it's not all smushed there. Okay, so type rock, paper, scissors, or Q to quit. And now I'm going to say if the user input, and this is converted to dot lower, right, is equal to Q, then what I'm going to do is I'm going to quit. Otherwise, I'm going to check if they typed in rock, paper, scissors, or if they type something else. And now I'm going to show you how we can check if the user input is equal to more than one thing. Because previously I've been showing you how we can check if it's equal to just a string, right? But now I'll give you a little bit of a, I don't want to call it a hack, but a little bit of a trick so that you can see if the user typed in rock, paper, or scissors all in one line rather than writing 3 if statements. So I'm going to say if the user input is in, and I'm going to use a list. You guys probably haven't seen this before if you're like a complete beginner in Python. And let me just kind of fix this a little bit. So PS, I'm going to type it myself and I'll explain what's going on here. Okay, so let's make this in quotes. Okay, and then this needs to be in quotes too. Okay, I'm really messing this up quite badly, but you get the idea. Okay, so what I've done is I've just created a list. Now, a list is anything encapsulated in these square brackets that is like separated by commas. So I have this rock, paper, and scissors string in this list. And so what I'm saying is if user input is in this list, I'm checking if whatever the user typed in exists in either of these 3 strings. So essentially we're just checking if the user typed in rock, paper, or scissors. Now you can put any strings in here that you want, but we're just checking obviously if this is in here. And that's how we can check multiple things on one line. There's other ways to do this too, but this is kind of one nice trick that we can use. So I'm going to say if user input, and I'm actually going to say is not in. Now this is another keyword again that you may not have seen before. What this is going to do is simply reverse the kind of thing that we were checking before. So we were checking if the user input was in rock, paper, scissors. So now when I say not in, I mean, obviously, as you would read it in English, this is checking if the user input is not in here. If it's not in here, that means they didn't type in something valid. And well, what we need to do is have them type in something valid. So what I'm going to do is say type continue here. And what this will do is just re-ask them to type in rock, paper, scissors, or Q. So we could give some error message saying that's not a valid option or something like that. But what I'm going to do is just have it so it keeps asking them to type something in until eventually they give us something valid. So when I hit continue, that means anything after here is not going to happen, right? If this continue is hit, we're just going to go back up to the top of the while loop. Sweet. And actually, rather than saying quit here, what I'm going to do is say break. So this will break out of the while loop, and then that will actually automatically end the program for us because we'll be at the end. We won't need to actually manually quit. So the break breaks out of the while loop, which means we'll go to wherever the end loop is done or wherever the while loop is done. And then we can actually just print something saying, good, no, not that, goodbye, exclamation point. Sweet. Okay, so now at this point in time, the user has given us valid input. They've typed in rock, paper, or scissors. So what we need to do is generate a random number that represents rock, paper, or scissors for the computer. So I'm going to say rand, random underscore number is equal to, and then this is going to be random.randint, and we'll generate a number between 0 and 2. So if they type in 0, that can be rock. If they type in 1, that can be scissors or paper. If they type in 2, that can be scissors. So let's write that down in a comment. To do a comment in Python, you hit the pound sign or use the pound sign, like the number sign, and then type anything after it. Anything on a line that comes after a pound sign will not be read by your Python interpreter, and it's just there so that as a programmer, it's easier to read and gives you documentation or comments about what's going on. So I'm going to say rock is 1 or rock is 0. I'm going to say paper is 1. And I'm going to say scissors is and then 2. Sweet. So the way that I'm going to do this now is I could do an if statement, or I could write 3 if statements, say, if random number is equal to 0, then the computer picked rock. If random number is equal to 1, if random number is equal to 2. I actually don't need to do that. What I can do is, let's see here. Okay, so what I'm going to do now here to actually assign some variable equal to rock, paper, scissors to represent the computer's kind of choice is I'm going to use a list. Now, again, this might be a little bit confusing, but I think you guys will get the idea if I do this. I'm going to take this list right here, rock, paper, scissors. I'm actually going to store it in a variable. I'm going to say options is equal to rock, paper, scissors, and I'm going to change this here to be options. So this is doing the exact same thing as before, except we're just storing this list of values now in this options variable. Now, if you haven't seen lists before, these are actually very interesting. They're known as a data structure, and they are collections of elements, right? We have multiple elements, multiple strings stored in this list. And well, the way we access these different elements in this list, let's say I just wanted scissors, or I just wanted paper, I just wanted rock, is we use what's known as an index. So if you write the name of your list, which in this case is options, that's the variable storing the list, you can put these square brackets, and then you can put a numeric index that represents these different elements. So in this case, the different indices of this list are 0, 1, and 2. And if we had another element, right, let's just go, test, then this would be index 3. So the way this works is you start counting at 0, and then you just go up by 1 every single time. So the very first element is indexed by 0, second 1, third 2, fourth 3. And so that's all that is. So when I say options at 0, that's going to give me rock. When I say options at 1, that gives me paper. When I say options at 2, that gives me scissors. And so I have some random number that's between 0 and 2, right? And 0 represents rock, 1 represents paper, and 2 represents scissors. Let me get rid of test. So what I can do is say, let's actually change this here. Say computer underscore guess, or computer underscore pick, I guess, is equal to, and then this is going to be options at whatever the random number is, because this will be between 0 and 2. And so we'll use that as the index to actually access the string, the thing that the computer chose, right? Rock, paper, or scissors. So now what we can do is we can print out what the computer chose. We can say computer picked, and then we can say comma, and we can say computer underscore pick. And then we will decide who actually won, right? So then we'll say who won. And let me just do comma. Let's do plus, and let's just add a period. The reason I'm not doing a comma and then the period is because if I do a comma, it will automatically add a space between this period and the computer pick, which I don't want. And so instead, we're just going to add the dot like that. Okay, so we're going to say the computer picked that, and then we need to decide who won, right? And so to decide who won, we need to, compare the user's pick to the computer's pick. So we're going to say if the user input is equal to, and then I guess we'll say rock, we'll then do kind of the winning condition for the user. So if the user picked rock, then what do they win against? Well, they win against scissors. And so now we need to check if the user picked rock and the computer picked scissors. So what I'm going to do is use this keyword called and say computer underscore pick is equal to, and then scissors. So if that's the case, we'll print out you1 exclamation point, and then we will say user underscore wins plus equals 1 so that they get one more win. So what this and does is it checks if the condition on the left side and the condition on the right side are true. So what happens in this if statement, or what's in this if statement, will only happen if both of these things are true. Pretty straightforward. That's how the and works. Alternatively, there's an or. And an or will kind of do the opposite. It will check if either the left or the right is true, or both of them are true. If any of those three things happen, this is true, or both of them are true, then what's in the if statement will run. Whereas with the and, it has to be both of these being equal to true for what in the if statement is going to run, or if what's in the if statement is going to run. Sorry, butchering my English here. Okay, so that's one of the win conditions for our user. And then if that's the case, we can just go ahead and say continue, and we can go back up to the top of the while loop and keep going. But we need to check the other win conditions, right? And there's two more win conditions. Let's go here and let's fix the indentation. Okay, and we'll say if the user input now is equal to paper and the computer picked, rock, then that means that we won, right? And so we would add 1 to the win. And then the last one is we picked scissors and the computer picked paper. Sweet. So the reason I'm doing this continue here is because after we've determined that we've won, there's really no point in checking these other if statements. So we could instead do these in elifs. So I could say if, elif, and then actually I could remove all these continues. And in fact, let's do this. And then we will go down here and we will say else. And then what we would do here is say print you lost. And then we will say computer wins, okay, plus equals 1. So the reason this works now is because we check if we won with the rock versus scissors. We check if we won with paper versus rock. We check if we won with scissors versus paper. And if none of those are true, that means we didn't win, right? There's no point in checking if the computer beat us in all the other scenarios. We just need to check if our 3 win conditions were true. If they are not true, then we know that we lost. And so we would print we lost, and then we add our computer wins. And this is an example of using multiple elif statements. We'll check this one. If it's false, we'll check this one. If it's false, we'll check this one. If it's false, we run this. If any of these are true, we immediately stop and we do whatever is inside of here, which is increment the user wins and print you won. Great. So now the last thing I'm going to say before I do goodbye is I'm just going to print out the number of user wins versus computer wins. So I'm going to say the user, or I'll say in this case, you won, comma, user underscore wins times, and then we'll print the computer won, and then computer underscore wins times period. Great. So hopefully that is all good. Let's quickly run through what we've done because we wrote a lot of code here relatively quickly. As you can tell, I'm kind of picking up the pace a little bit as we go through this. So we have our user wins, our computer wins. We're importing random, which we've already discussed. We have our list. First time we've seen this, called options, has our 3 values in it. We have while true. We have user input equals input. And then we say type, rock, paper, scissors, or Q to quit. We make whatever they type in lowercase. We check if the user inputted Q. If they do, we break, we're done, we stop the program. If they didn't, then we check if the user input is not in the options. If it's not in the options, that means they didn't type a valid rock, paper, or scissors. And so we press, or we go continue, which means we're going to start the loop again. We're going to ask them to type something in. Then what we do, if they typed in something valid, is we generate a random number between 0 and 2. This is what it stands for. Rock is 0, paper is 1, scissors is 2. We make our computer pick. So computer pick is equal to options at whatever the index is of the random number. We then say, okay, the computer picked this. We then check if the user won based on what the computer picked, right? And yeah, that's all good. And then we increment computer wins or user wins, and we will keep going until eventually the user hits Q. Once we're done, we'll break out of the while loop and we'll print these 3 things. Let's run it. Let's see if it works. Okay. Type rock, paper, scissors, or Q to quit. Let's just test Q. Okay, you won 0 times, the computer won 0 times. Goodbye. Nice, works. Okay, let's actually type something. Let's go rock. It says computer pick scissors. You won. Nice. Okay, type rock, paper, scissors, or Q to quit. Let's go paper. Computer pick scissors. You lost. Okay, that sucks. Let's go scissors. Computer picked paper. You won. Nice. Let's go rock. Okay, and let's go Q. And then it says the computer won 1 time. You won 3 times. Goodbye. All right, so that is rock, paper, scissors, keeping track of how many times both the user and the computer wins. Now we're going to move on to the next project, which is the choose your own adventure game. All right, so this next project is one of my all-time favorite beginner projects, and that is because it's so customizable. There's so much you can do with this. I'm really only going to talk about this for about 5 or 10 minutes because this is up to you guys to make this kind of as big as you want. So this is a choose your own adventure game, and I guess the best thing to relate this to, if you haven't heard of this before, is kind of these children books. And actually they have books that aren't children versions too, but they're kind of like pick your own story books where you'll go to a page, right? And it will say like, if you want to go left, turn to page like 42. If you want to like swim across the river, go to page 97, whatever. And then like it kind of brings you on all these different paths throughout the book based on decisions that you make. So same thing here. We're going to ask the user to make a bunch of different choices. We'll start with something simple like, do you want to play the game, right? And then if they say yes, we'll say, okay, you come to some bridge. Do you want to cross it or do you want to swim underneath it? And then based on what they say, if they cross the bridge, maybe we'll say, okay, you come to a dead end. Do you want to turn around or do you want to search the jungle? Whatever. Like you can be as creative as you want. I'm just coming up with stuff at the top of my head. But then if they had instead decided to swim under the bridge, maybe we say like, oh, there was a crocodile and your journey ended, whatever. So you guys can make it as complex as you want, but I'll show you like the basic structure and kind of the nesting of statements and how it works. So the first thing we're going to do is I'm actually going to ask the user for their name. This is something I don't usually do, but I think this will be cool. So I'm going to say name is equal to input. I'm going to say type your name, colon. And then I'm going to say print, and I'm going to welcome the user. I'm going to say welcome, comma, name, comma, to this adventure, exclamation point. And then we'll actually get right into it. And before I even ask them if they want to play, what I will do is I will just say, like, I'll ask them for a choice. I'll say, you come to a dirt road or something. Do you want to go left or right? Whatever. So the first thing I'm going to say here is answer in lower cases is equal to input. And I'll say, you are on a dirt road. It has come to an end and you can go left or right. And then I will say, which way would you like to go? Question mark. Okay, so let's just go here. And notice that it's doing this auto formatting. You guys don't have to worry about this. It's just my IDE auto formats my code when I save it. And so you can see it's kind of going on a new line. Don't worry about it. You can just do yours in the same thing. But anyways, that's like my prompt. You're on a dirt road. It has come to an end and you can go left or right. Which way would you like to go? And I'm expecting them to type in left or right. So the first thing I'm going to do is I'm going to check if they typed left or right. I'm going to say if answer is equal to left. And actually, before I do that, I'm going to convert this input here to dot lower. And I realized I kind of messed something up. Hopefully that fixed it. Okay. So we're going to say dot lower. And let me add the space here between the question mark. Okay, so answer equals left. So if the answer equals left, then we'll do something else. Otherwise, we'll say elif answer is equal to right. And then else we'll say print not a valid option, you lose. So I'm just going to make it so if they ever give us something that's not valid, they just immediately lose the game, okay? So if the answer is equal to left, then we need to pick what's going to happen when they go to the left. If the answer is equal to right, we need to decide what's going to happen if they go to the right. So I'll start by kind of doing the left path. And let me just put a print statement here so I don't get an error. You'll notice that if you don't have something indented after it's expecting something to be indented, it will like yell at you and be angry. So you can just put an empty statement like print, and that will kind of fix it. Okay, so now what I'm going to do is I'm going to ask them another question. I'm going to say answer, and you can name these variables whatever you want. Maybe it would make more sense to name them like Q2 or something, whatever. I'll say answer is equal to input. And I'll say, okay, like you come to a river. And you can walk around it or swim across. And I'll say type walk to walk around and swim to swim across. And make sure that when you guys do this, you're kind of like, telling the user what they need to type in, because sometimes it's not intuitive on what they should be typing. And so I always try to give them the option, like tell them explicitly like what I'm expecting them to type, so they don't give me an invalid option, like not intentionally, you know? So now I'm going to check inside of here if the answer is equal to swim, elif the answer is equal to walk, and then else I will print not a valid option, you lose, right? So we'll do that. Okay, so now I need two things to happen here. So print and print. Okay, so I'm going to pause for a second. Hopefully you're getting the idea of what's going on here, right? If they go left, I ask them a different question, and then I check inside of this if statement what they answer for that next question, and then I do something else. Whereas if they go right, I'm going to ask them a different question. And so it's cool because there's like all of these different paths that people can explore. And like if they only go left at the beginning, they're only exploring like half of the potential paths. And then as soon as they go right, there's all new different options. Now you could have the same options for different things they type, right? If they decide to go left or right, you could in theory ask them the same question if they go left or if they go right. But I like to do it differently. I think that's more fun. So let's just kind of continue on this path here. I'll say if the answer is equal to swim, then I'll print you swam across and were eaten by an alligator. Is that how you spell alligator? Maybe. You guys can tell my spelling is not the best. Okay, eaten. There you go, by an alligator. Nice. Now, if they decide to walk across, I'll say you walked for many miles, ran out of water, and you lost the game. Okay, so both of these options here were invalid. So if they decide to go left, doesn't matter what they chose, they were just going to lose. And so instead they have to go right. And so we've kind of ended the path now on the left, but if we wanted to, maybe swim was like the correct answer, quote unquote, we could add another path here. And we don't have to have them lose on one of these options. I could add another path for walk too, right? Like hopefully you're getting the idea. You can just chain these kind of if statements in as far as you want. So now let's do something for going right. And actually, before we do that, let's test this out. And let's make sure you guys understand what's going on here. Okay, so type your name. I'm going to say Tim. It says, welcome, Tim, to this adventure. You're on a dirt road. It has come to an end, and you can go left or right. Which way would you like to go? Let's go left. When I go left, it says you come to a river. You can walk around it or swim across. Type walk to walk around and swim to swim across. You're going to type swim. It says you swam across and were eaten by an alligator. And then there you go. Boom, you lose, right? Okay, so now let's go and do something for right. So for right, I'm going to say answer is equal to input. I'm going to say you come to a bridge. It looks wobbly. Do you want to cross it or head back? Question mark. And then the options I'll put here, I'm just going to put them in brackets. I'll say cross/back to kind of really indicate, hey, that's the two things that you're supposed to be typing, cross or back. And then here, I'm going to just copy this if-else structure just so I can fill it in. I'm going to say if the answer is equal to back, if the answer is equal to cross, and then I'll continue. So now I'm going to say if answer equals back, you go back to the, I don't know, like main road, whatever. We can make this whatever you want. Now you can decide to drive forward. I don't know, drive to the left or go to the right. Or you know what? We can make going back just be the wrong option. We'll just say you go back and lose. I don't think you guys need me to give too much detail here because I'm having trouble coming up with this. Okay, so we're going to say that crossing is the correct option. So if they decide to cross, then what we're going to do here is now we're going to ask them another question. We're going to say answer is equal to input. We're going to say you cross the bridge and meet a stranger. Do you talk to them? And we'll say yes, comma, no, question mark. Okay, and then same thing here. We can say if answer is equal to yes, elif answer is equal to no, and then else we'll say not a valid option, you lose. So let me copy that. Okay, not a valid option, you lose. And then here again we can decide what we want. So we'll say print, maybe yes is like the correct answer and it ends the game. We'd say you talk to the stranger and they give you gold, whatever, you win, exclamation point. Otherwise, no, we could say print, you ignore the stranger, if I could spell stranger correctly, and they are offended, and you lose. Okay. So again, I'm just like randomly coming up with this stuff. I'm sure you guys are laughing at the options that I'm going with here, but I'm just trying to show you the structure of this program and kind of how like the nesting works so that you can make this as advanced as you want. So now we've kind of implemented something for the right. So it asks you a question. Obviously you lose if you go back. If you go to decide to cross, then you're asked another question. You cross the bridge, meet a stranger. Do you talk to them? If the answer is yes, you lose, or you win. If the answer is no, you lose. If you answer something that's not one of those, then you lose. And then, of course, if you wanted to keep going from here, rather than telling them they lose or they win, you would just ask them another question. And you would keep doing this and keep nesting this if and else. And you can make multiple options too. You don't have to just do 2 options. You can make it so they could give you 3 options. You can make it so that you store one of their options in a variable, like name, right? And then you use that variable later on. Like maybe they picked up like a weapon or something really early. And if the weapon they chose really early is not correct when they go down a certain path, then maybe they lose. Whereas if it was correct, then maybe they can continue on or something like that. And so lastly, I'm going to say print, thank you for trying, comma, and then this is going to be their name. Okay, so let's run this and I'll just go through a few of the paths, but that's pretty much going to wrap up this game. There's not really much more to show you. This is just a cool one and I always find this fun, and obviously you guys can come up with better stories than I can. So type your name. I'm going to say Tim. Welcome, Tim, to this adventure. You're on a dirt road. It's come to an end. You can go left or right. I'm going to go right. Okay, you come to a bridge. It looks wobbly. Do you want to cross or head back? I'm going to cross. You cross the bridge and meet a stranger. Do you talk to them? No. It says you ignore the stranger and they're offended and you lose. Thank you for trying, Tim. Right? There you go. Then we could try this again. Type your name. Tim. You're on dirt road. Let's go left. Right. You come to a river. Let's walk. And it says you walked for many miles, ran out of water, and you lost the game. I'm not going to go through all the options. I think you guys get the idea now. That is the Choose Your Own Adventure game. Again, this code will be linked in the description if you want to download it, but this is kind of the template. Use the if, elif, and else structure and, make this as advanced and complex as you want. Now, let's move on to the last project, which is the password manager. All right, so now we're moving on to the last project, which is a password manager. Now, the point of this program is to kind of organize and store your passwords. So we're going to store all of the passwords along with the username or the account they're associated with in a text file, but we are not going to store the passwords in plain text. We're going to encrypt the passwords. Now, even though we're encrypting these passwords, which means they're going to need a kind of password to be able to decrypt them. So like there's like a master password for all of the passwords. This is not a secure way of storing your passwords. Do not rely on this for anything other than like a fun Python project. And I personally would not recommend storing at least any of your very sensitive passwords in this method. It's just like a cool thing, and I wanted to show you how to do it. And it's kind of a more advanced project out of the 5 that we've done. So the first thing I'm going to do here is I'm going to write the code that's allowing us to actually ask the user whether they want to list out their passwords or whether they want to add a new one. And we're going to store all of these in a text file. So I'll do this project first without encrypting any of the passwords, and then we'll go and encrypt them. So the first thing that we need to do is ask the user for like a master password. So we're going to say pwd is equal to input, and we'll say, what is the master password? Question mark. Now, we're not actually going to validate this password is equal to something. We're going to use this password to encrypt our passwords. So if they type in the wrong password here, it's still going to work, like the program will operate, but it won't show them the correct password. And you'll see how that means when we kind of get later into the video. Regardless, what I'm going to do now is ask them what mode they want to go in. So whether they want to add a new password or whether they want to view their passwords. So I'm going to say mode is equal to input. And we'll say, would you like to add a new password or view existing ones, question mark. And then the 2 inputs I'll allow will be, I guess, view and add. Okay, so that's what I'm expecting them to type in. Now what I'm going to say is if mode is equal to view, we will do something. Otherwise, elif mode is equal to, what I say, add, we will do something else. Otherwise, else we'll say print invalid mode. And I'm going to take all of this and I'm going to put this inside of a while loop. So I'm going to say while true, because we'll allow them to like add a password, then view them, and like so on and so forth. And so in this else here, I'll just say invalid mode, and then I'll say continue. And what this will do will bring them to the top of the while loop. And then I'm also going to add something here that says press Q to quit. And then I'm going to convert all of this to dot lower. And then I'm going to check at the very top here. I'm going to say if mode equals Q, then break the while loop. Okay, sweet. And then we could make this an elif, but we don't have to make it an elif since we have a break here. If this is true, it just won't even bother checking these. So up to you, but I'm not going to add the elif. Okay, so now that we have this, what I'm going to do is show you something called a function. So I'm going to create two functions here. I'm going to say define view, and I'm going to say pass, and then I'm going to say define, and this is going to be add. Okay, so what a function is an executable, reusable block of code. So the way you call a function is you write the name of it, which is this, okay, and then two parentheses. So the basic syntax is you write def to define a new function, space, name of the function, open and closing parentheses, and then any parameters that you want inside of here. I'm not going to really talk about what that is because I'm not trying to teach functions here. I'm just trying to show you how we can kind of split our code into different sections. And anyways, the way you call a function is by its name and then the open and closing parenthesis. So if I put, say, like print Tim inside of here, then I could call this function a bunch of times. And every single time I call this function, it would do whatever is inside of here, which would print Tim. So if I had, print Tim twice, every single time I call the function, it's going to print out Tim 2 times. Whatever's indented inside of here just happens when you call the function. Pretty straightforward, but the point of me creating these two functions is that rather than writing all of the code related to the view mode and the add mode in the while loop, I'm going to put them in this function so it's a little bit more organized and easier for me to kind of separate my program. So I'm just going to have pass inside of here right now. Now, pass is a keyword that literally does nothing. It is just there to make it so you don't get any like indentation errors because you need to have something indented after the colon. And so for now, we're just going to write pass. And you can see we've done that here too. So now instead of just using pass, I'm going to call the view function. I'm going to call the add function. So now, depending on what mode you select, it's going to call these two functions, which will then perform the operations for that mode. It's just a cleaner way to write the code. It makes it a little bit more organized. Okay, so let's start with the add function. What I want to do is create a new file if the file storing our passwords doesn't already exist and add the password into it. So the first thing I need to do is get the user account or whatever, the username, and then the password, and then I want to add it into the file. So I'm going to say, I guess name is equal to input, and we'll say account name like that. And then we'll say PWD, which stands for password, is equal to, and actually, sorry, this should just say password because we already have PWD up here. And in fact, let's call this master underscore PWD, and then we can call this PWD. So PWD is equal to input, and we'll say password colon like that. So now they're inputting their account name and their password. Now what I want to do is open a file or create a file if it doesn't already exist and add this password in. So I'll explain what this is doing in a second, but I'm going to say with open, the name of my file, which in this case is going to be passwords.txt. We're going to just use a text file for now. Then we're going to say comma, and then we need to define the mode to open this file with. Now the mode we're going to use is A, which stands for append. We're going to say as F, and now I'll explain what I just did. So when you use this with thing right here, this allows you to then do some things indented after it. And the point of this with, when you're opening a file specifically, is that as soon as you are done doing all of the operations with the file, since we use this with, it will automatically close the file for us. So you can open a file like this. You can say file equals open, and there you go. Now you have file. But the thing is, if you do this, you need to make sure you manually close the file after you open it, because if you don't do that, your Python process will still be kind of like holding on to and using this file, and it's going to cause problems if you try to open this file somewhere else. And so it's just better and safer to kind of use this with keyword, because now you don't have to manually close it. It will automatically close the file for you. So anyways, I'm going to say with open passwords.txt in A mode. Now, so this is the name of the file. The next thing is the mode to open the file in. Now, there's a bunch of different modes. The main ones are W, R, and A. Now, W means write, and what this will do is create a new file or override this file if it already exists. Very important you understand this. If passwords.txt already exists and you open it in W mode, it will clear that file and make an entirely new one. So only use W mode if you want to always override a file that potentially already exists. Okay, then there's R mode. This is just simply read mode. You can't write anything into the file if you open it in read mode. All you can do is just read the file. That's R mode. And obviously this is not going to destroy a file if it already exists. In fact, there'll be a problem if you try to open the file and it doesn't exist in R mode. Then you have A mode. This is append mode. This is probably the most flexible mode. What this allows you to do is add something to the end of an existing file and create a new file if that file does not exist. So if passwords.txt does not exist, a new file will be created called passwords.txt, and then we can write to the file. If passwords.txt already exists, we are able to write to the file and read the file from the very end. We can write to the file from the very end, and we can just read the entire file when we open it in A mode. And so for adding something, we're going to open in A mode, because if it exists, we append to the end. If it doesn't, we create it. Awesome. So now what we're going to do is say f.write. That's the name of our file because we said as f. And then we are going to write in the name plus the pipe plus pwd. So what this is going to do is take the name. It's going to separate the password with the pipe operator, and then it's going to put the password. And then we will have user and password inside of the file. So let's actually try this out. Let me run this. You can see it says, what is the master password? I just type whatever for now. Just type hello. And would you like to add a new password or view existing ones? View, add, press Q to quit. Okay, I'm going to type add. And then it says account name. Let's just go Tim. Password, let's go is_great. Okay, so now I'm just going to quit. Notice this passwords.txt file has been created. If I open it, I now have Tim and is great. And if I were to do this again, it would add the next line in. So actually, let me rerun this. Let me say add account name, Joe, password is Billy, and then notice it gets added in here. The thing is though, it got added on the same line, and I don't want this to be added in the same line. And so what I'm going to do is I'm going to quit here, and I'm going to make it so that I go to the next line after I add each password. And the way I do that is I add what's known as a line break. I think this is actually called a carriage return, maybe a line break at the end of the line. So every single time I add a line, I tack on this little invisible character, \n. This won't actually appear on the line. You won't see this on the line, but we will add that on. And what that tells the text editor to do is to go to the next line. So now the next time we write something in, it will be on the next line. So if I look at this and we run this now, add Tim A and 5432. And now if you look here, it goes to the next line. Okay, so hopefully that makes sense, but there you go. I'm just going to delete everything in that file. I'm going to quit this. And now we are able to add passwords and usernames into the file. What I'm going to do now is make it so that we can view all of the passwords. So to view all of the passwords, I need to, again, open this file. So I'm going to copy this. I'm going to say with open, and then this is going to be passwords.txt A as F. I'm going to change this from A to be R because I don't want to potentially create a new file or anything like that. I just want to read the existing file. And then what I'm going to do is I'm going to loop through the lines of the file and just print them out. So I'm going to say for line in F. I'm going to say .read, and actually read lines is what I want to do. Now what read lines is going to do is just exactly what it says. It's going to take the file. Sorry, this should be F. It's going to read all of the lines for it. And then what I can do is use a for loop to get all of the lines of the file. So let's just look at this. I'm going to say print line, and let's just see what happens now if we go to view mode. And then I'll kind of walk through this more. So let's run. Master password doesn't matter. Let's say view. And then, oh, there's nothing in the file, so it didn't show us anything. Okay, so let's go add account name. Let's go Tim, password, test. And now let's say view. And then notice it shows us Tim and test, but it's printing a new line after it shows us this account name and this password. And so I'm going to show you how we can kind of fix this now. So the thing is, remember how I told you we're adding this kind of invisible \n, the carriage return. Now, when we read the file, we actually read in that carriage return. And so we need to strip this carriage return from our line. And the way we do that is we use this thing called rstrip. Now, what rstrip will do is it will strip off the carriage return from our line. So that's all you have to know, just rstrip. That's what it will do. There's also something called strip, and strip will strip off the carriage return as well. But rstrip is like more specifically exactly for this. So what I'm going to do now is run the file or run the program. Master password doesn't matter. I'm going to say view. And now notice that it's not printing that new line after we print this line because we stripped off the carriage return. Great. So now the thing is, though, I'm printing Tim pipe test. I kind of want to figure out or separate the username from the password. So how are we going to do that? Well, I'm going to say that my data is equal to line.rstrip. And then I'm actually going to split this data. So I'm going to say my user and pass is equal to, and sorry, this should be pass w is equal to data dot split at, and this is going to be a pipe operator. Now, this might seem really confusing because, again, this is a beginner project. I know a lot of you guys haven't seen this syntax before. What dot split will do is it will take a string. It will look for this character right here, and it will split this string into a bunch of different items every single time one of these characters is found. So if you had like hello, pipe, Tim, pipe, yes, pipe, to, whatever, what would happen is this data.split would actually return to you the following. It would return to you a list that says hello, Tim, yes, and 2. So it would remove all of these pipe characters, and it would give you all of the unique strings that are between these pipe characters in a list format. And so to access these different elements, you would use index 0, 1, 2, 3, so on and so forth. Now, the thing is, we know we're only ever going to have one pipe operator, right? Unless the password or the username contains a pipe operator, we're just going to assume that it doesn't contain a pipe operator just to make our life a little bit easier. If it did contain a pipe operator, there'd be some more steps we have to do. I'm not going to do them for right now. Anyways, we know we're only going to have one pipe operator, which means the list that's going to be returned to us will only have 2 elements in it. In fact, it will always have 2 elements in it. So what that means is that we can actually just grab both of those 2 elements by saying user, comma, pass w. So when you do something like user, comma, pass w, this assigns the first element in the list to user and the second element in the list to pass w. And since we know our list always has 2 elements, that means we can do this, right? Whereas if we had 3 elements, we would then have to add another variable, right? And then x would be assigned to x. Hopefully that makes sense, but that's why we can do what we're doing, and that's kind of what the split operator does. So now what I'm going to do is I'm going to print out user, colon, comma, user, and then password, comma, password, or pass w, right? So now it'll look a little bit nicer. So let's go ahead and try this. I'm going to quit this program. I'm going to rerun it. It's going to say, what is the master password? Say test. I'm going to view. So now when I view, it says user Tim, password test. And I think I should do like a separator between the user and the password. And so what I'm going to do is just add a comma like that. Okay, so now if we run this, let's quit. Let's rerun. Master password test. Would you like to add a new password? I'm going to say view. It says user Tim, comma, password test. And there you go. And we could actually even split this up with a pipe operator. I think that will look cleaner. I'm not going to run it now, but we'll do it with the pipe. Sweet. So now we're able to add passwords and we're able to view them. But the problem is I can just look at this file and I can see what the password is. And well, that's not very good. We don't really want to do that. So we need to encrypt these passwords. All right. So how do we encrypt a password? Well, this is where it gets a little bit more difficult. That's why I've kind of waited until this point to do the encryption. So you guys could at least follow along with this part, see how to write to files, read from files, all that kind of stuff there. So the way that you encrypt a password, we could write a manual encryption algorithm, but I'm not going to do that. That's a bit beyond the scope of this tutorial, is we use a module by someone way smarter than all of us who knows how to do encryption. And the way that we use this module is we need to install it. So remember at the beginning of the video, I was telling you when we imported random that, hey, there's also other modules that are built by random people, right, that we can use. But the thing is we have to install them because they're not by default installed with Python. So this is where a lot of you are probably going to have problems if you haven't done this before. But open up your terminal or your command prompt, depending on your operating system, doesn't matter which one, and just type pip install and then type cryptography, if I can spell it like that. Pip install cryptography. Just press enter and pray that this works for you. Now, if this doesn't work for you, don't worry. I'm going to show you how to fix this. But for some of you, that should have worked. If that works for you, you're good. You can kind of skip probably the next minute of this video because I'm just going to explain how to fix this. If this doesn't work for you, try the following command, okay? Pip3 install cryptography. Pip3 install cryptography, press enter, see if that works. If that doesn't work for you, try python-m pip install cryptography. If that doesn't work for you, try python3-m pip install cryptography. If none of those work for you, this means that pip is not installed on your system. Pip is actually a recursive acronym that stands for pip installs packages. And well, what it does is it installs packages for you. And by default, when you install Python, it's not included in the installation. I don't know why they don't just include it by default. You have to like check a little box to say to install it. So you could just reinstall Python and check that box that says fix pip, Or you can follow the 2 videos that I have that are linked in the description, one for Mac, one for Windows, showing you how to fix this command. Now, they're not directly called like how to fix pip. They show you how to install a module called Pygame. But when it comes to installing the Pygame thing, just instead of doing Pygame, do cryptography, okay? So you need to install this cryptography module, sorry. Once you have that installed, we're good to go. If you know what a Python interpreter is and you have multiple on your system, this is going to be a bit more complicated. You need to make sure you're using the right Python interpreter when you're running your code, the one that you install cryptography into. Okay, so at this point in time, I'm going to assume you've successfully installed cryptography. Once you've done that, what you need to do is import it. So you're going to say from, and then cryptography, like that, dot, and you're going to type this thing called Fernet. Fernet like that. And then you're going to import Fernet. Now I'm looking at a cheat sheet I have because this is not something I do very often, so I don't have this memorized. But this is a module that is going to allow you to encrypt text, essentially. Now, the first thing that we need to do when we use this is we need to define what's known as a key. So essentially what this is going to do for you, and I'm not going to talk about it too much, is it is going to take a string of text and using a key, turn it into a completely kind of random string of text that you cannot get back to the original text from without knowing the key. Now, this key is something that we're going to combine with our master password. So imagine you have this key, okay? And then we have our password. So the key plus this password is what we're going to use to encrypt our text. Now, that means that if you type in the wrong password, when you go to decrypt the text, what's going to happen is you're going to get something that makes no sense. It's not going to be the original text because you need the key plus the password to be able to get back to the original text. So it's kind of key plus password plus, text to encrypt, and then that equals like random text, okay? And then you have random text plus key plus password equals, and then text to encrypt. Now, this is obviously like a vast simplification of what's going on here, but that's kind of what we're going to do with this module. So the master password in combination with the key that we're going to store will be able to encrypt and decrypt our text. If you type in the wrong master password, you will have a wrong decrypted text, okay? So what we need to do is write 2 functions. One function that can create a key for us and one function that can store a key. So retrieve a key. So I'm going to say define write underscore key. And I'm just copying this from my sheet over here that I have on my other monitor. I'm going to say key is equal to fernet dot and then generate underscore key. I'm then going to say with open, and I'm going to say key dot key. This is a key file. And then WB, this stands for write bytes mode, as key underscore file. And then I'm going to say key underscore file dot write key. Okay. So what this is doing is going to open a file. It's going to create this file called key.key in WB mode, which means write in bytes. You don't really have to know what that means. It's just a special file format. And then you press as key file as key file, and then key file.write, and you're going to write in this key that was generated by this thing called Fernet. Okay. That's what we're using up here that we've imported. So you're going to run this function one time. And when you run this function one time, it's going to create this key file for you. So let me show you. When I just call write key here, after I input the master password, it will then create this. So let's run this and just type some random thing. And then notice here we get this key file. Okay. And inside of here, you have this key. Boom. Good. Now remove the call to write key. You can keep this function in if you want, but you don't need it anymore because you already have the key. And so what I'm going to do is I'm going to comment it out. So to do a multi-line comment in Python, you use 3 quotation marks, single or double. Just make sure they're the same on both sides. You do 3 at the start of the comment, 3 at the end. And so now I've commented out this function to make sure I don't use it again, because if I use it again, it's going to be a problem. Okay, now that we've done that, we need a function to load this key. So in a similar way, actually, I'm just going to copy this. I'm going to change this now to be load key, like that. And actually, I probably shouldn't have copied that. I'm just going to say return open, and then this is going to be key dot key, and then dot read, and the mode is going to be RB mode. Now the thing is, I need to take this here. I need to say file is equal to open. I'm then going to say file dot read. I'm going to store this in key, and then I'm going to say file dot close, just to remind you that you got to close your file every time you open it. Okay, so I'm opening the file in read/bytes mode. So it's reading bytes. I'm then going to read the file. I'm then closing the file, and then I'm returning the key. Again, you don't really have to understand exactly how this is working. This is just part of the decryption stuff. Okay, so now we have the key. So now that we have the key, what we're going to do at the top of our program here is we're going to load it. We're going to say key is equal to load_key, which means this function needs to go above where I'm calling. So this is another interesting thing. Let me copy this right key as well and put it up here. Whenever you want to use a function, it needs to be defined before you use it. So I couldn't have this function defined below this line. If I did that, that would mean that I wouldn't be able to use this function because it wasn't yet created when I tried to use it. So I got to create it first, then I can use it, obviously. Okay, so now that we have that, what I'm going to say is fur is equal to furnet. I'm going to pass key. Now, this is just initializing this kind of encryption module. So you're writing furnet, you're going to pass it the key. Okay, so actually I'm realizing I made a mistake here. I just got to take this stuff and I got to put this below the master password. So I'm going to say master password, then key equals load key, fur equals furnet key. But then I'm going to change my key to be key is equal to load key plus the master password 2 bytes. Now, you probably don't know what this means. Bytes is kind of a different way of storing information. You've probably heard of bits and bytes before, not the snack, but like in terms of computing, right? You have bit and then you have bytes. And well, regardless, we have our key in bytes. And so we need to convert our master password into bytes so that this works, so we can add this together. Now, just like when you add 2 strings together, that's exactly what's happening here. We're taking the key, which is in this file, and we're just adding this master password in its bytes format to this key and then using that as the actual key. Okay, hopefully that's clear. That's like a lot of the hard stuff. Now encrypting stuff is really easy. So what I'm going to do now is when I go ahead and write my password, I'm going to first convert this password into its encrypted version. So I'm going to say fur dot and then encrypt, and I'm just going to surround my password with that. But first I need to encode my password. Now, the reason I need to encode this is because encoding my password will convert this into bytes. And actually I'm realizing here that this is going to be better. I'm going to say master password dot encode rather than dot bytes. Again, all encode does is it takes your string, turns it into bytes. And so same thing here. I'm taking my password, I'm turning it into bytes with dot encode, and then I'm encrypting it, and I'm going to store that beside the name. And I also realize that now I need to convert this to a string. So I'm going to say string fur.encrypt pwd.encode, and this will now encrypt and encode our password. Okay. So now when we store these passwords, they should be stored in an encrypted format. So now the thing is we need to decrypt them when we show them. So to do that is going to be literally the exact same thing we just had here. So I'm going to copy this, except instead of encrypt, it's going to be decrypt. Okay, so we're going to say decrypt like that. And then instead of pwd, this is going to be pass w. Okay, so I'm hoping this is going to work. I have a feeling it's not. I think I made a small mistake here, but we'll worry about that when we get to it. Okay, so now we should hopefully be storing encrypted information and reading non-encrypted information. So let me go in passwords and let me delete this because that is not encrypted. And so that's going to give us a problem right now. And let's go here and let me rerun this app. Okay, what is the master password? We now need to pick the master password that we want to use to encrypt our data. So I'm just going to make mine Tim, make yours whatever you want. Would you like to add a new password? Yes, want to add. Account name, we're going to say maybe just like Facebook. Password, we'll say Tim is great. Okay, would you like to add a new password or view an existing one? I'm going to say view, and then we get a problem. It says invalid token. Okay, so let me have a look here and see what's wrong. But if we go to passwords.txt, you can see that we are storing this in the file. And now I've actually already determined what's wrong, but let me just collect my thoughts and I'll be right back. So I've realized the problem here, and it is that we are writing in this B, what is it? I guess this is a quotation mark, and then another quotation mark here. And we can't be doing that. So I'm actually going to clear this file. So the thing here in Python, and this is, I guess I can teach you about bytes now. When you write a B and then you have something after this, like I say B and then hello, this is a bytes string. This is different than the string hello. When you have this little B before it, this means bytes. So the thing is we were writing in this little B and we don't want to do that because when we do that, that means when we try to decrypt this, it's all wrong because we have this B and this quotation mark and well, it's just incorrect. We can't be writing that into the file. And so what I did before is you saw I had a string surrounding this in our add file. We can't have that. Instead of having a string, we need to decode this. So I forgot that we have this thing called decode. It's the opposite of encode. It's going to take a bytes string and decode it to a regular string. So now if we decode this, all should be good. And same thing here. I had a, what do you call it? String like that. And that's no good. I couldn't do that. Instead, I just have to have fur.decrypt and then pass w.encode. So I'm going to take the string in because I'm writing in a string that's not bytes. It's just a string. And then what I'm going to do is convert that string into bytes and then decode that byte string, and then that should work. So now let's see if this works. I'm going to rerun the program. Apologize about that mistake. I'm going to say, what is the master password? We're going to go Tim. Would you like to add? I'm going to say add account name. Let's just go Joe, password 1234567. Okay. Now I'm going to say view. When I say view, it gives me user Joe, password B, and then 1234567. So it's showing me this bytes thing. If I want to remove this bytes thing, I need to decode this. So I'm going to decode like that. And now if I quit here and I rerun and I type in the master password, which is Tim, and I press view or type view, none type object has no attribute decode. Okay, what is the problem here? I was printing out this. Oh, sorry guys. I added the dot decode at the end of the print statement, not at the end of this fur thing. So I had it like after this bracket, it needs to be after this second closing bracket. So let me rerun this. Let me type in Tim. Let me type in view. And now notice it gives me the correct password, 1234567. However, if I go to passwords.txt, you can't see the correct password, right? It's storing this like random string of gibberish that really like means absolutely nothing. And so if I actually quit this, let me just clear the screen and rerun. Let's go to password manager. Let's go to run. And I type in the incorrect password. I'll just type Tim2. And I type view. Notice it still gives me the correct password. Okay. It's interesting that that's giving me the correct password. It shouldn't be giving me the correct password. So let me look at this for a second. Okay, so I'm going to apologize here because I made a mistake. I thought that we were going to be able to use a master password in combination with our key and just do some kind of like hackish manipulation to get this to work. Unfortunately, it looks like doing that's way more complicated than I thought. I just was looking on the internet right now. In fact, I'll bring up the documentation that I found. So we're using this thing called Furnet, right? And there's a way to use passwords with Furnet, but I mean, you guys can kind of read this here. It's a little bit complicated, and I don't really want to put you guys through all of this because this is just a beginner project. So I will leave a link to this documentation in the description if you'd like to have a look at how to do this. But for now, I think I'm going to end the video here. So I'm just going to remove this master password feature. Obviously, that's pretty important, right? Like you would want to have a master password. So I really do apologize about that. But if you do this now and you just use the key as you used it before, everything will still work. So right now, if you run the program and I'll show you, and we don't have a master password, says, would you like to add a password to view? If I type view, it gives me the correct passwords, right? Even though we use technically a different key that had the addition of our master password to kind of encrypt them previously, this still works. So anyways, that is where I'm going to leave it. Again, I'll leave a link to that documentation that shows you how to implement the master password in the description. Just too complicated for me to feel comfortable going through it in this kind of beginner tutorial. So we want to build Pig. Now, first we need to understand what this project is. So how does Pig work? Well, it is a multiplayer game, first of all. Everyone plays a little bit different, but the way that I play is that you essentially get a turn. So it comes your turn and you get to roll the die. When you roll the die, you're going to get some number from 1 to 6. If you get anything other than 1, you take that and you add that to the score of your turn. So let's say you get a 5, now you're at 5. Roll it again, you get another 5, you're at 10, and you can decide how many times you want to roll the dice. Now the catch is, as soon as you hit a 1, whatever you got on your roll is going to be done. Whatever you got on your turn is 0. Like you completely remove the score. So you can roll 5 times, 3 times, 4 times, 10 times, 20 times, as much as you want, but every additional roll, you're gambling the possibility of losing your score. So you need to decide when you want to stop. As soon as you stop, whatever your current score is, assuming it's not 0, is going to get added to your total score, and then you can determine the number of total rolls you want to have, or it's whoever reaches like 100 first or 50 first, whatever you want to do. In our case, we'll say like the max score is something like 50. Whoever hits 50 first is just the winner of the game. Okay, so how are we going to build this out? Well, let's break down the individual things that we need to do. First, we need to allow the user to roll the dice. This means we need to come up with a way to roll, so we have to have some random number generator giving us a number between 1 and 6. We then need to ask the user if they want to continue to roll, so either roll again or stop their turn. If they stop their turn, we need to take whatever their score is and add that to some total score. Then we need to constantly check if either player has a score that is above 50. If it is above 50, then we need to end the game and tell someone that they won. There's a few other things that are involved, but those are the basic steps. Let's start by generating a random number. So what I'm going to do is import the random module. Now, random allows you to generate random numbers. What I'm going to do is just define a roll function. Now, a function in Python is a reusable block of code. You make it using def, standing for define. You then put the name of the function and then a set of parentheses. We're then going to put inside of here in an indented block after a colon. So notice I'm kind of one tab over any code we want to run whenever we call the function. So what I'll do here is I'll say min value is equal to 1, max value is equal to 6, and then I'm going to roll the die in between them. Now, there's a few different ways to do this with the random module, but I believe we can say roll is equal to, and this is going to be random.rand, and then int like that. And then this is going to be the min value and the maximum value of our die. Then we're simply going to return roll. Now, the way the return keyword works is it's going to give whoever called the function this value kind of back. It's going to return it to them. So if I come down here and I say value is equal to roll, the way I call the function is I use my set of parentheses, and then I can simply print out the value here. And you'll see that if I bring my terminal up and we run the code, we get the value 3. We can run it again. We're getting 6, 3, 6, 5, 5, 5, 2. Let's see if we can get a 1. Okay, it looks like it really doesn't want to give us a 1. This would have been a fantastic turn. Okay, and there you go. We got a 1, so that would have ended our turn. All right. There you go. That is how we generate a random roll. Okay, so now that we have that, we want to kind of set up the game, and we might begin by asking how many players are going to be participating. And then we can keep track of all of the different players. Maybe we set it to, say, a maximum of 4 or something like that. So let's go down here. I'm just going to zoom out a little bit, and let's set up a while loop. What we say, actually not while loop, we're going to say input. So we'll say players is equal to input. And we're going to say enter the number of players, and we'll say kind of 1 to 4, like that. And then notice I'm putting a space here at the end, just so we have a little bit of padding between where the user is going to give us the answer. So the idea is we're going to ask the user, okay, give us some value between 1 to 4. Then what we need to do is we need to check if this is a valid number. So I'm actually going to kind of put a while loop here, and I'm going to say while true, and then I'm going to put this inside. The reason for this is I want to continue to ask the user to input a number until they give me one that's valid. So I say while true, and then I'm going to break out if they give me a valid number. So I'm going to say try, or actually, we can do the following. We can say if players dot is digit. Now, is digit is going to tell us if this is a digit or not. So if it's a number, if it's a valid whole number specifically is what it will give us. So I'm going to say if players is digit, I'm going to say players is equal to int, and then players. Now, what this does is convert what's going to be a string here into an integer. And the reason I need to check if it's a number first is because if I try to convert a string into an integer and it's not a valid integer, it's going to give me an error. So I don't want to crash the program. So I'm saying, okay, if this is actually a valid number, let's convert it into that number. The reason I need to do that is I now need to check if this number is greater than 1 and less than 4. If it is, I can then break out of this while loop because I have a valid number of players. Otherwise, I need to continue to keep asking them to enter a valid player. So I'm going to say if 1 less than or equal to players less than or equal to 4, okay, then I will simply break. What the break keyword will do is immediately exit outside of this while loop, meaning we'll have access to the players variable down here, and we can just print out what the number of players is. If we don't encounter this break keyword, we will continue to ask the user until they give us a valid number of players. Now, we could give them some output and say something like print invalid, try again, and we could do something here where we say something like print must be between 1 to 4 players. And actually, it can't even be a 1, it has to be 2, right? So we'll have 2 to 4 like that, and we'll put a 2, and we'll put a 2 because we need to have at least 2 players to be able to play the game. All right, so let's try this out. Let's run our code, enter the number of players. Let's enter 1. It says we need to do it again. Okay, so it didn't actually print anything out. I don't know why that happened. Oh, sorry. It's because, okay, I'll fix that in 1 second. That's an error. Anyways, we enter 2. It says must be between 2 to 4 players, which is a mistake, and then 2. So notice I made a bit of an error because I put this inside of the if statement when I wanted to put an else statement here and then put this here. Because if this is valid, we break, which means we exit the while loop. Otherwise, we tell them, okay, that was the error. So we just need to make that quick fix there with the if statement. Okay, in case you're confused, by the way, if statement checks if something is true. If it is, we kind of enter in this indented block, which happens after the colon. Otherwise, we have this else statement, which will trigger if the if statement is false, okay? So I'm going to clear and run, and let's go 1. Okay, must be between 2 and 4. Let's go 5. Let's go hello. Let's go 3, and we're good to go. Okay, so now we have the number of players, and what we want to do is essentially simulate each player's turn, where we ask them, you know, do you want to roll the dice? Yes or no? They tell us yes or no, they roll, and then we start kind of calculating their score. So let's do this. First of all, let's make some variables here. And let's say our max score is equal to, and then we can do something like, we'll go with maybe, yeah, let's go with 50 for now. We'd probably want to make that larger, but just kind of for the sake of time when we're testing this, we'll make it small. Then we want to have our player underscore scores. And what we'll do for our player scores is we'll just have a list which contains all of the individual scores. Now, we don't know if we're going to have 2 players, 3 players, or 4 players, so we're going to have this list kind of change size based on the number of players that we have. Now, the way that we can kind of create or initialize this list based on the number of players is we can say 0, 4, underscore, in, and then something like this, in range, the len of players. Now, what this is actually a list comprehension. I was thinking of the name there. What this does is it essentially puts a 0 inside of the list for every single player that we have. So what I'm doing is saying 4 underscore. Now, I could put I here, but the thing is I don't actually care about what the variable is. I just want to do this the number of player times. So I can put an underscore essentially saying, hey, I don't really care what the variable is. So like, you know, we need to have something there, but I'm just going to put an underscore because I don't really want to use this. And then I'm going to say in range, the len of players. So what this range function will do is loop the number of players, or the length of, actually, sorry, we don't need len, just players here. It will loop the number of players times that we have. Notice that our players is going to be an int, right? So if it's 3, this will happen 3 times. If it's 4, it will happen 4 times, etc. Ignore the len that I had there. I don't know why I put that there. Just a silly mistake. Okay. So now we can print out our player scores, and you'll see that we'll get an array filled with zeros based on the number of players that we have. So if we do 3, it gives us 3 zeros. If we run it again, 4, we get 4 zeros. So now we are able to store each of our players' scores inside of this array. Fantastic. Okay, now we need to go through our player turns. So we're essentially going to say, while the maximum of our player scores is less than the max score, then we'll keep looping. Now, what max will do is give us the maximum value from this array, or from this list. So if it's 23, it gives us 23. If it's 55, it gives us that. And we're saying, okay, as long as it's less than the maximum score, it means no one's reached the max, so we'll keep going. As soon as someone does reach the maximum score, we need to stop and then tell the user whatever the, tell the players, whoever kind of won the game. All right. How are we going to do this? Well, let's go here, and we will say, first of all, roll, we'll say should underscore roll is equal to input. And we'll say, would you like to roll, question mark? And we're just going to put here a y, which means we want the user to input the key y. So then we can come here and we can say if should roll dot lower is equal to y. The reason I'm converting this to lowercase, which is what dot lower does, is because if they enter a capital Y, I still want them to roll, right? So this is just checking, is it capital or lowercase? Doesn't matter. We're going to convert it to lowercase and then check if it's equal to the lowercase y. If it is, then we're going to roll the dice for them. So we're going to say roll is equal to, and actually I can't use roll because that's the name of my function. So I'm going to say value is equal to roll. Okay. Otherwise, I'm simply going to break. And actually, a better way to do this that's going to be a little bit cleaner for me is I'm going to say if should roll.lower does not equal y, then I will break out. Otherwise, I will say my value is equal to the roll. So the reason I'm doing this is because I want to have all my code kind of not indented if I don't have to have it indented. So I'm saying, okay, if you didn't hit Y, then that means we're just going to stop your turn. Otherwise, we're going to roll the dice. Now, there's a lot more code we're going to need to write, but I'm just kind of going through this, as I normally would, and then we'll kind of stop and fix things as we need to. So we're going to grab that roll, and we're going to check if that roll is equal to 1. If it is equal to 1, then whatever the player's current score is just going to become 0, and we're going to move to the next person's turn. Now, we still need to simulate the turns and all of that, which we'll do in a minute. But for now, just kind of bear with me. So we're going to say if value is equal to 0, then we can simply say print, or sorry, not 0. We're going to say you rolled a 1, turn done, exclamation point. Otherwise, we'll print you rolled a, and then whatever the roll is. So we can say something like, actually, value, like that. Okay, so let's put a colon. You rolled, and then whatever the value is. All right, so now that we have this and we're kind of printing out what they rolled, I'm just going to go up here and I'm going to mark the current score equal to 0 because we need something to keep track of what the player's score is. Now, if they didn't roll a 1, then what I'm going to do is I'm going to say the current score plus equals whatever the value of the die was. I'm going to tell them what they rolled, and then down here, I'm just going to print your current, or your score is, and then we'll print out whatever the current score is, and then we'll kind of continue. Now, here, I'm just going to break this because the idea is, all right, well, if you rolled a 1, your turn's done, so we're going to break out. All right, so this kind of simulates one person's turn, but again, we haven't really kind of handled the fact that we have multiple people going at once and allowing someone's turn to continue multiple times. So what we actually need to do is we need to use a for loop here. What we'll do is we'll put a for loop kind of right here, and we'll say for I in range players. So I is going to represent the current player. So we'll say player underscore index or player IDX. So player 0, 1, 2, 3, or player 1, 2, 3, 4, whatever you want to call it. And in this for loop, we'll then simulate one person's entire turn. So we'll mark the current score, but then all of the stuff that's going on here needs to happen until the player stops their turn. So what we'll do is we'll have a while loop, and we'll say while true, and then we'll put all of this here. Then outside of the while loop, we're going to say that the player underscore scores at index player IDX is going to be plus equal to whatever their current score is. So like the current score is kind of the score per turn, and then the total score is what we're going to be adding to after they finish their turn. So what we'll do after we add that is we'll say print your total score is colon, and then we will say that this is going to be the player scores at the player IDX. Okay. We'll go through this again in 1 second, but for now, we're making good progress on the turns. All right, so I'm just reading through this. It's looking okay. However, I'm realizing that if the value is 1, then we're going to have to set the current score equal to 0, just so that we make sure we don't add what their score was before they rolled a 1. All right, so let's kind of run through this here. We have our for loop. We say for player index in range players, which means we're looping over all of our different players so they each get a turn. We probably want to print out something like player, and then let's say player IDX plus 1 turn has just started, just so they know that it's now their turn. And what I'm going to do is print a \n right here and a \n. What this is going to do is just add a line break so that we have a bit of separation when the player's turn starts. So we say, okay, player, and then we're doing plus 1 because this is going to be 0, 1, 2, 3. But we probably want to show 1, 2, 3, 4, so that's what we're showing. So we say player, whatever it is, turn has just started. We could say player number turn has just started. Okay, we set the current score equal to 0 for the turn. We simulate the turn. We ask them if they'd like to roll. If they say yes, or if they don't say yes, sorry, we break out. Otherwise, we roll. If they get a 1, we say they rolled a 1, their turn is done, their current score is 0, we break out. Otherwise, we take whatever the current score is and we add to that the value that they rolled because it wasn't a 1, and then we continue this whole process again. So we tell them this is what you rolled, and then we say your current score is this, which is going to be the sum of what they rolled plus, what their current score is, okay? Then eventually we're going to get outside of this while loop when they roll 1 or when they tell us that they don't want to roll anymore. We're going to take that score, add that to their total score, and then print that out. Now, we're not quite finished, but this will simulate most of the game so far. All we really need to do is determine when someone wins. So let's zoom out a bit, just so we can kind of read most of what we have here. We have our roll function. We ask the player, or we ask to input the number of players we want. We have the maximum score, generate kind of an empty list for storing the scores, and then we have this code which is going to simulate the turns. Let's run this and see what we get here. Okay, so let's zoom in a bit. Enter the number of players. Let's go with 2. Player number 1 turn has started. Okay, would you like to roll? Yes. You rolled a 6. Your score is 6. Would you like to roll? Yes. You rolled a 4. Your score is 10. Would you like to roll? Okay, yes. Let's keep rolling. Yes. Yes, yes, yes. I'm trying to get a 1 here. And it says you rolled a 1. Your turn is done. Your total score is 0. Player 2's turn has started. Would you like to roll? Yes. 5. Okay, let's roll again. And we rolled a 1. All right. And you'll see that we can continue this, right? So I'm going to try to get a pretty high score, although this isn't working too well for me. Okay, let's stop rolling there. Now our total score is 15. Player 2's turn. Okay, yes, yes, yes. Yes, yes. Really gambling here. Okay, let's stop the roll. Okay, yes. Rolled a 6. Your score is 6. Yes, 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 yes. No. Okay, total score 42. Let's roll, 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 roll. And no, your total score is 51. And then notice the program ends here because all of the players' turns have finished and someone had a score of 51. So we end. We should really be telling them, that you won, which is what we're going to do now. But that kind of simulates the program. There's a few things we'd probably want to do to make this a bit better. For example, at the beginning of the turn, we should probably tell them what their score is so that they know that before they go into the turn so they can stop, once they hit what the max score is. Okay, so let's do this. We're going to say player 1's turn has just started. And then we're going to print here. Your total score is colon, and then the player scores at the player IDX. Okay, and then we're going to begin the turn. So we can actually just remove that \n, and we'll just put one right here, just so that we kind of go one line down. Okay, do all of this. And then as soon as this ends, what that tells us is that at least one player has a score above 50. Now, multiple players can have a score above 50, and the reason this works is as soon as someone hits 50, we don't end until every player gets a turn. The reason why that's fair is because whoever goes first would have an advantage. So in this case, we let everyone have at least that last roll, and then we see whoever has the max score after the last roll. So what we can do now is we can just find what that maximum score is. We can actually get the index of that score inside of our player scores, and that will tell us which player won. So the way we do this is we simply say max score is equal to the max of our player scores. And then we're going to say player winning IDX is equal to, or actually we can just say winning IDX is equal to the player scores dot index, and we can index the maximum score. What that does is give us the index, so either 0, 1, 2, or 3 of where that maximum score is, which tells us player 0, player 1, player 2, etc. So then we can just print player, comma, winning index plus 1. So we'll say player number, and the reason we're adding 1 is because, again, we're going to start at 0. So we want to make sure we're going from 1 to 4, not 0 to 3. And then we'll say is the winner with a score of colon, and then what the maximum score was. Okay, so that should wrap up the game. Let's give this one last run here. Okay, enter the number of players. Let's go with 2. Player number 1's turn has just started. Your total score is 0. Would you like to roll? Yes. Roll to 5. Let's roll again. Roll again. Roll again. And no. Okay, 16. Would you like to roll? Yes. Okay, that ended fast. You like to roll? Yes. 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 No. Okay, and total score is 0. Would you like to roll? Yes, 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 yes. Okay, yes, yes, and no. Okay, now it's player 2's turn, so let's roll. Yes, okay, that ended fast. Yes, okay, now we have the max score, so let's say no. Player 2 still gets a turn, even though we now have a score of 51. I'm just going to say no, and it says player number 1 is the winner with a score of 51. Okay, so that completes that first project. All of this code will be available from the link in the description, by the way, in case you want to download this. But I'll kind of scroll through it quickly so you can get a sense of how we wrote this. That was project 1. Hopefully you found that interesting and useful. Now let's move on to project number 2. All right, for project number 2, we're going to do that Mad Libs generator. The idea is we'll have some type of story. This story will have replaceable words, like an adjective, or a location, or a weather condition, whatever it may be. What we'll then do is we'll ask the user to give us all of the different words. We'll then inject them in the story, and then read the story back out to the user. Now, the first thing we're going to need for this is a story. So the process, as I kind of described there, is have a story with those injectable words, essentially grab what those words are, ask the user to input them, and then place them in the story. Now, I'm going to show you that there's a lot easier way to do what I'm about to do, or I'm going to mention there's a lot easier way to do what I'm going to do, but I want to show you a way that we can do it with any story. So that means that you can make this program really dynamic, and you could have like 20 stories, 50 stories, 100 stories, or you can just replace them without having to write any additional code. The way we're going to do that is by taking the story and placing it inside of a text file. That way, as long as the story is written in a specific format, we can read in the story, do the operations we need to, and then kind of run the program as we see fit. Now, what I always do whenever I need something like this is I don't write it from scratch because I'm a lazy programmer. I go to ChatGPT. So what I actually did here is I asked it using this prompt. I'm making a Mad Libs generator in Python. Let's make this full screen. I'm going to need a story where the user can give me some words. Can you give me the story, even though I spelled that correctly, and for all of the words where the user needs to give them to me, make them like this, angle bracket word. Now, it gave me a nice long story, and it had all the different words, and it kind of listed them all out. That was a bit long for me, so I said, that's okay, but can you make it in less words, please? And then it gave me kind of a shorter story. So the idea here is that whenever we have these angle brackets, we're going to kind of treat that as a word that needs to be replaced. So what we'll do is we'll take this story from ChatGPT, so I'm just going to copy this on my clipboard. We'll put it in a text file. We'll load that story in. For all of those individual words, we'll then kind of grab them, figure out what they are, ask the user to give us a word for them, and then replace them in the story. All right, how do we want to do this? Well, the way I will do this is I will copy that first of all, and I will go here to VS Code, and I will make a file called story.txt, and then I will paste that inside of here. Now, make sure when you do this that you put your story in the same directory where your Python file is. So here I have project2.py, and then I have story.txt in the same directory. Very important that you do that, otherwise this isn't going to work for you, okay? And if you want this story, you can go click the link in the description and just download the story from GitHub. I'll make it available for you after. Okay, so how do we do this? First thing we need to do is load this in. Now, I want to load this in as a string, essentially, and then be able to kind of parse through that string and look for all of those different words. Now, there's a few ways to do this, but the way I will do this is I will say with open, and I'm going to open story.txt in read mode as f, and then I'm going to put a colon. Now, what I've done here is I've used the open function, and the open function allows me to open a file. So I can open a text file, a JSON file, really any type of file I want. And the mode here, which is what I've placed second, is the way in which we're kind of reading it in. So I'm going to read it in read mode, which is R mode. If I put W, this stands for write mode, where we'd actually be creating a new file and overriding a file if it already existed with the same name. So we don't want to use W mode, we want to use R mode. This now allows me to read this story.txt file in. And the reason I'm using this with syntax is what this does is provide something known as a context for this file, which means I can do any file operations on this variable f inside of this indented block. And as soon as I get outside of that indented block, Python is automatically going to clean up the file for me, which means it will close it and make sure everything's good with the file. It's kind of best practice in terms of opening files here. So what I'm going to do is say my story is equal to f.read. Now, when I do .read, all this does is give me all of the text inside of the file. So I can simply print out story here, and you'll see if I run this, that I get my story appearing here in my terminal. Okay, so now that we've read that in, what I would like to do is look for all of the words in my story. Now, there's a bunch of different ways to do this, but essentially what we need to do is find the presence of this angle bracket. As soon as we find that, we want to find up to this closing bracket, right? So we want to find every individual word, take that word, store that in some kind of list that we're going to have access to, ask the user to give us a word to replace it with, and then go and replace all of the instances of this word with whatever the user told us. Okay, so let's do that. What we want to do is loop through our story. Now, our string, we can actually access all of the individual characters as an index. So what I can do, let's zoom in here, is say for I, comma, character, in enumerate, and we're going to enumerate the story. Now, what enumerate does is give us access to the position as well as the element at that position, just makes it a little bit cleaner for us here. So now I'm just going to check, essentially, if this is equal to an angle bracket. If it is equal to an angle bracket, then I kind of need to do something to mark the fact that I found the start of a word, and then I need to go until I find the end of it. So we're going to set up a few variables here, and we're going to say words is equal to this, because we want to store what all of these different words are. And then what should we do here? We should say start of word is equal to -1. Okay, so we're going to have this variable, and this variable is pretty much going to tell us if we've currently found the starting index of a word. If we have, that means we can then look for the end. If we haven't, then we're going to wait until we find that starting index. So what we'll do here is we'll say if char is equal to, and I'm going to make another variable. I'm going to call this target underscore start. This is going to be equal to the open angle bracket. I'm going to have my target end equal to the closing angle bracket, just so that if we were to change the format of the story, we could easily adjust this by changing the value of the variables. So I'm going to say if the char is equal to the target start, then what I'll do is I'll say the start of the word is equal to index I. So if I found that opening angle bracket, okay, we just found the beginning of the word. Let's mark that by indicating that in our variable. Now what we'll do is we'll say if the char is equal to the target end and the start of word does not equal -1. The reason why we're doing this is we're saying if we found the ending angle bracket and we had the starting angle bracket, right, which will be marked by the start of word variable, which if it's equal to -1 means we haven't yet found the beginning. If it's equal to anything else, that means we did find the beginning. Then we can take that entire word and add that to our words list. So what we'll do now is we'll say word is equal to, and this is going to be story at index start of word up to the index I plus 1. Now what this gives us access to is a slice, which is a subsection of the string. So this is the slice operator here in Python, where we indicate the starting character, so the character we want to begin taking a slice from, and then the ending character that we're going to go up to, but not including, or the ending index. So in this case, we know the start of the word, so we put that here. And we know the end of the word because that's the current index that we're on that we just found, but we need to add 1 to it to make sure that we include this ending index in our word. So we're going to grab that. We're going to put that inside of our word variable, sorry. We're going to say words.append word, which means we're going to now add this word into our words list. And then we're going to set our start of word equal to -1 because we've now found one whole word. So now we reset the start of word so we're ready to handle it for the next character that we find, which is that opening angle bracket. So this code here will actually find all of the different words for us in the story. So let's test this by printing our words. Okay, let's run the code. And I think my terminal is a little bit cut off, but you can see that we get all of the different words. Now, what you might notice here is that we have duplicated words. Now, the reason we have duplicated words is because this word could appear multiple different times. Now, that's fine if it does, but I only want to have the words that are unique. Now, the way that we can essentially do this is we can change from using a list, and instead we can use a set. Now, a set is a data structure which will only contain unique elements. So if I add the same element in, it's not going to do anything. We just have one instance of each unique element. The way to do that is just to write set here instead of a list. And then rather than append, we're just going to say add. Now, add will just add this to the set. And you'll see now that when we run this, we'll just get all of the different unique words. Perfect. Okay. Now that we have those words, what we want to do is ask the user to give us a value for each of the words. So the way we'll do this is we'll set up a dictionary. So we're going to say answers is equal to a dictionary. The idea is we want to have the word as the key. So something like name. And then the value in our dictionary will be whatever answer they gave us. So something like Tim. The reason we'll do this is so we can very easily look up the value of a word. So we say name, Tim, blah, 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 okay? And then what we'll do is we'll take whatever these values are and replace them in our story later on. The way the dictionary works is you add a key by doing something like this. Answers key is equal to, and then whatever the value you want. And you can access the key by just using the square bracket syntax like this. Okay, so we have our answers. This is going to be an empty dictionary. What we'll now do is we'll loop through all of the unique words that we have, and we'll ask the user to give us a value for them. So we're going to say for word in words, iterating through our set, and we're going to say answer is equal to input, enter a word for, and then we're going to do plus, and then whatever the word is. Now, notice we can't do a comma here because we're using the input statement, not the print statement. So we need to concatenate, which means add two strings together. So we take the word, add it to enter a word for, and then we can just put here a colon with a space at the end so that the user knows where to start writing. Okay, so that gives us an answer. We're then going to say answers at word is equal to answer. And let's spell answers correctly. Okay. That will now create a dictionary that has all of the words associated with all of the values. So let's now print out answers. Okay, so let's come here. It says enter a word for object. Let's go something like chair, weather condition, sunny, adverb, I don't know. Let's see, gently, place, school, emotion 2, sad, animal, bear, place 2, I don't know, house, terrain, what is this, grass, okay, character, Tim, adjective 1, jumps, emotion, happy, and there you go. It gives us now all of the different words and their answers. Now that we have that, we can take every single instance of these words and essentially kind of replace them in the story. So now we're going to have another for loop, and we're going to say for word in words. Now, the great thing in Python is that we have this method called replace all, or replace. I don't know which one it is. I think it's replace all. Either way, what this is going to do is replace every single instance of one string with another. So that's super convenient for us because we know the string we want to look at, which is that kind of angle bracket, and we want to replace that with our answer. So now what we'll do is we'll simply say story.replace. I think this replaces all instances of it. We're going to check that in 1 second. And we're going to replace our word, which is that angle bracket string, with the answers of our word. And then we can just print out our story and we'll be good. We'll have the entire program finished. So let me quickly run through the code and then I'll show you how this works. So we open up our story.txt. We read this in. We create a set of all of our unique words. We then say the start of the word is equal to -1. We have our target kind of opening bracket, target closing bracket. And this first block of code here goes and locates all of the different words that are inside of our story. So we say for I, character, and enumerate story, getting the index as well as the value. We say if the character is equal to that starting kind of open angle bracket, let's mark that by saying the start of word is equal to I. Then down here, if we found the ending bracket and we had the start of a word, we've just found the end of the word. So now what we can do is grab that word using our slice syntax, add that to our set, and then reset start of word. Then we have all of our words, so we need to generate an answer for them, which we ask the user to do. And then we simply go through and replace all of the instances of our word with the answer the user gave us. Awesome. Let's give this a shot. Let's make this full screen and run. Animal, bear, adverb, gently, character, Tim. I probably should do lowercase for it, but that's fine. Weather condition, sunny, terrain, grass, place, school, adjective 1, I don't know, throw, emotion 2, sad, place 2. Let's go with soccer field, emotion, happy, object, chair. Okay. And unfortunately, it seems as though this actually didn't work. So I'm going to have to look at what the problem was here. I already know what the issue is. So I said story.replace. However, what this does is this gives me a new string. So what I was doing is I was just kind of generating a string that I wasn't storing anywhere. So story didn't change. This gives me a new string. So what I actually need to do here is say story is equal to, and then story.replace, and then do this. Now, there's more efficient ways to go about doing this, but this will be perfectly fine for our purposes. So if we fix this up now, and let's save that. So again, just we kind of are now changing the story every time by updating that variable. What I'll do is run this again. Emotion, sad, adjective, throw, character, Tim, place, school, terrain, grass, place 2, soccer field, object, chair, adverb, gently, emotion, sad, animal, bear, weather condition, sunny. Okay. In the throw land of school. Oh, adjective. Okay, I probably used the wrong thing for an adjective there. Anyways, in the throw land of school, a bear was feeling sad. The bear had lost its chair. Suddenly, a Tim appeared. I will help you find the chair, they said. Together, they journeyed through grass and faced the sunny. Okay, I probably should have said like raining or something. Finally, they found the chair in a soccer field. The bear was so sad and thanked the Tim. They lived gently ever after. All right, you know what? That's not so bad. I think there was a few words that I probably messed up writing, but there we go. We get the story, and yeah, there you are. Now, if you wanted to, you could store that in a text file, but I think that pretty much wraps up this project. That was pretty cool, and obviously, if you kind of change the story around, give some better words, you could get some pretty interesting results there. Regardless, hope you guys enjoyed. Let's move to the next project. All right, so let's get into project 3. Now, the idea for project 3 is we want to randomly generate a bunch of different math questions, ask the user those questions, and then not let them continue until they get it correct. We'll then time how long it takes them to answer all of the questions. So the first thing we need to do is be able to randomly generate these problems. Now, there's a bunch of different parameters we can use, right? We have a set of operators we can use. It's like plus, minus, addition, multiplication. We could even use exponent and stuff if we wanted to. And then we have kind of the max values as the operands, like the min, max value, etc. So what I'm going to do is write a few variables that we'll use as constants that we can change that will make this either easier or harder depending on what you want to do. Now, first of all, we're going to need random because we're going to be randomly generating operands. Then we're going to need the operators. So I'm actually going to do this in all capitals. I'm going to say operators is equal to this. And then I'm going to say min operand and max operand. Okay. We'll say for the min, maybe we have a min value of 3. And for the max, we'll go something like 12. For the operators, I'm going to use a string. And I'm going to put in Python operators. Okay. It's important that these are ones that could actually be used in Python, because I'm going to show you the way that we'll actually figure out what the answer is. This is not going to be that long of a project, but it'll show you a cool function that you might not have seen before in Python. So what we're going to do is write a function called generate problem. Okay. Now what this is going to do is generate a problem for us that uses one of these operators and then a random operand on the left and right side. So we're going to say left is equal to random.randint, and this is going to be the min operand and the max operand. We're then going to say right is equal to random.randint, and again, the min operand and the max operand. Now I'm actually going to remove division because I'm realizing that the way I'm going to write this is not going to work too well with division. We need like a separate set of parameters. So for now, we'll just use these 3 operations, which I think is fine. Okay, we're then going to randomly select an operator. So we're going to say operator is equal to random. And there's actually this function called choice. What this does is just randomly pick one of the elements from a list. So I can say random.choice operators, and that'll just give me randomly one of these. Then I'm going to say my expression, which is XPR or EXPR here, is going to be equal to the left plus the right plus the operator. However, I need my left to be a string and I need my right to be a string. Okay. So this is going to give us the expression, which will be the left-hand side plus the right-hand side. And what we'll actually do is we'll just add a space in between here so I can print this out and you can just see kind of what it looks like. So let's add a space like that. Okay, so now let's call generate problem, and let's just print out the expression and then return it just so we can see what that is. Okay, so clear and Python project 3, and I got an error, can only concatenate string, not int to string. Okay, sorry, that's because I put this in the wrong order. So operand, or operator, sorry, plus the right. Okay. So let's fix this and run again. And we get 12 plus 9. Let's run a few more times. And you can see we're kind of getting random operands and random values. Sweet. All right. That's working. Now the question becomes, okay, we randomly generated this, but we need to know what the answer is, right? Since we're randomly generating it, it becomes a bit more difficult to calculate the answer. Now, what we could do is just use a bunch of if statements, right? And I can say if the operand is plus, add them together. If it's minus, subtract them. If it's multiplication, multiply them. That's fine. However, I want to make this a bit more dynamic such that we can kind of make this a bit larger and we don't have to do all those if statements. Now, the way to do that is we can actually do this. We can say answer is equal to a function called eval. Now, what eval does is evaluate a string as if it was a Python expression. Now, notice we have an expression that is valid Python code. Like 6 minus 12 is valid code that we can evaluate. So all I have to do is put this expression inside of the evaluation, and it actually just tells me what the answer is. So now what I can do is I can return my expression and the answer like that. And if I go here and say expr answer is equal to that, I can print them out. So I can print the expression, excuse me there, sorry, but I can print the expression and the answer, and it will tell me what it is. So I'm just showing you how we can kind of avoid having like, if it's this, do this, otherwise do this. That's fine, that's valid to evaluate it that way, but we can use this eval function. So if I run this, I get 7 minus 3, that's 4, right? 12 minus 4, 8, 10 plus 5, 15. So I figured you guys would find this eval function kind of cool. Hence why I wanted to show it to you. All right, so that is our generate problem, and that's really most of the coding done. What we need to do now is determine the total number of problems. We then essentially need to set the timer when the user begins, and we need to ask them to answer it, right? So what I'm going to do is say total problems is equal to 10. Set this to whatever you want, but the idea is I'm putting all of these capital or all capital variables at the top of my program. These are constants, meaning they're not going to change, and we can simply change them around like once we're kind of going to run the program a second, third time to make this more challenging, easier. Like we can set the parameters of the program from these variables right up here. Okay, so now that we have that, what we'll do to begin is we'll kind of just ask them the number of problems, then we'll set up the timer. So we're going to say for I in range, and then this will be the total problems. And then we'll print something like this. So we're going to say expression answer is equal to generate problem. So that gets us a unique problem. We're then going to print problem number, and then we'll say plus I plus 1 inside of parentheses, and this will need to be a string. So what we're doing is we're converting I plus 1 to a string, so it'll be like problem 1, problem 2, problem 3, so that they know. Then we're going to say plus a colon. Now notice the reason I'm using pluses here is because I don't want to have a space between my different values. I just want to have them kind of in line. So I'm saying problem number 1 colon space plus and then the expression. Okay, and then we'll put, actually, I'm realizing we're going to put this inside of an input statement, sorry. So we're going to switch this around, and we're going to say guess is equal to input, and then we'll have plus the expression plus a equal sign like that. So now what we're doing is we're saying, okay, problem number 1, here's the expression, so here's the problem, equals, and then the user can type in their answer, and then what we'll do is we'll keep asking them this until they get it correct. Sweet. So then inside of here, we'll do a while loop, and we'll say while true, we'll do this. We'll say if guess is equal to answer, then we will break. Now, the thing is, our answer is going to be an integer, but our guess is going to be a string. So we're going to convert our answer into a string so that we can compare the same types. Because if you compare an int to a string, even if they're the same value, like the string 10, the number 10, it's going to say false. Now I want to convert the answer to a string, not the guess to an int, because if I tried to convert the guess to an int to match the answer type, and they had typed in something that wasn't a valid int, then that would crash my program, which I don't want. So this way I'm kind of solving for that. I'm going to make sure that I don't have any potential crashes. Okay, so if they get it right, break. Otherwise, we're just going to keep asking it to them. We don't need to give them any feedback. They can just keep attempting the answer. Okay, so that's good. And I think that's actually going to be it for all of our problems. All right, so let's run this now, give this a shot. Now, I'm about to embarrass myself. I haven't done math in so long, so let's hope it gives me some easy ones. Okay, 9, 5 times 8, 40, Okay, 20, 10, 8 times 7. I always mess these ones up. Not 64, 56. Okay, 88. And there we go. We finish the problems. All right. So that was actually pretty good. Did I get any wrong? No, I didn't. Okay, let's try it again. Let's get one wrong this time. And notice it's going to keep asking until we get this correct. And then we continue. Okay, I'm just going to hit Control-C to exit out of that. And now what we'll do is we'll set up the timer. Now, I would love to make it so the timer, like, it shows you the timer. It's going to be a little bit difficult to do without going into some more advanced code. So what we'll do is we'll just start the timer as soon as they say, like, they're ready to start. And then we'll tell them what their time was at the end. And we can also tell them, like, number of correct answers. So let's do something like this. We'll say wrong is equal to 0. And every time they get it wrong, so we can just go here and say wrong plus equals 1. And then that way we can tell them kind of what their accuracy was at the end. All right, so wrong. We're also going to import time. All right. And now before we start doing all of this, we just want to ask them, like, okay, are you ready to begin? As soon as they hit enter, then we start the timer, just so they have a second to, like, gather themselves before it begins. So I'm going to say input. I'm going to say press enter to start. Okay, really, they can press anything they want, and it's going to continue as long as they go to the next line, so they could type something in if they want. Doesn't matter. So press enter to start. We'll print out like this, okay? And then it will begin, and I'm just going to take this and print it once they're done. And then we'll print nice work, and then whatever else we want to do. Okay, so as soon as we do this, so as soon as they hit input, we're going to start the time. Now, I imported this time module, and what I can do is I can say the start time is equal to time.time. Now, this is going to give me what's known as the Unix time. Yeah, I think that's what it's called. Let's see here. So actually, sorry, it says return the current time in seconds since the epoch. Don't worry too much about exactly what that means, but it's going to give us some kind of timestamp in seconds. So what we do is we kind of mark the start time. Then we just need to figure out what time they ended at. Then we subtract the 2 times, and that tells us the total amount of time. So as soon as they finish the for loop here, we say end time is equal to time.time. And then we just say total time is equal to the end time minus the start time. And then we can print out how long it took them. So we'll do that down here. Nice work. You finished in, comma, total time. And then we'll do comma, seconds, like that. Now we could parse this and do minutes, hours, etc. But I think just doing the number of seconds is fine. And that will be our program. Okay, let's give this a shot. So run the code, press enter to start. Okay, so that's 80. That is 17, -2, -6, 11, 77. Fortunately, it's giving me some easy ones here. 16, -3, 36. Okay, nice work. You finished in 16.95, blah, 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 whatever seconds. We could probably round this off if we wanted to make it a little bit better. So let's do that. And we will take this and round this to the nearest 2 digits. Okay, let's do this one more time. See if we can beat our time of 16 seconds. That was pretty fast. I don't know if I'm going to be able to do that. Okay, -2, -1, -1. Oh, what am I doing? 1. Okay, definitely not going to win now. 49, 14, 30, -4, 12, 0, 10, 21, 17. Oh, I was pretty close, even with that mistake. I was reading it as 7 minus 8, not 8 minus 7, hence why I made the mistake 3 times. Anyways, that was pretty good. All right, so that completes our program and all of our projects. So you're probably wondering now, what kind of project are we gonna work on? Now, I wanted to pick something that was unique and that I haven't done before, so we're actually gonna build a text-based slot machine. Now, the way this will work is the user will deposit a certain amount of money. We're then going to allow them to bet on either 1, 2, or 3 lines of the slot machine, just to keep it pretty simple. I know in real slot machines, they have a lot more lines than that. And then we are going to determine if they won. So if they got any lines, we're going to multiply their bet by the value of the line, add that to their balance, and then allow them to keep playing until they want to cash out or until they run out of money. So this is actually a fairly complex project because we need to do a lot of things. We need to collect the user's deposit. We need to add that to their balance. We need to allow them to bet on a line or on multiple lines. We then need to see if they actually got any of those lines. We then need to spin the slot machine, or we would have done that before, right? We need to generate the different items that are going to be in the slot machine on the different reels. And then we need to add whatever they won back to their balance. So there's quite a bit of stuff going on here, and this should be a challenging enough project to make it interesting for you guys. So before we even get into this, I just want to mention, I obviously am not supporting gambling here. This is just kind of a cool thing that we can do. We're not using any real money, and I think it's a good project. So just keep that in mind. Do not gamble. I'm not supporting that by making this video. And before I write any code, what I like to do here is just think of the different things that we need to do in this project and kind of pick a good starting point. The place where I like to start usually is collecting some user input. And for this project, we need to get the deposit that the user is entering, as well as their bet, right? Those are kind of the two things we need before we can start actually using the slot machine and generating, whatever the slot machine spun. So to do this, I'm going to make a function here called deposit. Now I'm just inside of Visual Studio Code. You can work in any editor you want, and I have this main.py function open. I assume you guys can open your own Python file and kind of work in your preferred environment. So this function here is going to be responsible for collecting user input that gets the deposit from the user. Now, a function, if you're unfamiliar, is just something that we can call that's going to execute a certain block of code and then can potentially return us a value. And you'll see how this works in a second. So what I'm going to do here is set up a while loop. And the reason I need a while loop is because I'm going to continually ask the user to enter a deposit amount until they give me a valid amount. So if they don't give me a valid amount, then they need to keep typing in until eventually we get one. So to do this, I'm going to say my amount is equal to input. And then inside of input, I'm going to pass a prompt, which is some text that will happen before we allow the user to start typing. So for the prompt, I can say, what would you like to deposit, ? And then I can put something like a $sign and then allow them to start typing after the $sign. Okay, now what I need to do is check if this amount is actually a number. Because they could type in anything here, right? They could type in hello world. They could type in nothing and just hit enter. They can do whatever they want. So I need to make sure that the amount actually is a number before I get out of this while loop. So I'm going to say if the amount dot is and then digit like this, then we can do something inside of here. Now, isDigit is just going to tell us if this is a valid whole number. So if it's something like 1,000, 10, whatever, if they type in a negative number, it actually won't be true. So if they do something like -9, then it's not going to be true, and we call isDigit. Anyways, this is a method you can use on strings to determine if this is a valid number. So if this is a digit, then what I'm going to do is I'm going to convert this into an int. So I'm going to say amount is equal to int amount. And that's because by default, this comes as a string, and we want to have a numeric value for our balance or for our deposit, so we need to convert this to an int. However, I can't do this before I make this check, because if I do that, then this could potentially fail, because if they try to type in something like hello world, then this here is invalid. I can't convert hello world into an integer, so that's why I'm first checking if they did actually enter a valid number. If they did, I then convert it to a number. Now what I need to do is check if this number is greater than 0. So I'm going to say if the amount is greater than, not equal to, but is greater than 0, then I'm going to break out of this while loop. If it's not greater than 0, then I'm going to put an else statement here, and I'm going to say print amount must be greater than 0 dot. Okay, there we go. Now I'm just going to add one more else statement down here, and I'm going to say print please, if we could type this correctly, enter a number. Okay, then finally here, we are going to return our amount. All right, so let me go through what we just did here. So we wrote a function, deposit. This is a while loop, so we're going to continue to do this until eventually we break out. And this break keyword just ends the while loop, and then will bring us down to this line. I ask, what is the amount you want to deposit? They enter something. If this is a digit, then I'm going to convert this to an integer, and I'm going to check if this is greater than 0. If it is, it's a valid amount. We can work with this, we'll break out, and then we'll return that amount, and we can use that later on. Okay, otherwise, I'm going to print this amount must be greater than 0, because if it's not greater than 0, well, we need to tell them that and then get them to try again. All right, so that handled this first if statement. Now, if the amount is not a digit, then what we're going to do is print, please enter a number, and we're going to continue this until we get a number and until we break. All right, so that's that function. Now to call the function, if we spell deposit correctly here, I don't even know how I messed that up so badly. Okay, deposit. To call the function, we simply write the name of the function and we put our 2 parentheses. And now as soon as I run my code, this function will run and we'll be able to actually enter a number. So let's do this. You can see in my terminal that it's asking me, what would you like to deposit? Let's go with something like $10 and all is good. Now, if I run this again and I enter something like hello world, it tells me, please enter a number. Okay, let's enter 0. All right, amount must be greater than 0. Enter 1. I'm good to go. So there we go. We've written our first deposit function and I've tested it. It's working good. We're all good to go. All right, so now what I'm going to do is I'm going to say my amount is equal to my deposit. And actually, we're going to call this balance. And this is kind of the start of our program here. And in fact, I'm going to put our program in this function main so that if we end our program, we can just call this function again, and then it will rerun the program, right? So I can say, do you want to play again? And then we can rerun the main function and we'll be good to go. So we've done that. Now I need to call the main function so that we start running main, and then it's going to do everything inside of here. Okay, so now inside of main, the next thing that I want to do is I want to collect the bet from the user. So there's actually a few ways I can do this, but I need to determine how much they want to bet and then how many lines they want to bet on. And then I would multiply their bet amount by the number of lines. So it probably makes sense to ask them the number of lines first and then ask them how much they want to bet on each line. So it's not confusing if I say, how much do you want to bet? They put $10 and then they say 3 lines and it ends up being $30. See what I mean? So let's say define, and we'll say get number of lines like this. And inside of here, we're going to ask them to pick a number between 1 and 3 because that'll be the number of lines that we have. And to keep this program nice and dynamic, I'm going to add what's known as a global constant at the top of my program. And I'm going to say max underscore lines is equal to 3. Now I'm doing this in all capitals because this is a constant value, something that's not going to change. And this is a convention in Python. You do it in all capitals, and I'm making it equal to 3. Okay, so now anywhere in my program where I'm referencing the number of maximum lines in my slot machine, rather than writing 3, I'll just write this. And then later on, I can easily change this to be 5, and the whole program will update based on that, right? So let's make this 3 for now. Okay, so get number of lines. Obviously, the minimum lines will be 1. We don't need to write that in. Okay, so we need to ask them to enter this. So we can actually just copy everything we have in the deposit function and just change a few values here. So we're going to say while true, rather than amount, we're going to say lines, and we'll say enter the number of lines to bet on, okay? And then I want to put inside of here kind of the options, so like 1 to 3. So I'm going to write 1 dash, and then I'm actually going to do a concatenation here, plus, and then I'm going to convert my number of lines or my max number of lines to a string, and then I'm going to say plus, and then I'm going to put a ending bracket here, question mark, and then a space. Okay, I know it seems a little bit confusing, but what I've just done here is I have now added max lines inside of this string. There's a few other ways to do this, but this is the most basic, so that's how I'm doing it. And I need to convert this to a string because if I add 2 strings together, they get squished together. But if this was a number and I tried to add it to the string, then this would cause an exception in my program. So enter the number of lines to bet on, 1 dash, and then I'm going to put in whatever the string version is of the maximum number of lines, end my bracket, put a question mark, and then I'm putting a space so that when they start typing, they're not like connected to the question mark. They're off by 1 space and it looks easier for them to read, right? Okay, so now same thing. I need to make sure that they actually did enter a number. So I'm going to say if lines.isDigit, then I'm going to say that my lines is equal to int lines like this. And I'm going to check now if the lines is within the bound that I had. So within 1 and 3. So the way to do this is I'm going to say if, and I'm actually going to say 0. Actually, we'll say 1 less than or equal to lines, less than or equal to, and then this will be the max lines. All right, so this is something you can do in Python you may not have seen before. If I want to check if a value is in between 2 values, I can write it like this. So what I'm saying here is if my lines is greater than or equal to 1 and is less than or equal to the maximum lines, then I'm okay. I can break. Otherwise, I need to tell them to enter a valid number of lines. So I'm going to say enter a valid number of lines. Okay, otherwise, same thing. We'll say enter a number. And then rather than returning the amount, we'll return the lines. Okay, perfect. So now we have a function that gets the deposit amount and the number of lines. So now in our main function, we'll say lines is equal to get number of lines like that. And now what we can do is print out the balance and the lines just so we can see what this is when we run the program. Okay, so now let's go here. Let's run. And how much would you like to deposit? Let's go with $100. Okay. Enter the number of lines. Let's try 4. Okay. Doesn't work. Let's try 0. Doesn't work. Let's try HE. Doesn't work. Let's try 2. Valid. And notice I now have a balance of 100 and the number of lines is 2. The next thing I need to get from my user input is the amount that I want to bet on each line. So let's do this. And we'll have a maximum bet as well. So we'll say max bet is equal to, let's go with something like $100. And let's say the minimum bet is equal to $1. And again, we're putting these as constants so that we can use them kind of anywhere in our program. So now let's just write this function from scratch. Let's say define get bet. So we can add our colon and continue, and for get bet, we'll just ask them how much they want to bet. And honestly, actually, now that I think of it, let's just copy the same thing from deposit. I don't like repeating all of this code, but they are slightly different, so it's fine to do something like this. So for the amount, we can actually use the same value, and rather than what would you like to deposit, we'll say what would you like to bet, question mark. Again, we're going to check if the amount is a digit. We're going to convert this now to an integer, and now we need to check if the amount is between the minimum and the maximum bet. So I'm going to say the min bet less than or equal to the amount, less than or equal to the max bet. Okay, and then break. And here I'm going to say the amount not must be greater than 0, amount must be between, and now I'm going to show you a second way that we can actually kind of put variables in our string. So I'm going to use an F string here, only available in Python 3.6 and above. I'm going to say amount must be between. I'm going to put my, squiggly brackets like this, and I'm going to say min bet and then max bet. So this is actually a very easy way to embed values inside of your strings. You put F before the string, and then you put your curly braces like this, and inside of the curly braces, you can write any variable, and it will automatically be converted to a string for you if it can be converted. So in this case, I don't need to convert min bet to a string or max bet. It's automatically going to get converted by Python, and I've just put my $signs here to make it look a little bit better when I say, between the min and the maximum bet. Okay, otherwise, please enter a number, that's fine, and then return amount. Okay, perfect. So now we're going to say bet is equal to, and then this is going to be the get underscore bet. All right. Now, we should actually make this a bit more clear. What would you like to bet on each line? Okay, so now that we've done this and we've gotten the deposit, gotten the number of lines, and gotten the bet, we'll probably want to print out here in our main function kind of what they've said so far, right? So we'll say you are betting, $5 on 3 lines. Your total bet is $15, something like that, right? So we're going to say print, you are betting, and let's do an F string here as well. And then let's do a $sign, and we're going to say whatever the bet is. So we're going to say you are betting whatever the bet amount is on, and then this is going to be lines like this, and then we'll write lines. And we'll say total bet is equal to, and then we'll put a $sign, and we're going to put inside of here a variable. I'm going to say total bet is equal to bet multiplied by the lines, okay? And we'll say this is the total bet. All right, so let's run this now, and let's see what we get. We no longer need to print out the balance in the lines, by the way. All right, so let's run this. How much would you like to deposit? Let's say $100. Enter the number of lines to bet on. Let's go with 2. Would you like to bet? How much would you like to bet on each line, or what would you like to bet on each line? Let's go with $10. And now it says our total bet is $20. Great. So this is okay, but I just realized that we actually need to check if the amount that they're betting is within their balance, because they can't bet more than whatever their current balance is. So we need to check that, and we could check this in a few different places. But since I've called this get bet, I'm not going to put it inside of here. I'm just going to do the check here, and then I'm going to recall get bet if they entered an invalid bet. So I'm actually going to put now this inside of a while loop, and I'm going to say while true. I'm going to say bet is equal to get bet, and I'm going to then say total bet like this inside of here. So we put total bet. Okay, now I'm going to say if my total bet is greater than my balance, then we'll say print you do not have enough to bet that amount, and then we'll say what their current balance is. Your current balance is, and then we'll put $sign. We're going to put our F string here, and this is going to be their balance. All right, and then otherwise, we will simply break out. Okay, so hopefully that makes sense. I also could just put a condition here for the while loop, but I think this is okay for right now. All right, so let's try this now. Let's run our code. How much would you like to deposit? Okay, $100. Let's bet on 3 lines. Let's try to bet $40. And says you do not have enough to bet that amount. Your current balance is $100. Okay, how much would you like to bet on each line? Let's go with $20. You're betting $20 on 3 lines. The bet is equal to $60. Okay, so we have now successfully got the number of lines, the betting amount, the deposit amount. Now what we need to do is we need to actually run the slot machine. Now this is where it gets a little bit more complicated, and I'm going to start importing some modules. So the first module I'm going to import is the random module, because we need to generate the slot machine values kind of randomly, right? So how are we going to do this? Well, the first thing we need to figure out is how many items we want to have in each reel and how long we want the lines to be. Now, slot machines can get a bit complicated in terms of how the lines work. I'm going to keep this really simple, and we're going to imagine that we have a 3x3 slot machine and that you only get a line if you get 3 in a row, okay? If you get 3 in a row, then you win. This might not be the most balanced slot machine. It might not be one you want to play on, but for this project, it's fine. So again, I'm going to set some values here that specify the number of rows and columns we're going to have in our slot machine. So I'm going to say rows is equal to 3 and calls is equal to 3. And if we wanted to make this a little bit better, we could say, I guess, actually, you know what? Row and call is fine for right now. I don't know exactly what they would call, like, I guess it'd be like reel count and number of reels or something like that. For now, though, this is fine. All right. Now what we need to specify is how many symbols are in each of our reels. Now, it should be the same, at least from what I know. It should be the same number of symbols in every single reel. We're not doing anything really complicated. When I say reel, I'm talking about kind of one column, right? So how many symbols are in that column? Because we're going to have to randomly select out of those symbols, and then we need values for our different symbols. So we need to pick kind of, first of all, how many symbols do we want to have in total, and what do we want those symbols to be? Now, to keep this easy, we can do something just like, you know, A, B, C, D. Like those are probably fine as the symbols. Yeah, we can do something like that. So let's say symbol underscore count is equal to, and let's make a dictionary here. Now for our dictionary, I'm going to have the symbol be a string, and I'm going to have the count of this symbol in each reel. So I guess what we can have is characters that are like at the beginning of the alphabet, like A, be the most valuable. So maybe we only have, I don't know, something like 2 A's in every single reel. And then for B's, we could have something like 4 of those. For C's, we could have 6. And for D's, we could have 8. Now, again, I don't think this is going to be a very balanced slot machine. I'm not going for the best odds here. I'm just trying to kind of make something work. So let's see if this actually works for us. If every single reel we have 2 A's, 4 B's, 6 C's, and 8 D's to choose from. Now, the thing that I think is going to happen here is we're going to get a lot of situations where it's just D's that are being in the reels, but let's see if this works at all in terms of randomly selecting. Okay, so that's what we've done here. Now what we need is something that's essentially going to generate what the outcome of the slot machine was using these values here. So to do this, I'm going to say define, and we'll say get underscore slot machine underscore spin, okay? And inside of here, what we're going to take is we're going to take the rows, calls, and symbols. And this will be the symbols that we pass. So these are 3 parameters that we're going to pass to this function. And then inside of here, we can use these parameters. So inside of this function, again, what we need to do is generate what symbols are going to be in each column based on the frequency of symbols that we have here. So we essentially need to randomly pick the number of rows inside of each column. So if we have 3 rows, we need to pick 3 symbols that go inside of each of the columns that we have. And for each column, we're doing kind of a new random pick, right? A new random generation of the symbols. Now, this can be a bit complicated. Now, the easiest way to randomly select values here for each of our columns is going to be to create a list that contains all of the different values we possibly could select from, and then to randomly choose 3 of those values. And when we choose a value, we'll remove it from the list, and then we'll choose again. Now, what I'm going to do here is not going to be the most efficient algorithm, but since we're dealing with small values, this is fine. So let's see how we work with this. Okay, so what we're going to define here is all underscore symbols. Okay, now this is going to be a list. And what we're going to do is write a for loop that's going to add however many symbols we have here into the all symbols list. So I'm going to say for, and since we're iterating through a dictionary, I can do the following. I can say for symbol, comma, symbol underscore count, and then this is going to be in symbols dot items. Now, when you use dot items, what this does is give you both the key and the value associated with a dictionary. So I can get the key here and the value, and I can just use both of them rather than looping through the dictionary, only getting the keys and having to manually reference the values. Okay, so now that I have the symbol and the symbol count, I want to add this many symbols to the, symbols list. Now, there's a few different ways to go about doing this. I think the easiest way to do this is just going to be to run another for loop so that I don't confuse anyone. So we're going to say for, and then this is going to be, let's do this, I in range, and then symbol underscore count. And actually, we don't even need I. We're going to put underscore. Now, this is an anonymous variable in Python. So whenever you need to say loop through something, but you don't actually care about the count or the iteration value, then you just put an underscore, and then you don't have an unused variable anymore. So I'm going to say for underscore in range symbol count. I'm going to say all underscore symbols dot, and then this is going to be append, and I'm going to append whatever the symbol is. So what's going to happen here is I'm going to loop through this dictionary. Let's imagine I'm on the first key value pair. My symbol is going to be A, and my symbol count is going to be 2. All right, so then I have another for loop inside of here where I'm looping through the symbol count. So the symbol count is 2, and what I'm doing is doing this 2 times. So I'm going to add this symbol twice into my all symbols list. All right, now that we have the all symbols list, we need to select what values are going to go in every single column. So how do we do this? Well, let's make a for loop that is going to do this for every column. So I'm going to say my columns is equal to a list. And inside of here, I'm going to place a bunch of lists, which are going to contain all of the values inside of my columns. Now, this may seem a little weird to any of you that have used a nested list before, because typically when you write a nested list, you kind of have all of the interior lists here that are representing your rows. So if I had like 0, 0, then this would be the values that are in row 0, right? Or in the first row. And then this would be the second row, and etc. However, here, we're doing it the other way around, where each of these nested lists is going to represent the values in our column. So keep that in mind. I'll explain how this works in case any of you are a bit confused later on, but I just want you to know that we're storing the columns, not the rows inside of here. Okay, so we have all of the symbols, and now for each of the columns that we have, we need to generate, the values inside of the columns. And how many values do we need to generate? Well, however many rows we have, that's how many values we need. So we're going to say for, and this is going to be call in range, and then calls like that. And then we need to say for, and this will be row in range rows. Okay, so for every column, we need to generate a certain number of symbols. So inside of here, I'm going to say that my column is equal to an empty list. This is actually not going to have our columns inside of it. I'm just was putting that there for an example. And now I need to select a certain number of values, from our all symbols list. So let's see how we do this. So we're going to say value is equal to random dot choice, and I'm going to choose from all symbols. Now I can use random because I imported random here. Now what we're actually going to do though is we're not going to use the all symbols list. We're going to use a copy of this. And you'll see why, but what we need to do is once we pick a value, we need to remove it from this list so that we can't choose that value again, right? So if there's only 2 A's, we shouldn't be able to select 3 A's. We should only be able to select at most 2. So if we select 1 A, we need to remove it so then the next selection doesn't have that as a chance. So that means we need to make a copy of this all symbols list, because if I start removing from this all symbols list, then when I try to do the next column, it's going to have values removed. So that's what we need to do. We need to make a copy. So I'm going to say current underscore symbols is equal to all underscore symbols. And the way you copy a list is you do this. You put a colon here. This operator here is referred to as the slice operator, because if I just did this and made it equal to all symbols, what happens is current symbols stores the same object as all symbols. Now that means anything I do to all symbols affects current symbols, and anything I do to current symbols affects all symbols. So this is not what we want. We don't want what's referred to as a reference. We want a copy. So the way you do the copy is you put a colon here. Make sure you add this, otherwise it's not going to work. Okay, continuing here. Now what we're going to do is select from our current symbols, and then we're going to remove whatever this value is from our current symbols list. So we're going to say current underscore symbols dot remove and then value. Now, when you do dot remove, it's just going to find the first instance of this value in the list and get rid of it. Okay. Now that we've done that, we want to add this value to our column. So we're going to say column dot push, and sorry, not push. I'm not in JavaScript right now. I'm in Python dot append the value. All right. And I just realized here, we don't actually need the column and we don't need the row. So we can just put underscores there. Now what we're going to do after this is we're going to say columns dot append, and we are going to append our current column. Now let me run through this because I understand it's a little bit confusing. We start by defining our columns list. Then we are going to generate a column for every single column that we have. So if we have 3 columns, we need to do everything inside of here 3 times. That's why we have this first for loop. Then inside of here, what all of this code is doing is it's picking random values for each, I guess, row in our column, right? For each value that we're going to have. So we say column is equal to an empty list. We say our current symbols, which are the ones we can currently select from, is equal to a copy of all symbols. Then we loop through the number of values that we need to generate, which is equal to the number of rows that we have in our slot machine. Then we say the first value we're going to get here, or a value we're picking, is random not choice current symbols. This picks a random value from this list. Okay. We then say current symbols dot remove the value so we don't pick it again, and then we add the value to our column. Okay, once all of that's done, so this for loop is finished, we now should have however many rows there are symbols inside of our column. We now add our column to our columns list. Then finally, we can go here and we can return our columns. Okay, and remember that when we're looking at this list here, every interior list gives us the value of the items inside of our column. I know, a little bit confusing. This was quite a bit of logic, especially if you're a beginner programmer, but I told you I wanted to make this challenging enough to be interesting for you and show you some new stuff. So don't worry if this doesn't make complete, entire sense. Maybe read through this a few times, pause the video, go back and listen to the explanation again. But this is, how we generate the items that are going to be in our slot machine. Now that we have this, we want a way to print this out. We want to look at this because I can't even really test this yet until I can print out what's inside of all of my columns. And I want to print this in like a nice way. So I'm going to make a function here and say define print underscore slot machine. And what we're going to take here is our columns. Now, when we have our columns, it's not really in a format that's easy for us to print because we have all of our columns kind of laid out as rows almost, right? Like we have maybe, actually this isn't going to be good, but we would have like A, B, C in one. Maybe we have like A. And again, these are our columns, not our rows. So what I need to do is kind of flip these around. So rather than having like A, B, C, A, it would go A, B, C, right? In the first column. And then this would say A, and then A like that. I know that I kind of butchered this example the way that I wrote it out. But we need to change it from being this way to be this way, right? That's how we need to print it out. So how are we going to do that? Well, this operation is actually referred to as transposing because we have what's known as a matrix. We don't need to get into all the fancy words, but understand this is known as transposing. So the way we're going to do this is we're going to write a for loop, and we're going to say for, and then this is going to be row in range. And then we need to determine the number of rows that we have based on our columns. Now, the number of rows that we have is the number of elements in each of our columns, right? Because that's the number of vertical spaces we have. So we need to look at a column and get the length of that. So we're going to say the length of columns 0. Now, this assumes that we have at least one column. And we should always have one column, so it's fine to put this here. But understand that if we did pass something that had no columns, this would crash because there'd be no column at index 0 to access. So I'm saying for row in range, the length of columns 0. Then what I'm going to do is I'm going to loop through all of my columns and only print the first value in it or whatever the index of my current row is. Again, I'll explain this in a second. I know this is a bit confusing. So I'm going to say for, and this is going to be column in, and then columns like that. And when I do this, now I'm looping through all of the items inside of columns. So it's giving me every individual column. So now that I have a column, I'm just going to print the value that's at the first row of that column. So I'm going to say print, and then I'm going to print column at row. And I'm just going to put a comma here and put a pipe operator. And the reason I'm going to put a pipe operator is so that we have some separation between the different items, right? Now, I just want to make sure, though, that I only put this pipe operator here if we're not printing the last column. Because if we're printing the last column, then we don't want to have the pipe like off, right? We only want to have 2 pipes in the middle, not one at the very end. So the way I need to check this, I need to say for I comma column in enumerate columns. Now, when you enumerate, what this does is give you the index, so 0, 1, 2, 3, as you loop through, as well as the item. So now that I have I, what I can actually do here is I can say, there's a few ways to do this. Let's actually go back to this. We'll say if I does not equal, and then this is going to be the len of columns minus 1. We'll do this. Otherwise, we'll print the same thing. We just won't print the pipe. Now, there's a bunch of different ways we could have done this, but this is just the way that I think is going to be easiest, so that's how we'll do it. So the reason I'm checking if I is not equal to the len of columns minus 1 is because the len of columns minus 1 is the maximum index we have to access an element in the columns list, right? If we have a columns list with 3 items, the length is 3. The maximum index is 2. So if I is not equal to the maximum index, print the pipe, otherwise don't print the pipe. That's how it's going to work. Okay, so now we have print slot machine and get slot machine spin. That's all. This is all we need for printing the slot machine. So we loop through every single row that we have. For every single row, we loop through every column. And for every column, we only print the current row that we're on. So we're going to print, row 0. So all of the elements in row 0 first, then row 1, then row 2. And this essentially transposes or flips our columns from being this way to be vertical this way. All right, so let's try this now. And then we'll kind of finish the program because we're actually getting quite close now. All right, so once we determine what they're betting, down here, what we need to do is generate the slot machine. So we're going to say slot, we'll say just slots is equal to, and then this is, what do we call this function? We called it get slot machine spin. Okay, so get underscore slot machine spin, and then it auto-filled this for me, but we're passing the rows, columns, and symbols. So rows is all capitals, actually. Calls is like this. And the symbols, I believe we called this the symbols count, or we called it symbol count. So let's go here and make that symbol count. Okay, so now we should have all of the columns in our slot spin, right? That's what that did for us. Now what we need to do is we need to print this. So we're going to say print slot machine, and we're going to pass to this our slots. And really, this is the columns, but I'm just calling them slots because each one is like what's in the slot, right? Okay. Let's give this a shot, guys. There probably will be an error because that's usually what happens when you write this much code from scratch, but let's see if this works. Okay, so we are depositing. Let's deposit $100. Enter the number of lines to bet on. Let's bet on 2. And then how much we like to bet on each line? Let's do $10. Okay. Now already we got a bit of an error here because I forgot to do something, which I'll add in a second. But if I scroll here, you can see that what's happening is we're printing everything correctly. We're just not printing it on the same line, which is what we need to do. So ideally we want D, A, and D on the same line, C, B, and C on the same line, and B, C, and A on the same line. So the way that we fix that, my apologies here, guys, is we go back to print slot machine. And here we add this thing called end equals, and we just make this a, an empty string. And in fact, let's actually do this. End is equal to a pipe with spaces. All right, so what end does is it tells the print statement what to end the line with. Now, by default, end is equal to what's known as the new line character or the return character or whatever you want to call this. Carriage return, there's different names for it. I call it the new line character. Now, \n, if you ever print this out, it's what tells the console to go to the next line. So we don't want to print that because if we print that at the end, then that means that we move to the next line after every single row. We only want to do this, after every single column. We only want to do this after every single row. So I'm going to change this to be a pipe. So now we'll just print this pipe at the end of our print statement. So after we print this, here, we're just not going to print anything. And now we need one more check to see if we should go to the next line or not, because every row we want to go down to the next line. So I'm actually going to say here, print, and we can just do an empty print statement. Now, by doing an empty print statement, it just brings us down to the next line because it prints a new line character by default at the end of the empty print statement. Seems a bit weird. That's kind of how this works. We're going to print the first row. This will go on the same line. Then we're going to print a new line character. So it brings us down to the next line, print the next row, new line character, next row, new line character, next row, etc. Right? So let's have a look at this now. Okay, let's go here. Let's run. How much would you like to deposit? $100. Let's bet on 2 lines. How much would you like to bet? $10. And there we go. Now we have our slot machine. Excuse me. And this is correct, right? So we have all of our columns and then all of our rows. And what we'd now be checking is if we have 3 in a row, right? That's what we're going to have to check. Okay, so we have our slot machine. We've spun it. We probably should have some input that asks, like, do you want to spin the slot machine? And then they can hit spin, blah, 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 be a bit more interactive. But that's how it works. And just to be clear here, we're going to check if we have 3 in a row. And if we do, based on the value of the symbol, we're going to multiply their bet and then give them that amount. All right, so let's write a function that can do this. Now, when we're checking if they won or not, we need to know what their bet is, which lines they bet on, right? And then we can actually check. Now, the way the lines works, again, I know this is not exactly how like a real casino slot machine would work. But we're going to make it so that if you bet on 1 line, you just bet on the top line. If you bet on 2 lines, you bet on the top and the middle. If you bet on 3 lines, you bet on all 3. I'm not going to let the user pick like where the 1 line is they want to bet on. We'll just say 1 is top, 2 is both the top 2, 3 is all of them. And that's how it'll work. Okay, so let's do this. Let's go define check winnings. Okay, now to do this, we need the slot machine itself. We need the lines. So we're going to say lines, and we need the bet. Okay, so how are we going to do this? Well, we just need to look at the rows that the user bet on. So let's start with that, and then we can check each row and determine a value also for the symbol. So we're actually going to take one more thing. We're going to say values. Now I'm also going to make the values here. So I'm going to say symbol underscore value. And I don't know what actually makes sense again to do for this, but we're going to say that D is going to be a 2 times multiplier. C is going to be a 3 times multiplier. This will be 4, and then this will be 5. So, you know, the more rare the symbol is, the higher your bet gets multiplied. Again, I don't think this is a fair slot machine, but that's fine. Okay, so check winnings. Now we have columns, lines, bet, and value. Now let's look through only the rows that they bet on. So the lines that they bet on. So to do this, we're going to say 4. And we'll say line in range. Then this is going to be lines like this. Now, the reason this will work is because if they bet on 1 line, then we're going to go up to 1 line but not include it. So that means line will be equal to 0, right? So if they bet 1 line, then this is 1, and that means this is only ever going to be 0. If they bet on 2 lines, then line will go to 0 and 1. So we'll check the 0th row, which is line 1, and the first row, which is line 2. If they bet on all 3 lines, then line will be 0, then 1, then 2. So we'll check all 3 of those rows, right? And this will work dynamically even if there was more lines to bet on. So inside this for loop, we need to check that every single symbol in the line or row that we're checking is the same. So we can get the first symbol that's in this row and then just make sure it's the same for the rest of the symbols. So to do that, we're going to say symbol is equal to columns 0 at the current line. Now, the reason we're using columns 0 is because we have all of the columns, not all of the rows. It makes it a bit more complicated. So we need to look at the first column because that's where the first symbol is always going to be for each row, and then get whatever line we're on. So first column, and then either, you know, line 0, line 1, line 2, etc. going down that first column gives us the first symbol, and we're going to assume that we always have at least, you know, 1 real, right? So at least 1 column. So now that we have the symbol, we're going to loop through all of our columns. So we're going to say for column in columns like that. Now, what we want to check, so the symbol to underscore check is equal to the column at whatever row we're looking at. So if we're looking at row 0, we're checking the first symbol in the column. If we're looking at row 1, checking the second symbol in the column, etc. Symbol to check. We're then going to say if the symbol is equal to the symbol to check, and actually we'll say if it is not equal to the symbol to check, then we are going to break. Okay, now the reason we're breaking is because if we found one of the symbols is not equal to the previous symbol, or equal to all of the symbols that should be in this row, then we just break out of the for loop. And what we'll do is we'll put an else statement here. And what this else statement will do is it will tell us if we didn't break out of the for loop. So I'm sure you probably haven't seen this before, but you can do a for else where if you break, this else statement does not run, but if no break occurs within the for loop, then this else statement executes. So in the else statement here, what we'll do is we'll figure out how much they won. So we'll say winnings is equal to 0. Okay, and then here we're going to say winnings plus equals, and then this is going to be the values at the symbol multiplied by the bet. And then we can go here and return the winnings. Okay, so let's look at this because I'm sure this is confusing. We have every line in the lines, which means we're looping through every row, essentially, that we're going to be checking that the user bet on. We then say the symbol that we want to check is whatever symbol is in the first column of the current row, because all of the symbols need to be the same, right? We then say for column in column. So we now know the symbol that we're going to check. Now we need to loop through every single column and check for that symbol. So we go to each column and we say the symbol to check is equal to the column at the current row that we are looking at. So if it's row 0, we're doing row 0. If it's row 1, etc. We then check if these symbols are not the same. If they are not the same, we break out, which means that we're going to go check the next line because they didn't win, because symbols were not the same. If they are the same, then we don't break. And if we get to the end of this for loop and we've not broke out, which means all of the symbols were the same, then that means that the user won. And what they won is whatever the multiplier is for that symbol times their bet, right? And this bet is the bet on each line, not the total bet, right? So they could win on one line, but lose on the other line. That's how it works. Okay, hopefully that's clear. I can't explain it much more than that. Just understand symbol values here, right? Gives us, 5, 4, 3, 2. So that's what I'm using. I'm saying values at whatever the symbol is multiplied by the bet. And that's how we're adding to the winnings. Okay, so that's it for determining how much they won. So let's run the game one full time now. And then we'll figure out how we can run it multiple times and reduce the balance and all of that, which is easier than what we just did. Okay, so we print the slot machine. And now we're going to say winnings is equal to, and what did I call this? Check winnings. Okay. Check winnings. We need to pass to this our slots. The number of lines. So I think we called that lines, right? The bet, which we have right here. And the values, which is called symbol value. So let's go symbol underscore value. All right, then we're going to print U1, and then whatever the amount is that they won. So let's make this an F string. Okay, and then U1, and then this is going to be winnings like this. And this could potentially be $0, right? Okay, so I think that's good. I'm thinking that we might want to also tell them how many lines they won on or what lines they won on. So let's actually return that as well from this function. So get check winnings. We're going to do one more thing here. We're going to say winning underscore lines is equal to an empty list. And if they win, we're going to say winning lines plus equals, actually not plus equals, dot append. And then this is going to be whatever the current line number is, but we're going to have to add 1 to it because this is an index and we want like line 1, 2, 3, not 0, 1, 2. So we say winning lines dot append line plus 1. Then we go here and we put winning lines, and now we're returning 2 values, the total amount they won, as well as what lines they won on. Okay, now let's go here to winning lines, and we're going to say winnings and winning underscore lines. You won these winnings, and then we'll say U1, we'll print another line like this, F U1 on, and then this is going to seem a little bit weird, but I'm going to do asterisks, and then I'm going to pass my winning lines. Now, again, I promised I was going to show you guys some new stuff, so I'm showing you some advanced syntax here, but what this does is actually called the splat operator or the unpack operator, and it's going to pass every single line from this winning lines list to this print function. So what that means is if we have lines like 1 and 2, it's going to pass both 1 and 2. So it's going to say U1 on and then 1, 2. So I'm going to say U1 on lines like this, and then it would say 1 space 2. If we want on all 3 lines, say 1 space 2 space 3. If we didn't want any lines, then it's not going to say anything. Okay, you'll see when we print this out how this works. So let's run this here. Let's make this full screen now, and let's go through an example. So deposit $100. How many lines? 4. Invalid. Okay, let's bet on 2 lines. How much would you like to bet on each line? $10. All right, so we won $0 because none of the symbols are the same. So let's try again. All right, deposit $100. Two lines, sorry. How much would you like to bet? $10. You won $0. Okay, so this is going to happen a few times. So rather than continuing to do this and hoping that we're going to win, let's make it so that we can run this multiple times without having to constantly rerun the program. So we have this main function. We have the balance and we have the lines. Now, the balance is going to stay the same, but all of this stuff here needs to happen multiple times, right? And we'll reduce from the balance and all of that stuff. So let's copy all of this into a function. And let's say define, let's say game, okay? We'll put this inside of here. So this kind of executes one game. Now, what we can do is write a while loop here. And this while loop can kind of handle running the game. All right, so I'm just thinking here, if we do this, we need some way to determine like from this instance of the game, so like per spin. So actually, let's just say this is maybe spin. We need to know how much they won or they lost. So I'm just going to return here the winnings minus the total bet, and that will tell us how much they won or lost from this spin. Because if they won $100 but they bet 15, then they only won 85. So then here we would update and we would add 85, right? But if they didn't win anything, then it's going to be negative whatever the total bet is, so like $15. So we'd subtract 15 from the balance. Okay, so here I'm going to say while true, and we'll print current balance is, and then we can just put comma. Actually, let's do this as an F string so we can put a $sign. Current balance is, and then we'll do $, and then balance, okay? And then we'll play game. So we'll say spin equals input, say press enter to spin. Okay, so they'll press enter to spin. So actually, we don't even need to put a value here because we don't care what they type in. Or actually, we can say this. Spin is equal to press enter to spin, and we'll say Q to quit. So if they type in Q, then we'll quit. So we can say if spin is equal to Q, then we will break the while loop, which will just end the game. Okay, otherwise we'll spin. So we can say spin like that, and we'll say balance plus equals spin. So the way that this works now is that spin is going to return to us however much they won or lost. It will tell them like what they won or lost. So then we'll just update the balance based on the result of that spin, and then we'll run this again and say, okay, current balance is this, press enter to spin, blah, blah, blah. And then when they spin, they're going to have to enter this info. And actually, press enter to spin probably doesn't make sense to go here, right? Because you only want to spin after you enter your information, although we can just have, this works. We'll say press enter to play. That's fine, and then they can do it inside of there. Okay, now that we have that, I think that's actually all that we need. I'll just make one last print statement here that says you left with, and then we'll put it inside $, and then this will be the balance, and we'll put an F string here. All right, let's run this and give it a shot. Okay, so run, go here. How much do you like to deposit? Let's deposit $1,000. Okay, current balance is $1,000. Press enter to play, Q to quit. Okay, enter. And we got an object here, balance plus equals spin. All right, looks like we need to fix this. So balance is equal to deposit, balance plus equals spin. We have winning lines subtracted by total bet. And what is the problem? All right, so the issue here is that I accidentally have the name of my function, spin, the same name as this right here. So we're just going to change this to be answer. So now this will work properly. Okay, so my apologies, guys. Let's go here and fix this. And let's say $1,000. Current balance is 1,000. Press enter play. Okay. Enter the number of lines to bet on. Let's bet on 2 lines. Let's bet $10. Okay. Balance is not defined. Looks like we need to fix another error. So what we need to pass here is balance to the spin function so that it can actually check this when we make a bet. So of course that makes sense. Just forgot to do that. So let's pass balance here. And now we'll actually be able to check that. All right, so let's try it again. Third time's a charm. $100. Current balance is $100. Press enter to play. Okay, number of lines. Let's go 3. Let's go $10. And you are betting on $10. You're betting $10 on 3 lines. Total bet is equal to $30. Okay, you won $0. You won on lines. And it has an issue here, unsupported operands for list and int. Okay, my apologies. That's because I put winning lines. This needs to be winnings. All right, fourth time's a charm. So let's make sure our variable names are correct. That was just a silly mistake. Let's clear and run. $100. Enter. 3 lines, $10. Okay, you won $0. You won on lines. Your current balance is $70. Okay, let's play again. 3 lines, $5. Okay, did we win anything? No, we did not. All right, let's play again. I'd really like to try to win something, but as we can see, the slot machine is not in our favor today. $10. You won $0. Okay, current balance is $25. All right, 3 lines, $2. You won $4. Okay, nice. So how did we end up winning $4? We bet $2, and we got a line here of D's. So that gave us ×2 multiplier. So 2 times 2, 4. So we won $4. There you go. And then our balance gets updated, to $23 because we were at 25, subtracted 6, add 4. Yes. Okay. So that makes sense. All right. So let's play again. Let's go 3 lines, $1. Okay. You won nothing. Let's play again. 3 lines, $1. You won nothing. 3 lines, $1. Oops. Let's go $3. You won nothing. Okay. Play again. 1 line, $3. You won nothing. All right. Well, I won't continue to play, but you get the point. We've just created a slot machine, and now if I hit Q and enter, we leave with $11. All right. So I think I'm going to wrap it up there. I'm going to zoom out a bit so you guys can read more of this code. I'll just kind of scroll through it. I'll also put it in the description in case you want to reference it on GitHub. But you can see this is what we wrote. So we did about 150 lines of code in, I guess, about an hour. Now I walked you through my thought process. I showed you a bunch of different Python features. We did actually some fairly advanced logic in terms of looking through rows and columns and looking at nested lists. I showed you about functions. I showed you about the anonymous variable. You saw this splat operator here. And when we won on a line, you saw it said we won on whatever the line number was. So hopefully this was helpful to you guys. Hopefully this showed you kind of how to structure a program. Notice that we put everything in separate functions. We've kind of spread our code out. We've made it very readable. And now we know if there's a bug anywhere, it's really easy for us to go and kind of figure out where that is because we've separated everything into different units, right? Different blocks of code. Anyways, I will wrap it up here. I hope you guys enjoyed this video, everybody, and welcome to a brand new YouTube video. So it's been a while since I've done a kind of beginner project, something that really anyone can follow along with regardless of their background in Python. And so I wanted to do one for this video. So what I'm going to be showing you how to do is actually create a graphical application. So this is not just going to be text, although it looks like that right now. And what's going to happen is we are going to create a turtle racing program. So essentially the user will be asked to decide how many turtles they would like to race. Based on their answer, a screen will pop up, as I will show you in 1 second, and then it will race that many turtles by just randomly moving them on the screen. Now, this is a great project to learn about how to build something a little bit bigger than a really simple Hello World application. I guarantee if you're new to Python, you're going to learn a ton here. I purposely used a bunch of different syntax and functions and kind of showed you how we can lay out a relatively large program for beginners. This is not a large program by any means, in kind of a nice structured way where everything is just done in kind of the proper format. So anyways, let's go ahead and get started here. I'm just going to show you a demo of what we're going to be building. So it says, welcome to Turtle Racing. Please enter the following information. How many turtles would you like to race? You can enter between 2 to 8 turtles. I'm going to select 8. When I do this, it's going to open up the turtle window. This is built into Python. There's nothing fancy you need to install. It's going to initialize all of our turtles, and then it's going to start racing them on the screen. So it looks like the red one is going to win here. Let's see. And oh, maybe not. So it says here, the winner of the race is pink, and then it waits 5 seconds and then it stops. Now I will show you how we can run this multiple times if you'd like to do that. That's the basics behind this program. Now let me show you one more time. If I race, say, 3 turtles, notice how they are evenly spaced out on the screen. So I'm going to be showing you how we can do that. And there you go. They race. Nice. And it says the winner. Anyways, let's go ahead and get started. So the first thing that I want to do here is I want to ask my user to input the number of turtles that we are going to have. So what I'm actually going to do here is I'm going to create a function. If you've never seen a function before, I'll explain them. They're pretty straightforward, but I'm going to say define, and the name of this function is going to be get underscore number underscore of underscore, and then we'll say racers like this. or turtles, whatever you want to call this. And then inside of here, this is where we are actually going to ask the user to insert the number of racers that they want to have. Now, the reason you're going to see me kind of write things in this way in different functions and kind of different blocks is because it really separates out what every single aspect of our program is doing. And it's just good practice when you're writing code to really have all of the different separate things happening kind of in different areas. So later on, if something goes wrong or you want to add something or change something, it's really easy to do that. You're not looking through a huge mess of code, and well, you'll see how this kind of evolves as we go through here. So what I want to do is I want to ask the user for a number. So I want them to insert a number between 2 and 10. And so I also need to validate that the number they're typing in is correct. So what I'm going to say is racers is equal to 0. And then I'm going to say while true. Now, the reason I have a while loop here is because I want to continue to ask the user to insert a number until they insert a valid number. So if they insert something invalid, then I'm going to keep asking them and say, hey, no, that wasn't valid. Give me something that's valid, because we can't start our program until we know how many turtles we're going to be racing. So I start with racers equals 0. I say while true. Now I'm going to use an input. So I'm going to say racers is equal to, and then input like this. And I'm going to say enter the number of racers, and then I will do kind of a little 2 to 10 thing here to indicate the fact that I would like them to type a number that is between 2 to 10. Now, you don't have to do it like this. You can write whatever you want. This is what I'm going to prompt the user with. And then notice that here I've added a space. So after my colon, I have a space. The reason I have a space is because the user starts typing immediately after this prompt. So this text will be printed to the screen. So I want to separate it from the colon so that it doesn't look like they're typing like right beside this line. There's like a little bit of a space. Anyways, what I'm now going to do is I'm going to check if this, what they inputted, is a number. The reason I need to check if this is a number is if the user didn't input a number, obviously that's invalid, but also I want to convert what the user types in into a number if I can do so. So in Python, by default, when you use this input statement, it's going to capture whatever the user types into the console and convert that into a string. So we need to take that string and potentially convert that into an actual integer, a numeric value, so that we can use that in our program. So I'm going to say if racers dot and then is digit. This is a method you can call on strings, and this will tell you if the string is completely numeric or not. So if the string is numeric, then what that means I can do is I can convert this into an int. So I can say int racers. If you tried to just do this line without checking beforehand if it was numeric, then this would crash the program, because if you had a string that was typed in that was not numeric, you try to convert, say, int of Tim to a int, right? You're trying to convert the string Tim into an int. This is invalid. That's going to crash. You can't do this. So anyways, let's move on now. If this is not the case, so if the racers are, or if what the user input, is not a digit, then what we want to do is tell them, hey, this is invalid. Please try again, right? So I'm going to print and say input is not numeric, ... try again, ! And then I'm going to say continue. Now, what this continue does is immediately brings me back to the beginning of the while loop. So we don't really need this continue. Well, we will based on what I write next, but think of it this way. As soon as we hit this statement, it immediately jumps right back up to the top of the loop. So anything below this, say I had a print statement saying like print hi, this print statement wouldn't run if we hit this continue before this print statement. So that's why I have the continue here. All right, so if the racers is a digit, so if what they inputted is a digit, then we are going to convert it into an integer, which is valid. Otherwise, we'll tell them it's not numeric. They need to try again, and then we'll continue. Now, if we make it past this, so we don't hit this else, and we did make this conversion, now we want to check if this number is within the range of 2 and 10. So I'm going to say if 2 is less than or equal to racers, less than or equal to 10, then what I will do is I will just return the racers like that. Otherwise, I will tell them that this number is not valid. So the idea here is I check if racers, which is now a number, that's why I wanted to convert it to a number so I could do this comparison, is less than or equal to 2 or less than or equal to 10. So if it's within our range of 2 to 10, this is fine. What I will do is return racers. So whatever the user typed in, we're going to return that from this function, which means whatever called this function will now have access to it. Otherwise, though, if this was not valid, what I want to do is I want to print number, not in range 2 to 10, try again, ! And then I could put a continue here, But there's really no need to do that because nothing comes after this continue in this while loop. And so by default, we will just go back up to the top. The reason I had the continue here is because I don't want to check if the number that is not a number, right? So what the user typed in, I don't want to check if that's between 2 to 10, because if I do that and we haven't converted this into a number, we're going to get an error. Let's say, what the user typed in again was Tim. I can't check if 2 is less than or equal to Tim. This is just undefined. This operation makes no sense. And so that is why I'm continuing to make sure if I don't get a valid number, I don't do this comparison and crash my program. All right, so now we have this function. So I'll show you how we can use this, right? We can just call the function, so get number of racers, and we can say something like racers is equal to get number of racers, and then we can just print out racers down here. Now what will happen is all of the code that we wrote inside of here, notice it's indented after the colon, right? It's going to run all of this code when we call the function. And then as soon as we hit this return statement, what will happen is we will actually return back to where we called this function. So back to this line, and we will pass whatever the value of racers was. So racers will be equal to down here, whatever is returned from this line. So whatever number the user typed in that was numeric in between 2 to 10. Then I'm going to print out those number of racers that the user typed in. And that's kind of the start of our program. Then we've got a few more steps to do after that. So let's try running our program. I'm going to say Python turtle race tutorial.py. Again, if you're in IDLE, just press F5 and come on, enter. Is this going to work? Okay, something's wrong with my terminal. Python turtle race tutorial.py. Okay, enter number of racers 2 to 10. Let's enter 5, and then it prints out 5. Now let's try something invalid. Let's try Tim. Now it tells me input is not numeric. Try again. Let's try Joe. Not numeric, try again. Let's try 11, number is not in range. Let's try 10, boom, that works, we get 10. Awesome, so this is indeed working. We just did a few tests here, and you can see that down here we are getting access to whatever this function returned. So now that we have the number of racers, what we want to do next is actually set up our turtle screen. So I will show you what I mean by that, but let's start by importing the turtle module. So the turtle module is built into Python, and this allows you to perform very basic 2D graphic operations with this thing called a turtle. So you'll see it in a second, but essentially it's like a little kind of header on the screen, and you can kind of move it around. It will draw lines, and it's a really great way to just learn the basics of Python in a nice visual way. So now we have the number of racers. Now we've imported turtle, and let's actually just see what happens now when we run the program after importing turtle. So we're going to run this. Let's import our number of racers. We can go 4, and we actually see that nothing happened. I was thinking the turtle screen might pop up, but I think it's because I haven't used this module yet. So anyways, that was a poor example. What I'm going to do next is show you how we can create a turtle screen. So ignore that last example. What I was expecting to happen didn't happen. Oftentimes when you import a module, like something will happen when you import it. So what I'm going to do now at the top of my screen is I'm going to define, first of all, the width and the height that I want my turtle screen to be. So usually whenever you're working with graphics, you need to define the size of a screen or the size of the canvas you're going to be working on. So in this case, I'm going to say in all capitals, width, comma, height is equal to, and then 500, comma, 500. If you haven't seen this notation before, this means width is equal to 500, height is equal to 500. You can separate as many variables by commas as you want, and then do the assignment with commas as well. So the reason I'm doing this in all capitals is because these are constant values. So in programming, whenever you have a constant value in a language where you can't explicitly define that, you usually have all capital letters to denote the fact that this value width and this value height will never change. They're just here so that we have easy access to the width and the height. All right, so now that we have the width and the height, we want to set up the turtle screen. So we're going to start by creating a screen. So we're going to say screen is equal to, and then turtle dot, and then in all capitals, screen. Now what this is going to do is initialize a screen for us with this turtle module, and then we can kind of set some properties of this screen, the first of which is going to be the width and the height. So now that I have my screen, I'm going to say screen dot, and then this is set up, and here we're going to pass the width and the height. So this method right here takes 2 arguments, a width and a height of the screen, and then it makes the screen that size. So now that we have that, let's run the program and let's see what we get. So Python turtle race.py, and notice you can see a screen pops up here immediately, and then it's asking me to input the number of racers. So I can input, say, 5, and then the program ends and the screen automatically closes. Great. But when I do this, notice that we get Python Turtle Graphics as the name of our window. We might not want that. We might want to change the name. So let's actually go ahead and do that. So I'm going to close this. Probably should have left the CMD open, but that's fine. And now I'm going to say screen.title. And in here, I'm going to put whatever I want the name of that window to be. So I'm going to make mine turtle racing exclamation point. Now let me go and open up my command prompt again. You can kind of ignore what I'm typing. I'm just trying to get to where my file is. So Python turtle race tutorial.py. When I run this, notice now the title is changed to turtle racing. Awesome. So let's just input a number and end the program there. Let me make this guy a little bit smaller. Okay, so now we've gotten the number of racers, we have set up the turtle screen, and what we want to do next is actually create our turtles, right? We want to start racing them on the screen. So I'm going to start by showing you kind of the basic commands of a turtle, so how you kind of move a turtle around the screen, some of the things that are associated with it, and then we'll create a bunch of different turtles and then obviously race them. So what I'm actually going to do though is I'm going to take all of this code related to the turtle stuff, so the screen setup, the screen title, all of that, and I'm actually going to move that to underneath where my racers are. And in fact, I'm actually going to make a new function. I changed my mind. I'm going to call this init underscore turtle. And inside of this function, we're going to set up everything related to our kind of turtle screen. Now, the reason for this, again, is that we just want to kind of structure our program nicely, so we won't show the turtle screen until we call this init turtle function. So after we get the number of racers, then we can pop up the turtle screen, because I don't really want it to be shown until we've picked the number of turtle racers that we have. So after we get the number of racers, we can say init turtle. That will just run all of the code in here, so we'll set up our turtle screen. So let's actually go ahead and run this, and let's see what happens. Notice that the turtle screen hasn't popped up this time, but then when we type 4, it kind of pops up really quickly and then it closed, because as soon as we pop it up, the program ends. There's nothing more that we need to do. We're on a good start now. That's kind of what we wanted to do. Okay, so now I'm going to show you how we can kind of move a turtle around the screen. So to do this, you need to start by creating a new turtle object. So to create a new turtle object, what you need to do is say, and in this case, we'll just say racer is equal to, and then turtle dot, and then with a capital T this time, turtle. So what this will do is actually create kind of a drawing object for you on the canvas that you saw, that white canvas that popped up. And then what you can do with this is you can move it around. So I'm going to say racer dot, and then just to show you one method you can use forward, I'm going to move it forward by 100 pixels. Now I'm going to do something here that may seem a little bit confusing, but I'm going to import a module called time at the top of my program. And down here, this is really the only new code that we've added. Right after I move my racer forward by 100 pixels, I'm going to say time.sleep and then 5. What this will do is pause the program for 5 seconds so that after we move our turtle, we have a second to actually see where it went. We don't just immediately close the turtle window. Although we may or may not do that, immediately close the turtle window. Anyways, we'll see here after this happens. So let's run this code right now. And let's see what happens. We'll say 4, and then notice it opens this turtle window, and then it moves this kind of pointer over here by 100 pixels. And then it closes, obviously, because now we are no longer sleeping. So hopefully that kind of made sense, but you would have seen, let's run this one more time, that it opens up the window, it moves our little pointer here, which funny enough isn't actually a turtle, right? Over 100 pixels, and then it closes. So this is one of the methods you can use with your turtle. The turtle will start in the middle of the screen. The turtle is really that drawing kind of arrow that you saw, and every single time you move it, it will create a line. So you don't only have to move it forwards, you can move it backwards, and you can also change its direction. So you can set it to move maybe in 90 degrees. You can set it to go left. You can set it to go north, east, west, whatever direction system you want to use, you can set it to go in that direction. So I can say racer.left, and then I can make it go left by 90 degrees, and then I can say racer.forward, move it forward 100 again, and then I can say racer dot, and then let's just go left. We can go left another 90 degrees, and then we can say racer dot backwards. Is it backward or backwards? Well, I guess we'll see when we run this, and then by 100 pixels. So let me run the code now, Python turtle race.py, and there we go. Oh, so it's saying turtle object has no attribute backwards. That is because this is backward, not backwards with the S. So just don't add the S for the plural there. And let's give this a shot now. So Python turtle racer, and there you go. That's what happened. See, we went right, we went straight, then we went left, then we turned left again, but then instead of going forward, we went backwards, and so we went the other direction. So you can kind of mess around with these, forward, left. There's also right. And inside of these methods here, what you're placing is, at least inside of the right method, is the angle at which you want to turn the turtle. So if you want it to turn 90 degrees, you put 90. If you want it to turn 180 degrees, you put that. If you want it to turn 45 degrees, you put 45. I'll let you guys mess with that on your own. And then this, the number of pixels, is, well, how far you're moving the actual turtle. So when we open up the turtle window, and let me time.sleep for, say, 20 seconds here, just so we have lots of room, so I can explain kind of the coordinate system. So let's run this. Let's open up the turtle window. All right, so this turtle window is 500 by 500 pixels. So the height is 500 pixels and the width is 500 pixels. Now, the very middle of this turtle canvas, it has the position of 0, 0. So the top of the canvas has a position of 250. The bottom of the canvas has a position of negative 250. The left of the canvas is negative 250. And the right of the canvas is 250. Let me open this up again. The way this works, right, is that if the middle is 0, 0, and we have a height of 500, then the top Y position on our canvas, when we're talking about just a standard 2D graph, is going to be 250, whereas the bottom Y position is going to be negative 250. So as you increase your Y, you go up. As you decrease your Y, you go down. As you decrease your X, you go to the left. As you increase your X, you go to the right. Hopefully that makes sense. And again, negative 250 and positive 250, the reason that's the top and the bottom is because the height is 500. I just divided 500 by 2 and then applied a negative to one of the bounds. Hopefully that's making sense, but that is the coordinate system. The reason that's important is because when I say I move 100 pixels, well, we need to understand where that's actually going to move us to and what scale this is on. So when I'm moving 100 pixels, I'm really moving 1/5 of either the height or the width of the screen, depending on the direction that I'm moving in. So we're going to race our turtles going up the screen, but you could totally race them going to the right, going to the left, whatever direction you want. Now, a few more methods that are useful when we're talking about turtles here are things like the actual icon that's representing the turtle, as well as the speed of our turtle. So what I can do here is I can change my racer speed. So I can say racer.speed and then set this equal to, say, 2. Now, let me actually check what the racer speeds are. Okay, so I just checked what the different turtle speeds are here. You can see that these are the potential speeds we have. So we can insert a speed between 0 to 10. And let me just show you this method again. We have the turtle object that we've created, dot speed. So we can set the speed of it to be slow or fast because you kind of saw how it was moving around the screen, right? So if we go here, let's go back to Google. We can see 0 to 10, where 0 actually means we're going the absolute fastest we can possibly go. 1 is the slowest, and then 10 is fast. So really it's 1 to 10, and then if you input 0, it's saying just go as fast as the turtle can possibly move. So let's try putting in a value of, say, 2 or even 1, and let's see how slow this turtle gets when I change its speed. So I change its speed, let's run, and now notice it's moving much slower than it was before. There we go, that is our turtle. Oh yes, it's going right now because I put that right 90 degrees. Awesome, so let's wait for this to close, and then I will show you that we can change, say, the color of the turtle, and we can change what the actual icon looks like and all of that. In fact, I'm not going to wait for it, let's just do it now. So if I want to change the icon of the turtle, what I can do is say racer dot, and then I believe, I'm actually going to have to look at my other screen here for a little cheat sheet. This is the shape, that's what it's called. So I've been referring to this as the icon. It's actually the thing you're seeing on the screen, but there's a bunch of different shapes that you can choose for your turtle. So I want to make mine turtle, but some other valid ones I think are circle, we have arrow, and then you're welcome to look up the other possible shapes that you have for turtle. I can't remember all of them, but I know that at minimum, 2 of them that exist are turtle and circle, and then obviously there is arrow as well. So sorry, those are the 3 that I know that exist. Okay, so let's change this to a turtle now, and let's see what happens this time when I run my program. I'm going to remove the sleep because I've slowed down the turtle, so hopefully we have enough time to see it now. So let's run this, enter some number, and now notice we get an actual turtle moving around the screen. Awesome, so that is good. Now I will show you how we can change the color of the turtle. So to change the color is pretty straightforward. You can say racer.color, and then inside of here, you can put a string that represents the color you want to change this to. So there's like a ton of different possible colors here. I won't go through them all, but for example, one is cyan. We could do red, we could do green, we can do blue, we can do yellow, black, orange, so on and so forth. So let's just change this to cyan. So let's run our code here. And notice that now we get a cyan turtle and that the line that it has is cyan as well. Now, there's a ton of other stuff you can do with turtles. If you want to see all of that, I would just recommend you just look up turtle Python like that. And then you can see if you go to the turtle documentation here that there's a whole list of all of the possible stuff that you can do with your turtle. So I'll be showing you some of this, but I won't obviously go through all of it. Okay, so the next thing to show you is what is called turtle.penUp. So whenever the turtle's moving around the screen, you notice it was kind of drawing that line, right? And we're calling that the pen. So as the turtle moves, it's kind of a pen and it's drawing this line on the screen. Now, if we want it to not draw the line, but we still want it to move, we can bring its pen up. So we can say racer.pen up like that. And now you're going to notice when I run this program after I've moved the pen up is that as we move this turtle around the screen, no line is being drawn, right? Because its pen is up. So what I can do is I can move the turtle with its pen up, I can put its pen down, and then I can continue drawing. So let's copy this line. Let's move the turtle forward by 100, left by 90, and then let's put its pen down. So we're going to say racer.pen down. So let's do this now. Python here, and now notice that as soon as it turns that corner, then the pen goes down. So all this stuff I'm showing you, you can change at any point in time. You don't have to change it before the turtle starts moving or something like that. All right, so now I've showed you pretty much everything I need to in terms of the different methods for the turtle object. Just keep in mind, you can make as many turtle objects as you want. So I said racer equals turtle.turtle. I can make a second turtle, right? I could say racer2, and then I can move these turtles in different directions. So just to give you a quick example, we can copy all of this, and then we can just change this to be, say, racer2. And we'll just make racer2 a different color. So instead of cyan, we'll make it, say, brown like that. Maybe we'll make its speed a bit faster, and then we'll change it so it goes forward like 150, just so you can see the difference in these two turtles. So let's change that to be 150. Again, notice I just had racer2. We can kind of copy this and put it down here to separate these things out. All right, so let's try this now. So let's go Python turtle race tutorial.py. Let's enter a number of racers, 3, and then notice the first racer is going to move around, and then our second guy kind of started moving really quickly, right? Because we wrote all of this code after we wrote this code. So I'm going to delete all of this, just wanted to show you that. And now what we are going to do is we're going to pick the colors of the different racers that we have. So once we know how many racers we have, we need to kind of create all of these turtle objects, and we need to pick their colors. So I'm going to create a list of colors up here in all capital, and I'm just going to type out a bunch of them. I have a list on my other monitor in case you see me looking over there. So I'm going to say red, we're going to say green, we'll say blue, we'll say orange. We have, if I can get my cursor here correctly, yellow. We have, what's another one? Black, purple. We then have pink. And did I do yellow? Yes, I did. What's the last one we have? Brown and cyan. Okay, brown and then cyan. Now note that there is a lot more colors than this. I'm just doing 10 for right now, so we can have at most 10 turtles. So now that we have all of these colors, we kind of need to pick, after we've gotten our number of racers, what turtle colors we actually want to use. So I'm going to show you a cool way that we can do this. So we can randomly select a bunch of colors from this color list that are unique. So at the top of my program, I'm going to import random. All of these modules are built into Python. You don't need to install them or anything like that. And then down here, what I'm going to do is I'm going to say random.shuffle, and I'm going to shuffle my list of colors. So all this capital list right here. Now, what this is going to do is it's going to take the list and just randomize all of the items inside of it. So I have no idea where these items are going to go, but all of the items that I have here will just be kind of randomly placed around in the list. Then what I'm going to do is I'm going to select the first number of racers item from this list that are there. And we'll use that as our colors. So I'm going to say colors is equal to, and then colors, and then this is going to be a slice up to the number of racers that we have. So let me just quickly explain this. We've gotten the number of racers, we've initialized the turtle, we're shuffling that colors list, so just randomizing the order of all the elements there. And then what this does is this gives us the first racers item from the list. So if we had a list, say 1, 2, 3, comma 4, and then we put this little slice operator, this is what it's called when you use the colon, and we set up to, say, 2, what this would give me is the first 2 elements in this list. So I would get a new list that looks like 1, 2. Now, if I did the slice of, say, 3, then this will give me the first 3 elements. So 1, 2, 3, that's kind of the basics of a slice. So the reason we're doing that is we're randomizing the list and then just taking the first, say, number of elements That number is equal to whatever the number is the user types in. So now let me show you this. We're going to print the colors after the user types in the number of turtles they want to race. So let's do this, Python turtle race. Let's insert 5, and then notice it kind of popped open that turtle window, closed it, and then it printed yellow, purple, green, orange, brown. Now, if I do this again and I type 5, you're going to notice we get different colors, right? And they're in a different order. So black, red, orange, brown, cyan. Now, this 100% will always select unique colors for us, so we'll never have turtles that have the same color. All right, now that we have all of the colors, we want to create all of these turtles. So we're going to make a new function here. We're going to say define and then create underscore turtles. Now inside of here, we're going to create a list of turtles, and then we are going to kind of place them on the screen in their starting position. So ideally, we want to have all of the turtles evenly spaced out at the bottom of the screen and kind of pointing upwards, ready to start racing. So let me show you how we do that. Well, the first thing that we need to do here is we need to determine what colors our turtles are going to be and how many turtles we're going to have. So this function as a parameter is going to take in colors. So we are going to pass this function when we actually decide to call it the number of colors that we have. And then what that's going to, or not the number, sorry, just the colors that we've actually selected. And by having this list here, we will also know how many turtles we have because the number of elements in this list will tell us the number of turtles that we want to race. So now what we're going to do is we're going to say that turtles is equal to an empty list. Then we're going to loop through all of the colors that we have. And for every single color, we're going to create a turtle and add it into the list. The reason I'm creating a list is because I don't know how many turtles I'm going to have, so I can't just define variables with like, I can't define 4 variables for 4 different turtles or 5 variables for 5 different turtles. I need to kind of dynamically create these turtles because again, I don't know how many I'm going to have. So I'm going to loop through now all of my colors. I'm going to say for I, comma, and then color in enumerate. And this is going to be colors. And what enumerate does is it gives me the index as well as the value of all of the elements in colors. So if I'm looping through colors, let's say like red and then green, then what's going to happen is on my first for loop iteration, I will be equal to 0. That's the position of this color. Color will be equal to red. And that's great. Then on my next iteration, I will be equal to 1 and color will be equal to green. And if I had one more iteration, say this was blue, then I would be equal to 2 because this is the third element or the second index / position. And then the color will be equal to blue. So that is what enumerate does, gives us both the index and the value. Now what I want to do is create a turtle. So I'm going to say racer is equal to, and notice you can name these variables whatever you want. And I'm going to make this equal to turtle.turtle, just like we saw previously. And then immediately I'm going to change the color of this turtle to be whatever color this is. So I'm going to say racer.color, and I'm going to make this, if my Sublime text stops crashing. Okay, it's crashing, so I'll be back after this stops crashing. All right, so I am back. That was really annoying. Sublime text just crashed on me, but I have a racer.color, and I'm going to set this color to be equal to color. The reason I'm setting it equal to color is because this will be a string. This string will come from this list of colors right here, and so every one of our racers will be a different color. Then what I need to do is set a few other things. I want to set the shape, so I'm going to say racer.shape, and this is equal to a turtle. Then what I want to do is place this racer in its starting position. Now, before I do that, I'm going to show you where they're placed initially, but I also want to turn these racers. So I want to say racer.left by 90 degrees. Now, the reason I'm doing this is because by default, the kind of arrows or whatever are pointing to the right. So if I want them to point upwards, because I want to race my racers upwards or my turtles upwards, then I need to turn them left by 90 degrees. So I'm going to take my racer or make my racer, which is just a turtle. I'm going to set its color. I'm going to set its shape. I'm going to set its kind of heading so it goes in and is facing upwards. And then I'm going to add it to this list. So I'm going to say turtles.append, and then I will append my racer. This way, I have access to all of my turtles, and then later on, I can actually say move these turtles forward, right? And we'll move them by a random amount, and that will kind of simulate these turtles being raced. Now, I'm just looking at my other screen here. One more thing that I'm going to do here is I'm actually going to put my racer's pen up. So I'm going to say racer.pen up. I'm then immediately going to say racer.pen down. And inside of here, I'm going to set the position of my racer. So we'll just say set pause, and we'll do that in 1 second. All right, so now let's run this code here. So Python turtle race tutorial.py, let's insert our number, let's say 3. And what happened? Well, we need to call this function if we want to see anything happening. So after we get our colors, let's call create turtles, and let's pass our colors. So now we'll have all the colors here. We'll loop through them and create our racers for each. All right, so let's run this Python turtle race. Let's go 5. And notice when I do this, it kind of spins up 5 turtles. They spin to the left. They're all different colors, and then it's done. So obviously this is not ideal, right? All of my turtles start in the middle of the screen, and so I need to move them so they are at the bottom of the screen. Now I could move them like backwards, turn them left, move them to their correct position, but that's kind of a pain. So there's this method for our turtles called set position. Actually, let me make sure it's called that. Yes, it's called set pause. So racer.set pause, and this takes an X and Y value and will set the position of your turtle to, well, this position. So this is why I'm putting the pen up, then I'm going to set the position, then I'm going to put the pen down. So when I move this turtle to its position, I don't draw a line from the middle of the screen to wherever it goes, because that's just not optimal, that's not ideal, that's not what we want to do here. So inside of set pause, I need to choose an X and a Y value for my turtle. Now the Y value is pretty easy because all of my turtles will start at the same Y, and then they'll kind of increase their Y as they race upwards. So we know what the Y value will be, or we can just pick some random Y value. But what is the X value going to be? Well, I want to space these turtles out completely evenly, right? So let me open up my kind of Windows Ink pad here. Where even is Windows Ink? Okay, so I've just opened up Paint here. I unfortunately couldn't find the Windows Ink thing that I normally use. I don't know where they would have hid it from me, but anyways, apparently it's gone. So go easy on me. I'm just using my mouse, but I'm going to illustrate what we're going to do here. So we have our canvas, right? Now, our canvas is of size 500 by 500, but to make math a bit easier, we're going to say it's 400 by 400. Again, my mouse is really hard to draw with. Okay, so 400 by 400. Now, we want all of our turtles to kind of be placed near the bottom of the screen. So to pick this position is pretty easy. We can kind of just take like the height of the screen, we can divide it by 2, we can add a small value to it, and then we'll say, all right, well, that's where we want to place the turtles at that negative coordinate. Because right here in the middle is 0, 0, right? So as we go down, this is negative. So if we place that negative 200, they'd be like right at the bottom of the screen. So we can move it up like 10 pixels, and then that would bring us to this kind of red line that we have right here. Now the question becomes though, what are the X values of our turtles? So obviously we want our turtles to be kind of spaced out. If we have 2 turtles, we probably want them somewhere like here and here, right? Want them equal distance from each other and then equal distance from the edge of the screen. Now I know this isn't exactly equal distance, but hopefully you're kind of getting the idea. Now if we have 3 turtles, we want one guy in the middle, one guy here, and one guy here. This way they're equidistant from the edge of the screen and from each other. So how do we figure out the X positions? Well, what we actually need to do is we need to figure out, first of all, the spacing between our turtles. Then what we can do is we can start our first turtle at whatever the spacing amount is. We can then add whatever the next spacing is to our next turtle, and then our next spacing, and so on and so forth. So how do we figure out the spacing between the turtles? Well, we actually take this number right here, this number right here, which is the width of our screen, and we divide it by the number of turtles that we have plus 1. So I want you to see this example. If we take 400 and we have 4 turtles, a lot of people would say, well, the spacing between each turtle should be 100 pixels. Now, the reason why that would actually be incorrect is because that would assume the first turtle starts at the far left-hand side of the screen. So if I put my first turtle right here, and then I go 100 pixels over, my next turtle is at position 100, right? If we're talking about the X. Then my next guy comes over here and he's at 200. And then my next guy comes here and he's at 300. It's really hard to do a 3 clearly. This is my attempt at a 3. Okay, so 100, 200, 300, and then this first guy's obviously at 0. So we don't want that. We want to kind of shift this whole line over so there's equal distance between all of the turtles and the edge of the screen. So what we really need to do is we need to divide this number by 5, and then we need to start our turtle at the first spacing position. So if we take 400 and we divide this by 5, oh god, this is testing my math skills. 400 divided by 5 should give us a value of 80. Yeah, I think 80 is correct. 8 times 5, yeah, 40, 400, yeah, okay, 80 is correct. So now if we do this at 80, let me kind of erase all of this here. We'll say that our first turtle gets placed at position 80. So the first guy goes right here. Should I even attempt to do an 8? Okay, we have 8, 0. Then our next guy is going to go at 160. And then we'll move over again. And then our next guy is going to go at 240. Our next guy will go at 320, and then this will be perfect. We'll have our 4 turtles. They'll be equidistant from the edge of the screen and equidistant from each other. Now, I know this seems like they're not equal distance because I've kind of drawn this not to scale, but that's the idea behind this. So hopefully this long explanation gave you the idea of what we're doing. We're going to divide the value that we have here by the number of turtles plus 1. Then we're going to place the first turtle at spacing position, so whatever the spacing is, so starting at 80, the rest of them will go up by the increment of spacing every time. So we'll leave that kind of open in the background in case we need to refer to it again, but this means we are going to set the position, and we need to figure out the turtle spacing. So I'm going to say spacing x is equal to, and then the len of colors, this is the number of turtles that we have, right, plus 1. We're going to put these in parentheses, and we're going to start by dividing the width by 2. So we're going to say width divided by 2. Sorry, not width divided by 2. Width divided by the len of colors plus 1. So whatever our width is, we divide it by the number of turtles plus 1, which is really just the number of colors that were given to us. And there we go. So now, where do we want to start placing our turtles? Well, what I was showing you before is I was saying we're placing at 0, 80, so on and so forth. The only issue with that is that when we're at the left, so we're to the left of the middle of the screen, we're at a negative coordinate, right? So really, when we're drawing the kind of coordinate axes here, this is 0, 0. So as we're over here, we're in the negatives. So that's fine. All that means is we need to add the negative width over 2 as our starting position to all of these right here. So the first position for our turtle will actually be at negative width over 2 plus this value right here. The reason that will work is because we will subtract this by negative 200. And then negative 200 plus 80, that will be equal to, what is this, 120, negative 120. Then we will go and be equal to negative 40. Then we will be equal to 40. Then we will be equal to, what's 80 plus 40, 120. And that will work. And that will still give us the equal distance. And it will just kind of translate everything over to the left, which is what we want it to do. So hopefully that's making sense. We just need to account for the negative coordinate system. So we're going to set position at negative width over 2. And then we're going to add to this I plus 1, let's guess why we need to do that in a second, multiplied by, and then the spacing x. So this will be our x position, and our y position will be equal to negative height divided by 2 plus 20 pixels. Now, this is kind of an arbitrary value I'm deciding. I'm saying we want to be 20 pixels from the bottom of the screen, so we take the negative height divided by 2 and add 20. The reason we have the I plus 1 is because we start indexing at 0, so the first color is 0. Really, we want to make that 1 because remember, we want to place the first turtle at the first spacing position. So negative width over 2 plus whatever the spacing x is, that's where the first turtle should go. Then the second turtle, well, that will be a 1, so that will give us 2, so then we'll be at the second spacing position. Then the third, then the fourth, so on and so forth. So this should place our turtles in the correct position. Let's see if it does so. So let's run our code here, and let's say we want to have 8 turtles. So when we have 8 turtles, notice that now we're going to move the turtles. They are perfectly aligned on the screen, and they have equal spacing between each other and between the edges, so that's awesome. Now all we need to do is just return our turtles like that. And now that we've created the turtles, we've placed the turtles, we've picked our colors and the number of turtles that we have, we can start finally racing them on the screen. All right, so now what I'm going to do is create a new function. I'm going to call this function race, and this function race is going to take in our colors. Now I'm going to change kind of the flow of our program a little bit. Let me zoom out here so you guys can kind of read more of what's going on. So right now what we're doing is we're getting the number of racers, we're initializing our turtles, we're picking the colors, and then we're creating the turtles. That's great, but I don't want to create my turtles until I'm ready to race them. So I'm going to take this create turtles kind of function call here, and I'm going to put that inside of this race function. Now the idea is that we're going to pass the colors to race, and then race will create our turtles for us. So we'll say turtles is equal to, and then create turtles, because this function returns the turtles. So then inside of here, we will create all of the turtles using our colors. And the reason this is important is because I want to know what color every turtle is. And by having access to colors and turtles, I can do that. So now rather than calling create turtles down here, we're just going to call race. So we're going to say race and then colors, and then this will create our turtles for us. And then in here, we can race them. So after I create my turtles, I want to start racing them. I want to start moving them. So I'm going to say while true. And then I'm going to move all of my turtles one by one. Now, the idea behind this is that we don't know how long it's going to take us for our turtles to get to the top of the screen. So what I need to do is have a while loop because I need to keep moving them until eventually one gets to the top of the screen. So inside of here, I'm going to say for racer in turtles. And then what I'm going to do is move this racer. So I'm going to say racer dot and then move. And sorry, this shouldn't say move. This is actually going to be racer dot forward because it's now facing the correct direction. It's facing up. So when I move it forward, that's the direction it's going to go in. So racer dot forward, and then I want to move it forward a random amount. So I'm going to say move is equal to, or maybe distance is a better variable name. Distance is equal to random dot and then rand range. And inside of here, we're going to put the minimum and maximum amount we want the turtle to possibly move at every iteration. So I'm going to say 1, 20. And what this means is every time I decide to move my turtle, I'm going to move it by either 1 or 20 pixels, or sorry, between 1 to 20 pixels. So it will randomly generate a number that is between 1 and 20 and move the turtle that amount. That's what rand range does. So you can make these values whatever you want. The larger you make this minimum value, the faster your turtles are going to move. And obviously, the larger you make this one, the higher probability your turtles are going to move faster. But really, this minimum value will dictate kind of the slowest speed of the slowest turtle, right? So just keep that in mind. I like to keep it at 1 so that the race kind of looks like they're like kind of inching forward rather than having big jumps every single time. Anyways, we're going to say racer.forward. We're going to move it forward the distance. Now, once we've moved our racer forward, what we want to do is check if this racer is kind of past the finish line. So the reason we're looping through all of the turtles, first of all, is because we need to move every single one of them. We have a list of turtles, right? We've created all of these turtles here, stored them in a list. Now we need to move every single one of them. So we loop through all of them and then we move them. Now for every racer, we check if it's past the finish line. So I'm going to say x comma y is equal to racer.pause. What this does is give me the position of this turtle. So I know the x and the y. I don't care about the x. I just care about the y. I'm going to say if y is greater than or equal to, and then height, and this is going to be divided by 2, and we'll subtract 10 here, then what I want to do is I want to say that this turtle crossed the finish line, that it was the winner. So to do that, I'm just going to return this turtle's color. So if this turtle passed the finish line, then it is the winner. What this function is going to do is it's just going to return whatever the winning turtle is. It's going to return the color of the winning turtle. So we'll say return, and then here we will return, and this is going to say colors at index I. Now, this may be a bit confusing, but the idea here, and oops, index I can't even use that. Okay, I'm going to show you a different way to do this. I thought I had coded this in a different way. I'm going to say colors at, and then this is going to say turtles.index turtle. So this may be a bit confusing if you guys haven't worked with lists before, but this is the rationale. We want to find the winner, the winning turtle color. We want to know the color of the winning turtle. So to do that, we need to access its color. Now, I don't think there's a way to get the color of a turtle from the actual turtle object. I may be wrong on that, but all we have access to here is just the turtle, right? We have the turtle that we're moving. That's all we have. So this kind of turtle.turtle, that's all we have. So the question then becomes, okay, how do I find the color of it? Well, I have the colors of all of my turtles here. So what I can do is I can find which turtle or the index of the turtle that was the winner, and then I can use that same index to figure out the color of it in this colors list. So think of it this way. If I have a list of colors, I have like blue and red, and then I have my 2 turtles, right? So let's just say I have turtle 1, and I have turtle 2. Well, turtle 2 is at index 1, right? So we have index 0 and index 1. So turtle 2 is at index 1. So if I can find the index of this turtle, all I have to do is reference that same index in my colors list, and that tells me the color of it, right? Same thing for turtle 1. Well, turtle 1's at index 0. Its color must be index 0 in the colors list. This expands with any length of turtles. So what turtles.index does is, notice this is the name of the list. I'm then passing the turtle that I'm looking for the index of. It tells me the index of this turtle. So, and sorry, this should be changed actually to be racer. That's my bad. I was probably confusing you guys there. But we have access to the turtle. So we say turtles.index racer gives us the index of this turtle object in the turtles list. We then use that same index on the colors list to reference the color of that turtle, and we return it. So not really much more I can explain there. That's probably the best that I can do for that. We're going to return the actual color. Now that we have the color, down here, we'll say winner equals race, and then we can just print out winner. The idea being that this function is only finished once we return this color. So just in case you're aware, or just in case you're unaware, sorry, in a while loop, whenever you return something, or just in a function in general, as soon as a return statement happens, the function immediately stops. So even though this is inside of a while loop, the while loop will stop running as soon as one of the turtles has won. So let's just run this code. Let's just see if this works, then I can explain to you some more kind of details about this. So let's go here, Python turtle race. Let's go with 5 turtles. So we're going to create our 5 turtles, and then they're going to start racing. So they kind of start racing up the screen. Notice that they're drawing every single time, and then boom, it says pink. The reason it says pink is because if you saw, pink was the first turtle to cross the finish line. Now it's worth noting here that there is a little bit of a bias in the first turtle. So the very first turtle has a very, very small probability of finishing earlier than all of the other turtles. Like it has a better chance of doing that in a sense because it's the first turtle that we move. We have to move the turtles sequentially. Like we can't move all of them at the exact same time. So we move the first turtle, then the second turtle, then the third turtle, then the fourth turtle. We check if any of them are past the finish line. Whatever one crosses first, we say that's the winner. So it's just a higher probability that the very first turtle we move will finish first. So the last turtle kind of has, the least chance of winning. But based on this randomness here, it ends up kind of counteracting that in some type of sense. So hopefully you get what I mean. I'm not going to worry about that for this problem right here. If you guys were concerned about the fact that one turtle has like a little bit of bias, which it kind of does, what you could do is you could see if one turtle crossed the finish line, and then if a turtle crossed the finish line, you could still move every other turtle, and whatever turtle moved the furthest, so was like the furthest past the finish line, that's the one that you would say would be the winner. There's no way other than that to really kind of fix this problem. So anyways, that is really all we need to do here. Like that is it for this program. So the last thing I'm going to do is I am going to print out in kind of a nicer way what the winning turtle is. So I'm going to say the winner is the turtle with color, colon, then comma, and I will say winner. So that's all we'll do. So now we just have a nicer kind of output message saying this was the winning turtle. And then I'm going to say time.sleep. And I'm going to sleep for 5 seconds just so that we have a few seconds to actually see which turtle was the winner before we just go ahead and close the program. So hopefully that's clear, but yeah, that's really all we need. So let's run this. Let's go with 10 turtles this time, and let's see what we get. Let's just enjoy the turtle racing show. Okay, so they're going to race. You're going to notice the more turtles you have, kind of the slower they go. Just because we have to move every single turtle one at a time. We can't move like a bunch of turtles. Like the more turtles we have, the more we have to move, and so the longer it takes to run. That's what I'm trying to say. But we saw that the winner is the turtle with color green. Let's run this one more time with 2 turtles, and you'll see that it goes like way faster because it's just these 2 guys that need to move. Purple was the winner. And then if we kind of go back into CMD, it says the winner is the turtle with color purple. Awesome. So I think that's really all I need to show you here. Now, all of this code will be available to download from the description in case you got lost or something's not working, but hopefully I did a good job at explaining a lot of these concepts. Hopefully you guys kind of learned how you can lay out I don't want to say large, but medium-sized Python program that has more than just a few lines of code, and you get the idea behind these functions, right? So now at this point, if I want to go change something, like say I want to change the width of my screen, since I use this width variable everywhere in my program and everything I did was very dynamic, right? I had like height over 2. I had width over 2. If I change the width up here now, everything will just work, right? Like if I change this to 700 and I change the height to 600, it doesn't even have to be square. Let's just run the program again. Let's go with 6 racers, and it's still going to be evenly spaced out on the screen. Right? Just because the way we did this is everything was dynamic, it used the variables, and we set it up in a way where if we made any changes later on, it wouldn't completely ruin or mess up our program. And what does it say the winner is here? The winner is turtle with color blue. So just keep that in mind. Hopefully you appreciate that kind of detail in writing this code. And same thing here, even with like validating the input, right? We're going to keep asking the user for a valid input until they give us something that's valid. And then race, we're using another function. Inside of this function, we could have just taken whatever, all of this code and placed it inside of here. But if we did that, then if we wanted to change the way that we were creating our turtles, well, we could do that, but it would just be a little bit harder. And if we wanted to say use this function anywhere else, same thing, just wouldn't work as well. So this way it's really easy to see, laid out very nicely, and this is just a better style of coding than writing everything in one line, right? Because we could have written this entire program in just one line, like we didn't have to use any functions. It could have just all been in the main line of the program, but then it wouldn't be very clear to see what part of the program was doing what. So you can see here I have my terminal open. It says, welcome to this typing test. You'll be given a block of text and need to type it as fast as possible. Press any key to start. So I'm going to start, and then it's going to bring up the text like this. Now I'm not going very fast right now, but the point is that we can just type the text. And if I get something wrong, so notice I'm getting something wrong here, it's highlighting in red. So this is something that, you probably don't already know how to do, and that is pretty simple actually, but I'm going to show you how to do in this video, how to get all of the text highlighting and kind of nice styling as you see here, and then the ability to clear the entire console. So you can see here, it says you completed the text, your WPM was 55. So I'm going to hit enter, and it says, do you want to play again? Let's play again, brings up some text. It actually does randomize the text, but in this case, we just got the same text that we had before. Anyways, there you go. That is the demo of the project. Now we're going to hop into the code. I'm here in my text editor. I'm going to be using Sublime Text for this video. Not really that important. You can use whatever you want. Anyways, what I've done is opened up a folder, and then inside of this folder, I have a file called tutorial.py. Now I'm going to recommend you do the same thing. Make a folder somewhere, probably put it on your desktop, put a file inside of there that is a Python file, and then you are good to start working. Now, as you guys saw, we had some really nice styling for our terminal. We had some different colors, and we were able to kind of write over the previous text. Now, the way we were able to do that was by using this module called Curses. Now, this is built into Python if you're on Mac or Linux, but if you're on Windows, you actually need to install it. So if you're on Windows, you need to follow along with this step. Otherwise, skip forward into the video until we actually start writing some code. Okay, so if you guys are on Windows, what you need to do is open up your command prompt here. And we're going to type the following command to install the Windows version of this Curses module. I'm going to say pip install, and then this is going to be Windows-Curses like this. So you should run this command, and it should install this for you. And if for some reason this command does not work for you, I will leave 2 videos on the screen. They'll be linked in the description as well, and there'll be cards on the screen showing you how to fix this pip command. Now they're called How to Install Pygame. Just follow along with the exact same steps, except instead of installing Pygame, you're going to install Windows Curses. Now you also can just try here, pip install, and actually, sorry, this Python-m pip install, and then Windows-Curses like this, and see if this command works for you. And if this doesn't work, then again, follow along with those 2 videos. Anyways, this should install the Curses module. And once you have the Curses module installed, then we are ready to go. Okay, so I have Curses installed, and this is what allows me to do the styling of the terminal. So the first thing I want to show you how to do is just to use this module and to kind of print stuff out to the terminal, because it's going to be different than what we typically do. We're not going to be using the print and the input statements. We're going to be using some statements from this module. Okay, so the first thing I'm actually going to do here is write another line, and I'm going to say from Curses import wrapper. Now, what this is going to do is give me something that allows me to initialize this Curses module, because when I initialize the module, what's going to happen is it's going to take over my terminal, and it's going to allow me to kind of run some different commands on it. So I use this wrapper, it initializes Curses, and then as soon as I'm finished with the program, it will kind of restore the terminal back to its previous state. So it's pretty important that you do this. Anyways, what I'm going to do here is say define main, and inside of main, I'm going to put a variable here, which is going to be called std_scr, standing for std screen. Now, std is your standard output. So the standard output is just kind of the terminal. It's where you're writing stuff out to. And what this module does is kind of take that over and give you a screen over top of it that allows you to write stuff to the screen. Anyways, that's what this is doing. So it is the standard output screen. Okay, perfect. So now that we're inside of here, for now, what I'm going to do is show you the most basic thing, which is just adding text to the screen. The way you do this is you say std_scr dot add and then string like that. So then inside of here, in quotation marks, you just put the text that you want to print out to the console. So just like a print statement, I'm going to put the text hello world. Okay, that's it. This is just going to output the text for you. Then what I'm going to do here is I'm going to call wrapper and then pass my main function. Now this might look a little bit confusing, but what I'm doing is I'm passing this main function to this wrapper function. So it's actually a function. I just call it like this using the parentheses. I pass main inside of there, and it's going to actually call this function while initializing all of the stuff related to this module. So anyways, that's the first step. All this is going to do is print hello world out to the screen. Now, before I do that though, I actually want to clear the entire screen, because if I don't clear the entire screen, we're going to have a bunch of junk on there. So what I want to do is I want to say std scr dot and then clear. This just clears the entire screen for me. And then as soon as I do anything, so I add text, I need to refresh the screen. So the way I do that is std scr dot and then refresh like that. Perfect. Okay, so this will actually print hello world out for me. All right, so now that we have all of this, I actually just want to add one more line here. I'm going to say std.scr dot and then get key like this with 2 parentheses. What this is going to do is just wait for the user to type something, so that way it doesn't immediately show this and then close the screen. Because right now, if we run this code, what's going to happen is it will print hello world, it will refresh, we'll see it for like a millisecond, and then it will end. We need to add this get key so that we don't immediately close the program. We wait for the user to type something, and then we finish it. Okay, so now that we have that, we can run this code. Now, to run this code is a little bit trickier than your standard Python code. You actually need to run it from your terminal or your command prompt. That's because this requires a terminal or command prompt to actually show you the correct output. So what we're going to have to do here is open up a command prompt or terminal, again, depending on your operating system. And we're going to have to get our working directory, which is right here on the left-hand side, into the folder where this file is. Now, I'm going to show you a shortcut on Windows here to do this. And on Mac, I'll describe kind of how you can do the shortcut. Obviously, I'm not on Mac, so I can't quite show it to you. Okay, so I'm going to open up my Windows Explorer here, and I just have it on my other screen right now. I just need to hide some of my files. And what I'm going to do is navigate to the path where my file is. So I assume you know where your file is. I mean, you should know where you placed it. And anyways, you can see here that my tutorial file is directly inside desktop and then beginner project. So what I'm going to do is click on this menu bar here. So notice where it's showing the path. I'm just going to delete all of this and type CMD. Now, when I do that, it's going to open up a command prompt. And notice the working directory, which is on the left here, is directly inside of beginner project. So all I'm going to do now to run the code is type Python and then the name of my file, which is tutorial.py. Now I'm going to hit enter. And when I do that, notice it shows me hello world. And when I hit enter again, it brings me back to my terminal. Okay. That's how you run the code. Now, if you're on Mac, you can do a very similar thing. You can open up your Finder, you can navigate to where your Python file is, and then you can right click and there should be something that says Open Terminal. Now, if you can't find Open Terminal, what you're going to have to do is use the following commands. CD like this. So CD stands for change directory. And to go to the parent directory, you type cd ... So notice that brings me to desktop. That's the parent directory of beginner project. Then if I wanted to get into beginner project, I would type CD and then beginner project like that. It would bring me into that directory. So from wherever you are, you need to change your directories into the correct directory where your Python file is, and then type Python space and then the name of the Python file you want to run. Now, for some reason that doesn't work, type Python 3 and then the name of the file. So for me, it's tutorial.py, but for you guys, it will be probably something else. Hopefully that clears it up. It's hard to explain that more because I'm not actually on Mac, but you need to open up a terminal and get this directory here on the left-hand side to be the directory where your Python file is. Or what you can do is you can look for the exact path of your file and type Python and then put the exact path. So it would be on Windows, something like C:/ and then the path to it, or on Mac, maybe Python 3 and then the path to the file. Anyways, that's pretty much all that I can explain for right now, but that is how you run this code. Okay, so now that we know how to run this, let's talk about how we can add some colors here and kind of style it a little bit. All right, so if we want to add color to our text, what we need to do here is create something known as a color pair. Now, a color pair is just a foreground and a background color. So the foreground is the text, the background is obviously what's behind it. So what I'm going to do is I'm going to create a pairing of a foreground color and a background color, and then use that pairing to print out my text. So I'm going to say curses dot and then a init_pair at the top of my function here. And it's important you do it in the function. If you try to do it outside, it's not going to work. You can only do this once you've initialized curses, and that's going to happen when we call this wrapper function and then it calls the main function. Anyways, I'm going to say curses.initPair. I'm going to put the ID of my pair, which is going to be 1. And then I'm going to say curses dot, and then this is going to be color underscore, and then whatever the color of the text is that I want. So in this case, I'll go with green for my foreground color. And then for my background color, which is the second color you pass, I'm going to say curses dot, and then we'll go with color underscore, and let's just go with white so that we can see kind of, a lot of color here. Okay, so what I've done is I've said that I want to have the pairing with the foreground color green and the background color white be represented by the ID 1. So I need to put an integer here, and this integer kind of represents this pair. So if I wanted to make another pair, then what I could do is the same thing. And I would just change the integer here to be 2. If I had it at 1, then it would override what this pair was. So I wanted to change it to 2. And then I could make this something like color dot. And then can we go with yellow? Let's go all capitals yellow and see if that's a valid color. Okay, so now we have a pair with 1 and 2 as the ID. So to use this, what I'm going to do is go inside of my add str here, and I'm now going to reference this pair. Now the way I do that is I say curses dot color underscore pair like this, and then inside of the brackets, I just put the ID of the pair I want to reference. So if I want it green and white, then I put 1. If I wanted it yellow and white, then I would put 2. And if I just wanted the default color, I just remove this. I don't need to include it. Anyways, let's give this a test here and see if this is going to work. So I'm going to go to my terminal and go python tutorial.py, and notice we get green text with a white background. And then if I hit any key, it's going to escape and bring me back to the terminal. Perfect. Let's try this now with the color pair 2 and run this. And notice we get yellow text on a white background. That looks pretty ugly, but that is fine. So for now, the pairs that I want to initialize are actually just going to be red. Let's go with blue. No, do you want blue? No, let's just go with red, green, and white. And then we can use those pairs throughout the program. So I'm going to say curses.init pair. 1 green is perfect, but for the background, I want the background to be black. Then I want one that is going to be red. So I'll say color red and color black. And then I want my last color just to be the standard white text. So I'll go 3, and then this will be color white like that. Okay, perfect. And for now, we don't need to add any color to that. Okay, so now we have our 3 colors. We have 1, which is green, 2, which is red, and 3, which is white. So now that we've looked at the colors, the next thing I want to show you is how we can locate text differently on our terminal, or kind of place it in a different place based on where we want to put it. So in this std scr.add string method, that's a mouthful, what we can actually do is specify the position, so kind of the row and column that we want to start this text at. So I'll show you what I mean, but for now, if we go with something like 1, 0, what this is actually saying is I want to go 1 line down and start at the 0th character. So start all the way furthest to the left, but 1 line down. So you go kind of your row and then your column. That's how this coordinate system works. Now you'll see very quickly how this works. It's pretty straightforward, but if I run this, notice that now we're just on the 2nd line down in the terminal. So it's very easy to kind of place text in different places. Now, if I go and do this like 1, 5, you're going to see that now we're going to be 5 characters over to the right. So if I run this, now we're 1 row down, 5 characters to the right. So we start writing from that place, okay? Hopefully that is clear. Now let's just see what happens if I actually write something else. So let's write this at like 1 and then 0 and see what happens when I kind of have 2 colliding pieces of text. So let's do this. Let's hit enter. Let's run the code. And notice that the hello world I wrote second kind of overrides what was already on the screen. So that can happen, and that will happen based on how you're writing stuff out. And that's exactly what we're going to do to kind of have our green text go over top of the white text when we're trying to type out the target text when we're doing kind of our speed test, right? So I just wanted to show you that. You can kind of pick the location on where you want this text to go. You just pass before the text the coordinates. So you go either the row and then the column that you want to place this in. And if you just want it to be at the top left, you can just leave it. You don't need to add anything, or you can explicitly say 0, 0 like that. Okay, so now we have pretty much gone through everything in the curses module. The last thing I'll show you is that we can actually get the key that people type. So notice here that I said std scr.getKey. So what I can do is store this in a variable and just print this out. And now this will actually tell me the key that the user typed in. And you'll see why this is important in a second, but we're going to need to register the user's keystrokes so that we can see what they're typing and keep track of their word per minute, right? So that's what key will do for us. We'll get the key that the user types. So let's go to our terminal. Looks like I closed it, so I'm going to have to open it again. Okay, so I've got the command prompt open now, and I'm just going to run this code. So python tutorial.py. I'll hit the key E, and then notice it prints out E because that's the key that I hit. Okay, now we've gone through the curses module. Now I want to start kind of building this speed test or this game or whatever you want to call it. So the first thing I want to do is kind of have a start screen here that says, hey, would you like to play the game? And if they say yes, or they hit any key, then we will, like continue with the game and we'll get into the game. So I'm going to write a function here. I'm going to say define start underscore screen, and this is going to take the std_scr. Now, the reason we need to take this is because we need to have access to this object to be able to write to the screen, because notice we're using the add string method, we're using clear, we're using refresh. So we need access to this to be able to actually write something onto the screen using the curses module. Anyways, what I'm going to do is I'm going to steal these lines right here. So clear, add string, and refresh, and I'm just going to put them inside of start screen. And what I'm going to say is press any key to continue, and I'll give kind of a description of the game. So I'll say, welcome to the speed typer test or whatever, speed typing test maybe. And then we can do a new line. So let's get rid of this here. And let me show you how we can print something on a new line. So we can use the coordinate system. We can do something like 1, 0, or what we can do is we can print this character, which is a \n. Now, when you print a \n, what this does is it brings the cursor down to the next line, and you're going to start writing wherever the cursor is. So after I print this out, my cursor is going to be at the end of this line. And if I were to print something else, so I were to do this line here, it would go right after it, kind of be squished together. But if I wanted to go down to the next line, I can put in this escape character called \n. This is the new line character, and it makes me go down to the next line before I start typing. So now I'll say press any key to begin. Okay, welcome to speed typing test. Press any key to begin. Boom. And then what I will do is refresh the screen, and I will just say key is equal to this. And I actually don't even need to store the key. I just want to wait for the user to type something. So that's what I'll put right here. Okay, that's awesome. So now what I can do is just call this start screen function from inside of this function right here. So I'll call start screen and I'll pass the std_scr like that. And now what will happen is when I run the main function, we'll initialize our colors, we'll call the start screen, we'll do this, and then we'll continue. So let's test this out before we go any further. Let's go Python tutorial.py. Welcome to speed typing test. Press any key to begin. Boom, and then we begin. Okay, so now that we've done that, we need something to kind of store what our target text is. We want to print that target text out to the screen and then ask the user to start typing it in. So I'm going to make another function here. And notice I'm kind of splitting all of my code up into different pieces of logic. That's a good practice you should try to get in the habit of, but that's what I'm trying to show you here. Anyways, I'm going to say define WPM_test, standing for words per minute test. We are going to take the std_scr like that. And inside of here, we're going to actually print out kind of what our target text is and then get the user to start typing it in. So I'm going to say target_text is equal to, and for now we'll go with hello world. This is some test text for this app, ! And this is what we want the user to type in. So we want to print this out, and then we want to print whatever the user has typed kind of over top of it, which you'll see in a second. So now I'm going to say current text is equal to, and I'm going to make a list. You'll see why we need this in a second. And for now, all I'm going to do is clear the screen, refresh it, and then actually print what this text is. So we'll start with that, and then we'll kind of keep track of what the user's actually typed. So I'm going to steal again these lines because we're just going to keep reusing them. And I'm going to say std_scr.addString. And rather than welcome to speed typing test, we'll just put the variable target text in here because this is what we actually want to display. So we're going to get the target text, which is this. We're going to have our current text, which will be what the user has typed. We're going to clear the screen, add this to the screen, and then refresh. And then again, we'll just get key. Okay. So now after we get past the start screen, what we want to do is call the WPM_test function like this and pass this. Okay, so let's give this a run and see how this is working. Python tutorial.py, let's hit enter. Notice it says hello world, this is some test text for this app. And when I hit enter, or any key for that matter, then it exits. Great. So now that we've done that, what I want to do is actually register the user's key presses, and then I want to take whatever they're typing and kind of overlay it on top of this. So as you saw in the demo, if they type the character correctly, I want it to show up green. If they type it incorrectly, I want it to be red. Okay, pretty straightforward. So what I'm going to do here is I'm going to start a while loop. So I'm going to say while true, and I'm going to continually kind of ask the user to type something in. And every time they type something, I'm just going to overlay it in a different color on top of the target text. So we're going to have to change this drastically from what I do right now, but this is just an example so you can see how this is going to work. So what I'm going to do is say key is equal to, and then std_scr dot, and then get key, which means I can remove this one right here because we're immediately going to jump into the while loop, and then we'll get the key. Then I'm going to add this key to the current text, and I'm going to draw the current text onto the screen. So I'm going to say, let's go current text like this, dot append, and I'm going to append the key. So we're going to have a list of all of the keys that the user has pressed. Then I'm going to loop through every single one of these keys using a for loop, and I'm going to kind of place that character onto the screen. So I'm going to say for, and we're going to go with char, standing for character, in, and this is going to be current text. What I'm going to do is say std scr dot, and then this is going to be add string. We're going to add whatever this character is, comma, and then I'm going to put the color that I want this to be. So in this case, I want the color to be, let's go with green. So that's going to be pair 1. So what do I need to do? I need to say curses dot, and then this is going to be color underscore pair 1. Okay, so let's just go through this quickly to make sure everything is clear. So what we're doing is we have the target text, we have the current text, we are clearing the screen, we are adding the target text to the screen, we're then refreshing the screen. We're then going to ask the user to enter a key. So when I say get key, this is going to wait for them to type something. As soon as they type that, we're going to append that to the current text. Then we're going to loop through every single character that they've typed, because they're going to be storing that in a list. So for char in current text, we are then going to display that character on the screen. So we're just going to add it, and it will be in a different color. Okay, now one thing that I want to do here is I want to constantly do this. So you'll see why I want to do this in a second, but I'm going to go here, and I'm going to add this string, the target text, and then after I add the other string, I'm going to refresh. So I'm going to clear the screen every single time this while loop runs. I am going to add the target text to the screen. I'm then going to add the other text onto the screen, so whatever the user has typed in a different color, and then I'm going to refresh the screen so that you see it. So this way, I'm not going to continually keep adding the same text to the screen. I'm going to clear everything and then add whatever I currently have. If the user adds another key, I'll add that as well. You'll see why I need this, but I'll show you if I don't clear what's going to happen in 1 second. Anyways, let's run this and let's just see what's happening. So it says press any key to begin. Okay, so hello world, this is some test text for this app. And now let's just type something. So let's go H, and notice it's showing up on a new line all of the characters that I'm typing. So that's exactly what I expected. Now, if I didn't clear the screen, what would happen is we would write all of this like multiple times onto the screen. So let me show you this. I'm just going to get out of this. Actually, we didn't even make a way to exit this. So I'm going to hit Control C. Okay, that doesn't work. We're going to have to just close the terminal because I didn't make a way to exit yet. We'll have to do that in a second. Anyways, if I don't clear the screen here and we rerun this, so let me go to my terminal. So CMD, cd desktop, cd beginner project, and python tutorial.py. Now watch what happens when I start typing, okay? So first of all, you can see that it didn't clear, but if I type this, it's going to repeat all of the text a ton of times, right? Because we're not clearing what we previously had. We just keep adding what we had to the screen. So that's kind of what I was getting at. That's why we need to clear. So anyways, let's make sure we include this clear. And now what I want to do is include some way for the user to actually exit the program. So I'm just going to check if the key that they hit was the escape key. And if they hit escape, I'm going to allow them to exit because obviously we want some way to get out of this program. So before I add this to the current text, I'm just going to check if the ordinal value of this key, and I'll explain what that is in a second, is equal to, and then 27. Now, if it is, I'm just going to break. What break is going to do is just get me outside of this while loop, so we'll break this infinite loop. Now, the ordinal value of a key is its numeric representation on your keyboard. So every single key on your keyboard has some number that represents it, and this number is known as the ASCII representation or the Unicode representation. You don't have to really know what that means. ASCII stands for American Standard something, something, something. I think it's like American Standard Code Information, whatever. Someone smarter than me in the comments will tell you what it stands for. I forget, or maybe I'll throw it up on the screen. Point is, every single character has some number that represents it. So I know that the character lowercase a is represented by 97, uppercase a is represented by 65, and it just so happens that escape is represented by 27. So we're going to check the ordinal value. When you take the ordinal value of an individual character, which is what the key will be, it will give you what it is. So if it's 27, then we'll break. That means they hit the escape key. Okay, hopefully that makes sense. We can test that out though. So let's open up our command prompt. So let's cd to desktop, cd to the beginner project, and then go Python, and then tutorial.py. And now if I hit escape, Notice I'm going to exit and I am all good. Perfect. That is exactly what I wanted. Now, one thing I will do here is I'm going to show all of this before I ask the user for a key. The reason for this is right now I'm having to hit the key kind of 2 times before it shows anything. So I want to show this first and then ask the user to kind of type in a key. And when they type in that key, then we'll add it to their current text. Now, one problem that we're going to run into here is that there's a bunch of special keys that the user could hit. For example, the backspace. If the user hits the backspace, I don't want to display the backspace character. I actually want to remove one of the characters that they typed. Now, since we're kind of doing this in curses, we have to manually handle all of this. So when I hit backspace, it's not just going to move me back. It's actually going to show kind of a really strange character on the screen. So let me show you what I mean. But if I run this code, so python tutorial.py, let's hit enter and let's hit the backspace. Notice that it's bringing my cursor backwards. But if I start typing stuff here, it's not actually going to delete that stuff, right? It's just bringing the cursor back. It's not actually deleting anything. So when I hit backspace, I want to delete the text that I was typing. So let's see how we can do that. So what I'm going to do now is after I check if the ordinal value of my key is 27, I'm going to say if the key is in, and then I'm going to check 3 things. Now, the first thing I'm going to check is key underscore backspace. The next thing I'm going to check, I have to actually look at here. It's going to be \b. And then the last thing is going to be /x. So \x, sorry, 7 and then F. Now, I understand this looks like complete gibberish, but the thing is the backspace key on different operating systems will be represented by a bunch of different characters. So it could be represented by key backspace. It could be represented by \b, or it could be represented by \x7f. Don't ask me why that's the representation, but that's what it could be. So just to make sure this is going to work for all of you, no matter what operating system you're on, just do this. Now, this is going to check if this key is in this. So essentially, if the key is equal to any one of these 3 things. If it is, then what we're going to do is we're actually going to pop off the last element from current text. You'll see what I mean here, but I'm going to say if the len of current text is greater than 0, then current text.pop. Now, this is one of the reasons why we used a list here to represent all of the characters that we're typing, because we can very easily and quickly remove the last character from it. So what .pop will do is it will remove the last character from a list, or the last element from a list. So if I have 1, 2, and I call .pop on this list, it just gets rid of 2. So now I only have 1, which is exactly what we want. Because remember, current text is keeping track of all of the keys that we have pressed. So if we hit the backspace, we want to get rid of the last key that we inputted. That's what this will now do. Now, we just need to put an else statement here, because if we hit the backspace, we don't want to add that backspace key to our current text. We just want to remove the current character. So we'll add the else to make sure that if this is the case, we're not still adding this key to the current text. Okay, hopefully that makes sense. Let's run this code. And let's hit enter and let's start typing. So I'm going to say hello world, and then I'm going to hit backspace. And notice when I hit backspace, I'm actually deleting the characters now, which is precisely what I wanted. So now that we've done this, let's see how we can get this text to go over top of the text that we currently have. Because obviously that's kind of what we want. We don't want this text to be, coming after it. We want it to kind of go over top of it. And then we want to change the color on if it is the correct character or not. Okay, so let me escape this by hitting escape, and let's see how we can go about doing that. So to do this, I'm just going to write a new function here because I think it makes sense to kind of separate displaying all of our, text in a separate function. So I'm going to say define display underscore text like this. We're going to take in our std source like this, or sorry, screen, not source. We're going to take in our target text. We're going to take in our current text. And then for now, we'll take in WPM as well. But I'm going to make this a default value of 0. Now, in case you're unfamiliar with this, these are parameters, which means we have to pass values to this function when we call it. And if you do something like equals 0, this means this is a optional parameter. So if I don't pass this parameter, it will just have a default value of 0. Now, the reason I'm doing this is because we're going to have to calculate the words per minute in a second, and we want to display that as well. We won't do that in this step this second, but we're going to do that later. Okay, so now that we have that, what I want to do is display the target text, and over top, I want to display the current text. So I'm going to take all of the stuff that I did here. So let's go with this right here, the add string and the character, and I'm going to paste this like that. So let's now go over here. So let's say we're going to display the target text. Then we're going to loop through all the characters in our current text, but I want to place them somewhere different. I want to place them on top of this text. So I'm going to say this for I, char in enumerate current text. Now, if you're unfamiliar with enumerate, what this is going to do is it's going to give us the element from our current text as well as the index in the list. So remember, current text is a list. Let's say we have the elements 1, 2, 3, 4 like that. What's going to happen when I enumerate over this is I is going to start out being equal to 0. 0 is going to reference this first index right here, and then char is going to be equal to 1. Now, of course, these would be characters, but hopefully you get the idea. So then the next element would be 2. So char would be 2, and I would be 1. This gives me the index as well as the element. It's just kind of a cleaner way than just going by the index and then manually getting the element. Hopefully that makes sense. But the thing is, whatever character that I am on, so if I'm on character 0 or character 1 or character 2, according to their indexes in the list, I can use that to determine where I should place this character. So I'm going to say 0, I like this. So the point is I is going to keep getting incremented by 1. This is representing what character that I'm going to place this on. And so I want to place it on the very first character, which is 0, and then on 1, then on 2, then on 3, then on 4. So this will be overlaid on top of my target text. Hopefully that makes a little bit of sense, but since I is going up by 1 in every single iteration, this means every character that I'm drawing onto the screen will kind of be incremented by 1, and it will go directly over top of my target text. So let me just show you, and hopefully this will clear it up. What I need to do, though, is I do need to call this function. So right between my clear and my refresh, I'm going to say display text, and then I'm going to pass this all of the parameters. So std scr. I'm going to pass my target text, and I'm going to pass my current text as well. Okay, and then inside of here, sorry, I'm referencing target text when instead I need to be referencing just current. Okay, hopefully that is all good. Now let's go ahead and run our code here. So python tutorial.py, let's hit enter. And now notice when I type hello, that it's going over top of my text, right? And if I hit space, of course, it's going to remove those characters because, well, that's what it's doing, but you get the idea. Okay, and then I can go like this. So now what we need to do is we need to change the color of this text based on if it's the correct character or not. Okay, but you can see that it is going directly over the top of this text. And even though it's kind of replacing the text, it looks like it's just changing the color. Okay, that's what we want. So I'm going to hit escape. And now we're going to modify the color based on if this is the correct character. Now we have what the correct characters are in our target text. And then we have whatever our current text is. So what we can actually do is we can compare every single character in our current text to the corresponding character in the target text and see if we're getting the correct one. So I'm just going to say the correct underscore char like this is equal to the target at index I. So if my target text is something like hello, and then I have my characters as like H, comma, and then L like this, if I'm accessing the 0th index, so I'm looking at the first character, I can look at the 0th index in this string, and I can check if the character I have here matches with that character. If they do, then I can show this in green. If they don't, then I can show this in red. So I'm going to say that my color is equal to, and then this is going to be curses.colorPair at 1 like that. And then I'll say if the char is not equal to the correct char, then the color is going to be equal to curses.colorPair. And then what do we use for red? I got to see this. We use 2. So let's go here and do 2. And then I'll put the color variable. So let me slow down to make sure I'm not going too quickly here. All we're doing is defining a color variable. This is equal to curses.colorPair1. So I'm just storing it in a variable. It's the same thing as if I were to directly put it inside of here. And then I'm saying if the character does not equal the correct character, then we'll change the color from the default green that I have right here to be red. And then whatever the color variable is, that's what we're going to show for this character when we draw it on the screen. And of course, we're just comparing the correct character to the current character, and we're getting the correct character by accessing the corresponding index in this string. So let me get rid of these here. And now let us try this. So let's go back here. Let's run the code. And let's hit enter, and let's go hello. And notice if I type something incorrectly, now it is showing up in red. But if I do it correctly, then we are getting it in the correct color. Awesome. Okay, so we are well on our way to completing this application. We have a lot of what we needed done. Let me just have a look at my cheat sheet here and see what we need to do next. All right, so the next thing that we need to do is actually handle what's going to happen when we complete the text. We also need to handle showing the words per minute because that's kind of the whole point of this typing speed test. So I'm going to run the code one more time and show you that if I type more characters than's in this text, we're going to get an error. Notice that we get a crash here, and it says index out of range. Now, the reason why we're getting this problem here is because we have more characters in our current text than we do in our target text, which means when we try to access target at index I, we get a list index out of range because we're trying to access an element in the target that doesn't exist. Again, that's because we have more characters in our list, in our current text, than we do in the target. So when I'm on like the 20th element of my current text here, and say my target text is only 15 elements long, then I'm going to get a problem, right? I mean, that's kind of a bad example, but you get the idea. That's what's going wrong. So we need to make sure that once we get to the point where we've typed in all of the text, or we've typed in the same number of characters as the target text, we stop and we don't let them type anymore. So what I'm going to do is after I look at the key here, and after I check if it's a backspace, I'm going to put in elif. I'm going to say elif, the len of our current text, this will tell us how many elements are in the list, is less than the len of our target text. So this will make sure that we cannot add any more stuff to our current text unless there is room to add it. So unless the current text is less than the length of the target text, we are not going to allow you to add another key. Even if they're the same, we're still not going to allow you to add anything else to this, because if you did, then that would cause the index out of bounds exception. So now let's try this and see if we're still getting that problem or not. So let me run the code. I'm going to begin, and let's just go, hello world, this is some test text for this app. I don't really care if I spell it correctly. And notice here, I'm hitting a bunch of keys, but nothing's happening because we are already at the length of this text. Awesome. Okay, so let's escape from that. All right, so now that we've done that, I want to start showing the words per minute. So we actually need to calculate what the person's word per minute is, and then we need to display that. Now, first, let's just display it, and then we can figure out how to calculate. So notice I'm taking in WPM here. So what I'm going to do is make a variable in my WPM test function and say WPM is equal to 0. So that's what it will be equal to start. Then I will pass WPM like that. And inside of here, we can just display it. So I'm going to add to the string. I'm going to say std.scr.add_string, such a mouthful here. I'm going to say in an f string, explain this in a second, WPM, and then inside of curly braces, WPM, and I'm going to put its location at 1, 0, so that we go one line below where our target text is. So what this is doing, this f string, is it allows us to actually embed Python expressions directly inside of a string without having to add two strings together. So usually you'd have to concatenate the strings, but this is a little bit nicer. You can use this in any version of Python that's 3.6 and above. So you do a lowercase or uppercase f, followed by just any string, double or single quotation marks, doesn't matter. Then you can write any regular string stuff that you would. And if you put curly braces like this, you can actually put a variable directly inside. Python will evaluate this as a string, and then you will display that. So I'm going to say WPM equals, and then just WPM, and that's all we need for right now. So if we run the code, so let's run this, and I hit enter, notice now we have WPM, which is on the line below. So now we just need to calculate the WPM, and once we do that, we will be all good. Okay, so let's figure out how to calculate that. So to calculate our words per minute, we need to know how much time has elapsed so far in the program. We can't calculate our words per minute if we don't know how long we've been typing for. So I'm going to go up to the top of my program here. I'm going to import a module called time. Now time is going to allow me to actually time how long I've been typing for. So I'm going to go inside of my WPM test function here, and I'm going to start by putting a start time variable, which is equal to time.time. Now what this is going to store is a very large number that represents the number of seconds past what's known as an epoch. Now you don't actually have to really understand this at all. The point is that this is going to tell us what kind of the current time is when we started doing this. So right before we hit the while loop, we'll record what our starting time was, and then inside of the while loop, every single iteration will calculate the WPM based on the start time. So you'll see what I mean here, but again, just kind of keep in mind that what this is doing is keeping track of the start time. It's a very, very large number that's going to be the number of seconds past a certain date. I think it's sometime in like 1970 or something. Doesn't really matter too much. Okay, so we have the start time. Now what I'm going to say is time elapsed is equal to, and then I'm going to get the current time minus the start time. So the reason why this works is because time.time, as I said, is some like really large number that is the number of seconds past a certain date. So if I call time.time again, this is now going to give me the new time. Now this time is going to be larger than whatever the start time was. So I take whatever the current time is, subtract it from the start time, and then that tells me how many seconds have elapsed. Now what I do need to do here though is use this min function, use this max function and say the max of this and 1. You'll see why we need to do this, but essentially this is going to result in us not getting a 0 division error, which we could get because what's going to happen is we're going to calculate the start time. We're then going to go into the while loop. We're going to immediately calculate the time elapsed. And the very first time we do this, the time elapsed is going to be 0 seconds because the time between when we calculated this and this is going to be like nothing. It's going to be the exact same time. So this will give us 0. And when we have 0, when we perform the next operation, that could give us a division by 0 error. Anyways, now what we're going to do is calculate the WPM. So the equation for WPM is a little bit complicated. I'm just going to write it out, then I'll kind of explain how it works. So we're going to get the len of the current text, underscore text like this. We're going to divide this by the time elapsed divided by 60. Now, the idea here is that if we have, say, 30 characters typed, so we have 30 characters, and we typed them in 30 seconds, then that means that our words per minute, our characters per minute would be 60, right? If we typed 30 characters in 30 seconds, and we're trying to figure out how many characters we're going to type in the minute, then we need to multiply our 30 characters by 2. The reason we need to multiply it by 2 is because 30 is half of 60. Now let's do the same thing except with a different time. So let's say we typed 30 characters in 15 seconds. Well, if we did that, then our words per minute is going to be 120. The reason why we know that is because we can take our time elapsed, so 15, we can divide that by 60, and that's going to give us 0.25. So we know we're kind of at a quarter of an hour. So now if we take 30, so let's take 30, and we divide this by 0.25, what this is going to give us is 120. Now you can do this with multiplication as well. I can say 30 multiplied by, and then rather than 0.25, I would multiply it by 4. And then the way I would get that is I would reverse this operation and I would do 60 over 15. The reason it's 60 is because we have 60 seconds in a minute. So that's kind of the rationale here, but this is only giving us our characters per minute. So this right here is characters per minute. We're going to get the len of our current text, which is how many characters we've typed. We're going to divide that by how much time has elapsed over 60, and that's the characters per minute. Now, it turns out that the characters per minute divided by 5 is the words per minute. So we're assuming the average word has 5 characters. So what I'm going to do is take all of this and now divide this by 5. And now this is the words per minute. So the characters per minute divided by 5 gives us words per minute. Now, one thing I'm going to do here, continues to get complicated, is I'm just going to round all of this. And the reason I'm going to round it is so we don't get some crazy decimal numbers. We just get the kind of flat words per minute, right? I'm sure that makes sense, but anyways, that is how you do WPM. Now, again, the reason why we have this max of 1 and then whatever the elapsed time is so that if this is 0, this will just give us 1, right? If it's anything less than 1, then it gives us 1. So that way, when I try to do my division, so I try to divide the len of current text by the time elapsed over 60, this isn't 0, because if that was 0, then I would get the 0 division error. Okay, so now we have the WPM, and this will be calculated every single time we hit a key. Now, I'll show you here how this works. So let's run the code, and let's see what our WPM is going to be. Okay, so notice as soon as I start typing, then the WPM will be calculated. However, right now I'm not typing, and the WPM is staying the same. The thing is, it really should be decreasing, right? But the reason it's not decreasing is because, let me escape out of here, this line in our code, key equals std scr.getKey, is actually what's known as blocking. Now, blocking essentially means that we're going to wait here. We're not going to do anything until the user types a key. We're going to wait for them to enter a key. That's what this line is doing. It's very similar to the input function in Python, right? Now, the thing is, I don't necessarily want that to happen. If the user doesn't type anything, I still want to show the WPM. I still want it to decrease, and I still want to show the text on the screen. So what I need to do is actually call this one method here that makes this call no longer blocking. Now, what I'm going to do is say std_scr dot, and then I think this is no delay, and I pass true inside of here. Now, what this essentially says is do not delay waiting for a user to hit a key. The problem is, though, now if the user doesn't enter a key, this line throws an exception. Now, an exception is an error in Python. We've seen them. So the way that we need to handle this is we need to say try like this. We need to say except like this, and then we need to say continue. So what this is going to do now is make sure that this line won't crash on us if the user doesn't type something in. And then if it does crash on us, we go into this except statement, and inside the except, we say continue. Now, what continue does is just bring us back to the top of the while loop. It's just going to skip all of this right here, because if this line caused an exception, then this key variable, it doesn't have a value, right? It doesn't work. We don't have a key because you didn't type in any key. So there's no way for me to check what key you typed in if you didn't actually type in a key or you didn't hit a key. So I need to skip the rest of this if we didn't hit a key. Hopefully that makes a bit of sense. Let's go through an example and I will show you how this works. Okay, so let me go python tutorial.py. Let's hit enter and let's start typing. And again, we're seeing that it's actually not updating the WPM. So let me have a look here and see what's going on. All right, so it turns out I just need to save the code and rerun. And now notice when I do this, everything is working, right? The WPM is going down. Now let's just change our code a bit just so I can show you kind of what was going to happen if we didn't implement this try and except. So let's get rid of the try and except. And let's now just have key equals to this. Remember, we have this std_scr.nodelay, which means we're not going to wait. We're just going to continue, right? So now watch what happens when I run the code. I'm going to hit enter and immediately my program's going to crash. We get this no input error because this line here, right, get key, didn't actually get a key. So that's why I did the try and except. I just wanted to show you that so that that explanation hopefully made a bit more sense. Okay, so now we're getting the WPM. Now we're able to type in the text. We're pretty much finished, except what we need to do is we need to figure out what's going to happen when you actually type in all of the text, right? Because at this point in time, when we type in all of the text, nothing actually happens. So we need to make sure that the user, when they get to the end of the text, they've typed in all of the characters correctly. And if they have, then what we'll do is tell them, hey, you know, you won whatever, and then we'll prompt them to play again. So what I'm going to do is right after this, I'm just going to check if the user's current text is equal to whatever the target text is. The only thing is the current text is a list and the target text is a string. So what I need to do is convert this list to a string to check if it is the target text. Now, there's a really easy way to do this in Python. When you have a list and you want to kind of combine it all together into a string, you can use something called .join. Now, what .join does is it takes a list as an argument. So I'm going to pass to this my current text, current_text like this, and you call it on a string. Now, what it's going to do is it's going to combine every single character from this list with this string right here as what's known as the delimiter or the separator. So if I were to make this a space, then what would happen when I run .join is I would get, say I typed hello world there, I would get HE space L space L space O. It would space them all out. If I made this a hyphen, then it would kind of combine them together with hyphens in between. But if I just make this an empty string, which is what I'm going to do, then what it does is it just combines all of the characters together because, well, it's combining them with an empty string, so they're just getting all squished together. Hopefully that makes sense, but that's what .join does. It just takes all the characters and combines them together with this as the separator. Very useful method when you want to convert a list to a string. So I'm going to say if .join current text is equal to the target text, then we are done. So what I'm going to do is I'm going to say std.nodelay false. The reason I'm going to do this is because I want to show something on the screen and then wait for the user to hit a key before I continue. So if I want to wait for them to hit a key, I need to get rid of this no delay thing, because if it's still no delaying, then I'm going to get an error if I'm trying to wait for them to get a key. Okay, then I'm just going to break. So I'm going to say no delay false. I'm going to break, and what that's going to do is bring me outside of this while loop. So now that I'm outside of this while loop, what happens is this function is going to be done. So it's going to bring me back to where this function was called. And then out here, I can actually show something on the screen and prompt them if they want to play again. So I'm going to say std_scr dot, and let's go with add string like this. We're going to add this on the second row down. So really the third row, because I'm putting 2. And I'm just going to say you completed the text, exclamation point, and then press any key to continue, ... And then I will say this dot, and then get key. So we'll wait for the user to type in a key. Okay. So let's run this now and let's see what's working or if it's working. So Python tutorial.py. Okay, hello world. So let's go hello world. This is some test, if I could type properly, for this app, exclamation point, and then it says you complete the text, press any key to continue. Great. And then of course our WPM is 47 because that's what we ended up. So we hit continue and then it's just going to exit the program. Now what I want to happen is I want it to actually bring us or prompt us to play again. So rather than just doing this and then ending, I'm actually going to put this in a while loop so that I can play as many times as I want. So you'll see what I mean, but let's go while true. Let's put all of this inside of here, and then let's get the user's key. And if they hit anything other than escape, we're just going to have them play again. So we're going to say key is equal to this, and we'll say if the ordinal value of the key is equal to 27. So if they hit the escape key, we will break, so they will exit. Otherwise, we'll just continue. So we'll just continue with the while loop. We'll call the WPM test function again, which is just going to rerun all of this. It will reset all of our variables for us, and we will be good to go. That's kind of the beauty of doing everything in functions. Now, I don't need to kind of have any weird logic to run this again. I just rerun the function, right? I just call the function another time, and we are good to go. So let's run this now and see if it is working. Okay, so let's hit enter, and then we'll go, hello world, this is some test. Clearly I can't type under pressure here when I'm on the recording. App exclamation point. Okay, 59, that's not horrible. You complete the text, press any key to continue. We hit enter, and what happened? It actually crashed the program. Maybe it's because I didn't save this. That would be why. I didn't save my code, so let's rerun this again and try. Enter, okay. Hello world, this is some test text for this. Oh, I was doing so well. App exclamation point. Okay, we hit enter and then it brings us right back in. Perfect, that is exactly what I want. Let me hit escape and then I can quit. Okay, so that is pretty much all we need for the functioning application. The last thing I want to show you is how we can randomize the text that's on the screen, because it's going to get pretty boring if we just always have the exact same text, right? And that's probably not the best. So what I've done here is I've created a file called text.txt. Now you can do this as well. I trust you guys can create a text file on your own. You can probably right click on your desktop or whatever and make a new file. And what I've done is I've put some different text here on different lines. So notice every single line has kind of a different piece of text that I want the user to be able to type. And I can add as many of these as I would like. So what I'm going to do is read in this text file, store all of these pieces of text, and then randomly select one of them for the user to be typing when they're going with this program. So I'll show you how we can do that. We're going to write a function here. I'm going to say load underscore text, okay? And all this is going to do is it's going to open up this file. It's going to get all the lines, and it's going to randomly choose one. Now, since we're doing something random, we need to import the random module. So I'm going to say import random like that. And we are now going to load the file. So to load a file is pretty easy. You can say with open. Then you're going to put the name of the file. I'm going to go text.txt. And I'm going to put the mode I want to open it in. For now, it's just going to be R. If you wanted to create a new file, you would do W. So that actually is write mode. So you would open a new file in write mode and you could write to the file. I'm not going to show you how to do that, but I just wanted to mention that. But we're going to open in read mode. I'm going to say as F. And then what I'm going to do is I'm going to read all the lines. So I'm going to say lines equal to F dot read lines. Now what this does, this with, is essentially ensure that this file will be closed after we open it. This is known as a context manager. It's pretty advanced. I don't want to explain it too much, but we say with, and then we have this open function. This is just how you open a file. And we say as F, which means we're going to take this kind of file object here, this file variable. We're going to store it in F, and then we can access the file by using F inside of this with. So just like the if statement, we have our indentation, right? So I'm going to say lines is equal to f.readLines. This is going to give me a list containing all of the lines of this open file. And then I want to randomly select one of those lines and return it. So I'm going to say return random.choice on lines and then .strip. Now what random.choice does is just randomly choose one element from a list. So if I have a list with 100 different things inside of it, just randomly picks one and just gives it to me. So it's just going to give me one of these kind of strings of text, one of these lines. Now the thing is, all of these lines of text have an invisible character at the end, which is \n. Now we looked at this. This is the new line character. The reason why they have this is to tell my editor to display the file in this way. If they didn't have the \n, I would have no way to know kind of where my line breaks are in the text file. So what I need to do is I need to remove this \n, which is what .strip does, from all of these lines. Because I don't want the user to have to type in \n, I just want to remove it, right? So I'm going to say .strip. .strip will just get rid of any leading or trailing white space characters, and a white space character is the \n character. So that's why I have .strip. Okay, so now we have load text. This will just give us some target text. So rather than manually coding in my target text, now I'm just going to say load text, and this will return to me one of the lines from this file. Now, it's very important that this file is in the same directory as where your Python file is. If you put this not in the same directory, it's not going to work. It just needs to be in the same directory. So you can see my tutorial and text.txt are right beside each other. Now, if you don't want to do this, that's totally fine. You can just manually hard code in the text, but I figured I'd show this to you because it is kind of useful. Okay, so that is pretty much going to wrap it all up. Let's do a few tests here and make sure I haven't messed anything up too badly, and then we'll wrap up the video. So let's hit any key to begin, and let's go subscribe. So this looks like it's working to Tech with Tim on YouTube, clearly not for typing lessons. Okay, perfect. 43, solid. I'm sure many of you can type a lot faster than that, but let's go on to the next one. And then notice it gives me a different string of text. We can escape. Let me just run it again. And okay, it's giving me another test. I'm just going to keep running this to make sure it's going through all of them. And awesome. Okay, so it does give me all of the different options that I have. Of course, you can add more to this text file if you like. So with that said, that is going to wrap up the video. There you go. We have our WPM tester, and I've showed you how we can add all kinds of styles and nice stuff to our terminal. I thought this was a really fun beginner project. I do kind of admit it's a little bit harder than maybe what I would consider beginner, but I still think you guys were probably able to follow along. At least I hope you were. Let me know in the comments down below. And this showed you a ton of cool stuff that now you can add to your own projects. In this video, I'll be walking you through a mini Python project where we will create an alarm clock / timer. Now this will be fairly straightforward, but I will show you how to play sound through Python and how you can do a fancy thing with the terminal, which involves clearing what you've already printed and then printing something over top of it. So you kind of get a live countdown timer, 10, 9, 8, 7, etc. And it looks a little bit better than printing out like a ton of lines of code. Probably something that's interesting and that you guys have not seen before. Regardless, that's what we're going to build. All right, so just to give you a super quick brief here on what we're going to be doing, essentially we're going to ask the user to input some kind of time, 5 minutes, 6 minutes, 30 seconds, whatever it is. We're then going to give them a live kind of countdown timer. And then as soon as that timer or alarm goes off, we're going to play a sound. Now that means the first thing we need here is some kind of sound effect so that we can actually play that when the alarm goes off. So to get a sound effect, you can just download one on your own. You can pick one that's on your computer and just drag it into the same directory as where your Python script is. So in my case, I have a folder open on my desktop, and inside the folder, I have my alarmclock.py file and then alarm.mp3, which is a sound effect I downloaded from this link, which I will leave in the description. So whatever sound effect you want, just make sure it's in the same directory as the file that you're writing your Python code in. Okay. Next, we need to install a module which is going to allow us to play this sound effect. So I'm going to open up my terminal here, or command prompt, whatever you want to refer to it as. And I'm going to type the command pip install play sound. So this is the name of the library module that we're going to be using to play the sound. Okay, pip install play sound. I already have it installed. If for some reason that doesn't work for you, you can try pip3 install play sound. If that doesn't work, try Python -m pip install play sound. And if that doesn't work, try Python 3-m pip install. If none of those work, I will leave 2 videos on the screen that show you how to fix this pip command. Okay, at this point, I'm going to assume you have play sound installed. And what we can do now is import this module. So we're actually going to go to the top of our program, and we're going to say from play sound, import play sound. Now, this here is a function that we can use to play a sound. So we can simply say play sound. We put the name of our sound, which in this case is alarm.mp3. Notice it matches the file name here. And since it's in the same directory, all I need to know is the name of the file. And then if I run my code, it will start playing this sound. This one is pretty aggressive. It's also fairly loud. Hopefully it's not going to annoy you guys too bad, but that is how you play sound. Very, very easy. Okay. Next, I'm going to import a module here called time. We're going to use time to kind of regulate the time. So we have, 1 second for each iteration as we're doing this countdown clock. Perfect. We're then going to make a function. So we're going to say define alarm. This is going to take in a number of seconds, and this is how long until we will play that kind of alarm sound effect. Okay. The first thing we're going to do inside of our function here is we're going to say time elapsed is equal to 0. We're going to need a variable to keep track of, well, how much time has elapsed. And then we're going to have a while loop, and we're going to say, well, the time elapsed is less than our seconds. We're going to do whatever is inside of here. Perfect. So the first thing we're going to do is say time.sleep 1. Now this means wait for 1 second. Very straightforward. Just pause the code right here, wait for a second, and then continue. Obviously, we need to do that because if we don't have this kind of regulation of time, then the alarm is just going to go as fast as it possibly can, as fast as your computer can run it, and well, we're not actually going to be waiting 20 seconds, 30 seconds, etc. Okay, next, we're going to say time underscore elapsed plus equals 1. Okay, and now we want to figure out how many minutes are remaining and how many seconds are remaining, and then print that out to the screen. So you can do this in whatever kind of format or order that you want. But in my case, I'm just going to take the number of seconds. I'm going to figure out how many minutes are in that and how many seconds are in that, and then print that out. If you want us to do hours, weeks, days, months, etc., feel free to go ham and do that. In my case, I'm just going to do minutes and seconds. So first, I'm going to say time left is equal to the seconds minus the time elapsed, because seconds is how many seconds we want to run this for. Time elapsed is, well, how much time has elapsed. So we subtract those, and that is how much time is remaining. Then we're going to figure out the number of, not hours, the number of minutes. So we're going to say minutes left is equal to the time left integer divided by 60. Integer division is 2 forward slashes, and that's going to give you the integer component of division. So for example, if we had 125 seconds like this, and we integer divide this by 60, then we're going to get 2, because 60 evenly divides 125 2 times. All right, very good. Next, we're going to say seconds underscore left is equal to the time left, and then this is going to be modulus 60. Now, the way the mod operator works, which is the percent sign here, is it gives you the remainder after division. So again, same example, we have 125 seconds. If we do the mod operator here by 60, that is going to give us 5. Because 60 goes into 125 2 times, so that uses 120 seconds, and then we have a remainder of 5. Okay, so that gives us the minutes and seconds left. Now we can print those out. So we're going to say print. We're going to use an F string available in Python 3.6 and above. So you do F, either lowercase or uppercase, doesn't matter. You do a string, and then inside of the string, you can use curly braces, and inside of the curly braces, you can just put a variable. So I can do minutes, colon, and then seconds, and now it's going to print however many minutes, colon, however many seconds are left. Great. Lastly, we can go here and we can call the alarm function, and let's just test this out with, say, 10 seconds to see if everything's working before we go a little bit further and kind of make things look prettier. All right, so let's run this here. Run the code, and notice that we will get an issue named minutes is not defined. Okay, that's because I need to put minutes left and seconds left. So let's quickly fix that bug and then rerun. Okay, 9, 8, 7, 6, 5, etc. It's just going to count all the way down. However, notice that this looks a little bit weird, right? We don't want to have like 0, 0, 0, 1. Instead, we'd want to have something like 0, 0, 0, 1. That's what we're used to seeing, right? Or, 20 minutes and 5 seconds. We want it to be formatted like this. So how do we fix that? Well, there's actually a fancy thing we can do in Python to automatically format our numbers. We can go to our variable here, which is a number. We can put a colon directly after it, and then we can put 0 to D, and this stands for make this 2 digits and pad it with a 0. So if it's already 2 digits, fine, we leave it the same. But if it's only 1 digit, we add a leading 0. That's what this is going to do. So I'm going to copy that, and I'm going to put that on seconds left as well. And now, just to quickly show you, if I run the code here, notice that we now get our formatting with our leading zeros. Perfect. All right, so now that we've handled our formatting, the next thing we need to do is kind of clear the terminal and make it so everything is on the same line and it looks like it's constantly updating kind of the same countdown timer. So to do this, we're going to use two sequences of characters, which are known as ANSI characters, or like commands or escape sequences, whatever you want to refer to them as. Essentially, these are invisible characters that when printed to the terminal will manipulate the terminal. In our case, it's going to clear something or delete something, but it could change the color of something. It could make something bold, underline, italicize. There's all kinds of styles and interesting sequences and characters you can print that manipulate the terminal. So I'm just going to show you two of them here related to clearing, but if you want to look at more of them, feel free to look them up. You're looking at ANSI, I guess it's characters or escape sequences. So we need two of them. The first one we're going to have is clear, and this is just going to clear the entire terminal screen so that it's empty. We don't see anything else. Now to do this, we're going to do \033, then this is going to be a square bracket, then 2, and the capital letter J. The next sequence we want is going to be clear and return, and this works a little bit differently, but this is going to return the character to, return the cursor to the home position so that when we print again, it's going to print over whatever was currently there, whatever was there before. So now this sequence is 033, square bracket, and then H. Okay. So what we're going to do is start by just clearing the entire terminal, right? Once we clear the entire terminal, then we're going to print out this. And then the next time we print it, we're going to clear, return to the home position, and kind of print over it. I know it seems a bit strange, but let's start by just looking at one of them. So I'm going to go here, and I'm going to say print clear, and we'll just do clear, okay, the first one. So now notice, when I run my code, that it clears the terminal, and then it starts printing stuff out. So that's fine, but it's printing everything on a new line, which we don't want. So what I can do is stop this. And now, if I use my other sequence, I'm going to go here in my f string, and I'm going to print clear and return before I print all of this, and now watch what happens. Okay, 9, 8, 7, and look, it's on the same line, and it's just updating the value. Okay, so we cleared the entire terminal, then we cleared and returned to that home position and kind of printed over what we had before. So hopefully that is making a little bit of sense. I know it's kind of weird how these escape characters function, but now we have like a decent timer being updated on the screen. So now the last thing we need to do is once our alarm is finished or the timer is up, we need to play the sound. So we're going to say play sound, and then this is going to be alarm.mp3. And we need to ask the user how many minutes and how many seconds they want to set the alarm for. So let's go ahead and do that. We're going to say minutes is equal to input, how many minutes to wait, or whatever you want to say here. Okay, now I'm just going to convert this directly into an integer. I'm going to assume that they give me a valid int. If they don't, that's going to crash the program. But again, we're just going to assume that's fine. Then we're going to say seconds is equal to int input, how many seconds to wait, like this. And now what we can do is we can say total underscore seconds is equal to minutes multiplied by 60 plus the number of seconds that they said. And then we can pass here total underscore seconds. And if we want to make this a little bit nicer, we can have some text here that says alarm will sound in, and then the minutes and the seconds remaining. Okay, so we're clearing, and then we're going to print the alarm will sound in, and then it will update whatever this value is and keep going downwards. Okay, so that is pretty much our entire program. Let's try this out here. Okay, so we're going to run how many minutes to wait. Let's wait 0 minutes. And how many seconds? Let's wait 12 seconds. Okay, alarm will sound at 11, 10, 9, 8. Goes on, and then hopefully we should hear the sound. Okay, so let's give this a second. 2, 1. And for some reason, I'm not hearing the sound. Okay. The reason I'm not hearing the sound is because my speakers are off, but I think you guys probably heard it in the recording because of the way that I have things set up. And there you go. Everything functions. It plays the sound, and we are good. All right, so let's dive into the project. Just as a quick brief here, what we're going to do is create a password manager that allows us to generate passwords with a minimum length. So maybe you pass a minimum length of 7. That means any password you get will have, well, a minimum length of 7. Continuing, we're also going to allow the user to set if they want the password to contain special characters and if they want it to contain numbers. This way it's slightly dynamic and we can create some different types of passwords. So with that said, let's get into the project. So I'm here in Visual Studio Code. I assume that you have a Python environment set up. You can do this in really any version of Python. And we're going to start at the top of our program here by importing 2 modules that we're going to use. So we're going to import random and we're going to import string. Now we're going to use string to just grab all of the lowercase and uppercase letters that exist, and then all of the special characters, as well as all of the numbers or digits. Kind of a cool thing that you may not have seen before. Now, there's 2 different things that we need to do here. The first thing we need to do is ask the user what the minimum length is, if they want numbers, if they want special characters, etc. And then we need to write a function which is actually going to generate the password. We can do this in any order that we want. For now, I'm going to start by writing the function. So I'm going to say def, and then I'm going to say generate underscore password. And for the parameters of this function, I'm going to pass the following, which is the minimum length. Then I'm going to pass numbers is equal to true, and then special underscore characters is equal to true. And for now, I'm just going to write pass here while I explain this. So these are the parameters, the things that you need to pass to the function when you call it. Again, we start with the minimum length, which will be a number. And then we have 2 optional parameters here where we can specify if we want the password to include numbers or if we want it to include special characters. The way you would call this function is like so. So I would say generate password. And if I passed just 10, then that would create a password for me that has minimum length of 10 and includes numbers and special characters. If we passed, say, like 10 and then false, that would mean we'd have a password of minimum length 10, would not include numbers, but would include special characters. So you can see that if I only pass one of the different arguments, then I'm kind of substituting that here for this parameter. Obviously, I could pass both of them as well if I wanted to do that. So I could say false and false, but by default, if you don't pass them, we're going to have that equal to true. Okay. All right, so now that we're here, I just want to grab all of the potential characters, so like numbers, special characters, letters, etc., that we could be using. So I'm going to say letters is equal to string.ascii underscore characters. Is it ASCII characters or ASCII letters? I think it's ASCII letters. Then I'm going to say digits is equal to string dot, and then I think it's digits. Yes, that's correct. And then I'm going to say special underscore chars is equal to, and then this is going to be, actually, let's make this special, is equal to string dot punctuation. I think I spelled that correctly. Okay, now I'm just going to quickly print these out just so you can see what they look like. And then we will continue. So I'm going to say generate password, and we'll just pass 10 for now just so that we can see what these are. Okay, so when I call the function, you can see that what we get printed here is all of the lowercase and uppercase English letters. Then we get all of the digits, and then we get all of these special characters, which are really just all of the punctuation on our keyboard. Perfect. So I just want all of those so that I can kind of create the set of characters that I'm going to select from when I generate this password. So now we need to combine all of these into one kind of list or one large string that we're going to randomly choose from. However, that string that we're going to randomly choose from should only contain what we have specified here. So for example, if we're including numbers and we're including special characters, then we want to be picking from all 3 of these variables. So either a letter, number, or special character every single time we kind of generate a new character for the password. If we're not using numbers, then obviously it's just letters and special. And then if we are using numbers but not special characters, then it's just letters and our special characters. So how do we do this? Well, we're going to say the following. We're going to say, should I do the selections? No, let's call this characters is equal to letters because we're always going to have letters no matter what. Then I'm going to say if numbers like this, then characters plus equals, and then digits. So if this variable is true for including numbers, I'm going to take all of my digits, which by the way are inside of a string, and I'm going to add those to the letter string. So that now they're combined. And then I'm going to say if special characters like this, then characters plus equal special like that. So now if we have our special characters, we add that to our characters, which will allow us to select from those when we are generating the password. Perfect. So now what we're going to do is start a loop. And during every iteration of that loop, we're going to generate a new character to add to our random password. And we're going to continue that loop until we meet the criteria. So until we have, for example, a number, a special character, and we are at the minimum length. So we need to set up a few variables here. The first variable I'm going to create is PWD, which stands for password. And this is what will store the password. The next variable is going to be called meet criteria. And actually, this will be meet criteria. And I'm going to make this equal to false. Now, we're going to set this variable to true once the password meets the criteria, and meeting the criteria will mean that it includes a number and a special character, or it just includes a number, or it just includes a special character, etc. And that's going to be based on what the input is to this function. So we want to make sure that we have at least one special character and at least one number if you made these equal to true. Next, we're going to have a variable that tells us if we do have a number in our password. So we're going to say has number. For right now, that's going to be equal to false. And then we're going to have has special, and that's going to be equal to false as well. Okay, so now that we have these variables, we're going to create a while loop, and we're going to say while not meets underscore criteria, like that, and actually not and, or PWD, the len of PWD is less than the min length. Okay. So this is the condition for our for loop, or for our while loop, sorry. So we're saying while we are not meeting the criteria, so while we don't have a special character or don't have a number or whatever that criteria is, or the length of our password is not yet equal to or greater than the minimum length, we're going to continue doing this where we're going to continue adding characters to our password. Hopefully that makes a little bit of sense. Now, I'm going to generate a random character that I want to add to my password, add it, and then if it's a number, I'm going to set has number equal to true. If it's a special character, I'm going to set has special equal to true. And then at the bottom of the while loop, I'm going to adjust this meets criteria variable to tell me if the password currently meets the criteria based on these two parameters. So we're going to say new underscore char is equal to random.choice, and then this is going to be from the characters kind of string here. So we've built this characters string, which has all of our available characters we can pick from. So we're going to randomly pick one using random.choice, just picks a random element out of the string for us. That's why we imported random. And we're going to add that to our password. So PWD plus equals, and then the new underscore char. We're now going to say if the new character is in our digits, so is in digits like that, then has underscore number is equal to true. And we're going to say elif the new char is in our special characters, then has special is equal to true. So again, this is telling us if this character exists inside of the digits, which we have up here, and it's telling us if it exists inside of our special characters, which we have right here. If it does, then we're going to adjust these variables so we know now if we have a special character and if we have a number. There's a few other ways to go about doing this, but the way I'm coding this is one of the more efficient ways rather than rechecking the entire password every single time to see if it has a special character or see if it has a number. Okay, so next, what we need to do now is update this meets criteria variable. So it's a little bit strange how I'm going to do this, but I want to show you kind of a more complicated way just as a bit of a learning experience here. So I'm going to say meets criteria is equal to true. Now you're going to see this as a common pattern when you're programming, that you actually start a variable equal to true, and then you try to prove that the variable is false, and then if that's the case, you set it to false. So I'm going to say meets criteria is equal to true, then I'm going to check a few things and set it to false if it needs to be false. Okay, that's how it's going to work. And if I didn't set it to false, that means, well, I've met the criteria. So I'm going to say if numbers like this, and remember, numbers is telling me that I should include numbers in the password. So I'm going to say if numbers, then meets criteria is equal to, and in this case, we can just say numbers, or not numbers, sorry, has underscore number. Then we're going to say if special, and did I just call it special? No. Special characters, then meets criteria is equal to meets criteria, and in this case, special has underscore special. Okay, Now, the way this works is that I'm starting by saying if we should include a number, then we're going to set the meets criteria variable equal to if we have a number or not. So if we do have a number, this is going to be equal to true. If we don't, it's going to be equal to false. Then after that, no matter what, so whether this is true or false, I'm going to do this other if statement where I say if we have special characters or if we should include special characters, then meets criteria is going to be equal to meets criteria and has special. Now, the reason I'm using this and here is because if has number was equal to false, or if at this point meets criteria is equal to false, then it doesn't meet the criteria, right? If we don't have a number, but we're supposed to include a number, we don't meet the criteria. So it doesn't matter what has special is, this should return false. So that's why I'm putting meets criteria here. Then I'm checking that with has special. So if we did have a number, for example, if this if statement was true, then this is equal to true. And if we have a special character, then that's equal to true. So meets criteria is equal to true. If we didn't have a number, but we do have a special character, then this is equal to false. Hopefully you can kind of understand where I'm going here and how this works. There's a bunch of other ways I could probably have written this a little more clear, but I just wanted to show you an approach of kind of doing it in this format and using a, what would you call it, a chained conditional or a compound conditional here with the and keyword. If you're not familiar with the and keyword, this expression returns true only if both the left-hand side and the right-hand side are true. So try, if you don't understand, to pause the video and kind of figure out what I'm doing here and how that works. But this will now kind of finish our generate password function. So from here, I'm now going to return my password. And at this point, it's guaranteed that my password is going to have at least one number and at least one special character and be the minimum length, assuming that this was true and this was true. All right, so let me zoom out here. We'll run through the code quickly, and then we can do our inputs. So the user is going to tell us the minimum length, if it should have a special character, etc. And we'll kind of test the program out. So we get our letters, digits, and special characters, fairly straightforward. We then create a string that contains all of the different characters we could be selecting from. So we've already explained how that works. Then we say our password is empty. We currently do not meet the criteria. We do not have a number, and we do not have a special character. Now we say while not meets criteria, or the length of our password is less than the minimum length. So if either of these two are true, then we're going to continue. Then we generate a new character by randomly selecting from the characters we can pick from. We add that to our password, and then we determine if that new character was a number. If it was, we're going to say has number is equal to true. And if it was a special character, we're going to say has special is equal to true. Then we're going to set meets criteria equal to true. And if we have a number, or if we should include a number, sorry, I keep mixing this up, but if we should include a number, but we don't have a number, we're going to set meets criteria equal to false. If we should include a number and we do have a number, then meets criteria will stay true. Okay, then we go here and we say if special characters, then meets criteria is equal to meets criteria and has special, which is what I just explained, which will make sure that this is going to be equal to false if we don't have one of the two things that we need. Then when these conditions are false, so when we are meeting the criteria and when the length of the password is at least the minimum length, then we will return the password. Okay, so let's just try calling generate password using some manual inputs, and then we can grab our user inputs. So I'm going to say pwd is equal to generate password, and then I'm going to print pwd here. And for now, we're just going to generate it with 10 minimum characters and containing numbers and special characters. Okay, notice that this is the password that we got. We can run it again. We'll get another password, and we can keep running this as many times as we'd like. So now the last step is to ask the user to give us the information that we pass to this function. So we're going to say the min underscore length is equal to input. Let me zoom in a little bit here so we can read this better. And I'm going to say enter the minimum length. Okay. Then we're going to convert this to an integer because we need this as a number value. We're just going to assume they give us a valid integer. If they don't, it's going to crash the program, but we don't need to handle that right now. We're just going to assume they give us valid input. Then we are going to say has number is equal to, and then input, do you want to have a number, or do you want to have numbers? Question mark, and then we'll say that we're going to accept either Y or no. All right. And then we're going to have has special. We're going to say, do you want to have special characters? Now for both of these inputs, I'm going to convert them to lower cases. So dot lower is just going to take whatever the user types in and convert it into lowercase. So we're going to do that here. And then I'm going to check if this is equivalent to y. So if the lowercase thing that they typed in is equal to the lowercase letter y, then that means yes, we should have a number. And then same thing here, check if this is equal to lowercase y. So if they type anything other than y, either uppercase or lowercase, then we are not going to include the number or not going to include the special character. Okay, so this is going to return a Boolean for us, giving us either true or false. Next, I'm going to go down here to PWD, and I'm going to pass all my parameters. So I'm going to say min length has number and has special, and then I can print the generated password is, and then whatever the password is. All right, so quickly run through this. We ask them first, what is the minimum length they want? We convert that into an integer because we need a number value. And by default, whatever's entered in the input statement is going to be a string. So we got to convert that to an int. Then we ask them if they want to include a number. We cast that or convert that to lowercase, and then we check if it's equal to y. The double equal sign in Python checks for equivalence, so we're checking if they're exactly the same. If it is, then this is true, and we will include a number. Then we do the same thing for special characters. We take all of our 3 values here that we've asked the user for, pass that to our function, and then print out what the generated password is. So let's run this. Okay, enter the minimum length. Let's go with 25. Do we want to include numbers? Yes. Do we want to include special characters? Let's go with no. And there you go. We get our password. We can run this again. Minimum length. Let's go with 20. Numbers, no. Special characters, yes. And we actually got a small error here. It says local variable meets criteria referenced before assignment. Let me have a look at why we're getting this. We'll fix that error and then we'll be done. All right, so the issue is that I accidentally spelled this wrong. So criteria has to have the IA, and I only had A. So it was saying I referenced it before assignment because I spelled the variable wrong. So let's just run this again and test this one more time. So 20, yes, and no. And there you go. We're all good. We generated our password. All right, so let's go ahead and dive right in. Now I'm going to start with the Pathfinder or the Maze Navigator, whatever you want to call this. And we're going to use a package here called Curses, which allows us to control the terminal and color it in the way that you saw and actually override what's currently in the terminal so that we don't have to keep printing a bunch of separate lines and kind of having a really messy standard output. Now, if you're on Mac or Linux, Curses should be installed by default for you, but if you are on Windows, you're going to need to install this. So go to your terminal. I'm just in VS Code and I've opened up a terminal here, and you're going to type the following command, pip install, and then Windows-curses like this. Now, again, you only need this if you're on Windows, so hit enter. Try that command. That should install it for you. And if for some reason that doesn't work, I'm going to give you 2 or 3 alternative commands. You can try pip3 install Windows Curses. If that doesn't work, you can try python-m pip install Windows Curses. And if that doesn't work, you can try Python 3. Now, if none of those work, I will leave 2 videos on the screen that should show you how to fix this pip command, one for Mac and one for Windows. Although I guess you only really need it for Windows because you don't need to install anything if you're on Mac or Linux. All right, now what I've done is made a Python file here called pathfinder.py. I've opened it in VS Code. You can work in any editor that you want, but I'm going to use VS Code. I've also pasted in a maze. You can find this maze from the link in the description on the GitHub repository, or you can just make your own maze. I am treating all of the pound sign here or number sign here as my obstacles in the maze. All of the empty strings are going to be things we can navigate, and then the O is going to be our start, and the X is going to be the end. Now, I do want to mention here that if you are trying to get better at Python, you also can check out a product I have called programmingexpert.io. This is a programming course, teaches fundamental programming, object-oriented programming, advanced programming, software engineering tools, all kinds of stuff. Just wanted to mention that. If you guys are interested, you can use discount code TIM. I'll leave that in the description. For now, though, we do want to build out this project. So we have our maze here. And the first thing I'm going to do is I'm going to import that Curses module and quickly walk you through how this works so you can see how we can print colored output. I do also have an entire tutorial series on the Curses module on my channel in case you are interested. I'm also going to say from Curses like that, import, and I'm going to import something called wrapper. And then while we're up here, we're going to import a queue. This is built into Python. You don't need to install it. And we're going to import time just so we can implement a bit of delay here in this program when we start actually trying to visualize things. For now, though, I want to show you how the Curses module works. So what we need to do here is define a main function. And this main function needs to have as one argument std_scr. Now, this stands for standard output screen. And this is what we're going to use to actually output all of this stuff for our program. So rather than using the standard print statements here, we're going to add stuff to this screen. This screen is going to override and kind of take over our terminal. And then as soon as the program ends, everything on that screen will be cleared and will be brought back to the original terminal. You'll see what I mean in a second, but for now, we're going to type the following, stdscreen.clear. So we're going to clear the entire screen. Then we are going to not write, but we're going to add string. And when we add a string to the screen here, we have to pass the position that we want to enter this string at, or that we want to add it to. So for now, I'm going to go 0, 0. That represents the top left-hand corner of the screen. So I believe we're going row and then column that we want to enter this in. I'll experiment in a second. Then whatever the text is that we want to show on the screen. So in this case, I can do a hello world exclamation point. Then we're going to do stdscreen dot, and then this is going to be refresh. And what that does is refresh the screen. And so we actually see what we wrote. And then lastly, I'm going to say stdscreen dot, and this is going to be get ch. What this stands for is get character. And this is similar to an input statement that we would have in Python. It just makes it so that we're going to wait here until the user hits something before we exit the program. If we don't have that, it would do this and then just instantly exit, and we wouldn't see anything because we weren't waiting long enough to actually view the output. All right, now that we have that main function, we're going to call wrapper, which we imported up here. And we're going to pass to it the name of this main function, but we're going to make sure we don't call the function. So I'm not calling it like that. I'm just passing the name of the function. And what this does is it initializes the curses module for us, and then it calls the function, passes this std screen object, and then we can use that in here to control our output. All right, hopefully that's clear so far. Let me save and let's run the code and let's see what we get. And notice that it kind of brings me to this blank window and it says hello world. And then if I hit any key on my keyboard, brings me back to the original terminal. One more time, if I run this, notice it shows me hello world, hit a key, and then I'm out. That is the curses module, very basic introduction. However, I want to show you what happens when we change these coordinates and how we can add colors. So let's say now we maybe draw this at 5. So 5, 0 is our position. Let's run the code, and notice we go 5 rows down, and we're at the 0th column. So that's how you can control where you're drawing this. You put the row and the column you want to start drawing. So if I go maybe 5, 5, and then let's save and rerun, save and rerun, notice we get hello world kind of more in the center of the screen. So very powerful what you can do here. And then if we want to add a color, this is a little bit more complicated. We first need to initialize a color. So I just got to look at my cheat sheet over here to remember how to do this. So we're going to say curses.init_pair. And whenever we create a color pairing here in curses, we give it an ID. So I'm just going to give an ID of 1, and then I put the foreground and the background color that I'd like to have. So I can say curses dot, and then color underscore, and then whatever colors. You can see there's a bunch of options here, green, magenta, red, whatever. So let's go with blue for now. And then the foreground color, or sorry, the background color, my bad, is going to be curses underscore color, and then black. So you put your foreground color and your background color. Pretty much all the colors you can think of are, you can access them with color underscore their name. And then now that we have the initialization pair, if I actually want to use this color, what I have to do is the following. I'm going to say blue underscore and underscore black is equal to, and this is going to be curses dot, and I believe this is color pair. Again, let me just have a quick look at my cheat sheet here to remember this. Yes, it's color pair. And we're going to put the ID of the color pair we want to use. So since I referenced this with ID1 or created it with ID1, now I reference ID1, and that's going to give me a color of blue and black. And the way I apply that now to my text is I just pass another argument to add string with this, so blue and black. And now when I start displaying this, it should be blue and black. So let's do this. Let's run the code, and notice I get hello world in blue text, and the black is just the default background, so it doesn't change the background color. But if I wanted it to be like a white background, then I would say color white, and then if I draw this now, so let's rerun this, notice I get kind of a white background for that text. Great, but let's go back to color black. Okay, so that's the first color pair. While we're here, let's initialize another color pair, because I want blue and black. I also want red and black. So let's change this to red, and let's make that 2. And then we'll use these later on. I don't actually want to write hello world onto the screen. So let's actually just comment all of that out for now. And let's work on the breadth first search algorithm, and then we can actually start displaying stuff on the screen. So the first thing I want to handle is printing this maze out. So obviously I want to view the maze on the screen. So to do that, well, how am I going to do that? I'm going to write a function here. I'm just going to call this print maze. And to be able to print the maze, I need the maze that I'm going to print. I need the standard screen or the standard output screen that I'm going to print the maze to. And then I'm going to take a variable here or an argument called path. Now, path is going to be the path I want to draw on the maze. Obviously, we don't know what the shortest path is yet, but I can pass a path here of coordinates, and then whatever values are in that path, I'll draw them a different color in the maze. So you'll see what I mean in a minute. So that's print maze. Now inside of here, I'm going to grab my two colors that I want to use. So I'm just going to say blue is equal to, and then this will be curses dot color underscore pair. And this will be 1. Let's say red is equal to curses dot color pair 2, just so I can use both the blue and the red. We'll draw the default maze as blue and then the path as red. Okay, continuing, I'm going to loop through everything in my maze because this is a two-dimensional array, so I have kind of all my rows, and then the columns would be the individual values in each row. So I'm going to say 4, and this is going to be I, comma, row in enumerate maze. Now, if you're unfamiliar with enumerate, this is going to give me the index as well as the value. So I'm going to get every one of these rows as a row, or every one of these nested arrays as a row, and then I will be what row I'm currently on, okay? Continuing, I'm going to say 4j, comma, value in enumerate, and then I'm going to enumerate over the row. The reason I can do this is because I have a list or an array, whatever you want to call it, but list in Python. So row is my list. Then I'm going to enumerate over the list that I have. I'm going to grab whatever column I'm currently on, which is what j is going to represent. And then the value is going to be whatever symbol here is in the column. Okay, so that's what I have. Then what I want to do is I want to simply draw this onto the screen. So I'm going to do the following. I'm going to say std screen dot, and we're going to add string. And now we need to determine where we want to add this string. Well, where I want to add it onto the screen is going to be whatever position I'm currently on, which is going to be represented by I and j. So I is going to tell me the row I'm on, j is going to tell me the column. So what I can do is simply add whatever I'm drawing here at whatever row and column I'm currently at. So I'm going to say ij as the position. And then I'm going to say value, and value is just going to be either an empty string, a number sign, an O, an X, whatever it is that I'm currently looking at. Hopefully that makes sense, but that's what we want for print maze, and then I'll handle the path in 1 second. For now, though, let's actually try printing the maze. So I'm going to uncomment the clear. I'm going to uncomment the refresh and the get ch, and now rather than adding my own string, I'm going to call print maze. I'm going to pass to it the maze variable, which is just a public variable or a global variable. Well, that's fine. I'm going to pass my std screen, and then this is a default argument of empty list, so I don't need to pass that. Okay, so let's run this now. Let me just make the terminal a bit bigger first. Let's run this, and notice my maze is printing out. Now, this looks a little bit squished together, like it's too close to me. So to spread this out a little bit, what I'm going to do is simply multiply the row in the column that I want to draw this at by 2. And actually, we can leave the row as just regular I. We can just spread the columns out a little bit more. So now we should get kind of 2 spaces between each of our elements. And also, let's add a color here. So let's add blue, and now it should be drawn in blue. So let's run this, and I guess I need to run again. Okay, and there we go. That looks a lot better. The maze is spaced out, and we can kind of see it all nice. Great. So let me exit that. All right, so now that we are printing the maze out, and I guess that's pretty much all we're doing, I need to talk a bit about how this algorithm works. So let me head over to the whiteboard. I will explain that to you, and then we'll start coding it out. So in front of me, I have a very simple maze. I'm also going to refer to this as a graph, and this is what I'll use to demonstrate the breadth first search algorithm. So the goal here is to find the shortest path from some starting node to some ending node, and I'm going to reference these nodes by their position in the graph. So we see these are different rows, these are different columns, and I'm going to have my positions in row column format, which means I would refer to this here as 1, 0, so row 1, column 0. Just keep that in mind as I write the positions, because you might be confused if you're reading it the other way. And like here, this would be 0, 3. All right, so how does the breadth first search algorithm work? Well, the concept behind the breadth first search algorithm is that we're going to continually expand outwards from a point until we find the ending point that we're looking for, or the ending node. I'm just referring to every single one of these squares as a node, okay? In kind of graph theory, that's what you would call them. So we're going to start here at this start point, and we're essentially going to slowly expand outward by looking at all of the neighbors of this point. So we're going to look at this neighbor, and if there was a downwards neighbor or a left neighbor, we'd look at those as well. but there isn't any left or down neighbors, so obviously we're starting here. So we expand here, and then from both of these points, we're going to look at all of their neighbors. So maybe we start with this one, we would look at this neighbor, then we would look at this one, and then we continue the process. And we do this one iteration at a time, which means that once I finish considering this neighbor here, I go and I do this one. Then, of course, we're going to move up to here, we're going to move up to here, and since we're doing this one step at a time, as soon as we hit the ending node, we will actually be guaranteed to have found the shortest path because we're only expanding our path from the starting node by one new node at every single iteration. Now, that's a super high level recap of how this works. Of course, I'm going to walk you through the code and more complicated demo, but that's kind of the concept here. One step at a time, we're slowly expanding outwards from this node and expanding our current path by one until eventually we reach this end node. And as soon as we find the end node, we know that we have found the shortest path because every other path that we have is either going to be the same length or longer to find this path, okay? So let's now look at a demo of how we actually do this. So first of all, we're going to use a data structure called a queue. Now, queue, I believe, is spelled like that. I'm also just going to refer to it with the letter Q. And this is what's known as a first in, first out data structure, or a last in, last out data structure, whatever you prefer to call it. Essentially what that means is that if I enter some item into the queue, just kind of like a phone queue or any other lineup that you would be in, if I entered this item first, then this is going to be the first item to come out. And the second item that I enter into the queue, that's going to be the second item to come out. Now that's important because we're going to process elements in the order in which they're entered into the queue. So just keep that in mind. So for our queue, we can have a back and a front. So we can say that this is the front of the queue, excuse my messy handwriting, and then this is the back, just so we're clear on kind of what element we're going to process next. So what we're going to start by doing is we're going to place our starting node here inside of the queue. Now, the way I do that is I just place the position of the node that I want to start looking from. So I'm going to put a position of 3 and then 0 because it's in row 3 and column 0. Now, every single step in my algorithm, what I'm going to do is I'm going to pop an element off of my queue. I'm going to take the element that's currently at the front of the queue. I'm going to remove it from the queue, and I'm going to start processing it. Now, the way I process an element is I essentially just look at all of its neighbors and try to find if we're currently on the end element or not. So in this case, I take 3, 0 off the queue and I say, okay, I want to process all of this element's neighbors and kind of expand outwards from this until eventually I get to this node. So what I'm going to do is look at the neighbors. I'm going to determine I have 2 of them, and I'm going to check if these neighbors are the end node. If they are, then I'm done the algorithm, I found the shortest path. But if they're not, what I need to do is add them onto the queue. So now they can be processed and we can continue expanding until eventually we find this end node. So let's erase this from the queue here. So 3, 0, we've now processed that element. I'm going to add this into some set here. So let me just create a set. This set will be known as our visited set. And okay, it's kind of hard to draw this the way that I want to. So let's just do this, 3, 0. And the reason I'm putting it in a set is just so I know, okay, I've processed this element. I don't have to look at it another time. Anyways, processing the element again involves looking at all the neighbors. So the 2 neighbors here are 2, 0. And what do we have? We have 3, 1. So I'm going to add those positions into the queue. Doesn't matter the order that I add them in. So I'm going to add 2 and what was this? 0. And then my other one is 3 and 1. Okay, so these are now the 2 new elements that I need to process to continue expanding my path. So what do? Well, I'm going to pop now the first element off of the queue, and I'm going to process this one and, well, repeat everything that I was doing. So let's cross it off. We'll erase it in a second. This is the current one that we're looking at. So now we need to consider all of this node's neighbors. Now it has a neighbor down and a neighbor up. It also has one to the right, but since the one to the right is an obstacle, we don't look at that. And for the one that's below us here, we see that the one below us is an element that we've already looked at. And the reason we know that is because it's in this visited set. So I can skip the neighbor below us because we've already looked at it. I don't need to process the same element twice, and I can just go directly to the element above. So I'm going to add a single neighbor here to my queue, and this neighbor is going to be in 1 and then 0. So now I've processed this element. It was not the final node that we were looking for, so let me delete it here. And now we're going to add this into this visited set. Now I didn't mean to butcher my element here, so let's go here. What was that position? That was 2 and 0. So let's add this in, 2, 0, like that. And now we've visited those two nodes. Now we're going to continue. So we're going to take the next element off of the queue, which is 3, 1. So I'll just delete it here. We will add it into this set. So you might as well just add it right now. Okay, 3 and 1. And then from 3, 1, that's right here, we need to look at all of its neighbors. So it has one going to the right and it has one going to the left. Well, of course, the one to the left we've already processed. So we can just add the one to the right, which is right here. And that has a position of 3, 2. So what I do is I add 3, 2 to my queue. If we can, that's a really bad 3, but you get the point. We add 3, 2 and we continue. And this process is going to repeat until eventually we hit this end node. And again, as soon as we hit this end node, we know that we found the shortest path because that's the first time we found it, and we would have found it on another path if there was a shorter path to get to it. So, I mean, I could continue this example, but hopefully you kind of get the idea. We're expanding outwards one node at a time until eventually we find the ending node, and then I will show you in the code how we actually kind of keep track of what path we were on, because that is a little bit more complicated, but this is the basic idea. We have a queue, we add elements onto the queue, we process them one at a time in the order in which they were inserted into the queue. This guarantees that every kind of new element that we're looking at is only expanding our current path by at most one node. As soon as we find the end node, then we can just say, okay, well, we found the shortest path, let's end the algorithm, let's draw the path out. Hopefully that gave you a very brief explanation of how this works. I don't want to go through the whole thing because it will take too much time. Now though, let's start coding this out and hopefully everything will be cleared up. All right, so let's code out a function here called find_path. And we're gonna take in here the maze, and then this is gonna be the standard screen. And I think that's all we need for find path. Now for find path, I'm just gonna declare a few variables here. I'm gonna say start is equal to X, end is equal to O. And actually, is this, no, we're going to say start is equal to O, end is equal to X. And what else do we want here? We want to figure out what the starting position is of our maze. Now we could just hard code in the position right here, but instead I'm going to write a function that will essentially look for this O and tell me where in my maze I'm starting from, because we're going to start from this position. We need to know the coordinates of this, right? So in this case, it'd be 0, 1, 2, 3, 4, 5. Okay, it's in row 0, so it would be 0, 5. That would be the position here of the start. But we want a function that will tell us that so we don't have to manually do that. So for now, I'm going to say define find_start. And just because I didn't really explain this, I just jumped right in. What we're doing here is we're going to start coding out that breadth first search algorithm that you just saw. So that's what find path is going to do. But first, we need to find the starting position. So we're going to take in the maze here, and we're going to take in whatever the starting symbol is. And what I'm going to do in here is simply say for, and this is going to be I, comma row in enumerate maze, and then for j, comma value in enumerate row. I'm going to say if the value is equal to start, then I can simply return I, comma j. So I'm going to return the row and the column where I found this starting symbol. And we're going to assume that we just have one of those symbols. Okay, now otherwise, we'll just return none if for some reason we couldn't find the start. Okay, so now in here, we're going to say start_pause is equal to find start. And then we're going to call the maze and the starts. Now we know the starting position. Now what we want to do is set up our queue and set up those iterations and finding the neighbors and all that stuff I was discussing. So for the queue, we have this queue module and we're going to use it. So the way we do that is we're going to say queue is equal to, and then queue.queue. And again, this is a first in, first out data structure. So the first element I insert is the first element that comes out. That's very important because the order in which we process the nodes really matters when we're doing the breadth first search. We don't want to process the most recent node we've added to the queue. We want to process the node that's been in the queue the longest, just like we would if you were accepting, a bunch of phone calls or if there was a lineup or something like that. That's exactly what a queue is, right? So we have our queue. And we need to insert something into the queue. So to insert something, we use this put method here. And we're going to put a tuple. And the tuple is going to contain the starting underscore position. And it's going to contain a list that has the start underscore pause in it. Now, the reason why we're adding two elements in here is because in the queue, I want to keep track of the current position or the node that I want to process next, as well as the path to get to that node. Now, the reason I want the path to that node is because as soon as I find the ending node, I'm going to take whatever path I currently have, and I'm going to start drawing that onto the screen. I'm going to show that on the screen. So for now, since we haven't found the end node, our current path just includes the start position, but every time I process a new neighbor or something along those lines, I'm going to change the path, and the path will continue to grow, and I'll be able to see what path we're at for every single node. Hopefully that makes a bit of sense, but that's why I'm storing two pieces of information, the position I'm currently on, as well as the path. And in fact, we could even optimize this further and just store the path and grab the last element from it. But I'm just going to do two things here just so it's crystal clear when I code this out. It's not the most efficient thing in the world, but for this tutorial, it's fine. Okay, so for now, we put that in the queue. We also want to make a visited set, which is going to contain all of the positions that we've currently visited. Now that we have all that set up, I'm going to say while we still have any elements in the queue. So while not, and then queue dot, and I think this is either is empty or just empty. I believe it's just empty. So while the queue is not empty, what we're going to do is we're going to get the most recent element from the queue, the one that's kind of next in queue. So I'm going to say current underscore position and path is equal to queue.get. Now get's just going to give me the element at the front of the queue. And since I have two things for every element, I have my path as well as the position. I'll grab the current position, which will just give me the first element, and the path, which will give me the second element. Okay, now that I have the current position, I'm going to say the row and column is equal to current position. So I'm going to break down the position into its two components, the row and the column. And I'm going to find all of the neighbors of this position and start processing them if they are not the end node. So first I'm going to say if maze, and then this is going to be at row call is equal to, and this is going to be the end. So we're going to say end like that. So we're going to look in the maze and see if this position is equal to an X. If it is, that means we found the end. And so what we can do here is simply return the current path. Because again, as soon as we find the end node, we know that we've found the shortest path or one of the shortest paths, because there could be two paths that are both the shortest. We'll find one of them, so we can just return the path, and then we can draw that if we want. Okay, continuing. Now what we need to do, if we haven't found the end node, is we need to continue branching out. So we need to find all the neighbors of the current node and then expand towards them. So we're going to write another function here called find underscore neighbors. Now the tricky thing with the neighbors is that we need to make sure that the neighbor that we're finding is not an obstacle and that it's a valid position in the maze. So you'll see what I mean here, but we're going to take in a maze, a row, and a call. And we're going to say our neighbors is equal to an empty list. And we're going to determine programmatically what all the neighbors are of this current position. So we're going to look up, left, right, and down. If you wanted to, you could do diagonal, but I'm not doing diagonal in this tutorial. But adding that is fairly easy. So for now, I'm going to say if the row is less than, not zero, sorry, if the row is greater than 0, then I'm going to add a neighbor. And this neighbor will be the neighbor above. I'm going to say neighbors.append, and I'm going to append the row -1 and then the current column. So we can add a comment here and say this is going to go up. Now, the reason I have to check if the row is greater than 0 is because if the row currently is 0, I have no more rows to look up. I'm at the bounds of my maze, and so I can't add that. But if the row is greater than 0, so it's 1 at minimum, then I can subtract 1 from it, and that's still a valid position. Next, I'm going to say if the row, and this will be +1, is less than the len of the maze, then I can add the row below. So I'm going to say neighbors.append, row +1, and then call. Again, because if the row +1 is equal to the length of the maze, then that means if I were to add row +1, I would get an index out of bounds error. I'd be too far. That means I'm already at the bottom of my maze. But if this is true, then that means I can add one more without going out of bounds. So that's for the rows. Now we want to do the same thing with the columns for left and right. So I'm going to say if the column is greater than 0, then this is going to be left. What I can do is say neighbors.append, and I can append the current row and the column -1. Okay, and I'm going to say if the column +1 is less than the len of maze 0. Now the reason I need to check maze 0 is because my maze may not necessarily be square. In this case, I don't actually think it is square. We may have more columns than we have rows. So I need to check how many columns we have, and I can just do that by grabbing the first row and seeing how many elements are in there. So that's what I'm doing here. If we don't have a first row, this will cause an error, but we're always going to have first row, so that's fine. And then I'm going to say neighbors.append row and call +1. And then here I'm going to return neighbors. And let's just put a comment here for right. Now in here, we did not check if these positions are obstacles. We'll do that inside of here. For now, we've just got all of the valid positions that are neighbors. Now we're going to check if they're obstacles or not as we loop through them. So I'm going to say neighbors is equal to, and then this is going to be find neighbors, not find path, find neighbors. And we are going to pass to it the maze, as well as the row and the column of the current position that we're processing, right? Finding all of their neighbors. We're then going to say for neighbor in neighbors, and we are going to check if this is an obstacle or not, and if we've already visited it before. Because if we've already visited it, we don't need to process it. So I'm going to say if the neighbor is in visited, then continue, because we don't want to process it. And I'm going to say if the neighbor, and actually, sorry, I need to break this down. I'm going to say row call is equal to neighbor, and actually we'll just go RC so that we don't shadow the variable name up here. But I'm going to say RC is equal to neighbor, standing for row and column. I'm going to say if the maze at, and this will be RC, is equal to a £, okay, then what we want to do is continue, okay? Now, if this is not the case, so if the neighbor's not in visited and the neighbor's not a £, then that means we need to process this neighbor. So I need to add it to my queue. So I'm going to say queue.put, and I'm going to put inside of here my position. So I'm going to put the neighbor, okay, which is just going to be a tuple containing the row and column. And I also need to put the new path that now contains this neighbor. So I'm going to say my new path is equal to, and this is going to be whatever the current path is up here. Okay, so where do I have path? Path is right here. And then this is going to be plus, and inside of another list, because I can add two lists together, I'm going to put the, the neighbor. So all this is doing is kind of tacking the neighbor onto the current path. This is not the most efficient possible way to do this. You guys can try to optimize this if you want, but for now, this is fine. And for the simplicity of the video, I'm going to do it in this way. And then I'm going to put new path. So I'm adding the neighbor as well as the new path. And the new path is just whatever the current path is plus the current neighbor that I'm considering, right? That's what I have when I'm adding to the queue. Okay, hopefully that makes sense. Lastly, what we need to do is say visited.add, and we add the neighbor to that to make sure we don't process it multiple times. And that's actually all we need for the breadth first search algorithm. Again, I know this looks pretty complicated, but that's all we need. Now what we want to do is make it so that we draw all of this stuff out so we can kind of see this happening. And then I'll walk through the algorithm one more time just to make sure it's crystal clear. So where we had this here, right, where we were printing the maze, I'm going to copy that. And I'm going to put that inside of this while loop, because at every step, I want to draw out what I'm currently considering. So I'm going to go up here, and I'm going to paste this before we're checking if we're at the final element or the final node. And I'm going to print the maze, except this time, I'm going to pass my path. And when I pass the path, now this will allow me to draw out the path, right? So I'm going to clear the screen, I'm going to print the maze, and I'm also going to add something to print maze so we draw the path. And then I'm going to refresh the screen, and I'm going to do this every while loop iteration so that I can see the progress going on as I go through this algorithm. So now let's go to print maze, and let's make it so that we print the path in a different color. So here I'm going to say if, and this is going to be I, comma j, is in the path. So if it's in the path that we have right here, that's valid to check that. Then what I want to do is draw this in a different color. Otherwise, I'll do this. So I'm just going to copy this line. I'm going to paste this in here. I'm going to change from value to be X because X is going to represent the current path. And I'm going to change the color to be red. So now rather than drawing an empty string, I'm going to draw an X and I'm going to draw it in red, and I'll draw it at the same position I would have before. But again, we're just changing what we're drawing. Okay, so that's pretty much all we need. The last thing we need to do here is just call this function. So this function is find path, and it takes in the maze and the STD screen. At least I believe that's correct. And I think with that, this should all work. Now there's a chance I made a mistake and we'll have to fix that, but for now, let's run the code and give this a test. So let's make the terminal nice and large. Let's run this, and notice it just instantly found the path. And we get that. Now, of course, we want to be able to visualize this, so we can make it a bit slower. And the way we can do that is by using this time module. So if I go here where my refresh is, pretty much anywhere in here, what I can do is time.sleep. And I can sleep for like 0.2 seconds, 0.5 seconds, whatever you want, just so that you have some time to kind of process what's going on. So let's sleep for 0.2. Let's make this larger and let's run this. And notice that now you can watch the breadth first search algorithm in action and see every path that it's currently considering. And there you go. We just found the finished path and the algorithm is done. All right, so there you go. That project is now finished. Was a bit longer than I was expecting, but obviously I wanted to explain this as best as I could. Let's walk through it step by step to make sure everything's clear, and then we'll move on to the next one. So we start here with main. We've already talked about curses. We know how this works, and we call find path. Now we call find path, we pass the maze and the standard screen. And inside of find path, the first thing that we need to do is determine where the start position is in our maze, because we're using coordinates, right? And we're trying to use that, so we need to know the starting position. So inside of find start, we just loop through the maze. So we go through all of the rows, we go through all of the values in each row. And if we find a value that's equal to the start symbol, which I'm denoting as O, then we're just going to return whatever position that's in. And that way I can now very easily change the start position, put it anywhere in the maze, and this will adapt. And in fact, let's just do that by putting an O up here. Okay, let's save and let's make sure there is a path. Yes, that's fine. Okay. Continuing, we then have our queue. So we define our first in, first out data structure, and we add our starting position and the starting pause. Now I'll give you guys kind of a challenge here. If you want, try to do it by just having the path and not having the starting position. There is a way to do that. Again, I just haven't done that in this video. Then I have my visited set, keeping track of all the elements I visited. I'm saying while the queue is not empty, what I'm going to do is get the current position and the path from whatever's at the front of the queue. I'm then going to get the row and the column of the current position, and I'm going to draw out the maze with whatever current path I'm on, whatever one I've got to at this point. I'm going to check if I'm at the end. If I am at the end, then I can return the path because I found that end node. If I've not, then I need to continue looking for the end node, right? So I'm going to say neighbors equal to find neighbors, maze, row, and call. I'm going to loop through all of the different valid neighbor positions. I'm going to check if they're visited, and I'm going to check if they're an obstacle. If they are, I'll skip them. If they're not, I need to add them to the path and add them into the queue because we need to check now if they're the end node and if we need to expand from them, right? That's how this algorithm works. Then I add them to the visited set. And this continues until we either find the path or we visit every single node that we have. So every single one of them has been added into visited that's not an obstacle, and we can't find a path. So this will end if either there's no path or you find the path. That's how that works. All right, find neighbors, pretty straightforward, gives us the valid neighbors. And then print maze, I won't explain that. We walked through that already. Okay, so that is that project. Let's just run this one more time for a sanity check that it's going to work when we change the starting node. And let's see what the shortest path is here. Okay, and there we go. We have found the shortest path. Of course, make this maze as large as you would like, and you can see, how that works. All right, so with that said, that is project number 1. Hopefully you guys enjoyed that. Definitely actually the most complicated one that we have now that I think of it. Now, though, let's move on to project number 2. All right, so now we're moving on to project number 2, which, as I said, is going to be the NBA project where we're grabbing basketball data. There's a ton of data you can get. If you're into basketball, this is going to be really cool for you. And even if you're not, you'll learn how to work with an API, how to process some data, external data in an application, kind of display that in some format, send a request, etc. So what I'm on right now is a link. It's data.nba.net/prod/v1/today.json. This is a free API. And what this gives you is links to all of the pieces of data that you have access to for free. So it's kind of weird, but this link gives you the links that you're going to look at to get specific data. So for example, if I search for, let's zoom in. Oh, that's a lot easier to see. So for example, we have this calendar, okay? So this says calendar. And it's prod v1 calendar.json. What that means is I copy what's called the endpoint, and I just tack that on. Oops, that's not what I meant to click, to the end of this here. So I paste that. So now I'm going to calendar.json. And if I hit that, it gives me a calendar that contains, I guess, some calendar data. I don't know exactly what this is doing or what this is showing, but the point is that it gives you a bunch of links for all different types of stats that you can get. So you can get like all-star roster, league config standings, league div standings, whatever you want, you can have a look at and you can grab that data. But you first go to this link and then it gives you the link to that data. That's how that works. Okay, hopefully that makes a bit of sense. I'm going to leave that open. Now, though, we want to essentially grab the data that link's providing from code. And the way we're going to do that is we're going to send a request to that link. It's going to return to us something called JSON, which stands for JavaScript Object Notation. I have an entire video on JSON on this channel, but pretty much this is a Python dictionary. That's the way you can think of it. And we can access the different key value pairs, grab the links for data sources that we want, and then send a request to those links and get data from that. So it's kind of a two-step process. We send a request to that URL. It gives us some data on the different links. We then send a request to one of those links and get the data that we actually want. And a request is essentially our computer requesting information from a remote server. We're going to send something called a GET request, which, as it says, requests information. There's other type of requests like post requests, put requests, patch, delete requests that do other types of stuff, but that's kind of beyond the scope of this tutorial. However, before we can do all of that, we need to go and install the requests module. Now, the way you do that is similar to how we installed curses before. Go to your terminal and type pip install, and then requests like that. Again, if that doesn't work, try pip3. If that doesn't work, try python-m pip install. Otherwise, you can watch those two videos that will be linked in the description, and it should show you how to fix that. But you need the request module installed. If you're on Windows and Mac, you do need to install this. Unlike curses, it will not be installed by default. And again, just a reminder, try pip3 in case that doesn't work. And then you can try python-m pip or python3-m. Anyways, I have this installed, so that's all working for me. And let's now go in here and start writing some code. So I'm going to say from requests, import, and we're going to import get. And I'm going to say from, and this is going to be pprint, import, and we're going to import the pretty printer like that. I'll show you the pretty printer, kind of a cool thing in Python. It's built in, and it gives us a nice formatted output for JSON data. Then what we're going to do is have our base underscore URL, which is going to be equal to https:// and this is going to be data.nba. and then net. Okay, this is the base URL. And then the endpoint is going to be the specific data that we want. So I'm going to say all JSON is equal to, and this is going to be /prod/v1/today.json. And today.json is the original one we were looking at that gives us all of those links. Now, though, we want to send a request to this link. So the way we do that is we say our response, because every time you send a request, you get a response, is equal to, and we're going to say get, and we're going to say base URL. We're going to append this, or we're going to concatenate this to all JSON. So we'll have, the full URL built out. And then we're going to have a look at what's known as the JSON of this. So whenever you send a request here, you have access to .json. Again, think of this as a Python dictionary. And now we can print all of that out. However, you're going to see if I print this with a print statement. So let's try this here. If I print the response, then we get kind of this garbage in the terminal that's just impossible to read. So instead of printing it using a regular print statement, we're going to use a pretty printer. Really cool thing if you haven't seen this. So to do this, we're going to say printer is equal to pretty printer. Make sure you add your parentheses. And then we can use the printer by saying printer dot and then pprint, so pretty print. And we're going to print the response. And really, we should call this data because we're grabbing the data, the JSON associated with it. So let's say data. Okay, so let's run this. And now notice that I get much nicer formatting here. Everything's kind of separated on different lines. That's what we had before. This is what we have now when we use the pretty printer. So inside of here, we can see that we have a bunch of links. Now, these links give us access to all of these different things, right? So gamebook, lead tracker, mini box score, whatever data it is that you want, you can pretty much get all of it. So what we want is the current scoreboard because we want to get information about games that are currently going on or that are going to happen today. So what I'm going to do is try to grab this current scoreboard key and get the link that's associated with it. So the way I do this, first of all, is I need to access the links key, right? So that I can start looking at this dictionary. Then I need to access the, let's have a look, the current scoreboard. So we'll do it step by step. Let me just close this terminal and let's do this. So we have our data. Now we want to say links is equal to data at, and then links. And let's print this out. So printer.pprint and then links. Okay. So let's have a look at that. And now when I print out the links, we just get all of the links in here. And now the link that I want is the current scoreboard. So I'm going to grab the current scoreboard link. So I'm going to copy that there. And now I'm going to say that my scoreboard is equal to, and this is going to be links. And then we're going to paste in here the current scoreboard. So now let's have a look at the scoreboard. Okay, let's run this. And notice here that this is the URL. So prod v1 2022, whatever, scoreboard.json. Now that I have that, as I was saying, I need to send a request to this endpoint. The endpoint is the slash after the base of the URL so that I can get that information. So now that we have that, we have the scoreboard URL. Let's make a function here and let's say get underscore scoreboard. Okay. Let's put this inside of here. And we're just going to separate things to make it a bit cleaner. I'm going to say define get underscore links. Okay. And inside of here, we're just going to return links. And now what I'm going to do is rather than links, I'm going to say get underscore links like that. And then I'm going to access the current scoreboard. So I've just made it so I can reuse this function here. So that gets me all of the links, sorry. So now I get the links, access the specific link that I want. And now I'm going to send a request to that link. So I'm going to say get, and we're going to say base URL. And this time we're going to say plus scoreboard. Okay. And we'll say that this is response. And actually, I guess we could just do data is equal to, and then we can get the JSON. And then again, we can use the printer. So printer.pprint, and we can print out our data. Okay. So now all we need to do is call the get scoreboard function. So let's call that. And what's going to happen now is it's first going to send a request to, to the alt JSON URL. It's going to give us the links. We're then going to access current scoreboard. Then we're going to send a request to that, get the data, and print it out. So let's clear this and let's run. And notice that I get all kinds of data here, right? And this is kind of hard to read. Like there's a lot of stuff, so it's difficult to look at what the keys are. So what I like to do here to actually see how I can kind of traverse this data is I would like to print out the keys. Because remember, this is a Python dictionary. So since it's a dictionary, what I can do is just grab all of the keys of the dictionary, and then I can see what data I want to grab next. So if I run this now, and we scroll to the bottom, notice that my keys are internal, num games, and games. So I probably want to access the games. So let's clear that and just access the games for now. So now I can go JSON and games. And now let's have a look at what this data looks like. So let's run this. And notice again, I get a bunch of stuff. So now I probably want to have a look at the keys of this. So let's say data.keys. Okay, let's run this. And what does it say here? List object has no attribute keys. Okay, so what that means, sorry guys, is that the games is a list of all of the different games. So what I can do instead now is I can say for game in games, because this is a list. We just found that out. And now I can simply print the game.keys. And just break. And what that means is I'm just going to do this one time. So I'm just grabbing, the first game and printing out all of the keys associated with a game. So I can view that. So now let's run this. Okay. And name games is not defined. Oh, my apologies. Let's call this games, not data. Okay. Let's clear the screen. Let's run. And now I get all of these keys, okay? All of this information I have access to for every individual game. And the games are games that are going to be happening today. That's what the games are. So now I got to pick what information I want to display, because I probably want to print out, who's playing, what the score of the game is, what time it is in the game. That's the stuff I had before at least, so I'll probably do the same here. So we can kind of pick what we want, but we have V team and we have H team. Those stand out to me as the visitor team and the home team. We also have period, and we should have clock. So I think those are the 4 ones I want for right now. So let's grab those. So we're going to say home underscore team is equal to, and this is going to be game at, and then this is going to be H team, right? Because that's the key we want to access. And then I'm going to say, I guess, away team is equal to, and not A team, but V team. And we can print out, I guess, the clock and the period as well. We'll say clock is equal to game clock, and we'll say period is equal to game period. And now we don't need to use the pretty printer because we're just going to print these on one line, and we will print an F string, and we can say home team versus, and then away team. And then we might as well just print the clock and the period as well, just to have a look at what those are, and then we'll continue from there. Okay, clock and period. So if you're unfamiliar with this, an F string allows you to embed expressions directly inside of a string when they're in curly braces. So, I mean, this is pretty intuitive, but an F string only works in 3.6 plus, so Python 3.6 plus. So I'm just putting the home team versus away team, comma, clock, comma, period, just so I can see what those look like. And I'm going to do that for every single game. So just to separate these a bit then, let's add a bit of a separator just so that we can see the difference in games. Okay, that's clear. Let's run the code and notice that I get all of this data, okay? So for each team, I have a team ID, a try code, wins, losses, series wins, series losses. I get a bunch of data, right? And then the score of those teams, because I guess some of these games are actually happening right now. So what I can do is print out the try code if I want to see, the actual name of the team, and then I could print out their score as well. So let's try doing that now. So for our home team, that's fine. Now we're going to say home team, and inside of here, we'll say try code. And for the away team, same thing, we'll say try code, just to clean it up a little bit. So let's run this now and see what we're getting in terms of the difference. So now we notice we actually get the abbreviations for the team. Then we're looking at, what was the next thing we were printing? The clock. Okay, so 44.1 is what's on the clock for this one. And then we have the period, and it says what the current period is for the games that are currently going on. Okay, nice. So let's get rid of clock and period. So those are the teams. Next thing that I want to print is the score of each team, right? So I'm going to print F, and then this is going to be the home team, and not the try code, but the score. This is the score in the current game. And then we'll print the away team and the score as well. And so now we get the teams that are playing as well as their scores in the game, and then we can print the clock and period after that. Okay, so let's clear, let's run. And notice here that we get, I guess, what is that? Chicago, I don't know what these teams are, but something 17-19, 31-22, 14-19, etc. Great. And then here we're just getting a hyphen because these teams are not yet playing, and 0-0, I guess those guys just started. Okay. Continuing now, we want to print the clock as well as the period. So let's say print, and we'll print F, and I guess we'll go, we should probably do, should we do clock or period first? Let's go clock, period, and then we'll see what keys we have on those. So let's run this. Okay, and we get current, so that's what we want to access for the period, and then it looks like the clock just gives us a value, so that's fine. We can just grab the clock itself. Okay, so let's go clock and then period, and we want to get current, like that. Okay, let's run this again. And now notice that we get 32.0, and then that's period 1, and then 142, period 1, 409, period 1. You guys can format this better. I'm just giving you the basics, obviously. Okay, so that's what we wanted for getting the scoreboard. Now, we also can get a bunch of other data, and like I showed you, we can get stats for the teams. So their points per game, I guess their points allowed per game. There's all these different stats. I'm not a huge basketball guy. I just thought this would be cool. But let's write one now that gives us the teams, and we can view their stats. And like I had before, we will rank them based on points per game. So to do this one, we're going to want to look at get links again. So let's not call get scoreboard. Let's call get links. Okay. Let's clear this and let's run the code. And let's see what links we have for stats. I didn't print, sorry, I need to print this. Let's print get links. And actually, we should probably use the printer to do this. So printer.pprint. Okay, so let's have a look here. And these are all the ones that we have. Now, let me remember which one I was using. I think it was league team stats. Yeah, league team stats leaders. Okay, this is the one that I want to get stats. Of course, there's a lot of other ones. So I'm going to copy that key. And now we're going to write another function. I'm going to call get underscore stats. Okay, that's fine for now. And I'm going to say stats is equal to, and then this is going to be get underscore links. And we're going to reference this right here, the league team stats leaders, okay? Then we will send a request. So let's just copy this. And rather than games, I guess this is going to be teams. And we'll have the base URL plus the stats, and then .json. And then we want to print out all of those keys so we see what we have access to. So let me take this in here. And rather than get links, we'll print out, we should really call this data. So let's call this data. Okay, now let's call get stats. So get stats like that. Okay, let's run this. And let's see what we get. And notice we get a lot of information. Okay, I want to print out just the keys. That's my bad. I meant to do that. So let's do .keys. And let's see what we actually get for that. Okay, scroll down and we get league. Okay, so that's the only key. So let's access league. So let's just put league here. There's internal as well, but we don't care about that. That's some other data. Let's see what keys are associated with league. So let's run that. We have standard, Africa, Sacramento, Vegas, Utah. I'm assuming we'd want just the standard league. Okay, so let's grab standard. Okay, let's run that. And for the keys, we have season year, preseason, regular season, playoffs. I'm assuming we probably want regular season, but again, you can change this if you want. So let's now grab regular season. Let's print that. And we only have the key teams. Okay, so now let's grab teams. And then this will be called teams. Let's see if there's any keys for teams. So let's run this now. And it says, oh, data is not defined. So let's change this to be teams. Okay. And rerun. List object has no attribute keys. Okay, so this is a list, meaning that if we want to grab the keys for each team, we can just do something like teams0.keys. And if we have a look at this now, we get all of these different pieces of information for the stats of each team. So I can get the nickname, the name, the team ID, team code, abbreviation, min, FGP, TPP. I don't know what a bunch of these mean, but I know PPG is points per game. So that's the one that we're going to use because I know what that means. Anyways, those are the different keys we can get for each team. So now we can loop through every single team and we can print out information for them. So let's do that. So let's say for team in teams, and then we'll grab the names. Say name is equal to team name. What else do we want? I guess we'll get the ID. We'll say the ID. Actually, no, I don't need the ID. We'll just go with name. And I suppose we get the nickname as well. Nickname is equal to team nickname. And let's go PPG is equal to team and then PPG. Okay, and then let's just print. For now, we'll do an F string, and we'll print the name, the nickname, and the points per game. Okay, so let's have a look at this now. Let's clear and let's run. And there we go. Okay, so apparently we have a bunch of teams here that are not in the regular season or don't have a rank or something. So we'll have to filter those out. We'll do that in a second. But for now, we have the all the teams, right? So we have the name, we have the nickname. We can choose which one we want to use. And then we get average and we get rank for points per game. So this is where it gets a little bit more complicated. I want to display these teams in the order of their rank, right? So I want rank 1 to be at the top, and I guess rank 29, 30, whatever, to be at the very bottom. But I also need to filter out these guys because I guess there are a bunch of teams that we don't really need in our data set. I don't know why those are being returned to us. So the first thing I'm going to do here is I'm going to filter all of the teams that have a name of team. So I'm going to do that. Say teams is equal to filter. I'm going to say lambda x. I'll explain this in a second. Don't worry. And I'm going to say x at team like this does not equal. And then we're going to say team because anyone that had the name team was like a blank team that we didn't really need. And then we'll do this on teams. Okay, so what the filter function does is it will run a function against every single element in our teams. In this case, that's what we're passing. And if the function returns true, it will keep the element. If the function returns false, it will remove it. So this is an anonymous function. That's what a lambda function is. This is our parameter, essentially the function called x. So I write lambda x, and then I say colon x team does not equal team. I'm saying let's grab whatever the team key is of every one of our dictionaries. And if it is not equal to team, then we will return true. So like this expression returns true or false. So if the function returns true, we keep the element. If it returns false, we don't keep it. Hopefully that makes a bit of sense. I can't really explain it more than that. However, when you have a filter function here, it returns a filter object, not a list. So you just need to convert it to a list. Okay, so now that we have that, let's just run this again. And you should see that all those kind of empty teams will be removed. So let's run it. And key error team. Oh, sorry, not team. This needs to be name. Okay, let's fix that. Let's rerun. And there we go. So now all the ones that had just team are removed. Now what we need to do, though, is sort our teams by their rank in their points per game. So to do this, we're going to say teams.sort, and we're going to say key is equal to, and again, we're going to put an anonymous function. We're going to say lambda x, and then this is going to be x ppg for points per game, and then this is going to be rank like that, and this is going to be int. Now this is going to sort in ascending order. So we're going to get rank 1 first, rank 30th last. Now the reason I'm doing this is because points per game is a dictionary containing the rank and the average. I want the rank, so I'm grabbing points per game rank for every team, converting that to an int. So then we sort it as an integer, not as a string, because notice these are string values, right? And that's how this works. You can pass this key function, and that's what you're going to sort every element by when you're sorting. Now let's run this. And notice that we're going to have all the ranks in the correct order. Now, of course, I don't want to display, this weird dictionary. I'd prefer to display the following: PPG and then AVG like that for the average. So now if we rerun this, we get the average number of points that each team scores per game, and we get them ranked from 1 to 30th. Lastly, if we want another touch here, we could do the following. I'm going to say I plus 1 dot, and I'm going to say for I comma team in enumerate teams, and now it will say the rank beside each team. So let's do that now, and let's run, and notice that now I get my rank, and I also could have just done PPG at rank as opposed to doing I plus 1, but this works as well. Okay, so that is going to wrap up this project. Let me quickly walk you through it. So we start by defining the URL that we're going to send our request to. We had to import and install the request module. We set up our pretty printer. We have get links, which gives us the link we're going to send our request to get specific data. We then have this function to get the scoreboard. That is the games that are currently running. And so we have current scoreboard. We get the JSON. We grab all the games associated with that. For every single game, because this is now a list, we loop through, we get the home team, the visiting team, the clock, and the period, and then we display this data. And of course, you can display this nice, so you can get some more info. I thought this was good enough for the tutorial. Then we have our get stats function. And get stats is going to grab the league team stats leaders. It's going to do the filtering, it's going to do the sorting, and it's going to go through and display all of the teams ranked by points per game. So I just called get stats to run that. You can call get scoreboard to run this. You can run both of them. You could write a little program that asks the user which one they want to run. I'll leave that to you guys. Now we're going to move on to project number 3. All right, so now we are moving on to project number 3, which is a currency converter. Now for this project, we need to go to this website, free.currencyconverterapi.com, to get an API key that we can use with this API. Now this is a free API, as it says in the name. You are rate limited, which means you have 100 requests per hour. You can do a maximum of 2 currency pairs when you're getting the exchange rates per request, and you're allowed to go back 1 year in history. Now you can pay for a premium version of this. Obviously, we don't need to do that for this tutorial, though. We just want to get the exchange rate data. Now, this data is updated, I believe, every 60 minutes when you're on the free version. I think if you go to the paid version, you get it every minute or 60 seconds or something like that. Again, it doesn't really matter for this tutorial. Anyways, go to the website, link in the description, click on Get Your Free API Key, enter your email. It will send you the API key, but make sure you verify your email, because if you don't do that, then it won't activate your API key. Anyways, I already have my key, and you don't want to share this with anyone. Of course, it's the video. I don't really care. I'm going to have to share it with you. But what I'm going to do is make a variable here in a new file called API key, and I'm going to paste in my key, which I'm just going to grab from my other screen. Now, while we're at it, we're going to paste in another variable here called base URL. Now, this is going to be equal to a different URL than you just saw. It is free.curconv.com. So that's the URL we want to be sending our request to for this project to get the up-to-date currencies, right? Okay, then what we're going to do is say from request import get. Now, if you were not following along with the previous project, which is fine, what you need to do is install requests. So pip install requests like that. You can also try pip3 install requests. And if that doesn't work, try python-m pip install. Lastly, you can try python3-m pip install. If that doesn't work, there's 2 videos linked in the description that will show you how to fix that command, one for Mac and one for Windows. Okay, now that we have that, we're just going to import the pretty printer as well, just so we can use that again. We use this in the last video. Sorry, so from pprint, not last video, last project, we are going to import the pretty printer. Okay, so this API works a little bit differently than the last one. We need to send what's known as some query parameters when we want to get some specific data. And the first thing I'm going to do here is show you how we can get a list of all of the currencies, and then how we display those currencies. Then we can get the exchange rates and all of that stuff. For now, though, I'm going to set up a printer. So I'm going to say printer is equal to pretty printer. Again, if you weren't following with the last video, then what this allows you to do is get some nicely formatted output for your JSON. The JSON is essentially a Python dictionary that's going to be returned to you when you send a request to a URL. Okay, so now that we have that, let's get the currencies. The way that we get the currencies is we say endpoint is equal to, and then I need to copy this in. So let me just copy this from my other screen. And this is going to be API/v7/currencies and then question mark. Now, this starts what's known as a query parameter. A query parameter is essentially a parameter, some data that you're going to send to the URL. And in this case, what we need to add is our API key. So we're using an F string available in Python 3.6 and above. We're embedding the API key directly in here, and that's what's going to allow this to work. If you don't have the API key, then this won't be validated and you won't be able to send a request. Now let's actually do this in a function. So I'm going to say define get currencies like that. And we're going to say this is our endpoint, and we're going to say that our URL is equal to our base URL plus our endpoint. And then we're going to say that our data is equal to, and this is going to be get. We're going to send a get HTTP request to this endpoint. So we're going to say get URL and then .json like that. And for now, we're going to say printer.pprint, standing for pretty print, and we're going to print out the data, and we'll just call the get currencies function. Okay, so that's all we need for now to look at the currencies. So let's run this. And no module name request. Okay, it needs to be requests plural. My apologies. Let's run this again. And notice that we get all of our different currencies, okay? So when I have a look at what we're getting returned here, we get a key that says results. Now, again, this is just a Python dictionary. That's the way you can think of it. Really, it's JSON, but it gets read in as Python dictionary. So I can access this results key, which is then going to give me a dictionary that has keys for every single currency. And then the value of all of those currencies is going to have an ID, a currency name, and optionally a currency symbol. So I want to be able to display that data to the screen. So what I'm going to do here is from this function, I'm going to return the data, and then this is going to be at results like that. And I'm also going to sort all of the results before I return them. So I'm going to say that this is results. Okay. I'm then going to say here data.sort. So actually what I'm going to do here on a new line is I'm going to say data is equal to, and then this is going to be the list of data.items. The reason I'm doing this is because data right now after I get results is going to be a dictionary. As we can see, I don't want it to be a dictionary. I want it to be a list. And the reason I want it to be a list is so that I can sort it by the different currency names. So I'm going to convert it into a list by getting all of the items. The items will give me tuples that contain the key. So would that be the currency and then the dictionary associated with each currency. Then I'm going to sort this. By default, it will sort by the first item in Python, so it'll sort by the currency name, and then I'm going to return my data like that. So now I can say down here, data is equal to get currencies, and I can say printer.pprint and data, and hopefully this will look a little bit cleaner now, and it should be sorted. So let's clear the screen. Let's run this. And then notice we're getting tuples here, right? Where it contains the currency, I guess you could call it ticker, and then the information associated with that currency. And it's in alphabetical order based on, I'm going to call it the ticker or the ID, whatever, for the currency. So now what we want to do is write a function that can display this in a much nicer format. So we're going to say define print underscore currencies. We're going to take in our currencies and we're going to loop through them and print them out. So we have data there. That's fine. So now we're going to say for currency, and then this will be, well, we should probably spell currency correctly. So for currency in currencies, we are going to grab the name of the currency. So if we look here, we see we have currency name. We want the ID and then potentially the currency symbol, but not all of them have it. So we're going to have to write some code for that. Okay. So let's say name is equal to, and then this is going to be currency, and I believe it's currency name. And then we want the ID. So we're just going to say underscore ID. I don't want to use ID because that's a built-in keyword in Python. And this is going to be currency. Actually, no, it's just going to be ID. Okay, and then the symbol will be, so symbol is going to be equal to currency, and then this is going to be .get. And we're going to try to get the currency symbol like that. And if it does not return a symbol, then we're just going to get an empty string. So when you use .get, that will try to find this key in the dictionary. If it exists, it gives you the value. Otherwise, it gives you the default value, which is an empty string, which I'm passing right here. Okay, now that we have that, we can print this out. So we're just going to print an F string again, and we'll have the ID first, because that's going to be the 3-letter symbol. Then we will have the name, and then optionally, we will have the symbol there. Okay, hopefully that makes sense. Let's now call this. So print underscore currencies. Let's pass our data and let's see what our output looks like here after I clear the screen. Okay, let's run it. And tuple indices must be integers or slices, not string. My apologies, guys. So we're going to say for currency, let's do this. For name, comma, currency, and currencies. The reason we have to do this is because this is a list of tuples. Forgot about that. So now if I run this, it should be good. And there we go. Now we fix the problem. So we can see that we get our little ticker, currency. If there's a symbol, it will display the symbol. If there's not a symbol, then, well, we don't show it. Okay, nice. So now that we have that, we want to write something that can get an exchange rate. So I'm going to say define exchange underscore rate, I guess, like that. And for the exchange rate, we need two currencies that we want to get the rate for, right? So we're going to say currency 1 and currency 2. Now, these currencies are going to be the IDs of the currencies we listed out. So like CAD, USD, whatever. The IDs is what we need to pass to this function for this to work. Now, the endpoint for this, I'm just going to copy it in here, is going to be the following. So endpoint is API/v7 convert question mark Q, okay, for query, right? We're going to say is equal to currency 1, and then notice this is underscore currency 2. So a little bit weird how this works, but for this specific URL, you pass the first currency underscore the second currency, and that's the pairing that you want to get information about. Now you can pass multiple pairings, like I could do USD underscore CAD here, and it would give me both of the results. Now we're just going to do one at a time, and then you say and compact equals ultra, and API key equals API. When you do compact ultra, gives you the most compact version where it's just going to give you the exchange rate. And then of course you need your API key as well. So we're going to embed that in this way. Hopefully that makes sense. Now we're going to send a request here. So we're going to say URL is equal to base URL plus endpoint. We're going to say response is equal to get URL.json. And sorry, not .json. We're going to say data is equal to response.json. And let's now just print this out. So let's go printer.pprint. And we're going to have to handle potential errors that can occur here if you pass invalid currencies. So for now, though, we can comment this out and we can just call the exchange rate. And let's pass this with USD and CAD. And it will give us the exchange rate between USD and CAD, not from CAD to USD, although I guess you could go both ways. Okay, let's run this. And notice that we get USD CAD and it's 1.259025. Looks about right. And if we pass the second pairing, it would have given us this key for whatever the second pairing was and then the value. Hopefully that is clear, but that's what we're getting from that. So what we need to do now is essentially check to make sure that this actually worked. And the reason I'm saying that is because if I pass something like, random string here and I run this, notice that my data is empty because there was no pairing with that name. So what I'm going to do here is I'm going to say if the len of data is equal to 0, then I'm just going to print out invalid currencies. I guess we could just do, I guess that doesn't really work. We'll do invalid currencies, and then we'll just return. Otherwise, though, we want to get the pairing, and we're only going to have one pairing here and here. One pairing here and here. Okay, interesting how I said that, but we're going to return data, and then this is going to be .items. Actually, not .items, .values. And we're going to convert this to a list first of all, because when you get the values, it gives you kind of this special object. And then we'll grab the 0th value, and we can, actually that's already a float, so we don't need to convert that. Okay, so let's now say rate is equal to that, and then print rate. Okay, and then this will be USD. So what I'm doing is I have my endpoint, right? I have my URL. I'm getting my response. I'm getting the data associated with that. I'm saying if the len of data is 0, then print invalid currencies. I also realized that we can just clean this up. So let's just make this data like that. Now, if the length is 0, that means, well, we didn't have a valid pairing. So we print that out and we return. Otherwise, though, we're going to convert all of the values. It's just going to be one value, really, to a list. We're going to grab the 0th element, which will just give us whatever the rate is. And then we can print that out here. Okay, so let's run this. And notice we get 1.259025. Nice. Okay, so now that we have gotten that, maybe I want to add some output in here actually that tells me a bit nicer what the rate is. So let's do that. I'm going to say, should not print, I'll say rate is equal to this. And we will return the rate, but before I return the rate, I'm just going to print out. And we'll do an F string here. And we will say that, what is this going to be? Currency 1, okay, to currency 2 is equal to rate. I don't know if this is exactly the way that I would write this, but I think that's fine. Like USD to CAD, for example, is this rate. Yeah, you know what? For now, we're just going to go with this. We'll say is equal to that. That's fine for me. Okay, so let's just run this one more time. And notice that I get USD to CAD at 1259025. Okay, perfect. That works for me. Now that we have that, we're going to write one more that is going to take a dollar value and convert that dollar value to the other currency. So we're going to utilize this function, but I'm going to say define, and then this is going to be, I don't even know what I would call this here. I guess convert. And convert will take currency 1, currency 2, and an amount. Now in here, we're going to say the rate is equal to exchange rate of currency 1, currency 2. I'm going to say if the rate is none, so if we're returning from here, meaning we had an invalid currency, then we're just going to return. We don't need to do anything. Otherwise, though, we're going to try to convert the amount that was passed here to a float. So I'm going to say try, and then I'm going to say amount is equal to float amount. I'm going to say accept, and then what I will do is say print invalid amount. So if you pass like a string amount, for example, here, something that I can't convert to a float, I say invalid amount, and then just return, so that way we don't have any issue when we try to do a multiplication, which you're going to see in a second. Okay, so we try that. If that doesn't work, we say invalid amount. Otherwise, we're going to say converted underscore amount is equal to, and this is going to be rate multiplied by whatever the amount is, right? And then what we can do is print with an F string here, and we can say, let's say amount, and then currency 1, and let's just say is equal to, and then we'll say converted amount, currency 2. Okay, and then just because we might as well just return the converted amount. Okay, so now we have 4 functions: get currencies, print currencies, exchange rate, and convert. So now what we want to do essentially is just write a program that keeps asking the user for a command and allows them to quit, but they can type in a command and do whatever they want with the currency converter. So I'm going to say define main. Inside of here, I'm going to say currencies is equal to get currencies. Okay. And then I will just print out like a little welcome message. So welcome to the currency converter. Okay. Exclamation point. And then we'll print the different commands. So I'll say list the different currencies. Okay. We'll say print, and then this is going to be convert, convert from one currency to another. Okay. And then print, we'll just call this rate, get the exchange rate of 2 currencies. Okay. Now that we have that, let's just do one empty print statement just as a separator, and then we'll say while true, and we're going to ask them to enter a command. So we'll say the command is equal to input, and we'll say enter a command, and we'll just say that they can type Q to quit, like that. Okay, so now in here we're going to say, actually first let's convert this to dot lower, just so that we can check, even if they type something uppercase, we'll still get the command. So first we'll check if they quit. So if command is equal to Q, we need 2 equal signs here, then we can just break out of the while loop. So let's break. We'll say elif the command is equal to list, then simple enough, we can just print the currencies. Okay, so print currencies like that. That's all we need for list. We'll say elif the command is equal to, and then I guess we can handle convert. Then we need to ask the user for 2 currencies as well as an amount. So we're going to get currency 1, which is equal to input, enter a currency name. Okay, actually, let's say ID. All right, then we'll convert that. Actually, we're going to convert it to dot upper, not dot lower. Now let's copy this again. So let's say that's currency 2. Actually, we'll say enter a base currency ID, enter a currency to convert to. Maybe we'll just do this. I think this reads a bit better. enter base currency, enter currency to convert to, and then we want one for amount. So I guess I could have just written this from scratch. We'll do this in between. I'll say amount is equal to input, enter an amount, and then we'll say in, and this will be in the base currency. So we can say in, and then currency 1. Okay, and well, we don't really need to convert that to dot upper because it's just going to be at a value. Once they do all of that, then we can call our function, which is convert, and we can pass our values. So we can say convert like that, and we pass currency 1, currency 2, and amount. Okay, lastly, so we say elif the command is equal to rate. Then we just want to get the two currencies. So let's grab currency 1 and currency 2, and let us call exchange rate. So exchange rate of currency 1 and currency 2, and else we'll say print unrecognized command. Okay, I think that is all we need. Now we need to, of course, call the main function. Okay, let me zoom out a little bit just so you guys can read a bit more. So we have our main function. We're getting all the currencies. We're just printing a little welcome message, and then we're running a while loop, and we're saying while true, we're going to ask them to enter a command, Q to quit, of course. If they enter Q, we will break, so that will quit. If they enter list, we'll print the currencies. If they enter convert, we'll ask them for the information we need. Then we will convert, and convert here, we'll do everything we need and print out the output. Then we have our rate, where we get our two currencies, and same thing, we get the exchange rate, and that will handle printing out the output as well. So I believe that's it. Let's run this though and test it out. So run, and welcome to the currency converter. Let's zoom in a bit here. List, convert, and rate, enter command. So let's try list. Okay, there we go. List everything out. Let's try to do the rate, and let's do USD and ZAR. Okay, and gives us 14.944. Okay, let's now try, was it exchange? No, it was convert. Convert, enter a base currency. Let's go USD. Enter an amount in USD. Let's go 1,000. Let's go XOF, which is one I just saw up here. West African CFA franc. Okay. And there we go. Gives us the conversion. Nice. And then if I hit Q, I can quit. And that is all the program needs to do. For this project, we're going to build a YouTube video downloader. Now, the way this will work is you will just type in a URL of video you want to download. You will then open up the browse window. So you'll kind of select the location you want to save it to, and then it will just be downloaded. Very nice. So let's create a new file here. I'll just call this youtube.py. And similarly to the last project, we are going to install a module here that will make our life easier. So we're going to go here and say pip install PyTube. Same thing as before. You're going to want to change this to pip3 depending on your operating system. Okay, so let's install PyTube. You can see I've already got it installed. All right, so now that that's installed, we're going to do a few imports here. We're going to say from PyTube, import YouTube. You can guess why we need that. We're then going to say import tkinter. This is built into Python, by the way, as tk. And we're going to say from tkinter, import the file dialog like that. Now you'll see why we need this in a second, but tkinter is a very basic 2D graphics library, or kind of like GUI utility library in Python that lets you build some graphical user interfaces. We're simply going to use it just to have a directory pop-up so that you actually get like a visual kind of place where you can select where you want the file to be saved. You'll see what I mean in a second, but you could do some more cool stuff with it. So if you're interested, you could check out tkinter. Pretty simple to get started with. Anyways, first thing we want to do is figure out how to download a YouTube video. So we're going to make a function here, which is download video. And what we need to download a video is the URL and the path that we want to save the file to. Now, similarly to before, we're going to do a try and accept block because stuff can always go wrong when you're using these kind of APIs. So we're going to say accept exception as E, and then we're going to say print E here. And inside the try block, we're going to start writing the code that we need to actually download the video. Now we're going to say YT, standing for YouTube, is equal to YouTube, and we are going to pass in the URL. Now what this will do is grab kind of an instance of the YouTube video based on the YouTube URL that we pass, and then we can kind of do a few things with it. Like we could get some stats about it, but in our case, we actually just want to download it. Now to download it, there's a few ways to go about doing this, but we want to download the highest resolution version. So the first thing we're going to do is get access to all of the different streams of this video. So we're going to say yt.streams.filter. We're going to say progressive is equal to true. And we're going to say the file underscore extension. Is that how you spell extension? I think it is equal to MP4. Now you could change this if you want, but I think MP4 is just the default that most of us are going to use. Okay, now that we have access to all of the different streams, so this is all the places we could be downloading it from, we're going to get the highest resolution stream. So we're going to say highest res stream is equal to streams.get underscore highest underscore resolution, like that. Now this is going to give us access to that stream. Now that we have access to that stream, we're going to download the video. So we're going to say highest res stream dot download. And we're just going to say the output underscore path is equal to the save path, which is the parameter passed into here. That's it. We can then go and say print video downloaded successfully, exclamation point. Okay, pretty straightforward, but we can go ahead and test this out. So we can just say URL is equal to, and we'll grab a YouTube video URL. And then for the save path, we want to specify where we want to save it. Now, if we don't pass anything, it will just save it in the current directory where we currently are. But I'll show you again in a second how we can kind of fix the path a little bit so that it's a bit easier to figure out where we want to save it. Now, in my case, I'll just manually type in the path. So I'm going to say C drive : users/tim/ desktop/ Python automation, which is the name of the folder that we are currently in. Okay, now we can call the function. So download video, URL, and save path. And now what we need to do is just get a YouTube video URL. Let me just grab one of my videos and I'll be right back. All right, so I just loaded up one of my YouTube videos, 3 types of projects that make you a programmer. But I couldn't help but notice, look at this link here, enroll in my free software development introduction course. That looks interesting. Let's click on that. And you can see that we have start your career in software development. And there's actually a free intro course you guys can take if you want that teaches you about how to break into software development if you are looking to actually land a job. Not going to show this too hard. Obviously, there is a paid course here as well, but there is a completely free one that gives you a ton of value. It is 1 hour long. If you guys want to check it out, do that from the link in the description. Anyways, we have our link. Let's copy the link and paste that inside of the URL variable. And now let's save and let's run our code. So Python youtube.py, give this a second to download. Okay. And you can see now that we get the 3 types of projects that make you a programmer. Video downloaded successfully. And I'd be able to open that up now and actually watch it if I wanted to. Pretty straightforward. So now, similarly to before, what we want to do is make this code a little bit better, just so that we don't have to manually type in this path and we don't have to manually type in the URL. So let's scrap all this and let's now write something that makes it a little bit more user-friendly. So what we're going to do is make a function here called open file dialog. This is going to open the file dialog, which will kind of pick where we're going to save the folder, or the file, sorry. First, though, we're going to say root is equal to tk.tk. Now, what this does is just instantiate the tk module and kind of creates a tk window, tkinter window, right? To be able to use this file dialog, you need a window, but the thing is, it doesn't have to be shown. So what I can do is I can say root.withdraw. Now, what that will do is it will just hide the window so you don't see it kind of appearing on the screen. So we initialize the window, hide the window, and now we're actually able to use this root variable here, or really any tkinter type stuff to be able to open the file dialog. So what I'm going to do inside of this directory is say folder is equal to the file dialog. Okay, and this is going to be ask directory. And then I'm going to say if the folder path. So if they actually type something in, then we're going to say print the f string selected folder. And I'm just going to print out what the folder was that they selected. And then I'm going to return the folder here. Okay, great. So now I'm going to go down and I'm just going to make one single line here. I'm going to say if underscore underscore name is equal to underscore underscore main underscore underscore. Now you might be asking, well, what the heck is this crazy line that I'm looking at, Tim? Well, what this line will do is make sure that you are directly running this Python file before it executes anything that happens under this. That's it. All that means is that if you run this code directly, this will run. If you don't, it won't. The reason you would ever even need this is because sometimes you'll have some code inside of here that might be reused by another file. So for example, maybe our currency.py file uses something inside of here. If we don't have this line and currency were to import this module, that would actually run all of the code. Like it would run all this stuff here. So actually, with that in mind, let's put this here so that anything we do is only going to happen if we directly run this Python file. I'm hoping that makes a bit of sense, but you guys can ask ChatGPT or look it up if you want some more clarification. Pretty standard Python syntax. Anyways, we're going to say the video URL is equal to input. And we're going to say, please enter a URL. And this is going to be a YouTube URL. And notice I just added a space here. The reason for that is this input doesn't automatically put a space after it. So I just put a space so that we'll get some separation with the colon. Okay, so we're going to get the video URL. We're then going to get the save directory. So I'm going to say save dir is equal to the open file dialog. And I'm just going to quickly do something here. I'm going to say if not folder like this, and I'm going to say print, please select folder, ... We got to change this to say save directory. And then I'm going to type continue, like actually, not continue. Yes, please select the dir. Okay. And then I'm going to put an else here. And I'm going to say download video URL, and save directory. And actually, rather than please select a folder, I'm going to say invalid save location. Okay, so what did I just do here? I wrote a very simple line that simply asks for some input, so it's going to get the video URL. I then had this save directory, so we're going to open the file dialog. You're going to see how that works in 1 second. I'm just going to make sure that they actually did select a folder, because it's possible they could just exit out of it. If they did, so which is actually in the else statement here, I'm going to download the video. If they didn't, which is what this is checking, I'm going to print they have an invalid save location. Now, if we want this to be a bit more clear, we could actually swap these around and say if they have a saved directory, then we'll download the video. Otherwise, we'll do this. And if we want, we could do a little print statement here and say print started download, just in case the download takes a while or you have slow internet, so people know something is actually happening. Yeah, zoom out a bit so we can read more of the code at once. Again, all of this will be available from the description. And let's give this a test. Python youtube.py, enter a URL. Okay, that's not the URL that I wanted. Let's go back here and grab my URL, paste that in. Okay, then notice it brings up a location. So I could go desktop and what was this? Python automation. Okay, now it's actually gonna, this isn't gonna be good because it's gonna save in the same thing. Okay, let's just save it to my downloads. I'm gonna select downloads as the folder. Notice it says started download. Okay, we'll give this a second and then it should be downloaded inside of my downloads. So if I go to my downloads, cd ... cd downloads ls, you can see that we have 3 types of projects that make you a programmer, and it's been downloaded. Okay, so that was it for project number 2. Hope you enjoyed. Let's move on to the last project. Moving on to our last project, we're going to write some code that will do an automatic folder backup for us. This is actually pretty simple, but I just wanted to show it to you because it is kind of a realistic and real world project. Anyways, what we need to start by doing is installing a Python module just like before. So we're going to say pip install, and we're going to install the schedule module. You could probably guess what this is going to do, but it is going to help us schedule a kind of task to run. Now, this will show you how to schedule really any task. It doesn't have to be a folder backup. We're going to make a new Python file here. I'm just going to call this backup.py. And inside of here, we're going to import a few things that we need. So we're going to import OS, which stands for operating system. We're going to import shouutil, or however you pronounce this, which will do some copying operations for us. We're going to import date time because when I back up a folder, I actually want to save the new folder as the date that this was backed up, so we can kind of have a history of all our backups. I'm then going to import the schedule module, and I'm going to import the time module. Okay, we've got our imports. Now, what we need to do is specify what the source directory is, so the thing that we want to back up, and what the destination directory is. So what I'm going to do is say my source dir is equal to, and I'm just going to manually type in the path for this that I want it to be. So I'm going to do c:/users/tim/pictures/ screenshots. Now you can do any folder that you want. You just have to find the path to it. Now, if you're wondering, how do I find the path to it? Well, there's a few ways you can do this. Now I have to show you on Windows, because I'm obviously on Windows. But if I open up my file explorer here and I go to my, if I can do this, pictures and screenshots, what I can do is just click in the address bar here and it just gives me the path, okay? So that's how you would do this on something like Windows. Now on Mac, you should be able to just open up a folder. So you should be able to like right click on it and go to the properties of that folder or get more info about the folder. And it should show you the path to where that folder is. So that's how you can pick the location, although I'm sure you guys can probably figure out how to find the path. Now we also need to have the destination directory. So I'm going to say destination dir is going to be equal to, and then here, what I'm going to do is c:/users/tim/desktop/backups. Now I just made a new folder on my desktop called backups. You can put the folder wherever you want, but obviously just make sure the folder exists that you're going to be backing up into. Okay, so now we have the source directory and the destination directory. We're going to make our function. So we're going to say copy folder to directory, and inside of here, we're going to take in our source and our destination, and we're going to say, first of all, today is equal to datetime.date.today. Now what that's going to do is simply give us the current day today. That's all this does, okay? Just gives us the date today based on our computer. We're then going to say the destination directory is going to be equal to os.path.join, and we're going to take in our destination, which is passed here, and we're going to combine this with the string of today's date. Now, the reason I'm doing this is that we're essentially going to have this backups directory, okay? And inside of here, we're going to have a bunch of folders. All these folders will be our backup, and those folders will be labeled like 11, 23, 2023, right? Which is the current date. So what I'm doing is I'm getting the current date, and I am combining the current date with my destination directory so that inside of this directory, I have a new directory which contains the backup, which is named today's date. Okay, now similarly to before, we're going to do a try, and we're going to say showutil.copyTree. Now copy tree just copies everything recursively, which means anything inside of the folder it will copy. And we're going to copy from our source to our destination directory, okay? Make sure you don't use dest, use destination directory because that's the new directory we just set up. Awesome. Then we'll do a little print statement here. We can do an f string. We can say folder copied to the destination directory. And then we can do accept exception as E. And actually, I'm going to do something different because I'll show you how this works. I'm going to accept the file exists error. And I'm going to print an f string and say folder already exists in the destination. Now what this is doing is essentially saying, okay, it's possible that an error occurs here when I try to copy my source directory to my destination directory. If that's the case, that means there's actually already a directory with the same name inside of this, base destination directory. So we are just going to catch that error so that our program doesn't crash. And we are going to handle that by just printing out, hey, this is the error that occurred. Okay, we're almost done. So first of all, right now, if I want, I can just do this. So copy folder directory, and I can pass my source directory and my destination directory. Now let's just open that up. So if we go here and we go to desktop, you can see I have backups. Nothing's inside of here, okay? Now if I go ahead and run my code, python backup.py, we'll see if we get an error or not. It says folder copied here. Okay, so if I open this up now, you can see we have screenshots appearing. Now, the name is a little bit glitched. Don't worry, this actually will be named the correct thing. For some reason, whenever you copy a Windows created folder, which is the one that I did, it kind of glitches in the IDE. So you can see date created actually shows the correct name here, right? But it's just appearing as screenshots because there's some kind of weird caching issue in Windows Explorer. So it does actually have the correct name. Just trust me, I was messing with this before too. For some reason, it has like this weird kind of caching thing. If you were to like restart the computer, you should see the correct name. Anyways, not a huge deal. I'm sure for you guys that worked because I got it working before. But now what we want to do is we want to schedule this to run every single day at a certain time, right? Because we want to back up consistently. So what we can do is the following. We can say schedule dot every dot day dot at, and we can specify a time in 24-hour time code that we want to do this backup at. Now for me right now, it's about 6:52. So I'm going to just put this to 6:55 right now. We can change that in a second. And I'm going to do dot do. And I just put the name of the function that I want to run whenever this schedule occurs. So what we've done now is we've scheduled this task, which is just a function, right? So notice I didn't call the function. I just put the name of the function. And what this will do here is call the function on my behalf. Now, what we're going to see is that there's a little bit of an issue because we have our source and we have our destination, which are parameters that we need to pass to this function. So what we can actually do is write kind of a fancy line of Python code, which if you made it this far, I will treat you with, which is something known as a lambda. Now, I'm going to say lambda, and inside of here, I'm going to put my source dir, and I'm going to put my destination dir. Now, what I've done is I've essentially written what's known as an inline or anonymous function. So the idea is this .do takes a function that it needs to call. The problem is we need to pass some parameters to that function. There's a few other ways to do this, but one way to do this is, okay, we're actually going to write the call to the function with the parameters that we need. But we don't want to call the function. We got to pass a function to this argument. So what we do is we write a lambda, and now what this does is it actually wraps a function. So it says, okay, lambda is a function that's going to call this. So now we're saying, okay, well, we have a function inside of here. So when we have .do, we call this lambda function, which then goes ahead and does this. I know it seems weird, but it's the same thing as doing this. Define L, and then inside of here, you put this. Okay, so let's copy this and paste that here. And then rather than writing the lambda, we just put L, which is the name of our function. Okay, this is the exact same thing. So the function does this, which just calls this. Rather than doing this, we use this lambda, which is this kind of inline anonymous function. A bit more of advanced Python syntax, but hopefully you found it cool. Okay, last thing we need to do. We're going to say while true, like this, and we're going to say schedule.run underscore pending. And then we're just going to say time.sleep, 60 seconds. Now let's just move this down a bit and I'll explain. So what we're doing is we're scheduling a task to run every day at 6:55. However, the way this schedule works is that it's not actually going to execute the task for us until we have this schedule.run pending call. So what we're doing is inside of a while loop, which means just infinitely, we are going to consistently run this run pending command, which will look for any scheduled tasks that have been scheduled that haven't yet ran, and it will run them for us. We're then going to sleep for 60 seconds or 1 minute so we don't just constantly keep calling this, but every 1 minute we're going to check, because this will go up every minute, right? If the task needs to be ran, and if it needs to be ran, we'll run it. If it doesn't, well, nothing will run. So technically you could just leave this Python file running forever in the background on your computer, and every day at whatever time you put, it's going to update your code. Obviously, if you turn off the computer, you need to rerun the Python file, but this is how you schedule a task to run at a certain increment. Now you can also do every week, every year, every minute, every second, like any increment you want pretty much, you can set and you can schedule a task. So in our case, we did every day, but you can do any increment you want. Now I need to make the time a bit further because it took longer to explain, and we can test this. So I'm going to say Python and backup.py. Currently it is, issue, invalid time format for a daily job. Okay, I think we need to do, sorry, it's because I have 6:57. It would need to be 0657. But what I actually want to put is the 24-hour time code, which is 1857. So now if I run this, it's good. It's just because I didn't have 4 digits for my time code. So actually a good error to run into there. We want 4 digits. Now it's 6:56 p.m., not 56:56 a.m. Sorry, so that's why I had that issue. Anyways, I'm just going to wait 1 minute here, and we should see that it will automatically actually do the backup for us. Let's give this a second, and I'll be right back. All right, so it actually worked. It says folder already exists because the folder is already in that location that we're trying to do. Anyways, though, it did automatically run this task as soon as it hit 6:57. Now we could just continue to let this run, and tomorrow at the exact same time, it would then go ahead and run this backup task. Okay, so I'm going to close this by hitting Control-C. That's how you can actually quit this program when you have it running. And there you go. That will finish this video. If you're looking for a quick Python project that you can use to practice your skills and learn about some new Python features, then this video is for you. What we're going to do here is build the popular game known as Mastermind. This takes about 75 lines of code. I'd rank it kind of intermediate difficulty, and it's going to teach you a lot about Python, especially if you're kind of a beginner or getting into those intermediate stages. I'm also going to show you how to properly lay out a program. Even though this is small, you're going to see how an experienced programmer names their variables, creates the different functions, and kind of just sets up the general structure of the program, which is some valuable information. So with that said, let me give you a quick demo of the game so you understand how it works, and then we'll get into building the project. All right, so I've got VS Code open here. This is where I'm going to run and write all of the code for this project. If you don't already have it, I'd recommend you download it from the link in the description. Regardless, you could still use the Python IDLE or whatever your preferred environment is. This is just what I'm using for this video. Now, I've already written the project just so I can demo it for you. So let's have a quick look at how it works. So this game is Mastermind. The general idea is you're going to have a player, in this case, that's going to be us, who has to guess a 4-color or kind of 4-digit code. So in this case, the computer is going to be the one generating the code. Typically, you play with 2 people and one person is kind of the code maker. Okay, so I've actually printed out what the code is here just so that we can see it and kind of compare to it as we go through this demo. Typically, you wouldn't show the user what the code is. So it says, welcome to Mastermind. Attempt to guess the 4-digit code. You have 10 tries. The colors that can make up the code are red, green, blue, yellow, white, and orange. So you're going to make a guess of 4 colors. Try to guess what the code is. I always like to start with just one color, so red, 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 red. Okay, so now we can see that we have 0 colors that are in the correct position and 0 colors that are in the code that are in the incorrect position. So now I'm going to go with, say, white, 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 white. Okay, 0 again. Now, obviously, we can see the code, so let's speed this up and go with 4 yellows. Now it tells me that I have 2 colors here that are in the correct position and 0 that are in the incorrect position. That's because these 2 Ys are in the correct position. If there was another Y, but I didn't have it in the correct position, then this would give me a 1. Okay, so now we have Y, 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 Y. So let's do G, G, Y, Y. Now it tells me I have 3 in the correct position, but I don't know which those are necessarily. So I'm going to go with maybe W. Actually, not W. Let's go with like O. Actually, G, O, Y, Y. Okay, and now it tells me I have 2 in the correct position, 1 in the incorrect position. The reason I'm getting incorrect is because I have a green here. So I've put that there. It's in the code, but it's in the incorrect position. So hopefully that makes sense. That's why it's showing it to me. And now we can just go ahead and guess the code. All right, and there we go. We guessed the code in 6 tries. There you go. That is the Mastermind game. It'll make more sense as we go through the tutorial. All right, so let's go ahead and start building this project. Now, I'm just going to spend a minute here and discuss what it is that we actually need in terms of the subcomponents for this project. Then we can build those one at a time and then kind of tie them all together at the end. This is a good practice whenever you're writing code. You want to think about it for a second before you just dive into the code. So the first thing we need to do is we need to generate a random code. This is going to be 4 colors or 4 digits, whatever you want to refer to it as, and they have to use kind of the 6 colors that are part of the game. Okay, that's step 1, generate a code. Next, we need a way for a user to guess what the code is. And we want to make sure that what they're guessing is valid. So if they guess only 3 colors, or if they guess 5 colors, or if they guess a color that doesn't exist, we need to give them some feedback and tell them, hey, that's invalid, make another guess. Now, after that, we need to compare their guess to what the real code is. To do that, we need to determine the number of correct colors, the ones that are in the correct position, and the number of colors that are in the code that are in the incorrect position so we can give them that output. This is probably the most challenging part. Don't worry, I'll walk you through how we do that. After that, we kind of just need to tie the game together, right? We need to do 10 guesses. We need to constantly give the output saying, this is how many correct, this is how many are incorrect. We need to determine if the user got the correct code, and we need to determine if the user lost the game. That's really all we have to do. What I like to start doing is building out each of the individual components, and then at the end, I kind of tie them together. So let's go ahead and do that. Step 1 is going to be to generate our code. So since we're going to be generating a random code, I'm going to start by importing the random module. And now I'm going to define all of the colors that we're going to be using. So I'm going to say colors in all capitals. The reason I'm doing capitals is because this is a constant, and that's kind of a convention in Python. It's a variable that's not going to change. So for my colors, I'm just going to refer to my cheat sheet here for what we have. We have red, green, blue, yellow, white, and orange. I don't know if these are the real colors that are used in the game, but these are just the ones that we're going to use. And in the real game, it has 6 colors. That's why I'm doing 6. Okay, next, I'm just going to define a variable called tries. I like to put all my constants at the top of the program, just so they're easy to find, and this is the number of tries you get in the real game, so I'm doing kind of the same thing, 10 tries. Okay, next, we're going to write a function, which is going to generate the code for us. So I'm going to say define generate underscore code, like that. Now, I'm actually going to make another constant called code length and make that equal to 4, just because if I wanted to make this game harder, maybe I make the code length 5 and I increase the tries. You can kind of make this dynamic by changing these different values, assuming that we use them properly throughout the program. Okay, so for generating the code, we need to create, in this case, a list. The list is going to contain all of the elements in our code, and we're going to have 4 elements. So I'm going to say my code is equal to an empty list inside of my function. By the way, a function is just a reusable block of code that you can call multiple times. If you're unfamiliar with it, it's just something that we can use later on, so I wanted to mention that. Okay, now that we have our code list, we're going to insert 4 random colors into that list. To do that, I'm going to say 4 underscore in range, and then I'm going to go the range of my code underscore length. And this underscore is essentially a placeholder for what you would normally put here, which is like I or X or some value. In this case, I don't care about what iteration I'm on, so I can just put an underscore, meaning I don't really care about what that variable is. It's kind of like a placeholder. It's known as an anonymous variable. Okay, what I'm going to do now is select a random element from this colors list. The way that I do that is I say color is equal to random.choice and then of colors. Okay, that's going to randomly select a color from this colors list. I'm then going to say code.append, and then I'm going to append that color into my code. This for loop is going to run 4 times, which is our code length. It's going to randomly select 4 colors and then put that into our code. Okay, then I can return the code from this function, which is what I can access when I call this function. So the way this would work is I'd say code is equal to generate code. Then it's going to give me a list of 4 random colors. Perfect. Okay, now we have a way to generate the code. The next thing we need to do is allow the user to guess the code. So I'm going to make a function for that. I'm going to call this guess underscore code. All right, so for guessing the code, we're going to have to ask them to enter some input. So I'm going to say their guess is equal to input. This allows the user to type in the console, and I'm going to say guess colon like that. Now, what I'm going to do is convert their guess to all uppercases, just so that if they type like a lowercase g here, we're going to convert that to an uppercase g. So when we compare it to the real code, we don't get an issue if they typed in lowercase. Then what I'm going to do is use the .split function. Now, I'm going to put a space inside of here, and what this is going to do is it's going to take all of the input and turn it into a list based on all of the spaces. So for example, if I have GG like that, and I have spaces in between them, then what that .split function is going to do is use all of the spaces to create elements in a list. So I'm going to get a list that has 4 G's inside of it, and it's going to remove all of those spaces for me. Hopefully that makes a bit of sense, but it's just going to take all of the spaces and kind of grab all of my individual colors using the spaces as what's known as a delimiter. If you wanted to do it with commas, you change this to a comma, and then you would expect an input like this, if I could type that correctly. Okay, hopefully that makes a bit of sense, but that's what .split does. All right, now that we have a list containing all of the different colors the user inputted, we're going to check the length of that list and see if it's equal to 4. That will tell us if they inputted 4 colors or not. So I'm going to say if guess, or if the len of guess does not equal 4, then I am going to print you must guess 4 colors. Okay, and really, rather than doing 4, I'm going to change this to be the code length, so that later on, if we want, we can change what the code length is. And then here I'm going to use an f string and do code length as well. An f string is available in Python 3.7 and above, and allows you to embed variables directly inside of a string using curly braces. So you put an f before the string and then curly braces like this, and you can insert the variable directly in the string. Now, while I'm at this, I'm going to put all of this inside of a while loop, because if they input an invalid code, then I need them to go through the loop again and give me another guess. So here, inside of this if statement, I'm going to have a continue, and what continue will do is just bring me to the top of this loop. Okay, so if the length of the guess is not equal to the code length, we print this, and then they're going to have to guess again and keep doing that until they give us 4 digits. Lastly, I need to make sure all of the colors that they guess are actually in the colors list. So to do that, I'm going to say for color in guess, which is now a list, and I'm going to say if color not in colors, then what I'm going to do is say print another f string invalid color, and then we'll put what the color was, and we'll say try again. Okay, then what we can do is we can break out of this. Then what we can do is we can put an else statement here, and we can say break. Now I'm going to explain what this means, but here I'm just going to return my guess. Okay, I think that's all we need, but let's have a look at it. So essentially what I'm doing here is I'm looping through every single color in the user's guess, because now this is a list and it contains all of the individual colors that were separated by spaces. I'm going to say if any of the colors are not in this colors list, so that's all of the valid colors here, then I'm going to tell them, hey, this is invalid, please try again, and I'm going to break out of this for loop. Now, when I break out of this for loop, what that's going to do is essentially just make it so I continue with this while loop. Now, what this else statement does here is essentially check if I didn't break out of the for loop. So what I'm doing is I'm saying if I never encountered this break keyword inside of the for loop, this else statement is going to run. That means that all of the colors they had were inside of the colors list, because if this never happened and I never braked, that means every single color I had was valid. Okay? Now, that brings me into the else here because I didn't break. So that's what the else is doing, telling you if you didn't break out of the for loop. And then from this else, I'm breaking out of the while loop. So this is while true. So the only time I get out of this while loop is if I pass through this for loop and all of the colors are valid. Hopefully that makes sense, but this is what you can do on a for loop. It's actually really cool syntax, allows me to determine if I broke or not. I didn't break, so I'm going to break here out of the while loop and then return whatever the guess is that the user gave me. Okay, so that is guess code. Now that we have guess code, the next thing we're going to do is say check code. Okay, and here we're going to take the guess and the real underscore code, and we're going to check how many are correct. All right, so this is a little bit more complicated, and what this involves is essentially looking through every single color in our code, and first of all, determining if the guessing color matches the real code color. So that's the first thing that we need to do. That's the easy part. Now we can determine how many colors are in the correct position. Once we do that, though, the more difficult part is determining the colors that are in the code, but that are not in the correct position. The reason for that is that we could have colors that are in the correct position, and we don't want to count those as being in the code, but being in the incorrect position. Again, I know this seems a little bit weird, but there's a few things we have to do here. So just try to follow along with me and I'll explain it as we go kind of step by step. But step one is going to be check the correct position. Then we need to check the colors that are in the incorrect position. And it's important we do it in that order to make sure we don't double count a color. So what I'm going to do here is I'm going to say color underscore count, or counts, is equal to a dictionary. And then I'm going to say correct underscore pause is equal to 0. And incorrect underscore pause is equal to 0 to keep track of the colors in the correct position and the incorrect position. All right, first thing I'm going to do here is I'm going to say for color in the real underscore code, and I'm going to keep track of the counts of all of the colors. So I want to know, do I have 2 reds? Do I have 1 yellow? Do I have 1 green? I'm going to store that inside of the color counts dictionary. So I'm going to have something like green and then 2, which means we have 2 greens inside of the code. The reason I want that is so that later when I'm checking the incorrect colors, I can make sure that I'm not using colors that were in the correct position or counting those towards my incorrect. You'll see what I mean, but just try to follow along. All right, so I'm saying for color in real code, I'm going to say if the color is not in the color counts, which means the key, right? So like key meaning like this, green. And sorry, I need to get out of this. If the key is not inside of the dictionary, then I want to add it. So to add it, I'm going to say color underscore counts, and then this is going to be at color is equal to 0. And then no matter what, let me just close this. I'm going to say color counts at color plus equals 1. So again, I'm looping through all of the colors in my real code. I'm saying if this color is not a key in the dictionary, then we need to add it. So I'm setting that key to 0. The reason for that is that if I try to increment a key that doesn't exist, I'm going to get an error. So if the color is not there, I add it in. And then no matter what, I increment the count for that color in my dictionary.
If you're unfamiliar with dictionaries, I have a ton of Python tutorials. I think I have one specifically on dictionaries. You can check that out from my channel. All right, so now that we have the counts, what I want to do is find all of the colors that are in the correct position. So I'm going to say for guess underscore color, real underscore color, in, and then I'm going to use a fancy function called zip, and I'm going to zip the guess and the real code. Now, what this zip function does is the following. It's going to take my two arguments and it's going to combine them into tuples. So if I have guess and real code, let's say my guess is equal to like G and R, and my real is equal to like W and yellow, then what the zip is going to give me is the following. It's going to give me a list that has, if we could do this properly, has G and W and has R and Y. Okay, so it's going to essentially combine the elements at the same position into tuples and then give me a list of that. The reason for that, or the reason I'm doing that, is so I can easily compare them, because now I have a tuple, and then what I'm doing here is decomposing the tuple into its two individual elements. So I'm getting the real color, or sorry, the guess color, and then the real color, which are the two elements from my tuple. Hopefully that makes a bit of sense, but that's how the zip function works. So now that I have that, I can compare them. So I'm going to say if the guess color is equal to the real color, because again, these are at the same positions in our codes, then what I'm going to do is say my correct underscore positions plus equals 1, and I'm going to decrease the count from my color counts dictionary. So I'm going to say color counts at, and then we can use either the real color or the guess color because they're the same, it doesn't matter, at guess color minus equals 1. The reason I'm doing this is I want to mark that this color that I just found is in the correct position. So I don't want to potentially count that when I'm counting the colors that are in the incorrect position. So you'll see how it works when I start looking at the incorrect position, but I'm essentially getting rid of that color from the count to make sure that I don't use it again and count it as an incorrect color, because it's not incorrect, it's in the correct position. So now I need to kind of remove it and forget about it because I've already handled it. Okay, now we've done all of the correct colors. Pretty easy, straightforward with the for loop. Now we need to do the same thing, but for the incorrect colors. So again, I'm going to copy this kind of for loop structure. And now I'm going to say, if the guess underscore color is in the color underscore counts, I could use the real code or color counts. It doesn't matter. If I use color counts, it's checking if I have a key that exists in color counts. So it's the same thing. And color underscore counts at the guess underscore color is greater than 0. All right, sorry for the cut here, but I want to quickly demo to you an example of a real code versus our guess and what we would tell the user and kind of why we're writing the code the way we are. So here we have our real code, which is green, orange, orange, orange. And then we have our guess, which is green, green, W, W. In this case, what we tell the user is that they have one color in the correct position. That's it. They have 0 colors in the incorrect position. The reason for that is that the greens here are in the correct position. So that means if I see another green, I'm not going to say that's in the incorrect position because there's not another green in the code that it doesn't match with, right? Here we have these two greens. They kind of cancel each other out. And now as we go through the rest of the guess and we compare that to the real one, we don't say to the user, hey, this is in the incorrect position. We would only do that if there was another green in the code. So hopefully that makes a bit of sense. Now, the reason we're going through this whole process of keeping track of the count is so that as we go through here and we see this green, we make sure we don't tell the user it's in the incorrect position just because a green existed before it. This green, since it matched up with a green that was in the correct position, shouldn't be looked at anymore, hence why we're subtracting it from this color count. Hopefully that makes a little bit of sense, but that's why we're keeping track of the counts. And that's why we need to first go through and keep track or find all of the colors in the correct position. Then only after we do that and we determine how many other colors are left to kind of match up, we go through this. Okay, you can mess around with a few different examples and try kind of changing the code around and you'll see what I mean. But hopefully that gave you somewhat of an idea of why we're writing the code the way we are. Anyways, what I'm doing here is I'm saying if the guess color is in the color counts, so if the key exists and the key there is greater than 0, meaning we still have a color that we can use to kind of match with this one, then we're going to say the incorrect position plus equals 1. And again, we're going to subtract our color count. So color count at the guess underscore color minus equals 1, because now we found one color that's in the incorrect position. So we want to make sure that we're not going to say another one is in the incorrect position if there was only, say, one color to match with. So we need to, every time we tell the user one's in the correct position or in the incorrect position, kind of eliminate that color from the code to be matching against as we continue kind of doing this check and matching. All right, now that we have this, we should know how many correct and incorrect positions there are. So we can return both of those pieces of information with correct pause, incorrect pause, separated by a comma. We can just get both those pieces of information out of the function. Okay, now we have the three main components of our game. We now need to link them together with some main kind of game logic. So I'm going to make another function called game. Inside of here, I'm going to start by generating the code. So I'm going to say the code is equal to generate code like that. All right, that gives us our code. Next, I'm going to have a for loop, and I'm going to say for actually attempts in range, and then this is going to be 1, comma, and then tries plus 1. Okay. The reason I'm doing this is because the range function will go up to but not include the last value here. So I'm going to just start at 1 and go to, in this case, 11, which means I'm going to go from 1 to 10 so that I have kind of the correct try number. Hopefully that makes a bit of sense, but you'll see why I'm doing that in a second. All right. Then the first thing we need to ask the user to do is guess the code. So I'm going to say guess is equal to guess underscore code. Very simple. You can see how our functions are helpful now. This is going to get the user's guess. Once we get the user's guess, we want to compare that to the code. So I'm going to say correct pause, incorrect pause is equal to, and then what do I call this? Check underscore code. We're going to pass the guess and the code. Then we need to tell the user some output. So we're going to say print f string, and we're going to say correct positions, and then this is going to be correct underscore pause. I'm going to do a pipe, and then I'm going to say incorrect positions, and then incorrect underscore pause. Okay, very good. And then it's going to ask them to guess again. So that's really all we need. Although I want to check if the user won or if they got the code. So actually, before I do this, I'm going to say if correct underscore positions is equal to the code underscore length, then I'm going to print you guessed the code in, and we'll do an f string here as well. And then this is going to be attempts and then tries like that. And then I'm going to break out of the for loop so I don't tell them this after I already told them that they guessed the code. All right, then we're going to have an else statement here, and I'm going to say print you ran out of tries, the code was, and then I'm going to do asterisk and then the code. Now what this will do is just print out every individual element from my list. So essentially what asterisk does is just takes every individual element and kind of passes it to the print function, which means the code is going to be printed space separated from this variable. You'll see what I mean if we actually encounter this case, but it's kind of a cool thing you can use to print out a list and have it look decent with kind of space separated values. All right, I think that's all we need. I'm just looking here and making sure this is okay. And yeah, I think that's it. Lastly, what we can do is just print kind of some intro text here. So we're going to say print, welcome to Mastermind. You have, and then this is going to be f string tries to guess the code, ... And then I'm going to say print, and then the valid colors are, and then again, asterisk, and then this time we're going to do colors. Okay. Lastly, we need to call this game function. So I'm going to say if underscore name equals underscore main, then game. This will run the game one time. If you wanted to run the game multiple times, you could put this inside of a while loop and then continue asking the user, do you want to play again? If they enter yes, you run the game again by calling the function. If they enter no, then you just quit and stop running the game. If you're wondering what this line is here, this just makes sure that we're actually directly running this Python file, because you can import Python files. And if you were to import this file without having this line, like let's say you just had game here, then it would run the game when maybe you don't want to do that. You just want to be using some of the functions that are inside of our code. So this just makes sure you're directly running the Python file. All right, I think that's going to be it for the game. I want to quickly run through the code, then we'll just make sure it's working. So let's go through this first. We're printing, our welcome messages. We generate the code, and then for the number of attempts that we have, we're going to do this. We say the guess is equal to guess code. Okay, that just gets the user to guess our code. We then compare the code to the real code, and then we tell them, we check first if they actually guessed the code. If they did guess the code, and we can determine that by seeing if their correct position is equal to code length, we tell them they guessed it in this number of attempts, and then we break out of this for loop. Otherwise, we tell them the number of correct positions and incorrect positions they had in their guess. If we get to this else statement here, what that means is we never broke out of this for loop, which means the user never guessed the code and the for loop ended. So they ran out of tries. We tell them you ran out of tries, and then we tell them what the code was. Pretty straightforward. That is game. We have check code. We already ran through that. Guess code and generate code, and then all of our constants at the top of the program. And you can see kind of how this program is well laid out. It's very easy to understand what's going on. All right, so now let's run our code and see if this works. Okay, so I'm going to run it here. We have welcome to mastermind. You have 10. This should say tries to guess the code. The valid colors are the following. I always like to start with just one color. Okay, so correct position 1, incorrect position 0. Okay, now let's try this. Correct position's 2. Okay, that tells me the Y is in the correct position. Or sorry, not the Y, the R. So I'm going to go R, Y, W, W. Okay, so now I know my Y is somewhere else. So I'm going to go R. Let's go blue, Y, W. 2 correct positions. Okay, let's go R, O, Y, O. And we guessed it. Okay, nice. Got the code. That was actually pretty lucky there that we guessed that on try 5. Now, of course, we could run the code multiple times, test out all of the different cases, but I think for now, that's it, and our code is working. In this video, I'll share with you how to build a custom aim trainer in Python that you can make as easy or challenging as you want. Now, this is a great project for anyone who's a beginner or intermediate Python programmer just looking to work on something fun that will help you practice your skills. I don't assume any advanced Python knowledge in this video, but I am assuming that you've worked with Python before, you've maybe done a project or two in the past, and you have some idea about basic syntax like for loops, functions, classes, etc. Regardless, this is a great project. I won't delay the intro anymore. Let's go ahead and get into it, and I'll show you how we can build this aim trainer. So now that I've gone through that, let's go into a new file here and let's start working on this aim trainer. But actually, I'll just quickly demo it so we can talk about kind of what we need to do here. So you can see that what I'm doing is tracking some different stats. So I've set a number of lives. That's essentially how many targets you have to miss before the aim trainer is going to finish and tell you what your stats are. I've set it really high for the demo, but typically we'd have this at something like 3 or 5. We then have stats that are keeping track of the number of hits you have, the number of targets you press per second, and the total time elapsed. Obviously, we have targets that are appearing randomly on the screen. You can press on them, and you'll see that they are shrinking and kind of growing as they appear. So they grow up to a certain size, pause for a second, and then shrink back down. That's exactly what we're attempting to do. Okay, so now that we've looked at that quick demo, we have some kind of idea of what we need to build here. Let's go into a new Python file, which I'm in right now, and let's start working on this project. Now, for this project, I'm going to use a module called Pygame. Now, Pygame is something we need to install. So what we're going to do here is go to our command line or terminal and type pip install and then Pygame. Now, I already have this installed, so I'm not going to run that command. For you, you may need to do pip3 install Pygame if you're on Mac or Linux. You can also try python-m pip install Pygame or python3-m pip install Pygame. If none of those work, I will leave 2 videos on the screen that show you how to install Pygame. Okay, so now that we have Pygame installed, we can start working it. So we're just going to do a few imports here, define our Pygame window. Don't worry if you've never used Pygame before. It's super straightforward, and it's actually a really great thing to build some basic user interfaces in Python. So I'll walk you through all the steps. Let's start by importing Pygame. We are then going to type pygame.init, which is going to initialize Pygame and initialize the fonts and some other things that we need. I'm then going to go up here, and before Pygame, I'm going to import math because we're going to use that. I'm going to import random. We're going to need that as well. And then I'm going to import time. Okay, I think that's all we need. Now that we've done that, we're going to define the width and the height of our window. we're going to create a window object, and then we're going to create what's known as the main loop for our Pygame project. So we're going to say width, comma height is equal to, and then I'm going to go with 800 and 600. Now keep in mind, if you're on a smaller display, you may need to make this a little bit smaller. I'm on quite a large display, so you'll see that this is kind of a good size. But for some of you, you may want to do 600 by 400. This is the number of pixels you're going to be using for the window, okay? So now that we have the width and the height, I'm going to define a window object. So I'm going to say win is equal to pygame.display.set_mode. And inside a set of parentheses, I'm going to pass my width and my height. Now what this will do is initialize a Pygame window and display that on the screen. So this is going to pop up kind of a black window that will have an 800 width and a 600 height because we passed that inside of the parentheses. Once we have this window, we can then draw things onto it, which we'll do in a minute. So next, we're going to say pygame.display.set_caption. And the caption for this is simply going to be aim trainer. Now the caption is just the name of the window. You don't need to set this, but I like to do this for my projects. Okay, so now that we've done that, let's create what's known as the main loop of our program, which is essentially an infinite loop that will check for different events. So pressing on the screen, quitting the window, if a target appeared or disappeared, that's what we're going to be doing inside of the main loop. So we're going to say define main, which is our main function. Now inside of here, we're essentially going to create a while loop that will run forever until we quit the window. So we're going to say while run, and we'll define a variable here called run. We'll make that equal to true. And inside of the while loop, what we're going to do is loop through all of the different Pygame events and see if the user quit the window. Now, you'd think that it's already built in that when you press the X button, it's going to close the window. That's actually not the case here in Pygame. What happens when you press the X button is an event will be triggered, and we then need to respond to that event and close the window for the user. So to do that, we're going to say for event in pygame.event.get. Now, what this is going to do is loop through all of the different events that are occurring. So that will be kind of equal to the event here. And then we will check if this event is equal to the quit event. If it is, then we'll quit. So we'll say if event.type is equal to pygame.quit like that, then we're simply going to say run is equal to false. And we're going to break out of this for loop here. Okay, so now what we have is a while loop that's going to run while this variable is true. We then loop through all of the different events that are occurring as we go through this while loop. So at pretty much every millisecond or however fast this while loop is running, we're looking at all of the events. If one of the events is quit, then we're going to break the loop and get outside of it. So now if we're outside of the loop, we're going to say pygame.quit, and that's going to quit the Pygame window and close it. And then we're going to come down here and we're going to say if __name is equal to __ main, then run the main function. Now what this will do is just ensure that we're only running the main function if we're executing this file directly. Don't worry too much about this if you haven't seen it before, just a nice line to add in to make sure if we import one of these functions from another file, it doesn't cause this game to run. So now let's quickly test this out. You can see when I run this, a window appears that says aim trainer, which is 800 by 600. And then if I click on X, it closes the window and all is good. Perfect. That's all we needed for right now. Okay, so now that we have our main loop implemented, what we need to do is start putting some targets on the screen, viewing those targets, and then seeing them kind of shrink and grow. So what we're going to do is create a class, which is going to represent our targets. So we're going to say class target like that. And inside of the class, we're going to define a few variables that we need for the target. Remember, it's kind of growing and shrinking. So we're going to set a maximum size for the target, which is essentially the size at which we want to start shrinking. So we'll grow up to the maximum size. As soon as we hit that, we'll start shrinking. So the max size will be 30. You can change all of these values, by the way. I'm then going to say the growth rate is equal to 0.2. Now, this is how many pixels we want to grow the target per frame. Now, we'll talk about frames in 1 second, but both of these values you can adjust, and as you adjust it, it will make the aim trainer more difficult or easier, depending on the direction you go in. Then I'm going to set the color for my target equal to red. You'll see why we want that in a second, just so that we can kind of change the color target quite easily. Okay, next we are going to define an initialization. This is what's known as the constructor for our target. Inside of here, I'm going to take in self, x, and y. Self will refer to the target itself that we are calling this constructor on, and x and y will be the position where we want to place this target on the screen. So we'll kind of randomly generate those positions, and then we'll store them inside of the target object. So we'll say self.x is equal to x, and self.y is equal to y. We're then going to define two variables here. 1 is self.size is equal to 0. Now the size will be the radius of the target. It's going to start at 0, and then we're going to increase it by this growth factor until it hits the maximum size. Once it hits the maximum size, we'll start shrinking it down, so then it gets to 0, and then once it's at 0, we'll make the target disappear from the screen. We're also going to have an attribute here called grow. We're going to start this equal to true, but then we need to make this false as soon as we hit the maximum size, so we start shrinking rather than growing. Great. So now let's write a method that we can call to update the target size, which we'll need to do. So we're going to say define update, and we're going to take in self. Now what we'll do in here is we'll essentially check if we should be growing or shrinking, and then adjust the target based on that. So we know that we need to start shrinking the target as soon as the current size of the target is going to be greater than the maximum size. So I say if the self.size plus the self.growth rate is going to be greater than or equal to the self.maximum size, then I need to say self.grow is equal to false. So as soon as I add this growth rate and it causes the size of my target to be greater than or equal to the maximum size, I need to set grow equal to false. Okay. Then I'm going to come down here. I'm going to say if self.grow. So if we are growing, then self.size plus equals the self.growth rate. Otherwise, if we're not growing, we must be shrinking. So we'll say self.size minus equals the self.growth rate. Okay, so now we have a function that will handle sizing our target and making it larger or smaller based on if we're growing or not. Okay, now we need a function that actually draws the target onto the screen. So we're going to say define draw. We're going to take in self, and we're going to take in a window object that we want to draw this target onto. Now, the way we draw something in Pygame is different depending on the thing that we're drawing, but in our case, we want to draw a circle. So we're going to say Pygame dot draw dot circle. Okay, now what we pass here when we're drawing a circle is the window we want to draw the circle onto, the color of the circle, and then the center position of the circle as well as the radius. Okay, having all of those different pieces of information allows Pygame to put this on the surface. So in Pygame, we're constantly dealing with surfaces. This window here is going to be our window object that we've created, and we're saying, yes, we want to draw this circle onto the window. Where do we want to draw it? What color is it? How big should it be? That's what it's asking us. So we're going to put win because that's where we want to draw it. We're going to put self.color because that's the color we want the target to be. And then we're going to pass a tuple that contains the x, y position of the center of the target. So we're going to say self.x, self.y, that's the center of the target. Then we're going to pass the radius or the size of our target. So we're going to say self.size. And when we pass self.size, whatever the current size is, well, that's the size we'll be drawing for the radius of the target. Meaning as the size increases, we'll be drawing larger and larger circles. Now for now, this is just going to draw a red circle. However, if we want to draw kind of that target style circle where we have, red, white, etc., we actually need to draw 4 circles. The first one will be the largest circle, then we'll draw smaller and smaller circles that will overlap each other, and cause this kind of ring pattern to appear. So what I'm going to do is draw 4 circles here. So I'll just kind of copy this down 4 times. And what we'll do is we'll adjust the size. So we'll say self.size times 0.8. Now it's important that we do this by some kind of multiplication factor so that as the size of our target changes, so does the size of all of the rings inside of the target. I can't just say, draw this size 20, draw the next one size 30. I need to do it dynamically based on what the current size of our target is because it's going to grow and it's going to shrink, right? Okay, so we do times 0.8. Then we're going to do times 0.6 and then times 0.4. And if you want the rings to be spaced out differently, then you can adjust these values. But I think this will give us a nice ring shape for our target. Now what we need to do is just adjust the size, or sorry, not the size, the color of our targets. So we have self.color here. And in fact, let's go and say we have a second color, which is equal to white. Okay, so we'll use the color variable for the red rings and the second color variable for the white rings. So now I'm going to go here and change each kind of second target drawing here to be the second color. So we have color, second color, color, second color. You can see that we're constantly going smaller in size. So what happens is we draw this very large circle. Then on top of that circle, we draw one that is a little bit smaller. Then on top of that, a little bit smaller, on top of that, a little bit smaller. And what that does is overlap these different circles, causing us to have this kind of ring shape. In Pygame, the order in which you draw things is important. When you draw something after something else, it's going to go on top of that object or overlap it. So that's why we're able to accomplish this here with these 4 draws. Okay, that's fantastic. So now we have our target. We've created that. And what we need to do is start making these targets appear on the screen. So how are we going to do that? Well, we need to go into main here, and we need to create a variable called targets. Now, this is where we're going to store all of the different targets. Then what we'll do is we'll loop through all of the targets we have, we'll update their size, and we'll draw them on the screen. But every X seconds, we need to kind of place a new target onto the screen. So to do this, we're going to create what's known as a custom event. Now, this event will essentially be triggered every 500 milliseconds or 600 milliseconds or whatever we want. We can then check for that event. When that event occurs, we can then make a new target at a random position and add it inside of this array. So let me show you how that works. We're going to go to the top of our program, and we're going to define 2 variables here. The first variable we're going to define is the target underscore increment. Now, this is going to be equal to 400 milliseconds. Now, you can change this if you make it if you make it less, so like 300, 200, it's going to be much harder. If you make it larger, it's going to be much easier because the targets appear later. So I've gone with 400 milliseconds, but you can adjust that as you want. Next, I'm going to say target underscore event is equal to pygame.userEvent. And then I'm just going to define another variable here, which is the target underscore padding, which is essentially how many pixels I want this to be off the edge of the screen. We'll just put this here for now, and then we'll kind of look at that in a second, but I'll set that to be 30. Okay, so we have a custom event, which is the target event, which is a pygame.userEvent. We then have the increment, which is the number of milliseconds that we want to delay until we create another target. Now that we've defined those variables, we're going to start using them down here. Sorry, I didn't mean to kind of scroll through that crazy. So what I'm going to do is essentially create a timer. So I'm going to say pygame.time.set_timer. And the timer that I want to trigger is the target event. Then I'm going to put the target increment. Now what this says is trigger this event every target increment milliseconds. So we're going to trigger the target event every 400 milliseconds. That's what we're doing. Okay, so now that we have that timer, what we'll do is we'll go inside of our event loop here and we'll listen for that event. And when that event occurs, we'll make the target appear on the screen. So I'm going to say if event.type is equal to, and now we're going to use our custom event, which is the target event. So as soon as I see this occurring, I want to create a new target. To create a new target, I need to randomly generate an X and Y position for it, then create the target and add that to my target array or my target list. So I'm going to say X is equal to random.random integer, and we're going to generate a random integer for X in the range of our target padding and our width minus our target padding. Now, the reason I'm doing this is to ensure that my targets don't appear off the screen. Since we're drawing from the center position of our target, that means the radius of our target will go to the right and it will go to the left. So if I had a position like 10, 10, so I'm drawing at X position 10, X position Y, but my target has a radius of 30, that means my target will really appear from kind of negative 20 here all the way to 30, right? Or sorry, not 30, all the way to 40, because the radius is 30, so it's going to take up 30 pixels on each side of the X and Y coordinate. Hopefully that makes sense, but if this is the center position, then the radius kind of expands outwards. So I need to make sure my center position is such that when the radius is applied to my target, it doesn't appear off the screen. So that's why I have this target padding here. I'm generating a random integer between the target padding and between the width minus the target padding to ensure the center position causes the target to not be off the screen. Now I'm going to do a similar thing for my Y. I'm going to say Y is equal to the random.randint, and this will be, again, the target padding, and then the height minus the target padding. Okay, I'm then going to say target is equal to target, and I'm going to pass my X and Y. So I'm initializing a new instance of the target class. Then I'm going to say targets.append target. And what this will do is now push this new target object into this list so then we can use it and loop through it. Great. So now every X seconds, every 400 milliseconds, whatever we define in the variable, we will create a new target. What we need to do next is update all of our targets and draw them on the screen. Now, what I like to do is put all of my drawing inside of a separate function. So I'm going to write a new function here called draw. I'm going to take in a window object, and I'm going to take in my targets. Now in Pygame, remember I told you that the order in which we draw things is important. If we draw something over top of something else, what that's going to do is overlap it. So essentially what we need to do inside of this draw function is we need to clear the screen every single time we draw. So we're going to wipe the entire screen clear by drawing something over top of it. Then we're going to draw all of our objects. Then we're going to update the display. And we're going to do this every single frame. So every frame, we wipe what was on the screen previously. Then we draw onto it what we want to see next. So it's kind of frame by frame rendering. That's what we're doing here. That's not how it works in every single system. Anyways, what we do is we type win.blit, .fill, and then we can fill the window with a specific color. Now you can just write in a string the color you want. So if you want it to be yellow, you can write yellow. If you want it blue, write blue. But if you want a more specific color coding like what we have, then you can use an RGB value. So what I'm going to do is go to the top of my program, and I'm going to say my BG_color is equal to, and then I'm going to specify the red, green, blue value that I want to draw. So in this case, it's going to be 0, 25, and 40. Now, if you're not familiar with how RGB works, this is essentially 3 values in the range of 0 to 255. Now, all 3 of these values tell you the number of red, green, and blue. So the first value, 0, means I want to have no red. 25 means I want 25 green, and then 40 means I want 40 blue. And the maximum is 255. So as you kind of change these values, you get different colors. That's kind of how RGB works. In Python, you define 3 values in a tuple, and then you can use them inside of a function like this. So I can pass my background color, and now I'm going to fill the entire window with the background color. Next, I'm going to loop through all of my targets. So I'm going to say for target in targets. Then what I'm going to do is say target.draw, and I'm going to pass this window object. So if we go and we look at the draw function here, you can see that it accepts the window. So we just pass the window here, loop through all of the targets, draw them all on the screen. Lastly, we type pygame.display.update. Now the display is only going to draw all of the things that we've kind of rendered up until this point when the update function is called. So once we've drawn all of the targets and we filled the screen in, then we will call update and we'll draw them onto the screen. Perfect. That's the draw function. So now we need to make sure we call the draw function. So I'm going to go inside of my while loop and I'm going to call draw, and then I need to pass my window and my targets. So I'm going to pass win and targets like that. Now we're almost done, at least with this step. What we need to do next is we need to make sure that we update all of our targets before we draw them. So I'm going to say for target in targets, and I'll simply call target.update. Okay, so now what this will do is update all of the targets. By updating them, we're going to change their size, right? We're going to make them grow or shrink depending on where they currently are in the animation. Now, there's a few more things we need to do, but for now, let's run this and see what happens. Okay, so actually, just need to fix something there. Let's run, and you see that the targets kind of appear very quickly on the screen. Now, the reason they're going so quickly here is we haven't set what's known as the frame rate for our window. So let's fix that, then you should see that things get a little bit better. Okay, so how do we fix the frame rate? Well, inside of this while loop here, essentially what's going to happen right now is all of this stuff is just going to run as quickly as our computer can execute this while loop, because it's kind of an infinite loop, right? But what we can do is regulate the speed at which this runs by introducing a frame rate. So to introduce a frame rate, we're going to create a clock object. We're going to say clock is equal to pygame.time.clock. We're then going to go inside of here, and we're going to say clock.tick, and we'll just put a 60 inside of here. Now, 60 means I want you to run this while loop at 60 frames per second, meaning that no matter what computer we're on, as long as it can run minimum 60 frames per second, then we're going to run at 60 frames here. So this tick just regulates the speed at which this while loop runs, which means this code should run at the same speed on your computer as it does on mine. If we didn't have this, we're running based on the processor speed, which can vary drastically, even just based on what you're doing on the computer. Okay, so let's go ahead and run this now, and we should see that now our targets are kind of appearing a little bit better, right? So they're growing, they're shrinking. Yes, some of them are overlapping. That's fine. We haven't introduced logic for that, and they're appearing on the screen. Now, what you'll notice is if we let this code run for a while, it will start to get slower and slower. Now, the reason it's going to get slower and slower is because we're not disposing of our targets once we put them, once we shrink them down to a 0 size. Right now, what happens is this targets list just keeps getting larger and larger and larger and larger every time this event happens. What we actually need to do now is we need to make sure we remove these targets as soon as they have a 0 size. So we start growing them, and then as soon as they shrink all the way down to 0, we'll want to get rid of them so our computer doesn't have to handle them anymore. So how do we do that? Well, the way we do that is the following. We're going to say, if the target.size is less than or equal to 0, then we want to remove this target from the targets list. So we're going to say targets.remove and then target. Now that's just going to get rid of it and take it out of this list, meaning the next time we run this code, we're not going to be iterating over it, which means we won't kind of be doing all of these unnecessary operations on a target that's currently invisible. Hopefully that makes a bit of sense why we're doing that, but we just need to remove it as soon as it has a 0 size. Now, the reason we put this if statement here and not before the update is because we want to update it first, which means if it currently had a size of 0, because it starts out on 0 size and it's growing, then what will happen is it will get a size of 0.2 or 0.4, whatever the size ends up being, meaning we don't remove it if we just added it inside of this array. If I had put this if statement before, then we would never see a target appearing on the screen because as soon as it was added, it would have a 0 size and then we would remove it. So since we're updating first, that means if we just added the target, it will be growing, so it will have a larger size than 0. So we won't remove it, until its size shrinks back down to 0 after it has already been displayed. Okay, so let's run this now, and you'll see that the code works the exact same. Now what happens, though, is as soon as the target reaches 0, we remove it, and we don't get any errors. Okay, there we go. So now our targets are appearing on the screen. The next thing we should probably do is make it so we can press on the targets. So what we need to do is essentially get our mouse position whenever we click down, see if that's colliding with the target, and if it is, then we need to remove that target and then increment some kind of variable indicating that we pressed on the target. So how do we do that? Well, the first thing that we're going to do here is just define some variables related to kind of our analytics as we play this game. So we're going to have a variable called target pressed, which is equal to 0. We're then going to have the number of clicks that we've made in total, which will be 0. We then want to track our time. So we're going to say the start time is equal to time.time. You can find the time imported all the way up here. Okay. So the reason I'm doing this, I just want to say, okay, when did we start running this code? And then what I can do is track how much time has elapsed since we started, and that will give us the total duration of the round that we're currently in. Now, I also want to have misses. Now, misses essentially means that we missed a target. So it popped up on the screen and then it disappeared. As soon as we have a certain number of misses, then we're going to end the game. So that's kind of what we're tracking here. And I think those are the only variables we need right now. Okay, so now we have those. Let's go here, and where we have if target size is less than or equal to 0, what we need to do is increment our misses by 1. So misses plus equals 1. Because as soon as the target is removed, because the size is equal to 0, that means we didn't press on the target, and it appeared and disappeared and we didn't see it, so we need to increment misses. Whereas if we collide with the target when we're pressing our mouse on it, then that means it was a successful click. Okay, so now what I'm going to do is I'm going to write a variable called click, and I'm going to make this equal to false. What I'll now do is I'll look inside of my events. I'll see if the user pressed the mouse down. If they did, then I want to set click equal to true. So then we check if the current mouse position has collided with the target. So I'm going to say if event.type is equal to, and this is going to be pygame.event. Actually, no, it's going to be pygame.mousebuttondown. Sorry, that's the event there. Then we're going to say click equals true, and we're going to say clicks plus equals 1 because we've pressed. So we're going to increment the number of clicks that we have in total. Okay, great. So we've now set click equal to true, clicks plus equals 1. Now we need to handle colliding with our targets. Now, the way that I like to do this is just by writing a simple method on each of my targets or on my target class. So I'm going to go here and say define collide, and we're going to take in an X and Y position, which will represent the mouse position that we want to see if we've collided with this circle. All right, so performing collision for our circle is fairly straightforward because we're just looking at the center coordinate of our mouse position versus the center coordinate of our circle position. So what we can do is we can simply take the straight line distance from the 2 points and see if that distance is less than or equal to the radius of our circle. If that's the case, then we've pressed on the circle. I don't really know how to explain it much more than that, but essentially, if you have some kind of distance between your mouse position and the circle, and it's less than or equal to the radius, then you're within the circle. If it's greater than the radius, then you are outside of the circle. There's other ways to perform this collision, but this is probably the easiest. So how do we get this? Well, what we need to do is use the distance to a point formula, and that is going to be the following. It's going to be self.x minus x, and then all of this is going to be raised to the exponent 2. We're then going to add that to the self.y minus the y, and we're going to raise that to the exponent 2, and we're going to take the square root of all of this. So we're going to say math.sqrt of all of that. That's going to be the distance between the 2 points. I'm going to double check this because it's been a long time since I've written this formula. And then we are simply going to return if the distance is less than or equal to the size. And this is going to be the self.size. Okay. Now, the only thing you need to kind of follow when you're writing this formula is that whatever order you put the coordinates in, you need to maintain that. So in this case, I'm using the coordinates of my circle first, and then the coordinates of my mouse. Since I'm raising this to the exponent 2, it essentially gives me the absolute value of this first component. Then the same thing will happen here. All I'm trying to say is I can't swap this and do like y minus self.y. If I wanted to do that, I would have to swap the other coordinate as well and say x minus self.x. Either order works. You just have to maintain the same order when you do this. So we'll go in this order, and you'll see this is fine. Okay, so now we have this collide function. Now that we have that, we can start using it. So notice we've kind of tracked if we clicked here. So if we did click, then we want to check if we're colliding with our different targets. So I'm going to say if click, and then we'll say target.collide, and then we need to get our mouse's position. So up here, I'm going to say the mouse underscore position is equal to pygame.mouse.get underscore pause. And then what I'll do is pass that position. So I'm actually going to pass an asterisk and then the mouse pause. Now, when you use an asterisk inside of function arguments, what this will do is break down the tuple into its individual components. So that might be confusing, but mouse position gives us the XY coordinate of the mouse in Pygame. So since this is a tuple, this is considered one object, right? Like pause is equal to XY. But you can see that inside of our function, right, we're taking X and Y. We're not taking a tuple that contains X and Y. So what we need to do is break this tuple into its individual elements by using the asterisk. So when I do this, it essentially takes the first element, passes that as one positional argument. Takes the second element, passes that as another positional argument. So it's equal or equivalent to me passing mouse position 0 and mouse position 1. It's just a shorthand for doing that, okay? So we're just going to use the asterisk. This is known as the splat operator. Okay, so if we have clicked and we are colliding with this target, then make it disappear. So to make it disappear, we'll simply remove the target and we'll increment the targets pressed by 1. Okay, so target pressed plus equals 1. There you go. That's all we need to do for handling our collision. So let's run this now, and let's see if this works. And we get an error. What is the error here? It says some issue. Let me just run this again with the terminal open. For some reason, my terminal keeps cutting off the errors. It says int object has no attribute self. Y.self. Okay, so I can see why we got that error. So let's go back and fix this. I'm sure you guys probably caught that yourself. It's not y.self, it's self.y. Okay, so now let's run this and see what happens when we press the targets and notice that they disappear. Meanwhile, if I click outside the target, it doesn't disappear because, well, we weren't within the bounds. So now we've already kind of got the core logic working here for pressing the targets. What we need to do next is really just display some of our statistics and then end the game, and we'll be finished with this tutorial. All right, so what we're going to do now is we're going to draw kind of a top bar that will contain some of the statistics for our app or for our round or game or whatever you want to call it. So the way we'll do that is we'll write a new function here called define draw top bar. Now to draw this top bar, we're going to take in the window and we need to take in some stats, right? Some information that we want to display. So what we'll take is the elapsed underscore time. We'll take the targets pressed, and we'll take the number of misses that you currently have, because what we'll do is we'll kind of track the number of lives remaining until we need to end the game, right? So that's the next thing we need to do as well. If you've missed more than 3 targets, well, we need to end the game, or however many lives we define. So let's actually define that up here. Let's go ahead and say lives is equal to, and let's set our lives equal to 3. We can then just quickly write some code down here. We can say if the misses is greater than or equal to the lives, then what we will do is we'll just say pass, but really this is where we need to end the game, okay? So if the number of misses we have, the number of targets we haven't pressed is greater than or equal to the number of lives we have, then we end the game. We also could just subtract from the lives, but I think this is fine as well. Okay. Then while we're at it, we'll just call draw top bar and we'll pass in the information we need. So we need the window, we need the elapsed time. Well, to get the elapsed time, we'll create a variable. So we'll say elapsed time is equal to time.time minus start time. So remember, I was telling you if we have access to the start time, then we can get the amount of time that's been elapsed by taking the current time and subtracting that from the start time. That's all it's doing, gives us current time minus the time we started. This will give us the number of seconds that have elapsed. So now we'll pass the elapsed time variable. We then will pass the targets pressed, and then we'll pass the number of misses that we had. Okay, why is that kind of highlighting here? All right, not sure why that's giving us that weird error, but regardless, let's go here. Okay, so now inside of this function, we want to draw this top bar. Now this top bar is really just going to be a rectangle that has some text on it. So let's draw a rectangle, and then we'll draw the rest of the stuff we need. So let's say pygame.draw.rect. Now this is how you draw a rectangle. You use rect, not rectangle. Then we're going to draw this on the window. We need to choose the color we want, so I'll just go with gray. And then we need to pass a rectangle object. Now, a rectangle object is going to be the X and Y of the top left-hand corner where we want to draw the rectangle, and then the width and the height for that corresponding rectangle. So we're going to draw this at 0, 0, because we want it to take up the entire screen. 0, 0, by the way, is going to be the top left-hand corner of our Pygame window. Okay, so we always start at 0, 0 from the top left. Then we need to pass the width and the height. Well, the width of our rectangle is going to be the width of the window. So we'll just pass width. And then the height is going to be some defined height that we're actually going to put in a variable. So we'll go here and we'll say top bar height is equal to, and we'll just go with a height of 50. We can use whatever height we want, but I think 50 is fine. Then I'm just going to pass my top bar height here and draw it there. Okay, so now this will draw a rectangle onto the screen. Next, what we need to do is draw a bunch of different kind of text objects on the screen that represent our different statistics. So this is where it gets actually a little complicated. But whenever we want to draw text in Pygame, we need to create a font object and then render an instance of that font. So what we'll do is go to the top of our program and we'll say our label underscore font is equal to pygame.font.sys font. And then we need to pass a font. So in this case, I'll go with Comic Sans. You can pick any font you want that's supported by Pygame, but I just recommend going with this. And then you choose the font size. In this case, I want to go with 24. Now you can see there's some other kind of things you can do here too. Like you can pass if it is bold, italic, etc. In our case, we'll just go with the standard Comic Sans of size 24. Okay, so now we need to render this font. So the process is create the font object, then you render an instance of the font, then you draw that onto the screen. So the first thing we'll draw is our time. So we're going to say the time underscore label is equal to, and this will be our label font dot render. Now what you do in the render is you pass a string of the text you want to render. You pass 1 for anti-aliasing. Don't worry about that. Just pass 1. And then for the color, you pass the color that you want it to be. In this case, we can draw it in black. Now for the text that we want to draw here, essentially we want to take our time, which is in seconds, and we want to convert it into minutes, seconds, and then milliseconds. So the way I'm going to do that is I'm just going to write a function called format underscore time. Now format time is going to take in the number of seconds that we have, and it's going to return to us a string that contains the number of milliseconds, seconds, and minutes in a nicely formatted kind of thing, okay? So we're going to say milli for milliseconds is equal to math.floor, which will round something down. Inside of here, we're going to take the int of our seconds multiplied by 1,000 modulus 1,000 divided by 100. Now, what this will do is just give us the number of milliseconds that we want to be displaying, okay? I know this seems a little bit weird. I'm not really going to explain it too much. You can try to kind of break it down yourself. It just gives us the number of milliseconds from this seconds, which will contain a bunch of decimal places. Then we're going to have seconds. Now, seconds is going to be equal to the int of the rounded seconds mod 60. And we're going to round this to the first decimal place. Okay, what we're doing is we're taking the number of seconds, we're modding it by 60. That'll give us the number of seconds that we have. And then we will handle the number of minutes here by doing an integer division. So I'm going to say minutes is equal to int and then this is seconds, integer divided by 60. We need the mod here to make sure we don't get something like 70 seconds or 90 seconds, because that's going to be handled by our minutes. Okay, so now, actually, sorry, that shouldn't be seconds. This should be secs like this, because we need to use the same value. All right, now that we have that, we're going to return a string. I'm going to return an f string, which is new in Python 3.7 and above, or maybe 3.6 and above. Anyways, inside of the f string, you can use these curly braces to embed variables. So I'm going to say minutes, colon, 0 to d. Now, the 0 to d means I want to pad this number such that it always has 2 digits. And if it doesn't have 2 digits, start it with a 0. So this will format it such that you get like 01, 02, 03, or 00 if we have no minutes, which is kind of what we want. Then we're going to do seconds. So we're going to do the same thing, 0 to d. And this is also why I need to convert these into ints, because this only works when you have an int type as opposed to a float type. Okay, so we have our 0 to d, 0 to d for the formatting. And then we will just put our milliseconds here, like that, which I actually already formatted for us, and we can put that with a dot. We can do a dot or we can do a colon, up to you. I'm going to go with a dot. Okay, so format time will give us a nicely formatted time string. So now inside of our label font, we're going to put an f string. We're going to put time, colon, then we're going to call format time with the elapsed time. So that will give us the string that we want to display inside of here after we have time. Okay, now that we have this time label, we want to display this on the screen. To do that, I'm going to say win.blit. Blit is how you display another surface. In this case, I want to display the time label surface, which you've just created. I'm going to put what I want to display, which is time label. Then I'm going to put the x, y coordinate of the top left-hand corner of the object I want to display. So I'm going to go with 5, 5, which means the top left-hand corner of this time label will be at 5, 5, and we'll draw downwards and to the right from there to draw our text. Okay, so I think that's all we need now. What I'm just going to do is I'm going to take this pygame.display.update out of my draw function, and I'm going to put that inside of here. All right, so I'm going to kind of put that down here. And what's the issue here? It says targets pressed is not defined. Did I not have that defined? Targets pressed, okay. And then let's go here to the click. Targets pressed plus equals 1. Okay, so I just need to fix that variable name. Apologize about that. I have my display now outside of these two functions that we're displaying afterwards. And now if we run the code, we should see we get our time displaying up here nicely. So notice since I drew it at 5, 5, it's 5 pixels down, 5 from the left. That's kind of what we're seeing. Okay, so now that we have the time, we want to display some other information like the number of misses, number of lives, etc. that we have remaining. So let's go here and do the rest. So the next one I want to do is the speed. Now your speed is simply equal to the number of targets you've pressed based on the current time. So like the targets per second. So the way we do that is we take the targets that you've pressed and we divide that by the elapsed time. So I'm going to use my round function. I'm going to take targets pressed and divide that by elapsed time. And I'm going to round this to the first decimal place so we get something like 2.1 or 1.1 or something along those lines. Now that we have the speed, we'll create our speed label, right? Which can be equal to the label font dot render. And then we can go here with an f string and we could say speed colon speed. And then I'll put a t/s standing for targets per second. I then need to put my 1 for the anti-aliasing to be true, and then black, and then we can draw this on the screen. So we'll take this, paste this down here, change this to our speed label, and then we're just going to set the x coordinate we want to draw this at. So I want the y coordinate to be the same, but the x, I need to space this out from my time label, so I'll just set this to be 200 so it goes a bit further to the right. Now let's do the rest of our labels. So let's copy this. So next we'll have the hits label. This is the number of targets that we've currently pressed. So we'll say hits, and this will be targets pressed, get rid of the t/s, and then we'll blit that one. So copy this and then draw the hits label. Rather than 200, this time we can go with something like 450. And then lastly, we need to display the number of lives we have remaining. So we'll say lives label is equal to, and then I really should just copy this. So let's copy that there, and we'll say lives is equal to the total number of lives minus the number of misses that we currently have. Okay, then we'll draw this one with the lives label, and we'll draw this at 650. Okay, so I think that's going to be good for the top bar. Let's run this now, and you should see that as we press targets, we start updating our different stats. However, you'll notice that some of our targets are appearing at the top bar, I'm going to show you how we fix that in 1 second, and you can see our lives are subtracting kind of as we miss the targets. Okay, so why are they appearing in the top bar? Well, the reason they're appearing in the top bar is because we haven't padded where we want to render the targets based on the position of the top bar. So what we'll need to do now is go to where we have the randomly generated positions. And for our X coordinate, we'll just say our target padding plus the top bar height, just to make sure the minimum Y coordinate is always going to be beneath that top bar. So now that we've done that, if we run this, we should see that none of our targets will be rendered in that top bar anymore. They can be close to it, but they're always going to be bordering it. They'll never be kind of beneath it, meaning we're not going to miss them. Now, obviously, I'm performing quite poorly here because, well, I'm under pressure and I'm on the video. I'm sure you guys will be doing better than me. Okay, almost done here. Last thing we need to do is simply end the game once the user has no more lives. So how do we do that? Well, to end the game, we are simply going to call a function that will display the user's stats. So very similar to drawing the top bar, we're going to draw a bunch of stats onto the screen. So I'm going to write another function called endScreen. Now this is the last function we need. And inside of endScreen, we're going to take win, the elapsed time, the targets underscore pressed, and the number of clicks that you had so that we can calculate what the accuracy is. Now what we'll do in here is we'll essentially kind of pause the execution of our code, and we will render something onto the screen that displays the stats. And then as soon as the user presses a button, we'll just end the game, okay? So what I'm going to do is say win.blit, and then we're going to blit the background color so that we clear whatever was currently on the screen. Because what I want to do is just have some text that appears in the middle of the screen. So what we'll now do is we'll copy kind of all of the text we had from here, and we'll paste this in. But now I only want to display a few things. So I don't need to display the lives anymore. I can display the hits, but I also want to display the accuracy, okay? So accuracy, I don't know if I spelled that correctly. And then I'm going to define the accuracy here. So for the accuracy, this is simply going to be equal to the number of targets we've pressed divided by the number of clicks that we had. So I'm going to say round the targets pressed divided by the clicks multiplied by 100. We'll round that. Actually, do we even need to round this? Yeah, we'll round that to 1 decimal place. Okay, so this is going to be the accuracy that we have. So now we'll just change this text to be accuracy, and then we'll display the accuracy and then %. Now what I'll do is I'll take these different labels and I'll just render them in a slightly different position on the screen so that it is in the center, right? Because here we're displaying them on the top bar. Now we want to display them in the middle of the screen. So to display them in the middle of the screen, I'll actually copy this. Rather than the lives label now, I'll have the accuracy label. And we just need to change these here so that we're rendering in the middle of the screen. Now, the way we render in the middle of the screen when we're using a label is we need to take the middle coordinate of the screen, okay? So it's a bit difficult to explain this visually or without having a visual. So let's actually go into Paint quickly here. Let's imagine we have a screen, okay? If we want to display something in the middle of the screen like this, the natural thing to do would be, okay, well, let me just find kind of this middle X position and then start drawing here. Well, that works if you have something like a circle where you're drawing in the middle of the circle, but in our case, we're drawing from the top left-hand corner, which means if we draw something from the middle coordinate, we end up drawing it to the right and down. So what we actually need to do is draw from the middle. So let's say this is X over 2 minus the width of the object we're drawing minus 2. Or sorry, not minus 2, over 2. So if you take the width of the object over 2, which is this right here, and you now move back by that to here, then you start drawing the object in the middle of the screen. Hopefully that makes a bit of sense what I just explained. But we're going to take the kind of width of the entire screen, divide that by 2, then subtract that by the width of the object that we're drawing over 2. That will then give us the X position where we need to draw the top left-hand corner such that the object will be in the middle. So let's get rid of that, and let's make a function that calculates that for us. So we'll say define get middle. This is going to take in a surface, okay? And what this is going to return is that middle position. So we're going to say width over 2 minus the surface.get underscore width over 2. So now we can use this function on our different labels to determine what X coordinate we should draw them at. So we're going to say for the time label, well, we want to draw this at get middle of the time label. Then for the speed, this is going to be get middle of the speed label. And then for the hits, this is going to be get middle of the hits label. And then for the accuracy, get middle of the accuracy label. Okay, so that should be good, and that should draw everything on the screen. However, what I want to do is have it so it kind of pauses until the user presses something. So what I'm going to do here is I'm going to manually update the screen. So pygame.display.update. I'm then going to run a while loop in here that will wait for the user to press something. Once they press something, it will then close the screen. So I'm going to say run equals true. I'm going to say while run. I'm going to say for event in pygame.event.get. I'm going to say if event.type is equal to pygame dot in all capitals quit, then I am simply going to say quit like that. Otherwise, I'm going to say if event.type is equal to pygame, and this will be dot, and we'll go with key down. So this just means if we press any key down, then I'm going to say run equals false, and I will break out of this loop. Now what this quit function will do is just completely quit the Python program for us, and then what this will do is kind of just exit the loop, which will then cause us to get out. Now what I could actually do is just put quit here as well, or I could make this even a little bit more elegant, and I could copy this all and say, or it equals this, and now we just have that in one line. So we really just have this one while loop. This is just kind of running forever and just waiting for us to press any key or to click quit. As soon as we do that, we just close the window. Okay, so now all we need to do is call this end screen function as soon as we kind of lose the game. So we'll go here, and rather than pass, we'll call end screen, and we'll pass this the information we need. So we need the window. What else do we need? The elapsed time, the targets pressed. So targets pressed, and the number of clicks. Okay, so now we should be fully finished our program. Let's run this and make sure it works. And let's just see what happens now if we kind of click a few of the things here, and then we kind of let some of our lives run out. Okay, 2, 1, and we got an error. Let's see what that error is. Was it an error, or did it just quit immediately? Let's see here, give this a second. Okay, argument 1 must be pygame surface, not tuple. Win.blit, okay. Sorry about that, guys. Let's go fix this now. Go in end screen, and rather than win.blit, this is going to be win.fill. So we need to fill with the background color, not blit with it. That's my bad. Let's give this another shot here. Click a few targets. Okay. And now let's lose. So 2 lives, 1 live, and it shows our information. However, it's showing it all on one single line. That's because we didn't change the Y positions. So let's make these like 100, 200, 300, and 400. And while we're at it, let's change the color here to be white, because black is a little bit of an eyesore there on the blue background. So let's change these all to be white and white. And let's run this. And now let's just run a few targets or click a few targets and kind of let this lose and see if it displays correctly for us. All right, so there you go. We got our time, our speed, our hits, and our accuracy, and we have finished this project. In this video, I will be teaching you some valuable Python scripting skills by running you through a complete project. Specifically, I will be showing you how to deal with command line arguments, how you can copy different files or directories, search for different files or directories, use modules like OS, SYS, subprocess, and a bunch of other modules that are very helpful when you're trying to create Python scripts that can automate workflows and just make your life easier. Personally, just knowing a few of these commands has helped me and saved me countless hours in different development projects, and the project that I'm actually working on here with you is kind of a variation of something I actually had to do when I was working for my startup and creating kind of an advanced script that had to go through and automatically compile a bunch of code for me. Anyways, I think you guys will find some great value in this. So with that said, let's get into the video. All right, so let me start by walking you through the project that we're going to complete. Now, this is a project that kind of mocks what you would be doing in a real world scenario. Obviously, I don't know what you guys need to automate or what scripts you need to write. So I've tried to create something that's very general that allows you to get a bunch of knowledge in a ton of different areas. So this may not cover everything you need to do, but it will give you a ton of that base knowledge and show you what's possible with Python scripting and how you can kind of set up these scripts to be as effective as possible and what commands you should be using for a lot of the common operations. So let's have a look at it here. First thing that I want to look at is just the directory I have on the left side of my screen. Now, you guys can download this by going to my GitHub. I will leave a link in the description, of course, and just clone the repository, download the repository, and get access to this data directory here. Now, this data directory is going to kind of simulate kind of a large project, some code or some files that you would already have and that you want to traverse through and do something specifically with. Now, that's usually what automation is or scripting is for me in Python. It's going through some existing data or an existing file structure and kind of parsing things out, grabbing specific data, looking for certain names or writing code into different files. So I've tried to kind of emulate that here. So you can see we have this data directory here, and inside of here, I have a bunch of stuff, right? I have some empty directories. I have some directories that are representing kind of games that would be written in Go. I have some random Python files. They're just empty, just for example purposes. I have a text file. I have another kind of Go file here, and you can see that there's a bunch of stuff in this directory. Now, what we're interested in here for this kind of mock project is parsing out all of the game directories. So what we want to do is want to take all of the games that are inside of this directory. We want to copy these into a new directory. We want to change the names of the directories such that we don't have this game kind of suffix on them. And then we want to compile all of the game code that exists inside of these game directories. Now, this is something I actually had to do when I was working for my startup, as I mentioned in the intro. So I've kind of put a variation on it here. Now, to go even a step further, once we get all of this game data, we parse it out, we put it into a new directory, and we compile all of the code. I want to write a JSON file into that directory that gives us some metadata or information about what we just did. So how many games are there? What are the name of our game directories, etc. And that's something that we could kind of quickly look at to get a summary of the information. So you can imagine this would be something similar to what you may want to do when you are writing your own Python scripts. Okay, so I have kind of the project text here. Excuse any spelling mistakes that are in this file, but I just wanted to walk you through very organized, step-by-step what we're going to be doing. So some assumptions here, sorry. The data directory contains many files and directories. So imagine this is massive, right? There's a ton of different code in here, and it's not feasible for us to do this manually. We want to have a script that automatically does it for us. Obviously, that's not really the case here, but again, kind of picture that we had, thousands of files. In that case, it would be very helpful to have a script to help us do this. You are only interested in the games contained in this directory, so you don't care about the rest of the junk in there. You just want the games, which are going to be stored in a directory that contains the word games. So whenever we see the word game, and that's in the directory name, then we know that we're interested in that directory. Next, each game directory contains a single .go file that must be compiled before it can be run. Okay, perfect, that makes sense. And these Go files could be named different things. Notice one is called main, one is called code, one is called file. So we're gonna have to do kind of special stuff to handle these different names and compile all of this code. Okay, so now what are we gonna do for this project? Well, we're gonna find all of the game directories from the data directory. We're going to create a new /games directory, or whatever we want to call it, that's going to contain all of our game code. We're going to copy and remove the game suffix of all of the games into the games directory. So that means copy the directory, strip off that kind of game aspect of it, put it into the new directory. We're going to create a JSON file with the information about the games. So how many games, what the game names are, etc. We're going to compile all of the game code and then run all of the game code. Now, we may not actually run it here, but we will, at minimum, go to the compile step. Perfect. So the only thing we need to do here to get started is make sure we have Python installed. I'm going to be using Python 3.9, I believe, but I think anything above 3.8 should work. And if you want to be able to compile and run this Go code, then what I'm going to suggest to you is that you download a Go interpreter or compiler. So let me just bring this up here, Go code. I'll leave this link in the description as well, but if you go to go.dev, pretty simple URL, click download, it will download and install Go. It will automatically add it to your path. Then you'll have access to the Go command that we'll be using later in the video. Last thing, if you want, there's some helpful extensions here in VS Code. If you're using VS Code, you probably want to install the Python extension and the Go extension as well. Okay, so now that we've got through that, let's start writing our code. So I have a Python file here called getGameData. You can call this whatever you want. And notice I've put this in the same directory as where my data directory is. Now, you don't need to do that, but it is going to be helpful to have it kind of close to the data directory so you know the path to where that is. So again, if you want, go to the GitHub. I'll leave that link in the description. Download this code. It will have the finished code as well, but you can just kind of delete the file and write it along with me if you want. And then you'll have this data directory, so you don't have to kind of create this on your own. So you want to work in a Python file that is in the same directory as the data directory. Now, the first thing we're going to do here is just import a bunch of modules that we're going to be using. So we're going to import the OS module, which I believe stands for operating system. We're going to import JSON, which is how we're going to work with JSON files. We're going to import shutil, which is going to allow us to kind of do some copy and overwrite operations. We're going to say from subprocess import, and we're going to import pipe and run. Now, this is going to allow us to run really any terminal command that we want. So we can, for example, compile and run the Go code using this. And then we are going to import sys, which we are going to use to get access to the command line arguments. So the very first thing I want to start by doing here, if we go back to our project text, is we want to find all of the game directories from some directory. In this case, is called /data. We want to create a new directory, some kind of target directory where we're going to be copying this into. So what I want to do is I want to grab from command line arguments what the source directory and the target directory is relative to the current path, so that I know where I should be storing kind of all of the games that I find and where I should be looking for those games to make this script a bit dynamic. So what is a command line argument? Well, let me just show you down here in the terminal. So a command line argument is something like Python. I pass my file name, so get game data, and then I do something like hello world. Okay, so hello and world are command line arguments. You've seen this before whenever you've ran any command, like when you make a folder, mkdir, and then you put the folder name is a command line argument. So in this case, we might do something like Python get game data, then we pass /data, which is going to be our source directory, and then we pass something like /new games or something like that, and that's our output or target directory. So I want to show you how we can parse out those command line arguments. So to do that, we're going to use the system module. So first I'm going to say if __ name is equal to __ main. Then in here, I'm going to grab the command line arguments. Now, the reason I'm using this is because I only want to execute the main script here if I'm running this Python file directly. If I'm not directly running this Python file, I don't want to be executing the code that's going to run through and do all of our operations. Otherwise, if we tried to import the Python file and we didn't have this line, it would go ahead and run all of that code when we don't want that to happen. So when you have this here, this just checks that you ran the file directly, and it won't execute anything in here if you were importing, say, a function or a class or something from this file. Hopefully that makes sense. But what I'll do here is say args is equal to sys.argv, okay? Now, just to show you how this works, we'll print out args, and let's run our code. So I'm going to say Python, get game data, data, new data. Okay, hit enter, and notice that my command line arguments are, first of all, the name of the Python file, and then I have my two command line arguments, so data and new data that I passed here. Now, if you are on Mac, you will probably need to run Python 3 get game data. Okay, so now that we have our arguments, I want to make sure that we have a valid number of arguments, which in this case is going to be 3. 3 because we have the file name, and then we have the 2 extra arguments, and we want to make sure we have those 2 extra arguments. So I'm going to go here and say if the len of args does not equal 3, then I will raise an exception. And here I will say you must pass a source and target directory only. Okay, so that's fine. So now if we run our code here and I only pass, for example, the source directory, then notice that I get my exception. If I pass my target as well, then all is good. Okay, so now I want to get my source and target directory. So I'm going to say source target is equal to sys.argv. And then I'm going to do 1 colon like this. And actually, we can put this as args. Now, the reason I'm doing 1 is just to strip off the name of our Python file, which we don't want, and just get the 2 arguments here and then store them in separate variables. Okay, now that we've done that, I'm going to create a function. And this main function is going to accept our source, okay, and our target. And I don't know if that's actually the right thing that we want to call it. Yeah, I guess that makes sense. Source is where we're looking. Target is where we want to put our new directory. So that's fine. We can leave it like that. And then here we'll go and call the main, passing our source and target directory names. Perfect. Now that we have done that, what we actually need to do here before we go any further is we need to create a complete path from the location where we're running our Python file to whatever this directory is. So in the case where I pass, data or target, well, I want to get the full qualified path from, say, like my C drive all the way to this directory so that it's going to work in my program. If I just try to use data or I just try to use target, we can get some weird errors depending on what operating system we're running on. So what I'm going to do here is say my source_path is equal to os.path.join. And the first thing we need here is the current working directory, which I can get by using the command. I got to check my cheat sheet here because I always forget. os.getcwd. Okay, so I'm going to join the path of cwd and my source directory. Now, you should always use os.path.join when you're trying to create paths. Don't think you're going to be clever here and have a path like, C drive : / and then you add, like you're doing a string concatenation. Don't do that. The reason you should not do a string concatenation is because if you're working on different operating systems, the path dividers are different. When you use os.path.join, it automatically will join the path based on the operating system you're working on. So you always want to use this. Don't do string concatenations to try to create paths. It might work sometimes, but it's not kind of a good practice to do that. Okay, so we've created our source path. Now, to explain this line here, cwd is our current working directory, which means the directory we ran this Python file from. So wherever we ran this Python file from, that's the working directory. So in this case, it's going to be users tim desktop Python scripting. Then whatever these paths are going to be relative to that working directory. So I combine them together, right? So now the directory will be this, and then it will have my source, which would be data, right? And then the next one will be my target. Okay, so let's copy this and make this target and change this here to be target. Okay, so now we have our source path and our target path. Now, what do I need to do next here? Well, I need to find all of the game directories from my source directory. So let's write a function that can do that. We'll say find all game dirs like that. We need to know where to look, so we'll go source. Okay, now I'm going to create a variable up here, and this is going to specify what we're looking for in our directory. So like what needs to be in their name. So in this case, I'm going to say game dir pattern is equal to, and we'll just call this game, which essentially means we're going to look for the string game in any directories, and that will tell us that we want that directory, right? Now what we're going to do is we're going to essentially walk through the source directory, look at all the files and directories, and then match any directories that have this game in them. And if we have that, then we'll add them to a list, we'll return them, etc. Okay, so let's do this. I'm going to say my game_paths is equal to, and this is going to be a, just an empty list. And actually, I want to change this, say find all game paths, because it's going to give us the full path, not just the directory name. Next, I'm going to say for root, I believe this is going to be dirs files in os.walk, and I'm going to walk the source path, okay? Now, what walk will do is walk recursively through whatever the source directory is that you pass to this os.walk command. So it's going to give you the root directory, the directories, and the files that are contained in the current level that it's walking through. Now, what this will do is recursively continue to look. So in this case, it'll look in data, but then it would, after looking in data, look inside of blank, then look inside of hello world, then look inside of rock, paper, scissors game. It would look through all of those directories. Now, we only care about the directories that are immediately inside of data. However, if you wanted to recursively look through all of them, this is what you would use, hence why I'm showing it to you here. Now, since we only care about the first kind of top level directory, we only really need to run this command one time. So at the end of my for loop, I'm just going to put a break so that I only do this once. And this is just an easy way for me to grab kind of all of the values one time, right? So you just break at the end of the for loop. So we only run this one time. Okay, now that we've done this, we need to loop through all of the directories. So I'm going to say for, and you should not use dir because that's a built-in command. So I'm going to say directory in dirs like that. And then I want to get the name of my directory and match that against my game dir pattern. So what I will do is say if my game dir pattern is in my directory.lower, and I'll put this lowercase just in case we have a capital game or like a capital on the G or something like that. You don't have to do this, but I think it makes sense to do that. If this is the case, then I'm going to add this path to my game paths. So what I will do here is say my path is equal to os.path.join. And then I'm going to take my source and I'm going to take my directory like this. And I'm going to say game paths dot append my path. Okay. Then down here, we will return our game paths. Now, the reason I'm doing this is because this dirs list here gives me all of the names of directories, not the paths to those directories. Now here, I want the full path. The reason I want the full path is so that I can easily copy it later on. If I don't have the full path, I can still create that full path, but it's just easier to return all of the full paths right now. So that's why I'm doing it. So I'm saying path is equal to os.path.join, taking my base path where I know this directory is contained inside of, and then I'm joining them together, right? Taking the directory name, adding it to the base, and then adding this to my array or list of paths, and then I will return them. Fantastic. So let's try this out now and make sure that this works. So let's say our game underscore paths is equal to find all game paths, and then we'll pass here the source path, and we'll print our game paths. Okay, so let's give this a shot here and see if we get any errors or not. So here we're going to pass data. That's going to be our source directory. So make sure you have data there. And then target will be our target, although it doesn't matter right now. All right, so notice now that I get my full paths to all of the directories that contain the name game. So I have my hello world, I have my rock, paper, scissors game, and I have my Simon Says game. Now notice that I've ignored the blank directory. I've ignored any files, even if my file had the name game inside of it, because I was only looking in directories. Fantastic. Okay, so that is working. The next thing that I want to do here is I want to take all of these paths and I essentially want to just get the new directory name that I want to copy these directories to. I know this seems a bit weird, but remember what we're doing here is we're taking all of these directories and we're copying them into a new directory, but we're removing the game part from that directory name. So when I copy, Simon Says game, I'm just going to copy Simon Says, not the game part, into a new directory. So I need to get that kind of destination path before I can perform that copy. Because to do a copy, I need a source, I need a destination. Right now, we just have the source, so we have to create the destination. Now, one thing we also have to do is create the new directory, and we can actually create the new directory right now. So let's make a new function here and say create underscore dir. And all we'll take for this is the path to the directory that we want to create. Inside of here, I'm first going to check if this directory exists. If it exists, I don't need to create it. If it doesn't exist, then I will create it. So I'm going to say if not, and then this is os dot, actually, is this going to be, I think it's os.path.exists. Yes, okay, that's correct. So if this does not exist, then I will say os.mkdir, which stands for make directory, and then I will make the directory at this path. Okay, that's it for creating the directory. So let's go here and let's say create dir, and the directory that we want to create is going to be the target path, right? So we'll just pass the target path there, sorry. Okay, next, we want to get all of those destination paths. So I need to make a function that is essentially going to look at this whole path, and it's just going to give me the directory name, but removing the game aspect. Now, I know this seems a bit backwards how I'm doing it. I'm doing it intentionally so that I can show you how you strip apart paths and take like certain components of the path. So believe me, I know there is an easier way to do this, but I'm trying to show you like how you can use a lot of different commands here. So hopefully you appreciate it. Anyways, let me just quickly look at my cheat sheet here, okay? And I'm going to say that this is called get name from paths. And I'm going to take in my paths, and I'm going to take in what I want to strip off of my directory name. So I'll call that toStrip. I don't really know what else we would call that. Okay, so I'm going to go here and say new names is equal to an array. And I'm going to say for path in paths. Now what I want to do is I want to split my path into just the directory and the base part, right? So like the parent directory of just the directory. Because remember, we have the full entire path. So when we had game paths, we have the entire path to the game directory. So we're going to split it to just the game directory and then whatever that base path is. Now, the way we do that is we can say underscore because we don't care about the beginning part. And then we can say dir underscore name is equal to os.path.split. And then we can just split the path. Now, this is automatically just going to give you the very last aspect of the path, whether it's a directory or a file or whatever it is, and then the remaining part of the path on the left side. Again, don't try to get clever and do this yourself by splitting different like slashes or trying to find the path divider. Just use these built-in functions because they handle the different operating systems for you. Okay, so now we have the dir name. Now what we need to do is remove the game aspect or whatever aspect from this dir name. So I will say new dir name is equal to my dir name dot replace, and I'll replace whatever the toStrip string is that we pass, which will be game, with an empty string, which will just get rid of it from the directory. Then I will say new names dot append my new dir name. Then I will return my new names. Fantastic. Okay, so now let's get our new names. So let's say new game dirs is equal to get name from paths, and our paths are going to be the game paths, and to strip, we're just going to strip off the string game. Fantastic. Now let's print our new game dirs. All right, now notice I have create directory as well, so we should see that a new directory gets created here when I run this. Let's try it and see what we get. And notice now that we get hello world, rock, paper, scissors, Simon Says, plus the target directory was created. So I'll delete that so we can create again later. Okay, now we do have the underscore here. Now that makes sense, right? Because we're just looking for game. Now in this case, we can look for underscore game and we can remove that entire thing, but it's up to you how you want to do this, right? If you look for underscore game, then if you started the directory name with just game, it wouldn't count or it wouldn't remove it. So you could do some advanced logic to remove this if you want, but for now, we'll just make it underscore game. I think you guys know what I'm saying here. Okay, so let's clear that. And what do we need to do next? Well, now that we have our kind of destination, our source directories for all the games, as well as where we want to put these games, now we need to, well, we need to write them, right? Like we need to actually do the copy operation. So what I'm going to do is make a new directory or new function, not directory, and I'm going to call this copy, okay? Now what copy is going to do is take a source and a destination, and it's going to copy the source into the destination. Now I will actually kind of change this a little bit, and I will say copy and overwrite. Now the reason for this is that if the directory already exists, I want to overwrite it, and I will show you how we can do that. Now, keep in mind the commands I'm going to use here are just one option to do this. There's like a million ways you can go about copying and deleting directories, but I'm going to show you how we delete a directory if it already exists, and then, of course, how we copy it. And this will be a recursive copy, which will copy everything. So if there was another directory inside, it would copy that directory as well and all of the contents of that directory. A lot of the copy operations don't do that, so just keep in mind if you want a recursive copy, you probably want to use the option I'm showing you here. So I'm going to say if os.path.exists destination, then I need to start by removing the destination folder, which I'm going to use my shutil for. So I'm going to say shutil.rmtree, which stands for remove tree, which is essentially a recursive delete. And this is going to be the destination. Now after this, I will say shutil.copyTree, and then I will copy the source to the destination. All right, that's all good. That's all we need for copying and overwriting, or overriding, however you want to. I think overwrite is the correct term there. Okay, so now that we've done that, we can use this function. So we need to essentially loop through all of the different paths that we have, so the source paths as well as the destination paths, and then we need to run this copy command. So I'm going to say for, and we'll call this src destination in. I'm going to use this zip function. I'll explain how this works in 1 second, but I'm going to pass my game paths and my new game directories. I'm going to start by saying my destination path is equal to os.path.join, and I'm going to join my target path with my destination folder name. Then I will run the copy and overwrite function with my src and my destination path. Okay, so let me explain how zip works. What zip will do is it will take matching elements from two arrays and combine them into a tuple, which then gives me access to them at the same time. So notice, right, these arrays or these lists are going to be the same length. So this first one is going to be all of the original game paths, and this is going to be our new game directory names that have this underscore game removed. Now I want to be getting the game path associated with the new game directory name because I want to copy whatever's here into this new directory name. So I zip them together. So to show you a quick example, if we have 1, 2, 3, and we have like A, B, C, then if you zip these together, what you're going to get is an array that has 1 and A, or a tuple, sorry, that has 1 and A, 2 and B, etc. It just combines them together. So the matching elements at their indices get kind of matched up, and that's why I can say source, destination here, and iterate through the zip. Okay, so now this should actually be good. However, I need to make sure that I create this directory before I do this. Otherwise, we're going to get an error where it says our path doesn't exist. Okay, so let me slow down for 1 sec. I'll explain what we've done. We can run it, and then we can continue. So what we've done here, right, is we've gotten the source path as well as the directory path. We have found all of the game paths that we're interested in, so essentially those directories from the source directory. We have then found what we want our new game directory names to be. We have then created the target directory where we want to copy all of these into. And now we are actually performing that copy operation. Okay, so we're at that point. So let's run this and see how it works. So Python get game data, and then we're passing data and target. I hit enter, and when I look in target here, you can see I now have hello world, rock, paper, scissors, and Simon Says with the contents of those directories because I just copied them in. Perfect. So now let me delete this, and we can continue. So the next thing I want to do is write a JSON file that just has some metadata about the different games, so what the game directory names are and how many of them there are. This is fairly straightforward, so let me create a function. I'll say make JSON metadata file, and here I will just take my path. So what do I want the file to be, or where do I want it to be? And then I will take my game dirs. Okay. Now here I'm going to say that my data, this is the data I want to write into the JSON file, is going to be equal to, and I will say my game names is simply my game directories, and I will say number of games, and this will be the len of my game dirs. Very straightforward, not the most useful data, but just want to show you how we write JSON. So now there's a few ways to do this, but the preferred method is to do the following. I'm going to say with open path in W mode. W stands for write. This will override the file if it already exists. If you wanted to read the file, you'd use R. So I want to write and override if it exists. So I'm using W, and I'm going to say as F, and then I'm going to say JSON dot dump, and I'm going to dump my data into my file. Now, if you've ever seen JSON be used before with dump S stands for dump string, and that's going to dump the JSON data you have into a string. We don't want that. We want to dump it into a file, or just really save it into a file. So we pass the data that we want to save, which in this case is a Python dictionary, which can kind of be represented as a JSON object. And we want to save it into this file object that I'm opening using something known as a context manager. Now, the reason I use this is because as soon as we're outside of this with, we are automatically going to have the file closed for us. If we didn't use with, we would have to manually close the file. And there can be some problems doing that, especially if an error occurs before we're able to close the file. We can have kind of a memory leak going on. So it's just preferred to use this. It's referred to as a context manager that just makes sure your cleanup operations happen no matter what, essentially. Okay, so we have this JSON metadata file. So let me copy this function. Let's paste it here. We'll say make JSON metadata file. And now we need to pass a path that we want to use. So I'll say JSON underscore path is equal to os.path.join, and I will join my target path with my metadata.json name. So I've just come up with this name. You can name it anything you want. And then I will pass here the JSON path and my new game dirs. Right, there we go. Okay, so let's run this again and see if it creates the JSON file. Okay, go to target. And notice we now have our JSON file. If I save, it will auto format here. And you can see we have our game names and our number of games. Fantastic. Okay, so let me delete that. All right, now that we have done that, I need to show you how we can compile this Go code and how we can run the Go code. All right, so let's write a function here that will allow us to compile the code inside of a directory. Now, let me just space out my functions here so they're a bit easier to read. Okay, and let's do it here. So define, this will be compile game code. Now here, we'll take a path, which will be the path to the directory we want to compile the code inside of. Now, what we need to do here is we need to locate or determine the name of the file that we want to compile. You know, no pun intended or rhyme intended there, but you know what I mean. So we have main, we have code, we have file. Now, in this case, we could hard code that, but we don't want to do that. We want to have this dynamic so it works with kind of any Go file, no matter what the name is. So essentially, we're going to look through the directories of our games, and we're going to search for any file that ends in .go, right? So let's create a variable here and say game code extension, and I'll just make this .go. So that's what we'll search for. Now, if we find that, then we'll compile that code. Now, we could compile all of the files that have that name, or we could compile just the first one. In this case, I'll just do the first one because we're assuming we only have a single code file in each of our directories. All right, so let's say code file name is equal to none. And then let's walk through this directory like we did before. So we're going to say root dirs files in os.walk our path, and this time we're only interested in the files. So I'm going to say for file in files, and let's not forget to break here at the end of our for loop so we only do this one time, not recursively. Okay, so for files in files, I'm going to say if the code, what did I even call this? Game code. Okay, game code extension. If the game code extension is in the file, then I will say my code, let's do this, my code file name is equal to file, and then I will break. Okay, that's actually all we need. I know I went fast there, but that's all we need to determine what the name of our code file is. So we loop through all of our files here, right? So for file and file, and we say, okay, if this .go extension is associated with the file, then we'll say code file name is equal to file. And then we'll break, which means we'll just find the first one. We don't need to continue looking. Now, what I just realized, though, is that this could be a little flawed because I could technically have a file that's like .go.py. I know that would be a weird name, but that wouldn't be a .go file. That would be a Python file, right? Well, I think that would be a Python file, but it would be a bit weird either way if we had something like that. So what I'm going to do instead is use a little bit of a better way of doing this. I'm going to say if file.ends with. So I'm going to check if this is at the end of the file. I think that's a better way to do this check. Okay, perfect. So now what I'm going to do is I'm just going to make sure that we did have a code file. If we don't have one, I'm going to return. If we do have one, then I'm going to run the command to compile this. So I'm going to say if the code file name is none, then just return, just so that we don't get an error when we try to compile a file that doesn't exist. Now we need to actually compile the file. So the first thing I'm going to do is say my command is equal to, and then I'm going to make a variable up here, which will be my compile command. So I'm going to say game compile command. Now, the way you write these commands is just in an array of, I keep saying array, in a list of strings that represent the commands that you need to run. So it's going to be go and then build. So this is the command, go build, then whatever the name of the file is. So this is my like base command. So I'm going to say my command is equal to my game compile command plus, and then I'm going to put another list here, and I'm going to add inside of here the code file name. Now what this will do is make the command be go build, and then whatever the file name is, then I can pass this to a function that I'm going to write, which will just run any command that I pass it. So we're going to say run command. We do actually need the path that we want to be running this command from. Okay. So now I'm going to say that our current working directory is equal to os.getcwd. Is that what it is? Getcwd? Yes, that's correct. And I'm going to show you how we change our working directory into this path. The reason for that is that I need to run this command. Well, I don't need to, but I'm going to run this command directly in the directory where our game code is. So rather than being in the directory where my Python script was run, I'm going to change into that directory, run the command, and then change back to a different directory, just to show you how you do that. So I'm going to say os chdir, which stands for change directory, and I'm going to change into the path directory. Then I am going to go and run the command. Now, to run the command, we're going to use the sub process command run, which I believe I imported from up here. Yes, I did. So we're going to say run, and we're going to run our command, and we're going to say our standard output is equal to pipe, and our standard input is equal to pipe, and I'm going to say universal new lines is equal to true. Now, this is where the command gets a little bit complicated, right? What does all this mean? Well, the standard output and the standard input is the location where the command is, well, accepting input and spitting out the output. Now, pipe is kind of this special thing that we can use that makes a bridge between our Python code and the process that we're using to run this command. Now, I'm not really going to explain it more than that, but just understand that that's why we're putting it here. It essentially allows us to communicate between the process that can actually run this special command, because this command is not a Python built-in command, right? Like, this is a command we just run in our terminal or in our command prompt. Again, you don't have to understand it. Maybe that explanation was good, maybe it wasn't, but this is how you do it. You import run and pipe from sub process. You pass the command. Again, the command is just going to be an array of all of the different words that are in that command, or a list of all of the different commands. And then if you wanted the result, it will be given to you in this result variable. So you could print out the result, you could read it in as a JSON object, blah, blah, blah. You could do whatever you want, and you could see what that result is. And in fact, we'll print out the result just so you can see what it looks like. So I'll say compile result like that. Okay, now the last thing we'll do, just as good practice, is we're going to change our directory back to the current working directory we were in before we ran, or before we changed directories into this path, just to make sure when we run this command another time, we don't get any potential errors, okay? So we got the working directory we were in, changed into this path directory, ran the command, and then we went back into whatever the previous directory was, just so that we don't have any potential problems here. Now we need to call this function. So we'll say run command and path. That's actually fine. We can just pass those values. Great. So now where do we call our compile game code function? Well, we're going to call that from inside of our copy here. So I'm going to say compile game code, and I will compile game code in the destination path, because once we've done the copy and overwrite, once this is finished, now that directory exists, let's compile the game code, then move on to the next directories. So at this point, the project is pretty much finished. Let's run it though. Make sure it works. Okay, compile result, and notice it gives you kind of this like result object, right? I'm not going to, again, kind of dig into exactly how this works, but you can see that if you wanted to look at the standard out, then it would be std out from this compiled process, or sorry, not compiled, completed process. And if this had any result, like if there was an error, you'd be able to see it there. And the return code would most likely be an error return code as well. Now let's look at target here. So we have target, we have hello world, and now notice inside of my directories, I have my compiled code, right? I have main.exe, code.exe, file.exe, etc. If you were on Mac or Linux, you would get, I believe, a .sh file or an executable file on your operating system. It would be different than if you were on Windows. Okay, so I think I'm going to wrap up the video here. All of this code will be available on GitHub. I'll also zoom out a bit and kind of slowly scroll through in case any of you want to pause the video and have a look at any of the lines here. But I thought this was a useful project just to teach you some basic kind of automation. I don't want to call it automation, scripting, syntax, tools, commands you can use in Python. I write code like this all the time in Python. It's really helpful. This is kind of my go-to language when I need to do like file or file system operations. So hopefully you guys found some value from this. And of course, if you did, make sure to leave a like, subscribe to the channel. You guys can check out my programming expert course if you want to learn how to become a Python programmer or a software engineer as fast as possible. And I look forward to seeing you in another YouTube video.